Hi everyone, welcome to PrepFusion. So today we are going to see our new marathon that would be based on information theory. So usually when we study information theory, we study two topics, information theory and coding. And in coding there are two parts, source coding and channel coding. So in this particular marathon, we are going to see information theory, where we are going to cover entropy, mutual information, channel capacity theorem and some miscellaneous topics we are going to see. Okay, so this is the part we are going to cover, and usually people ignore this particular chapter, but it is of very high importance and it is very easy as well. You might have studied this particular chapter in formula based, but here you will understand, you will develop the understanding of entropy, mutual information, channel capacity, not just the formula. Okay, so you watch that video, and once you are done watching this video, what I expect from your side? Comments. Okay, only thing I expect from your side is comments. You should comment down and you should share it with your friends. So just try to comment down that, sir, what is the different thing that we have learned? Here you would realize that something in a different manner has been taught. So once you are done watching this video, you will comment down, and the next marathon would come once we hit 30,000 subscribers. So as soon as we hit 30,000 subscribers, I will bring this source and channel coding marathon as well. So here we are going to discuss about Hamming codes and cyclic codes. Along with that, in source coding, we are going to see Shannon-Fano coding and we are going to see Huffman coding. So this particular topic would also come after this particular marathon. Okay, so this is of roughly around 11 hours of marathon. This video will be of roughly around 11 hours, and this would be roughly around 4 to 5 hours. This channel coding and source coding part would be completed in 4 to 5 hours. Okay, sir, what all are the prerequisites? So go step by step. First we studied about random variable, then we studied about random process, and then we studied about digital communication. Here digital communication is not ended, but if you have the knowledge of this much, then you will be able to understand information theory. Although not much knowledge of digital communication will be required here, but still, if you have covered all these points and then you have come here, then it would be very good for you. Okay, I am not sure like what is the reason behind that. You would see that random variable 2 is having lesser views and random process is having more views. Basically, you cannot understand random process without studying random variables. So why people are watching random process more than the random variable? That is not understandable to me. Like digital communication system, you cannot understand digital communication system without learning random variable and random process. Like whole random variable and random process would be used in digital communication system. So why digital communication system is having more views than random process? It is not understandable to me. Okay, so follow step by step. Random variable 1, random variable 2, random process, and then digital communication 1. Right? If you have this much knowledge, then you would be able to cover this much part as well. So these four marathons plus this marathon and this marathon. So these 6 marathon combined, I am pretty sure it will be asked for more than 7 to 8 marks. More than 7 to 8. This is the minimum number I am telling. Minimum 7 to 8 marks will be asked from these 6 marathons only. You can see it would be a content of roughly around, this would be 17, 18 hours, 29 hours, 12 hours, and then this is 10 hours, 22, 5, 27. So within 50 hours, roughly around the content will be of 50 hours in these 6 marathons, and it would be asked for more than 7 to 8 marks. And believe me, you will be able to solve every single question. All you need to do is that get the notes. Notes you can get from the Telegram group. For all these videos, notes have been already uploaded. For our information theory, for this particular part, I will upload the notes tonight. Okay, tonight I will upload the notes for this particular part. Right? So have the notes, get the printout, and just sit on the table and start studying. Okay, your 7 to 8 marks will be confirmed, and these marks are rank defining marks. Because not everyone would be able to understand communication system, but once you study, once you follow all the content, and you would surely you are going to love it. Okay, so notes will be uploaded, everything is already there, so just start studying. Once you end the video, I would expect comments from your end. You will be commenting down that, sir, how did we feel like studying from here? This is what I would be expecting from your end. Okay then, yeah, thank you very much. Let's get started learning about information theory. Hi everyone, welcome to PrepFusion. So we are going to study our new chapter now, information theory and coding. Okay, a very important topic. Usually people find it lesser important, but you can see these marks. Okay, in GATE 2022 it was asked for 5 marks, in GATE 2025 it was asked for 6 marks. A very small chapter. People usually consider this as a less important chapter, but now you can see they are asking questions from this particular chapter. Okay, from this particular chapter they are asking questions in the GATE examination. So now this has become a very important chapter for you. So if you are thinking that, sir, can I drop this particular chapter, then my answer would be no. don't drop this chapter at all, because a very easy question would be asked. If you know the concept, then you will be able to solve it. Secondly, people think that this particular chapter is formula based, but we will try to focus more on the concept here. Surely we will study formula, but I will try to give you the intuition behind all the formula. Okay, so just hold on to the video, pick your pen and paper and start studying. Okay, so let's get started with our chapter, that is information theory and coding. So first we are going to see the part of information theory, and then we will study source coding, and then we will study channel coding. Okay, what is the meaning of everything? We are going to study every particular thing that is necessary for your examination. So we have seen the block diagram of digital communication system, right? This was the transmitter side, this was your transmitter side, and this was your receiver side. So this kind of diagram we have already seen, right? There will be sampler, there will be quantizer, there will be encoder, modulator. Modulator means here I used to write down line coder. So line coder is modulator only. Basically encoder, what encoder would do? Encoder will generate some bits. Now what line coder would do? Line coder will make this bit 0 as -5 and this bit 1 as +5. So it is modulating the bits into waveform. It is modulating the bits into some pulses. So that was a modulator only. So in place of line coder I am putting modulator here, and then that will be traveling through the channel. In the channel what will happen? Noise will be introduced. AWGN channel would be there, noise will be introduced, and now the signal will be reaching to the receiver. So first there will be a receiving filter, then there will be threshold detector, then there will be decoder, and then there will be low pass filter. So all the blocks we have studied one by one. Everything is crystal clear about this particular block diagram. Now there could be another way of representing this digital communication system. I am representing this system only, but in another way. What I am doing? Now what this sampler and quantizer was doing? When MT was fed to the sampler, sampler gave you MST, sampled signal of message signal, right? And then quantizer, what quantizer was doing? Whatever the signal was coming here, quantizer mapped these input values to a particular voltage level. Let's just say input was changing from -5 to +5. So what quantizer did? -5 to -3 was mapped to -4. -3 to -1 was mapped to -2. Then 0, 2 and 4. So basically at the output of quantizer, what you are getting? You are getting these 5 kind of symbols. Sir, previously you used to call these guys as symbol, like pulse of +5 volt and -5 volt. You used to call sir, this is S0 symbol, this is S1 symbol. But here whatever the output quantizer is giving me, I will call that output as symbol. Is that clear to you? Because basically they are the symbols only, no? Basically 5 kind of symbols we are generating: -4 volt, -2 volt, 0 volt, 2 volt, 4 volt. Now what this encoder would do? It would convert -4 volt into 0 0 0, -2 volt into 0 0 1, 0 into 0 0 0, 2 into 0 0 1 and 4 into 0 1 0. In that manner this encoder will convert. So basically these symbols are only being converted, no? And now what line coder would do? Line coder can pick 3 symbols at a time. Line coder can pick 3 bits at a time. If it is picking 3 bits at a time, then what it would do? 0 0 0 will be mapped to -4. 0 1 0 can be mapped to -2. So this is what your line coder would be doing. So basically what I am saying is that from the sampler and quantizer, whatever the output that I am getting in this chapter, that output will be known as symbol. Okay, whatever the output that you get after the quantizer, that output will be called as symbol. Is that clear to you or not? Fine. So basically what I am going to do, I am going to denote sampler and quantizer as one block only, and I will call that particular block as source. What I am doing, I am calling this particular block as source. So what will happen? The MT will be fed to the source, and this source will be giving us some symbols. Okay, this source will be giving us some symbols, or you can say it will be giving us some voltage level, but here I will be representing symbols. So let's just say this source is giving us 4 symbols: x1, x2, x3, x4. What this source encoder would do? What is the job of encoder? Here I used to write down only encoder. Here I am writing down source encoder. So what it would do? x1 will be mapped to 0 0, x2 will be mapped to 0 1, x3 will be mapped to 1 0, x4 will be mapped to 1 1. Now it is not necessary that x1 will be mapped to 0 0 only. x1 can be mapped to 0, x2 can be mapped to 1 only, x3 can be mapped to 1 0, and x4 can be mapped to 1 1. this can also be possible. Sir, why it is possible, how it will be possible, everything we are going to study when we talk about source encoder. As of now, I am just telling you that what is the job of this source encoder. Whatever the symbol this source is generating, just you need to map these values into some bits. That's it. Now, what is this channel encoder, sir? Previously, we used to study about only one kind of encoder. That was a simple encoder. X1 was mapped to 0, 0, X2 was mapped to 0, 1, X3 was mapped to 1, 0, X4 was mapped to 1, 1. Now you are saying that, sir, it is also possible that this can be X1 can be mapped to 0, X2 can be mapped to 1, X3 can be mapped to 0, 0, and X4 can be mapped to 0, 1. Sir, you are saying that this kind of things are also possible. Although this will not be possible, this is actually wrong coding. But when we study this source coding, at that time I will tell you that this particular thing is also possible. Is that clear to you? Okay. And then what will happen? These bits that has been generated, whatever the bits that has been generated, that will be fed to our channel encoder. What this channel encoder would do? So channel encoder will always look at the noise. This channel encoder will be working based on the noise. So the job of this channel encoder is that I will generate some bits. What was fed to the channel encoder? Bits will be fed, right? 0, 0, 0, 1, 0, 0, 1, 1. So this channel encoder will make sure that I will send the bits in a manner that it is less affected by the noise. Basically, 0, 0 was fed, but what channel encoder would do? Channel encoder will send 0, 0, 1. 0, 0 was fed, but channel encoder will send 0, 0, 1. 0, 1, 1 was sent, but channel encoder will send 0, 1, 1, 0, 1. Why it is doing so? To reduce the effect of noise. Now, how this is reducing the effect of noise? That we need to study in channel coding. So that we will study in channel coding. So is that part clear? Like here I have mentioned coding. So what is the meaning of coding? We need to study two kinds of coding. One will be source coding and one will be channel coding. Is that clear to you? What is the meaning of channel coding? Channel coding will make sure that the effect of noise is less. This is the job of channel coding. And what is the job of source coding? Whatever the symbols were generated here, to convert that into bits, and it will convert in a manner that these symbols will be converted in a manner that redundancy is the lowest. Now what is this redundancy? Everything we are going to study, but as of now only on the top level I am telling that what is our flow of chapter. Is that clear to you? So basically this source is generating four kind of symbols: x1, x2, x3, x4. Then these are going through the source encoder. X1 will be mapped to some bits, X4 will be mapped to some bits, X2 will be mapped to some bits, X3 will be mapped to some bits, and X4 will also be mapped to some bits. Then channel encoder will make sure that the noise that we are going to encounter, that should have the least effect or least effect on these symbols. So it will add some extra bits. It has added some extra bits. These extra bits will make sure that effect of noise is minimum. And then what is the job of modulator? The job of modulator is to send these symbols through the wire or through the channel. It could be wireless channel, it could be wired channel. Then it will be fed to the demodulator. What demodulator would do? Opposite process of modulator. What channel decoder would do? Opposite process of channel encoder. What source encoder would do? What source decoder would do? Opposite process of a source encoder. Right? So they will just do the opposite process. So everything we are going to study. As of now, my target was the flow should be clear to you. I hope the flow is clear. Even if it is not clear, then also it is fine. As of now, you just need to understand only one thing, that our source is generating four kind of symbols: x1, x2, x3, x4. Okay, and then we will have some received output here. So in place of empty, I am writing down x. My input was random variable x and my output will be random variable y. Now our target would be that x should be equal to y. Basically, looking at y, I should be able to tell everything about x. Like basically, if I receive y1 here, then I should be knowing that it is coming from x1, or it could be coming from x2, or it could be coming from x3, or it could be coming from x4. So if I am able to look at y1, then I should be able to tell that whether it is coming from x1 or x2 or x3 or x4. That would be our target. That means we have done the reliable transmission. Is that clear to you? All these points will again come back. Basically, I just wanted you to know that what will be our flow of learning. This will be our flow of learning. So first we will be studying about the source and channel. What we will be studying? This source and channel together. So first we will be studying about source, then we will be studying about channel, and then we will be combining both of them. Okay? Is that clear to you? So what this source will do? Source will generate some symbols. This source will generate some symbols x1, x2, x3. So let's just say there is a source S which is generating symbols x1, x2, x3. And now we are going to understand the meaning of information. What is the meaning of information? Now this source, let's just say this source was you, okay, or this source is me. This source is me. This source is nothing but my mouth only. So from my mouth I generated symbol x1, and that symbol x1 was, I am saying that sun will rise from the east. Now I am telling you this statement that sun will rise from the east. Will you be surprised? No. You already know that sun will be rising from east. So what is the probability of this event happening? 1, right? You already know that sun will surely rise from east only. So I am saying that tomorrow sun will be rising from east. Will you be surprised? No. And if I ask you, did you get any information here? No information, because I already know this particular thing. There is no information. This is a certain event. No, this is a certain event, that this event will surely happen. The probability of this event happening is very high. So this event will surely happen. That means there is no information. Now what if I say tomorrow the sun will rise from the north? Now you know that actually sun rises from the east. What I am saying, the sun will rise from the north. So now you will be very surprised. Now you will say that, sir, you have given me some great information, right? So what is the probability of this event happening? 0. And how much information you got here? Infinite information. Why infinite information, sir? Because I did not even know this particular thing. I did not even know that sun can rise from the north. But sir, you are saying that tomorrow sun will be rising from the north. That means some infinite information you have given me. Is that clear to you what I am saying? Like if there is a certain event, that is going to happen only, like if I say tomorrow sun will rise, then you know that sun will be rising for sure. That means you are not getting any information. But if I say that tomorrow there will not be any sunlight, then you would say, okay, yeah, this is some information that you are giving me. Here, probability of this event happening is 0. That means a lot of information I have given you. That means infinite information I have given you. Now tomorrow it may rain. What is the probability of this event happening? It would be somewhere between 0 to 1. Because it may rain as well, it may not rain as well, right? What is the probability of this event happening? You cannot say, sir, it would be 1. You cannot say, sir, it would be 0. It may rain, it may not rain. So how much information you are getting from here? So, some decent kind of information. Some decent kind of information you are getting. Some decent kind of information you are getting. Is that clear to you? If the probability is high, that means information is lesser. If I say Australia will beat Nepal in cricket, okay? In cricket, Australia will beat Nepal, because Nepal is not a great cricket playing nation. Like Nepal is a weaker cricket team when it is compared to Australia. So Australia will beat Nepal. Yes, you will not be surprised. There is very less information. Very less information. Very less information. But if I say Nepal will beat Australia, you will say, yes, sir, there is more information. That means this is very surprising for you. When you are getting more surprised, that means less probable event is there. What is the probability of this particular thing? Sir, it would be very high. What is the probability of this particular thing? If I call this as x1, this as x2, what is the probability of this particular thing? Sir, it is very low. That there is only 10% chances are there that Nepal can beat Australia. But there is 90% chances are there that Australia can beat Nepal. So here you are getting lesser information and here you are getting more information. So from here, what did you understand? The first point that you understood is that information is inversely proportional. Information in some symbol x is inversely proportional to the probability of that symbol x. It could be x1, x2, x3. That's why I am putting xi here. So information in some symbol xi is inversely proportional to the probability of occurrence of that particular symbol. Is that clear to you or not? So then same thing I have written down in the next page. Information is inversely proportional, information is proportional to the uncertainty. What is the meaning of that? Information is proportional to the uncertainty. That means this event is uncertain, this event is certain, that means no uncertainty. This is completely uncertain. If it is uncertain, that means probability is lesser, that means information is high. So information is proportional to the uncertainty. Is that clear to you? Or you can say information is inversely proportional to the probability of occurrence. So if there is a symbol x which is generating, if there is a symbol x or there is a symbol s, I should not say symbol, if there is a source s or source x which is generating x1, x2, x3 symbols, which is having probabilities of px1, px2 and px3, then the information contained in x1 will be inversely proportional to the probability of occurrence of x1. Is that clear to you? Okay. So this is what I have written. Let x is a discrete random variable with possible outcomes of x1, x2, x3 and xn. The information of event x equals to xi is defined as, so information contained in symbol x equals to xi will be, basically here I have written down the symbol x is generating x1, x2, x3 and till xn. Okay, x1, x2, x3 and till xn. So information content will be inversely proportional to probability of occurrence of that event. Okay, so pxi is probability of occurrence of right. So what will be your ixi? That would be log, when I remove the proportionality constant, when I remove this proportionality sign, what I will get? I will get log base b when I remove this sign, this is what I am getting. Okay, so this is the information content in a symbol x equals to xi, that is log base b 1 by pxi. It could be written as, sir, what is the meaning of base b? That I will talk about it, don't worry about it. So this could be written as this particular thing, 1 upon pxi is simply pxi and then minus sign you can take outward, right? Log 1 by is equals to minus log a, very simple thing, right? So when you remove this proportionality sign, what do you get? Log with base b. Now this base b could be anything. It could be base 2, base 3, base 4, base 5, base 6, base 7, base 8, base 9, base 10. Most famous bases are these: base 2, base e, base 8, base 10. And this is the most famous one. 99% chances are there that we will be using this one. 99.99% chances I am saying. 99.99% chances are there that we will be using base 2. All the calculation we will do with respect to base 2. Okay. So base 2 is, if our base is 2, then the unit of information will be bits. I am talking about the unit of information, that would be bits if the base is 2. If the base is e, then the unit would be nets. If the base is 2, unit is bits. Okay. If base is 8, then unit would be octets. Okay. And if the base is 10, the unit would be Hartley. You need to remember this one. Okay, very, very important. Now we will understand more about information, okay, with respect to an example. So what this particular example is saying, a binary source is generating symbols by tossing a fair coin. It produces an output 1 if head is appearing, and it produces output 0 if tail is appearing. Let's just say our binary source was x, which is generating two kind of output. Why I am calling it binary source? Because it is generating two kind of output, that is 0 and 1. So it is generating two kind of output, 0 and 1. So what is the probability such that x equals to 0 is generated? X equals to 0 you will get when tel is appearing. So what is the probability of tel being appeared? That is 1 by 2. And what is the probability of head being appeared? That is also 1 by 2. So what they are asking, determine the information content of each output symbol. So you need to determine information content such that x is equals to 0. So that would be equals to, so log base 2. What I will be using? I will be using base 2. So basically this formula of information I will be using. And most of the times I will be writing it down in this manner. Okay. Most of the times I will be writing down in this manner. This is something that I am going to use a lot of time. This is how I will be writing it down. Okay. So log base 2, what is pxi? That is 1 by 2 and a negative sign is there. Basically I was supposed to write down 1 upon 1 by 2, no? 1 upon 1 by 2. Right. So what I did, 1 by 2 I took upper side and minus sign I can take outside. Basically this formula you already know, pxi, log 2 pxi. So in place of pxi what I am putting 1 by 2 and then there is a negative sign as well. That's it. So what you are getting? 1. What will be the unit? 1 bit. So the event x equals to 0 is giving me 1 bit of information. And how much information this would give me? That would also give me 1 bit of information. So when you toss a coin, when you toss a particular coin, then probability of getting head is 1 by 2 and probability of getting tail is 1 by 2. So if you are getting head, that means you are getting 1 bit of information, and if you are getting tail, that means you are getting 1 bit of information. What is the meaning of 1 bit of information? You will understand it more. Let's go to next example. Now what you are doing, you are again tossing the coin, but this coin is not fair. Probability of getting a head is 0.8, probability of getting a tail is 0.2. Okay, so probability of x equals to 1 is 0.8 and probability of x equals to 0 is equals to 0.2. So what will be the information content in this particular thing? So that would be 0.8 but with the negative sign. Log 2 0.8 but there is a negative sign as well, right? Don't forget about that negative sign. Now I need to do the calculation. So what will be the answer of this calculation? Zero 0.8 log 2. So 0.32 bits. Okay. What will be the answer of this calculation? That would be 2.3 bits, 2.32 bits. So what do you understand from here? When I am tossing this particular coin, and then I ask you, what are the chances that I am going to get a head? Like I am tossing this coin and then I am asking you, what do you think what I will be getting? I am tossing this particular coin, okay? And then I ask you, what do you think what I will be getting? You will be saying that, sir, you will be getting a head. Why so? Because, sir, probability of head is more. So where you will put your money on? You will put your money on head. Why? Because probability of head occurrence is more than the probability of tail occurrence. That means if probability is more and I toss the coin and head only appears, will you be surprised? You will be surprised but very less surprised, because you know that probability of head occurrence is 0.8. That means there are more chances that head would appear. So you will be lesser surprised. That means you are getting less bits of information. You are getting only 0.32 bits of information. But what if I toss the coin and tail appears, which was having a probability of 0.2 only? Then you will be more surprised. More surprised means you are getting more information here. So then you are getting 2.32 bits of information. Is that clear to you or not? I toss a particular coin In the previous case, what was the scenario? If I toss this particular coin and then I ask you, will I get a head or tail? What you will say? Sir, I don't know, because both are having the same probabilities. So sir, I don't know. So even if head is appearing or tail is appearing, in both of the cases, your level of surprise would be same, because you know that anything could appear, head or tail. This is a fair coin. But if I am tossing a biased coin where I know that more chances are there that head would appear. So if I toss the coin and head is appearing, then will you be surprised? You will be surprised, but very lesser surprised, because you know that more chances were there of head only. But what if tail appears? Then you will be more surprised, because you know that there were very lesser chances of tail appearing. That means the more information you are getting when tail is appearing, and lesser information you are getting when head is appearing. Is that clear to you or not? Okay. So this is the meaning of information. I hope I am able to tell you the actual meaning of information. Is that clear? Okay. So one formula we have seen here. This formula we will be using. Ixi is equals to minus log 2 pxi. Okay. Information content in symbol xi would be equals to minus log 2 probability of occurrence of xi. Now what this is saying? A discrete memory source. A discrete memoryless source. Sir, what is the meaning of this discrete memoryless source? We will talk about it. Don't worry. Okay. Discrete memoryless source. Discrete means output will be discrete. Input will also be discrete. Source means source. What is the meaning of memoryless? That means it is not having any memory. Have you studied memoryless system? That means present output will be depending on present input only. Basically, if I apply an input x naught, it is giving me output y naught. Then I apply input x1, then it is giving me output y1. So y1 was depending on x1 only. Y1 was not depending on x naught. And y naught was depending on x naught only. Y naught was not depending on x1 or any previous symbol. So present output would depend on present input only. This is the meaning of memoryless source. And discrete meaning you already know. Input is also discrete, output is also discrete. Here also discrete random variable, here also discrete random variable. So that would be your discrete memoryless source. Is that clear to you? So it is generating 4 discrete symbols that are S1, S2, S3, S4 with probabilities this much. Determine the information content in each symbol. So what do you think? Which particular symbol will have them more information? This one. Why this one, sir? Because if S1 appears, if S4 appears, then you would be more surprised. That means you will be getting more information, because probability of occurrence of S4 is very less. Is that clear to you? So what I am saying, information content in S1, I am directly write down in this manner. That would be minus log 2.5. That would be equals to 1 bit of information. Information content in S2, that would be minus log 2. You can solve it, you will get 2 bit, right? Because it would be 1 by 4, so 2 to the power 2, it would be 2 bit. Surely it would be more than this, because it is having lesser probability. Less probability, more surprise. More surprise means more uncertainty. More uncertainty means you are getting more information. What will be your IS3? This calculation I need to do, and next calculation also I will have to do. That would be minus log 2.1. Okay, 0.1, 3.32. Surely it will be lesser than 3.32. So it would be 2.73. So if they are asking you the information content in some symbols, will you be able to tell it? Surely I will be able to tell it. Now let's study about average. Here I am calculating the information content of symbol S1, information content of symbol S2, information content of symbol S3, information content of symbol S4. What if I want to take the average? How will I take the average? Let's see that, okay? But before that, let's solve a simple mathematical problem. If I ask you to calculate the average of these 5 students, what will be your answer? So that would be 10 plus. Sir, why you are doing so? You will understand, okay? I want to build up some concept. Divided by 5. So this guy was getting 10 marks. This guy was also getting 15 marks, 20 marks, 25 marks and 30 marks. What I am doing? I am taking the average. So what I will get? 30 50 and 50. 30 plus 20, 50, and this will also be 50. So 100 divided by 20, so 20 marks per student, right? What is the unit of this average? That would be per one student is getting average 20 marks, right? Is that clear to you? Can I write it down in this manner? Sir, 10. Now, how many times 10 is occurring? One time out of 5. So, probability of occurrence of 10, that would be equals to 1 by 5. Probability of occurrence of 15, probability of occurrence of 20, and probability of occurrence of 25, and probability of occurrence of 30, all will be equals to 1 by 5. Is that clear to you or not? So, can I write it down in this manner? 10 into 1 by 5. 10 marks, probability of occurrence of 10 is 1 by 5. 15 marks, probability of occurrence of 15 is 1 by 5, plus 20 marks, probability of occurrence of 20 is 1 by 5, plus 25 marks, probability of occurrence of 25 is 1 by 5, plus 30 marks, probability of occurrence of 30 is 1 by 5. What will be the answer I will be getting? Same answer I will be getting. Say yes or no, right? How will you calculate the average of this particular thing? Sir, I will calculate 10 plus 20 plus 20 plus 25 plus 25 divided by 5. What will be the answer? Again 20 marks per student. This is the answer. But sir, can I do one thing? 10 marks, probability of occurrence of 10 is 1 by 5. Okay, let's just remove it. Plus 20 marks, probability of occurrence of 20 is 2 by 5. Plus 25 marks, probability of occurrence of 25 is 2 by 5. What you are getting? Again 20 marks per student. So what do you think? How will I calculate the average information? In this particular question, everything was written same, and then they asked you what is the average information of a source S. Information contained in S1 multiply with probability of occurrence of S1 plus information contained in S2 multiply with probability of occurrence of S2 plus information contained in S3 multiply with probability of occurrence of S3 plus information contained in S4 multiply with probability of occurrence of S4. So this is the same question that I have written. A discrete memoryless source is generating these probabilities. Determine the average information of the source. Here what I will say, average marks of the students. A group of 5 students is there, or you could have said average marks of the class, because in the class there are 5 students, S1, S2, S3, in that manner, and they are getting some marks. So basically class is generating 4 kind of symbols: 10, 15, 20, 25, 30. Probability of occurrence of 10 is 1 by 5, 15, 1 by 5, and so on. So similarly here I am having a source S which is generating 4 symbols: S1, S2, S3, and S4. Information contained in S1 came out to be 1 bit, 2 bit, 2.73, 3.32. 1 bit. Okay. In S2 it came out to be 2 bits. In S3 it came out to be 2.72, 2.73, 3.32. And here it came out to be 3.32 bits. So these are the information content. And if I ask you to find out average information, so average information of the source. Why source? Because source is generating these symbols, no? So what I want you to find? Average information. So how do you find the average? Average is always find out probability of how much information this is giving, average information. So how much information this is giving? 1 bit. Probability of occurrence 0.5 plus how much information it is giving? multiply with probability of occurrence, that is 0.25. How much information this is giving? 2.73. Probability of occurrence, that is 0.15, right? Plus how much information this is giving? 3.32, and probability of occurrence 0.10. We will solve it, we will get some answer, but let me know the unit. What will be the unit? Here what was the unit? Marks per student. Marks per student. So it was getting 10 marks, 15 marks, 20 marks, then eventually the unit was marks per student. It is giving you information of 1 bit, 2 bit, 2.73 bits, 3.32 bits. So unit will be this much information you are getting per symbol. Look, usually average information will be taught, they will write down the formula and they will write down the unit. But I am telling you the region behind everything, and that's why I took this example. Is that clear to you why we are relating this particular thing? Why we are relating our communication system with simple mathematics? S1 is giving you this much bit of information, S2 is giving you this much bit of information, S3 is giving you this much bit of information, S4 is giving you this much bit of information. So from the source, you are getting some bit of information per symbol. Is that clear to you? From the source, you are getting this much information of bits per symbol. So we need to calculate this particular thing, that would be 0.5 plus 0.5, 2.73 multiply with 0.15, multiply with 0.15 plus 0.332 plus 1. So 1.75, roughly around 1.75 we are getting. So we are getting 1.75 bits per symbol. This much information we are getting. Roughly around this much information, this much average information we are getting from here. 1.75 bits per symbol. Is that clear to you or not? So this is the average information, and this average information is known as entropy of source X. Okay, what is the name? Entropy of source S. What is the meaning of entropy? In class 12th or in engineering, somewhere you would have studied entropy. In thermodynamics, you might have studied entropy. So wherever entropy word is coming, that means entropy will talk about uncertainty. What is the meaning of entropy? Entropy of source S. That means uncertainty of source S. Entropy of Himanshu. Uncertainty of Himanshu. Entropy is simply uncertainty. So wherever entropy word would be written, I will be calling that uncertainty in the whole chapter. Okay. So what is uncertain? What is entropy? Entropy is the measure of uncertainty or unpredictability of a random source. So this was your random source. Entropy of random source S. That means how much uncertainty is there in random, how much uncertainty is there in your source S. So whatever the uncertainty is there, that much information it is giving you. So it is giving you an information of 1.75 bits per symbol. If it was not having any uncertainty, let's just say S was transmitting only symbol S1. S was transmitting only symbol S1. So what will be the probability of occurrence of symbol S1? That would be 1 only. It is not transmitting any other symbol. So is there any uncertainty? If I go to source S, will I ask him that what kind of symbol you are going to generate? No, I already know that it will be generating S1 only. So what will be the probability? Sorry, what will be the uncertainty? That uncertainty would be 0. That means your entropy is written by capital H. So entropy of S would come out to be 0 only. And you can check as well. What will be the information in S1? That would be information of S1. That would be 0. So probability of occurrence of S1 is 1. What is the information? That is 0. 1 into 0 would be 0 only. Is that clear to you? Is that clear what I am saying? It will be more clear, we will see more example, but as of now, let's write down the formula. You don't need to mug up the formula, you have understood the concept. If you have understood the concept, you don't need to mug up the formula, but usually people mug up the formula. So what it is saying, there is a source X which is generating these symbol X1, X2, X3. The entropy of source X is given by capital H of X. And when I'm talking about entropy, I'm saying x is discrete random variable. Okay, we are talking about discrete random variable only. So your x is discrete random variable. So when I talk about entropy, that means x is discrete random variable. So entropy of x would be given by probability of occurrence of x1 multiply with information content in x1 plus probability of occurrence of x2 multiply with information content in x2 plus probability of occurrence of s3 multiply with information content in s3 and so on. This would be x1. What will be your information content in x1? That would be log 2 px1, but there will be a negative sign. Don't forget this formula. Negative sign would be there. There would be a negative sign. Similar thing will happen here as well, but there would be a negative sign for sure. Similar thing would happen here as well. There would be a negative sign for sure. Okay, I am writing down with respect to base 2. This can be generalized for any base, but I am writing down with respect to base 2. Is that clear to you? Okay. So what you are getting, if I write down that textbook formula, then textbook formula would be written somewhat like this. Summation goes over I. Is that formula is clear to you? So will you mug up this particular formula? No. Will you mug up this formula? No. Nothing you will mug up. You have the concept clear to you. I will find out the information of every symbol, multiply with the corresponding probabilities. Then I will add them up. What I will get? I will get the average information, and that is entropy. So let's calculate entropy of some examples. Okay. But before that, some mathematical problem we are going to see, because again and again we are going to encounter this particular condition. Okay. Again and again I will be asking you this particular thing. X is equals to 0. 0 into log to 0. What you will say? Sir, 0. Here, what is log to 0? Log to 0 is, sir, minus infinity. What is the value of log 0? What is the graph of log x? This is the graph of log x. So what is the value of log 0? That is minus infinity. So 0 into minus infinity, it is undeterminate form. So what will be the answer? So for finding out the undeterminate form, what we need to do? We need to put the limit. So let's see the limit. So x log to x at x tending to 0. So what do you think what you will be getting? This is the form of 0 into minus infinity, or 0 into infinity I can say. What does that mean? I can apply L'Hopital rule. Spelling. Right. So what I can do? Limit x tending to 0 log 2x. What is that? Infinity divided by 1 by x. So you can apply the L'Hopital rule actually for this particular condition, that is infinity by infinity. This x has gone downward, it has become 1 by x, right? Is that clear to you? Infinity by infinity, I can apply the L'Hopital rule. So what I can do? Limit x tending to 0. What will be the differentiation of log 2x? So log 2x could be written as ln x divided by ln 2. Do you remember this particular thing? Log base a b. So it could be written as log base any log b divided by log a. Now here you can put any base. So log x divided by log 2. I have put the base of e. Log 2x. Log 2x could be written as log x divided by log 2. I have put the base of e. So it would become ln x divided by ln 2. Is that clear to you? Very simple thing. Very, very straightforward. So this is how your log x could be written. Ln x divided by ln 2. So ln 2 will be a constant value. I don't care. If I differentiate ln x, what I will be getting? 1 by x. 1 by x divided by ln 2 is a constant value. I am differentiating it. I have simply done the differentiation, nothing else. Differentiation of log 2x, what that would be? So that would be 1 by x ln 2. That's it. So differentiation of log 2x I have done. That is 1 by x ln 2. This much basics should be clear to you. If you are studying communication system, that means this much mathematics you already know. And what will be the differentiation of 1 by x? That would be minus 1 by x square. Now this goes upward. What you will be getting? Limit x tending to infinity, x square x ln 2. This and this get cancelled out. Minus sign is there. Array yaar, y infinity x tending to 0. Sorry guys. This is x tending to 0. So if you put x tending to 0 here, what you will be getting? 0 divided by ln2, answer would be 0 only. So what did you understand here? Limit x tending to 0, x log 2x. So anytime you get this condition, sir, 0 into log 2 0, I will always say it will be equals to 0. You will not say, sir, 0 into log 2 0 will be, sir, this condition. So, sir, this is indefinite form. We have proved it, 0 into log 2 0 is equals to 0 only. So, anytime this particular condition is occurring, what you will say? Sir, it would be equals to 0. Limit we have find out. What it is coming out to be? 0. So, in our analysis, a lot of time, like at least 10 times this condition would occur. 0 into log 2 0. Directly, I will write down there 0. Is that clear to you? Okay, well and good. Let's calculate the entropy of source X, which is generating 4 symbols x1, x2, x3, x4 with the different probabilities. So this probability condition is given, this probability condition is given, this probability condition is given, and this probability condition is given. So what you need to tell me? You need to tell me the average information or entropy of source X. Okay, entropy of X. So what that would be? Will you apply any formula? No. Probability of occurrence of this one, multiply with average information. Sorry, not average information, I should say information. What is the information? This much is the information, but there is always a negative sign. Is that clear to you? Plus probability of occurrence of this one, multiply with information. That would be log 2 0.4, but there would be a negative sign, so this would become negative. Okay, don't focus on the formula, focus on the concept. In the examination, we will never apply the formula. Directly we will solve it. Like we will not write down the formula, we will directly solve it. Right? Probability of occurrence of x3, that is 0.3, multiply with its information. So here plus sign would come, although plus sign would come. What will be the information? The information would be log 2 0.3. Then there would be a negative sign, so this plus sign would convert into minus sign. And then minus 0.1 log 2.1. Okay. So what is the answer you are getting? That we can see. We will see it later on. I will do all the calculation and I will put the answer. Here also you can do the same thing. Minus sign would surely be there. I am just writing down the final answer. So just you will remember this particular thing. Probability log 2 probability plus probability log 2 probability. Minus sign is already going on. Plus probability log 2 probability. And the same thing will be happening. Plus probability log 2 probability. So here also we will be getting some answer. Okay. What do you think? What will be the answer you will be getting here? Minus 0 probability log 2 probability. Probability, okay, probability is 1. Probability log 2 probability. Probability log 2 probability. Probability log 2 probability with the negative sign. What is the answer of this one? 0 into infinity, indefinite form? No. 0 into infinity is 0 here. So this is 0, this is 0, and this is also 0. What about this one? What is the value of log 1? Log 1, that is equals to 0. So 1 into 0 will be 0. What is the answer you are getting? 0. We are going to make some conclusion out of it, okay? Answer is 0. Here, what is the scenario? Minus sign always outside. 0.25 log 2 0.25. Probability log 2 0.25. Probability log 2 probability plus probability log 2 probability. Right? So can I write it down in this manner? Minus 4 into 0.25 log 2 0.25. Okay. When you solve it, it would come out to be equals to log 2 4 only. Okay. Log 2 4. What will be the answer? 2. So this answer is 2. I will write down the unit as well. Bits per symbol. Here also I will write down bits per symbol. Okay, I will take a break. I will calculate all these scenarios and we will get our answer. Okay, so I will calculate this scenario as well. I will calculate this particular scenario as well, and I will see what answer we are getting. You can also do the calculation on your own. Yeah, so I have calculated these values, and values are coming out to be, for this case, entropy is 1.84. What is the conclusion that we are going to make from here? That we will see now. And here entropy is 1.25, here the entropy is 0, and in this case entropy was 2 bits per symbol. Okay. Is that clear to you? Now let's just say there is a dice. Okay, there is a dice. On the dice usually there are 6 output, but I am saying that on this dice there are only 4 kind of output: x1, x2, x3, x4. Okay, there is a dice. On this dice there are only 4 kind of output are possible: x1, x2, x3, x4, x5 and x6 are not occurring at all. Okay, this is what I am saying. Now I am talking about this particular case. I roll this dice, okay, and I ask you what will appear. You will say, sir, 101% x2 will appear. There is no uncertainty. There is no uncertainty. 101% x2 will appear. So how much uncertainty is there? 0. So if any of the symbol is 1, that means uncertainty would be 0. If I roll this dice, you will say, sir, 101% x2 will appear. There is no uncertainty. Now if I go here, if I ask you what will appear, I roll this dice and I ask you what will appear. You will say, sir, I am not sure, but more chances are there for x1. But I am not sure. There could be uncertainty. x2 can also appear because 0.2 probability. x3 can also appear. 0.05. x4 can also appear. But sir, more chances are there that x1 would appear. So there is uncertainty. There is some non-zero uncertainty. What about this one? Sir, here as well there is uncertainty, but more chances are there that x2 would appear. But even x3 can also appear because x3 is also having the same kind of, nearly the same kind of probability. Is that clear to you? Here probabilities are, in this case, probabilities are very far away. 0.7, 0.2, 0.05, 0.05. So a lot of chances are there that 70% chances are there that this should appear. So there is lesser uncertainty, no? In which case there is more uncertainty. If you want to place your bet, if you want to put your money, first thing is that we should never be doing gambling, okay? I am not telling you to gamble. I am just giving an example. So if you want to gamble, in which case you would like to gamble? In this case or in this case? In this case, right? You would want to put your money in this case because you know that more chances are there that x1 would appear. Because there is lesser uncertainty. Here also there is uncertainty, but more than this case. And what do you see? 1.25, 1.84. So here there is more uncertainty. In which case there will be maximum uncertainty? In this case only, no? Because in this case, if I ask you what will appear, you will not make any comment. You will say, sir, anything can appear. I am highly uncertain. x1 can appear, x2 can appear, x3 can appear, x4 can appear. Because you are highly uncertain here. All are having the same probabilities. If all the symbols are equiprobable, what I am saying, if all the symbols are equiprobable, then the entropy of source x would be maximum. Not by the mathematics, but by the pure intuition we are understanding it. If one of the symbol is 1, what does that mean? That means there is no uncertainty, 100% x2 would appear. Here more chances are there that x1 would appear, but again not sure. More chances of x1 is there, but again not sure. There is some uncertainty. Here more chances of x2 is there, but x3 can also appear, x4 can also appear, x4 can also appear, x1 can also appear. Uncertainty is there and it is more uncertain than this case. It is more uncertain than this case. Why is that so? Because here there is very high chance of x1, but in this case probabilities are nearby, 0.4, 0.3. They are nearby. They are near to each other. And in this case the highest uncertainty is there. What is the meaning of entropy? Entropy is nothing but uncertainty. Okay, entropy is nothing but uncertainty. So highest uncertainty is there in this particular case, and here all the symbols are equiprobable. It is generating 4 symbols and all the symbols are equiprobable. 1 by 4, 1 by 4, 1 by 4. So highest uncertainty would be there when all the symbols are equiprobable. Do you remember quantizer? At the input of the quantizer, there was a random variable x which was having a PDF of fx of x. We made this kind of PDF. Like random variable x was taking value between -5 to 5. And then I said that output of the quantizer would have the maximum entropy if the probability of occurrence of all the levels is equiprobable. Output of the quantizer would have the maximum probabilities if all the levels are equiprobable. Do you remember this statement or not? Are you able to understand this statement here? When the entropy would be maximum, when the entropy of these x1, x2, x3, x4, these would be maximum if they are equiprobable. From where x1 would be coming? X1 would be coming from, let's just say, -5 to -3. From where x2 would be coming? Sir, it is coming from -3 to -1. From where x3 is coming? It is coming from -1 to 1. From where x4 is coming? Sir, it is coming from 1 to 3. And from where x5 is coming? Sir, it is coming from 3 to 5. So if probability of occurrence of x1 is equals to x2 is equals to x3 is equals to x4 is equals to x5 is equals to 1 by 5, that means they are coming from here. That means random variable x taking value between -5 to -3 should be equals to probability of random variable x taking value between -3 to -1 should be equals to probability of random variable x taking value between -1 to 1 should be equals to probability of random variable x taking value between 1 to 3 should be equals to probability of random variable x taking value between 3 to 5. So this particular thing we saw in quantizer. Now we are able to relate. Why did we see it in quantizer? Is that clear to you or not? So maximum uncertainty would be there if all the symbols are equiprobable, because I cannot comment. I cannot comment, sir, what would be appearing. X1 would be appearing, X2 would be appearing, X3 would be appearing, or X4 would be appearing. Is that clear to you? Usually people mug up the formulas, some apply mathematics, but forget about mugging up, forget about mathematics. We have just built up our intuition here. Is that clear to you? So all these things I am going to write down, but before that, this is the note that we are writing down. Let a source X is generating k equiprobable symbols. That means it is generating k symbols x1, x2, x3 till xk. So what will be the probability of all of those? All of those symbols, what will be the probability of occurrence of x1, x2, x3, x4? Let's just say it was generating 4 symbols. So probability of occurrence of x1 was 1 by 4, x2 was 1 by 4, x3 was 1 by 4, and x4 was 1 by 4. So it was generating 4 symbols, so probability was 1 by 4 or 1 by k. So if it is generating k symbols, then the probability will be 1 by k. So what would be your h of x? So here, sir, our h of x would be maximum. Here our h of x would be maximum. Sir, what that would be? Sir, probability log to probability. Minus sign is already there. Then probability log to probability. Probability log to probability. It is happening for how much time? It will happen for k times, right? Here also probability log to probability, it happened for 4 times. There were 4 symbols, no? 1, 2, 3, 4. It happened for 4 times. So it will happen for k times. This will go on for k times. So 1 by k log to 1 by k is multiplied k times. What I am saying? This particular thing is multiplied k times. So k times it is being multiplied. So k and k will get cancelled out. This is 1 by k, that would become k to the power -1. So what you will be getting? Log 2k. Okay. And what will be the unit? Unit would be bits per symbol. So what is the maximum value of h of x? So h of x could be 0 or it could be equals to log 2k. Uncertainty cannot be negative, no? There is no meaning of negative entropy in case of discrete random variable. In case of continuous random variable, we will study something else. This we are studying about discrete random variable. In the examination, they never asked about continuous random variable, but they can ask in future. That's why we will study continuous random variable as well. But as of now, what do you see? Entropy can never be negative. It would be between 0 to log 2k. That means uncertainty would be equals to 0 or it would be equals to log 2k, where what is k? K is the number of equiprobable symbols. Equiprobable symbols generated by the source. Okay, so if a source is generating four symbols, then simply the answer would be log to 4. So here, that's why I wrote down the answer directly. Source X is generating 4 symbols. So what will be the entropy? Source X is generating 4 symbols. What will be the maximum entropy? What kind of question can be framed? The question can be framed is that there is a source X which is generating 16 symbols. Okay, what will be the maximum value of the entropy? So what you will do? Sir, log to 16. Answer would be 4. 4 bits per symbol. That's it. Is that clear to you? In this question you can write down anywhere. Space is there, so you can write down source X is generating 16 symbols. Find out the maximum value of entropy. That would be log 216. That would be 4 bits per symbol. Because all symbols should be equiprobable if I want my entropy to be maximum. And if all are equiprobable, then the answer would come out to be log 2k. Okay, log 2k. So it is generating 16 symbols, so answer would be log 216, 4 bits per symbol. Okay, so somewhere there would be some space. In this particular space, you can write it down. Or what I can do, I can give you more space here. Okay, more space I am keeping for you. So in some space you can write down here. You can write down the question here. Okay, so in this particular space you can write down your question. If there are 16 symbols, then what will be the maximum entropy? That would be log 216. That would be 4 bits per symbol. All good? All fine? Okay, let's solve this particular question. So a stationary continuous continuous valued source X is distributed according to the PDF given. The source is quantized by 4 level of quantizer as follows. Find out the average information of the quantized symbol Q of X. What it is saying? So there is a quantizer that has been fed with a random variable X. Now this random variable X has been quantized in Q of X. This has been quantized in Q of X. Now what is this Q of X? Q of X can take 4 kind of values. -3, -1, +1 and +3. It can take 4 kind of values: -3, -1, +1 and +3. So this is the scenario here. What they are asking? They are asking the entropy of this Q of X. That means this Q of X is working like a source which is generating 4 kind of symbols, which is -3, -1, +1 and +3. So what is the probability of occurrence of, what is the, I should not write down X because X is the random variable. So what I should say, what is the probability of occurrence of, is that clear to you what I have written down? Probability of occurrence of Q of X equals to -3. So Q of X is generating -3, -1, +1 and +3. So when your Q of X would be equals to -3, when your Q of X would be equals to -3, when your X is between -4 to 2. That means my X should be between -4 to -2. -4 to -2. So 1 by 16 into 2. That would be 1 by 8. Is that clear to you? So Q of X taking value -3, the probability is 1 by 8. Why I am interested in this probability? Because what would be my answer? What I need to find out? I need to find out the entropy of this particular thing. That would be how much output it is generating. Basically here what I find out, H of X. So H of X was generating this much output, they have corresponding probabilities. H of X were generating these many outputs, they have corresponding probabilities. So I am interested in the probabilities. So 0.2 log 2 probability, 0.4 log 2 probability, 0.3 log 2 probability, 0.1 log 2 probability, and then there was a minus sign. So what I am interested in, it will generate 4 kind of symbols: -3, -1, +1, +3. I am interested in their probabilities. So what do you think, what will be the probability of Q of X taking value equals to -1? You can calculate on your own. That would be equals to probability of random variable X taking value between 220. If you understand the random variable random process, then communication system is very easy. Otherwise, it is very difficult. You can find out this area. This area would come out to be 3 by 8. Okay, you can find out this area. It would come out to be 3 by 8. How did I write it down? I did not even do the calculation. How did I write it down? It would be 3 by 8. This would be half. This whole will be 1. This would be half. This would be half. So now this is completely half. That means this portion is 1 by 8. I already know. So this portion will be 3 by 8. Because 3 by 8 plus 1 by 8 will be 1 by 2. Although in the examination, when this question would come, they will not give this particular value. So you will equate the whole area equals to 1, then you will find out this particular value, that will come out to be 5 by 16. Although this value is also not required. To solve this particular problem, this value is also not required. If they are saying that it is a valid PDF, then you would know that this area is 1 by 8. So this area has to be 3 by 8. This area has to be 3 by 8. And this area has to be 1 by 8. So probability of q of x taking value minus 3, that is coming out to be 1 by 8. This is coming out to be 3 by 8. What this would come out to be? From 0 to 2. This would also come out to be 3 by 8. Because of the symmetry, this area would be 3 by 8. This area would also be 3 by 8. And that would come out to be 1 by 8. So basically minus 3 is occurring with the probability of 1 by 8. Minus 1 is occurring with the probability of 3 by 8. Plus 1 is occurring with the probability of 3 by 8. And plus 3 is occurring with the probability of 1 by 8. My matter of concern is only the probability. So what will be the answer? Minus sign is already there. 1 by 8 log 2 probability plus 3 by 8 log 2 probability plus 1 by 8 log 2 probability plus 3 by 8 log 2 3 by 8. So I need to do this calculation. So I can do this calculation. You can also do it. Let me pause the video and then I will write down the answer. So answer would be 1.81 bits per symbol. Okay, all good, all fine. So this is your average information of the quantized symbol q of x. So all these symbols are there. Minus 3, minus 1, plus 1, plus 3. These are having the probabilities. We wrote down the probability and got our answer. Is that clear to you? Very, very straightforward and very simple topic it is. Next, what we need to do. So as of now, we are holding on this entropy thing. We have understood the meaning of entropy. It will again come back, but let's talk about the channel now. So what was our diagram? This was our diagram, right? 1 hour back, we studied about this diagram. So there will be source, there will be source encoder, there will be channel encoder, modulator, channel would be there, then demodulator, channel decoder, source decoder, and then we studied that there would be this source x. Better like should not be saying that this is the input. I should not be saying this is input. Like from source, a random variable, these kind of symbols are being generated. x1, x2, x3, x4. So I should say that this all these symbols are belonging to this capital X. This is the source, basically source x. I should not say this is the input. I should just say that there is some source x which is generating x1, x2, x3, x4, these kind of symbols which are going into the encoder. Okay, and finally what I will get? I will get my output y. So here only I should write down the output y, right? Basically I will get the symbols y1, y2, y3, y4 or anything else as well. So I can get this was my input x1, x2, x3, x4. These symbols were generated. It went through the whole system and eventually I am getting y1, y2, y3, y4. Okay. So kind of I can say that from the transmitter x is going and from the receiver finally I am getting capital Y, right? So in this manner I can say. Is that clear to you? So I can say the input is x, output is y, and in between there is a channel. But sir, directly channel is not there, no? In channel there will be effect of noise. Along with that, these blocks are also there. So as of now, I need to ignore these blocks because I haven't studied about these blocks. So what I would do, from the transmitter, these symbols are being generated, and at the receiver, these symbols are being received. That's it. This is what I am going to talk about now. Is that clear to you? Why I came back to this slide, is that clear to you? I will say that from the transmitter x1, x2, x3, x4, these 4 symbols are being generated, and at the receiver, I am getting y1, y2, y3, y4. These 4 symbols I am getting. Is that clear to you? Then how this channel will be represented? So that I am talking about. So inside block I am not caring about. this transmitter is generating 3 symbols, let's just say x1, x2, x3, and these 3 symbols were traveling through the channel, and finally we got 2 symbols y1 and y2. So what I am saying, 3 symbols were there. Source X was generating 3 symbols, x1, x2 and x3, and I am getting 2 kind of output. I can get 3 output as well, I can get 4 output as well, I can get 1 output as well, I can get anything. So I am saying that I am getting 2 output, y1 and y2. Okay, let's make them a bit far. 2 outputs I am getting, y1 and y2. So what does that mean? That means that when symbol x1 was generated, the output could be y1 or output could be y2. Basically this will be generated with some probability of occurrence of x1, probability of occurrence of x2, probability of occurrence of x3. x1 is generated, it can either go to y1 or it can go to y2. So probability is such that y1 is received given that transmitted signal was x1 or transmitted symbol was x1, and here what I will be writing down, probability is such that y2 is received given that transmitted symbol was x1. Is that clear to you? These are known as conditional probabilities. Here this is the way of representing the channel. There is no concept here. This is the way of representing the channel. This is how the channel will be represented. What they will say, input symbol, and finally at the receiver what you are receiving. So x1 was generated with respect to x1, output could be y1 or y2. So probability is such that probability of receiving y1 such that x1 was transmitted, probability of receiving y2 such that x1 was transmitted. Similar thing could happen with x2 as well. x2 can also result in y1 and y2. So what I will write down here, probability of receiving y1 such that x2 is transmitted, probability of receiving y2 such that x2 is transmitted. Then what can happen? Next can happen, same thing can happen with x3 as well. Same thing can happen with x3 as well. What I will write down here, probability of receiving y1 such that x3 is transmitted, probability of receiving y2 such that x3 is transmitted. So here what kind of probabilities are written? Here always conditional probabilities are written. What this is known as? This is known as conditional probability. Probability of y by x. What it is known as? Conditional probability. There is something called joint probability as well. What is the meaning of joint probability? We used to write down A intersection B, right? Event A and B. What is the meaning of intersection? Intersection means and. So in communication system, this intersection is replaced with comma. Okay, intersection is replaced with comma. So probability is such that y is received and x is transmitted, or better opposite also you can write down, both are the same thing only. Probability is such that x is transmitted and y is received. So if I am writing down x1 y2, what does that mean? Probability is such that x1 was transmitted and y2 was received. Is that clear to you? Okay, so what I will write down, x1 y2, or better here I should write down x comma y. We will study about everything again and again, so have some patience. Have some patience, you are going to understand every single thing about all these topics. Okay, so what this is your joint probability. Can you just recall one thing? Probability of A by B, what that was equals to? A intersection B divided by PB. So what will be your probability of y by x would be equals to probability of x comma y, or y comma x you can write down, divided by probability of x. So probability of, so from here what you can write down, this formula is more important. Probability of x comma y would be equals to probability of x y by x. Okay, this is very important. Probability such that x was transmitted and y was received would be equals to probability such that x1 is transmitted multiply with probability of receiving y1 such that x1 is transmitted. This is how you should be able to say. Okay, this is the statement. What is the statement? Probability such that x1 is transmitted, probability such that x is transmitted and y is received would be equals to probability such that x1 is transmitted multiply with the probability such that y is received given that x1 is transmitted. Y is received given that x is transmitted. I am saying with respect to x1, y1, it could be anything. x1, y2 could be there, x2, y1 could be there, x3, y2 could be there, anything could be there. But on these lines, these yellow line, green line, these blue line that I have made, always here what kind of probability would be written? These will be your conditional probability. So this will not be given in the examination. In the examination, they will draw the diagram and they will just say that, they will not say anything. So by default, you need to know that these are the conditional probabilities. Is that clear to you? That's why I made this diagram. So by default, you need to know that these are conditional probabilities. These are not the joint probabilities. Joint probability and conditional probability both are different. So by default, it should be clear to you that whatever the probabilities that are written on these lines, yellow line, green line, blue line, these are conditional probabilities. So all the statements, everything I have written here, this was our channel, right? x1, x2, x3, received output was y1, y2. So this is probability of receiving y1 such that x1 is transmitted, probability of receiving y2 such that x1 is transmitted. All these things are written. What is the meaning of y2 by x1? Probability of receiving y2 by x1 I am saying, right? Probability of receiving y2 such that x1 is transmitted. This is known as conditional probability. We will come to this particular point, but let's first talk about this thing. Probability of y2 comma x1. What does that mean? Probability such that y2 is received and x1 is transmitted. What this is known as joint probability. Joint means x1, y2 are together. Joint probability. What is the meaning of conditional? There is a condition that x1 is transmitted, y2 is received. So this I already know. Okay, it is given that x1 is transmitted. Then what is the probability that y2 is received? What is the meaning of this one? It is given that y2 is received. That means you are standing here. You know that y2 is received. Now what is the probability that it would be coming from x1? This is what they are asking. You know that y2 is received. What is the probability that it could be coming from x2? So what it could be written as? You know that y2 is received. What is the probability that it is coming from x2? You know that y2 is received. What is the probability that it is coming from x3? You know that y2 is received. What is the probability that it is coming from x1? So these two are different, right? y2 by x1, x1 by y2, both are complete different thing, right? Is that clear to you? Basically, what does that formula say? What would be your probability of y by x? That would be y comma x divided by x. And what would be your x by y? That would be x comma y or y comma x, whatever you can call it, divided by py. Is that clear to you? From both of the condition, what you can find out? Probability of x from here as well. Both are the same thing, yx or xy, a intersection b, b intersection a. Both are the same thing only, no? Probability of yx, what that would be? Probability of y, probability of xy. Just I am doing the multiplication here. So from here, what did you understand? These two are equal. So what you can see, probability such that x is transmitted, multiply with the probability given that x is transmitted, y is received, is equals to probability such that y is received, probability such that it is coming from x given that y is received. So whatever that you write down, that you already know. Is that clear to you? This statement is also very important. This particular line is also very important, because in the diagram this particular thing would be given. Probability of y by x, this would be given. They will ask you to find out this particular thing. So what you will do, you will use this particular relation. You know p of x, you know p of y, or it might happen that you know this particular thing. It might happen that you know this particular thing. So basically this kind of relation you will have to use, because y by x would be given, they can ask you x by y. So we will solve these kind of problems, don't worry about that. But are you able to relate all these things? These are basic probabilities. If you are studying random variable, random process, that means if you are studying information theory as well, probability should be clear. You might have already studied mathematics. right? So these much are very basics of probability which you have already understood in class 11, 12 as well. Okay, very basic thing. And what is the meaning of probability of x1 by y2? Given that y2 is received, what is the probability that it is coming from x1? And what is the meaning of y2 by x1? Given that x1 is transmitted, then what is the probability that it is going to y2? Because if x1 is transmitted, it can go to y1 as well, it can go to y2 as well. So what is the probability that it will go to y2? This is the meaning of x1 by y2. Sorry, this is the meaning of y2 by x1. And what is the meaning of x1 by y2? Given that y2 is received, now y2 could be coming from x1 as well, it could be coming from x2 as well, it could be coming from x3 as well. So from where it is coming? That's the thing. Is that clear to you? Okay. And now very important discussion we are going to do here. Okay. Very important discussion is there. Just let me know what will be the value of this one. Probability of x1 plus x2 plus x3 based on this diagram. Source x will generate some symbol, no? Either it will be x1 or it will be x2 or it will be x3. In every case here we took all the probabilities are equals to 1 only. If you add all of them, it would be 1. It would be 1 only, which is pretty obvious, right? You will be transmitting something, no? Either you will be transmitting x1 or x2 or x3. So probability of x1 plus x2 plus x3 would be 1. If you are transmitting something, that means you will be receiving y1, y2. Say yes or no? That means if I transmit x1, either I will be receiving y1 or I will be receiving y2. Is that clear to you? Basically, probability of y1 plus y2 will also be equal to 1, no? Transmitted symbol, received symbol. Probability of addition of probabilities of all the symbols would be equal to 1. Very simple thing, right? So now here what I am doing, you are transmitting 3 kind of symbols, x1, x2, x3, right? You are transmitting 3 kind of symbols, x1, x2, x3. Now in all these symbols, if you transmit x1, x2, x3, if you transmit x1, x2, x3, all these symbols can generate y1. If you transmit x1, there is a chance that you can get y1. If you transmit x2, there is a chance that you can get y1. If you transmit x3, there is a chance that you can get y1. So can I say that basically this is the region of x1, this is the region of, this much region is of x1. This is the region of x2. What I am doing, I am drawing the Venn diagram and this is the region of x3. So can I say that all will have all will have a common portion of y1. Like if I am transmitting x1, someone will say that sir, it can go to y2 as well. If you are transmitting x1, it can go to y2 as well. Yes, it can go to y2 as well, but it can go to y1 as well, no? So if I am saying that this much portion is of y1, then the remaining portion will be of y2. Is that clear what I am saying? If you are transmitting x1, then some part could be going to y1. If you are transmitting x2, some part could be going to y1. If you are transmitting x3, some part would be going to y1. Is that clear to you? So from here what you can see, what will be your probability of y1? Probability of y1 would be equals to probability of, what is this part? x1 intersection y1, x1 intersection y1 plus, what is this part? x2 intersection y1 plus, what is this part? x3 intersection y1. So what you can say, probability of receiving y1 symbol is equals to probability of x1 transmission and y1 received plus probability of x2 transmission and y1 received plus probability of x3 transmission and y1 received. This is more intuitive, right? From here you are getting the feel, but don't forget this diagram as well. Is that clear to you? Or what I can write down? Can I write it down in this manner? X comma y, probability of x comma y was equals to p of x dot p of y by x. Basically y get cancelled out, in that manner you can remember. So basically it's like that, probability of y1 would be equals to probability of transmission of x1 multiply with probability such that y1 is received given that x1 is transmitted plus probability of transmission of x2 multiply with probability x2 is transmitted given that x2 is transmitted, received symbol is y1 plus probability of transmission of x3 multiply with the probability given that x3 is transmitted but received symbol is y1. This is your probability of y1. Similar thing could happen with y2 as well, because x1, x2, x3 could result in y2 as well. So what will be your probability of receiving y2? So that would be equals to probability of x1 transmission multiply with y2 being received such that x1 is transmitted, plus probability of x2 transmission given that x2 is transmitted, y2 is received, plus probability of x3 transmission multiply with given that x3 is transmitted, y2 is received. Is that clear what I am saying? Again, you don't need to mug up anything, but there should be a way. But most of the problems we are going to solve with respect to this diagram only, so you will not have to worry. But how all these expressions are coming, that I am telling here. What is the meaning of receiving y1? What is the meaning of probability of receiving y1? What is the meaning of probability of receiving y2? So basically in the diagram what you would do, what you got to know, you see this expression y1 x1, y1 x2, y1 x3. If in the examination they are asking this particular thing, what they are asking, probability of y1, this is what they are asking. So you will stand here, what you are getting here, y1 x1, y1 x2, y1 x3, x1 x2 x3. So if I am standing here, how many ways are there for reaching y1? Sir, this way is there, y1 by x1. Sir, this way is there, y1 by x2. And sir, this way is there, y1 by x3. And multiply with their corresponding probabilities. So what I would do, how would I reach y1? That would be probability of x1 multiply with probability of y1 by x1 plus probability of x2 multiply with probability of y1 by x2 plus probability of x3 multiply with probability of y1 by x3. What you will do, you will reach at y1. So in the examination, these problems will not be very tough because we are not going to apply the formula there. With the diagram only we are going to solve it. But here everything, how these formula came, all these things we are learning. Okay. Now the similar thing I am going to draw with respect to the received output. Output would be y1, y2. Output would be y1, y2. Now output is y1, y2. From where it can come? It might have come from x1, it might have come from x2, or it might have come from x3. So if y1, y2 output is there, it might have come from x1. So if I ask you what is the probability of occurrence of x1? So it would be right. Now if I am asking this particular thing, that means I don't know the probability of x1. So what I can do, I can write it down in this manner. x1 by y2. So this is the probability of x1. What would be your probability of x2? So that would be received output is y1 such that it is coming from x2. What is the probability of x2 transmission? That would be probability of y1 multiply with given that received output is y1, it is coming from x2 plus output is y2 given that it is coming from x2. Okay. Probability of x3 y1 dot x3 by y1 y2 dot x3 by y2. So don't mug up anything, just draw this diagram. So two kind of possible output are there, y1, y2. If I need to find it out that from where it is coming, it could be coming from x1, it could be coming from x2, it could be coming from x3. So what will be my probability of x3? So simply I can see here is that it would be y1 comma x3 plus y2 comma x3. Can you write down y1 comma x3? Yes sir, there you go, yx, this relation yx. So probability of y1 dot probability of x3 by y1, probability of y1 dot x3 by y1, or you can say in the statement as well, what is the probability such that x3 is transmitted? That would be equals to probability of receiving y1 multiply with probability such that y1 is received and x3 is transmitted. I should not say and, given that y1 is received, x3 is transmitted, plus probability of receiving y2 multiply with the probability of transmission of x3 given that y2 is transmitted. So these particular things, these things will not be shown in the diagram. Okay, usually what will happen in 99% of the cases, these things will be given and they will be asking you these particular things, probability of y1 and y2, which will be very simple. We will solve the problems, but as of now, is this diagram clear to you? Yes sir, this diagram is clear to you, these diagrams are clear to you. From here, whatever the conclusion that I can make, that surely I will be able to make. Now there are four kind of statements. You need to think on your own, which of these four will be equals to 1 and which of them will not be equals to 1. Okay, and what this would be equivalent to, and from these particular 5 statement we are going to make this particular conclusion. So don't look at here. Okay, don't look here, just ignore it completely. Just tell me what will be the condition here, which of them would be equals to 1 and which of them would not be equals to 1. What this is saying, what do you think? Probability of x1 by y1 plus x2 by y1 plus x3 by y1. Right? So here, what do you know? In all these 3 probabilities, what do you know? I know that, sir, y1 is received, that I know. y1 is received. Now if y1 is received, you know that either it could be coming from x1 or it could be coming from x2 or it could be coming from x3 only. Probability says that y1 is received, given that y1 is received, probability says that it is coming from x1, plus given that y1 is received, probability says that it would be coming from x2, plus given that y1 is received, probability says that it is coming from x3. What will be the addition? 1. Because y1 would be coming, if I know that I have received y1, then I know that either it would be coming from x1 or it would be coming from x2 or it could be coming from x3. That's it. What about this one? Will that be equals to 1? What do you know here? That sir, x1, x2, x3 is transmitted. Here one thing you don't know. Here what do you know? That sir, x1 is transmitted. So if x1 is transmitted, what is the probability that y1 will be received? Let's just say I am saying that probability is 1. When I am transmitting x1, 101% y1 is being received. Now I can say that when I am transmitting x2, 101% y1 is being received. This is also possible. It is not necessary, no, that x1 should be going into y1 and y2 as well. Or what I can say, when I am transmitting x1, the probability says that y1 is received is 0.9 and probability says that y2 is received is 0.1. Is that clear? Basically, if you are transmitting symbol x1, it could be either going into y1 or it could be going into y2. It is going into y1 with the probability of 0.9, it is going into y2 with the probability of 0.1. Is that clear to you? Okay. So basically, we are not interested in this particular part. We are interested only in y1. We are not interested in this particular part. And here what I am saying, probability of receiving y1 such that x2 is transmitted, that is 0.7. And this particular thing is, let's just say, that is 0.3. So if you add all of them, what you are getting? 1.9. That is pretty simple, no? Here what do I know? That I am transmitting x1. What is the probability that y1 is being received? It could be anything. If I am transmitting x2, what is the probability that y1 is received? It could be anything. If I am transmitting x3, what is the probability that y1 is received? It could be anything. So it may or may not be equals to 1. So I will say it is not necessarily equals to 1. Is that clear to you? Not necessarily 1. Not necessarily equals to 1. Necessarily की spelling नहीं आती भाई. Not necessarily 1. Very simple thing, no? Like if x1 is transmitted, it can result into y1 with any probability. If x2 is transmitted, it can result into y1 with any probability. If x3 is transmitted, it can result into y1 with any probability. What about the next one? If you are transmitting x1, what is clear to you? Given that x1 is transmitted, given that x1 is transmitted. So if x1 is transmitted, I am pretty sure that either it will be resulting in y1 or it will be resulting in y2. Basically, what do I know? I know some fixed thing. What is that fixed thing? That fixed thing is that I am transmitting x1. So if I am transmitting x1, either it will be resulting in y1 or it will be resulting in y2. So surely this will be equals to 1 and this will not be equals to 1, because here as well, what is the condition? Here what you are saying, x1 by y1, x1 by y2. What does that mean? That sir, I know that y1 is being received. Now what is the probability that it is coming from x1? It could be anything. It could be coming from x2 as well, it could be coming from x3 as well. I am standing at y1. What is the probability that it is coming from x1? What is the probability that it is coming from x3? It could be anything. I don't know, but it could be any random value. Similarly, if I am standing at y2, what is the probability that it is coming from x1? What is the probability that it is coming from x2? It could be anything, right? Is that clear to you? So this is also not necessarily equals to 1. Surely very soon these kind of questions are coming in your examination. Very soon, 101% I am sure. Very soon these are coming. Okay, so not necessarily 1. They will write down 4 statements and they will ask you which of them are correct. Which of them are 100% correct. So these kind of things they will ask you. So these are 100% correct. Now sir, anything random, let's just say someone would frame y2 by x1 plus y1 by x2. So this is very random. It could be anything, right? y2 by x1, y1 by x2. So what did you understand here? What did you understand? That it would be equals to 1 only when this guy is not changing. It would be equals to 1 only when the denominator is not changing. So basically, whatever that you know, that should not change. Here I know x1. That means I am pretty sure that it will be resulting in either in y1 or in y2. If I know y1, then I am pretty sure that either it will be resulting in x1. Sorry, if I know y1, that means I am pretty sure that either it would be coming from x1 or it would be coming from x2 or it would be coming from x3. That's why the probability is 1. These are very random. That I know I am sending x1, but what is the probability of getting y1? It could be anything. I know I am sending x2. What is the probability of getting y1? It could be anything. I know I am sending x3. What is the probability of getting y1? It could be anything. Similar thing goes here as well. I know that I have received y1. What is the probability that I am getting it from x1? It could be anything. I know that I have received y2. What is the probability that I am getting from x1? It could be anything. So whatever that you know, that should not be changing. Is that clear to you? So how I can write it down? How I can write this particular thing down? I can write it down in this manner. Summation P of x would be changing, but y would be stable. So yj usually we write down and xi we write down. So who will be changing? I will be changing. J will be some constant. So I will be changing from 1 to 3. So probability of x1 by yj plus probability of x2 by yj plus probability of x3 by yj, where j can take any value. So this is how I can write it down. But if I need to write down the general statement, then I will not write down 1, 2, 3. In this manner I can write it down. Is that clear to you? Then how will I write down this particular statement? This is y by x. So yj xi. Who is stable? X is stable. In place of this x1, x2 will also be there. No, what I mean to say is that here you could have written down y1 by x2 plus y2 by x2. This is also true. We have we have understood the analysis with respect to x1. The same analysis can go for x2 as well. The same analysis can go for x3 as well. Is that clear too? So similar analysis I can write down here as well, right? Similar thing I can write down here as well. Here what I can write down? Probability of what should not change? Whatever that I know, that should not change. So I know y2, that should not change. Here I know x2, that should not change. Here I know x3, that should not change. So y2 should not change. Plus and similarly, that's it. This is true. That would be equals to 1, right? So how this could be written? Sir, it would be summation of x by y. With x I will write down I, with the y I can write down j. So this is not changing. So j is not changing. Who is changing? X is changing. So summation I, this is how I can write it down. And next, this is how I can write down this one. Sir, yj divided by xi. So who is not changing? Sir, this is not changing. This is not changing. Who is changing? J is changing. So summation j. Right? And what about the last one? What is this? Probability of x1 being transmitted and y1 being received. Probability of x1 being transmitted and y2 being received. Probability of x2 being transmitted and y1 being received, plus probability of x2 being transmitted, y2 being received, plus probability of x3 being transmitted, y1 is received, plus probability of x3 being transmitted and y2 being received. What that would be equivalent to? That would be surely equivalent to 1, because I have write down all the conditions, or you can check out from here as well. If you add both of them, which two guys you will add? So x1 y1, x2 y1 plus x3 y1 is there. Next, what I will write down? This is your probability of y1. What will be your probability of y2? Probability of y2 would be x1 y2, x2 y2, x3 y2. So these 6 only I am adding up. So these are the 6. x1 y1, x1 y2 and x2 y1, x2 y2, x3 y1, x3 y2. Right? So what I am seeing, x1 y1, x1 y2, or better I can say y1 x1, y1 x2 and y1 x3 plus y2 x1, y2 x2, y2 x3. It is pretty simple, right? Very straightforward thing. x1 is transmitted, it can either result in y1 or it can result in y2. If x2 is transmitted, it can result in y1 or it can result in y2. If x3 is transmitted, it can result in y1 or it can result in y2. So addition of all these would be equals to 1. So these I have written down in statement. So first one is xi by yj. Who is changing? This should not change. Who is changing? I should change. Y by x. This should not change. Who is changing? J should change. And here both can change. Basically x1 y1, x1 y2, x2 y1, x2 y2, x3 y1, x3 y2, and that would be equals to 1. Is that clear to you? Very, very important slide. You are not going to find it anywhere, even in the textbook as well. But this is complete mathematics and surely it can be asked in your examination. So these two slides are very, very important. The discussion of channel that we have done, that is also very, very important. Usually here very less time is spent, but I am pretty sure next good question, if it is coming from information theory, then it would be coming from here only. So everything should be clear to you, whatever that has been written in these slides. What is the meaning of conditional probability? What is the meaning of joint probabilities? How do we write down all these probabilities? Everything should be clear to you. Okay. Now some matrices are there that we will make conditional matrix, we will make a joint matrix. So everything we will make, but let's just take some break. Let me take some break. I will drink some water and then I will come back and we will talk about the conditional matrix. Basically it is nothing. You just need to make the matrix of probability of y by x. I will represent it in the matrix form. Okay. So how will I represent in the matrix form, that we are going to see, but let me take a break and then I will come back. Okay. Yeah, welcome back. So now we need to study probability matrices. Okay, very simple thing. Like what was our channel? This was our channel. Like this was the condition. X1 was being transmitted, X1, X2, X3 was being transmitted, and Y1, Y2, Y1 and Y2 was being received. So basically, probability matrix means whatever the probabilities are there, that I need to write down in a matrix form. Okay. So conditional matrix. If I am making the matrix of probability of y by x, what I am doing? I am making this matrix. Okay. I am making this particular matrix. So on the vertical line, I will write down my transmitted symbols. Transmitted symbols are x1, x2, x3. Okay. And horizontally, I will write down received symbols that are y1, y2. Horizontally, I will write down received symbols that are y1, y2. Is that clear to you? And all the probabilities I need to write down in matrix form. That's it. So this particular portion will be of a y1 x1. So probability of y1 by x1. This particular portion will be of a y2 x1. So probability of y2 by x1. y1 by x2. y2 by x2. y1 by x3. y2 by x3. This is your conditional matrix, probability of y by x. This is what I am writing down. Is that clear to you? Similarly, basically these values will be given now. From here only I can put these values. So this is our matrix. Why you are writing down this matrix, sir? It is of no use, but in the examination, if these kind of metrics are mentioned, directly they will write down probability of y by x. This matrix has been mentioned. So you should be able to know what they have actually written. So by default, you would know that on vertically they have written x1, x2, x3. Horizontally they have written y1, y2. So this would be probability of y1 by x1, y2 by x1, y1 by x2, y2 by x2, y1 by x3, y2 by x3. Similarly, you can write down this conditional matrix as well. Which conditional matrix? This conditional matrix also you can write down. So here as well, by default, horizontally I have written down x1, x2, x3. Horizontally this is the condition. I should not say horizontally, it is vertically, sorry. Vertically x1, x2, x3. Horizontally y1, y2. Okay, again we'll make the matrix. So this particular thing will not be mentioned in the examination. What they would do, this would be mentioned and directly these values will be mentioned. So you should be able to know what this is representing, probability of y1 by x1. So you would know that vertically x, horizontally y. Okay, so what this would represent? So this matrix is x1 by y1. So probability of x1 by y1, probability of x2 by y2, sorry, probability of x1 by y2, it would be x1 by y2. Here probability of x2 by y1, probability of x2 by y2, probability of x3 by y1, probability of x3 by y2, right? Well and good. Okay. Now, sir, these values will not be mentioned because here what is mentioned? Y by x is mentioned. You need to remember this particular thing, that here y by x are mentioned, not x by y. So if you need to find out x by y, how will you find out? Sir, I know one particular thing, that this is equivalent to what? And that is equivalent to, there you go. So this particular thing I know. So if I need x1 by y1, let's just say I need probability of x1 by y1. So let's just say I know this particular thing. So what I would do? Divided by probability of y1. Basically x by y you need to find out. So p of x comma y divided by py. Or what I can do? Sir, it would be equivalent to probability of x1, y1 by x1. Because this would be given, right? Divided by probability of y1. So nothing you need to mug up. Directly there we will write it down. No need to mug up anything. Okay. Most probably we will write down this particular thing, because x1 by y1 directly I will be able to write down probability of x1 comma y1 divided by probability of y1, because probability of a by b I remember. Probability of a comma b divided by probability of b. So x1 comma y1 divided by probability of y1. Okay. And then x1 comma y1 I will have enough practice to write down x1 comma y1, because probability of x1 comma y1, what you can see, probability of x1 multiply with probability of y1 by x1. So this particular thing would be given and this particular thing would be given. So probability of x1 comma y1 you would be very easily able to write down. It would be equivalent to probability of x1 dot probability of y1 by x1. So this very easily you will be able to write down. Probability of y1 also you will be able to write down. How many paths are there? One path, two paths, three paths. So we will do all these kind of things. We will practice enough and you will have good enough practice for writing down these kind of things very easily. Okay, so it will not be very tough. In the examination, it is not going to be very tough. Don't worry about that. Okay, so these are our conditional metrics. Okay, these are our conditional metrics. Next, there is something called joint probability matrix. What do you think? What I will be writing down here? Joint probabilities, right? I will be writing down here. If I have written down capital, so here also I will write down capital. So p of x comma y. This is what I will be writing down. That's it. Okay. Mostly it is of no use. It is just time pass only, you can say. Mostly it is time pass only. Why it is time pass? Because we will never be making these matrices in the examination. But these matrices could be given in the examination. So if it is given, then you should know what is the meaning. But to solve a particular problem, we are actually never going to make it. In the initial phase, we might make it, but later on we will build up good enough practice that without even making these kind of matrices, we would be able to solve the problems. So what I will write down here, probability of x1 comma y1, probability of x1 comma y2, x2 comma y1, x2 comma y2, x3 comma y1, x3 comma y2. Okay, now I know one thing. What is that? This could be written in some other way as well. What is that other way? What is that other way? This could be written in some other way as well. What that would be? Probability of x1 comma y1, what that would be equivalent to? So that would be equivalent to probability of x1, probability of y1 by x1. Say yes or no? Right? You should have good enough habit of writing down these particular things. Probability of y1 by x1 would be equal to probability of x1 comma y1 divided by probability of x1. So from here we got this particular thing. Now someone will say that sir, it could be written as probability of y1 dot probability of x1 by y1. Yes, it could be written in this manner as well. Both are equal. But why would you write down this particular thing? Because this will not be mentioned in the examination. No? What will be mentioned? y1 by x1 would be mentioned. So better I should focus on this one. Someone will say that sir, this is also how you can write down. But why would I care writing down in this manner? I would care writing down in this manner because probability of x1 will also be mentioned and this will also be mentioned. So simply what I would do, this and this being multiplied, what I will get? Probability of y1 comma x1. So directly I will get this particular value. Is that clear to you? Okay. Probability of x1 comma y2 by x1. Probability of x2 y1 by x2. Probability of x2 y1 by x2. Probability of x3 y1 by x3. Probability of x3 y2 by x3. So this is what I am going to make. Okay, well and good. Very simple thing, very straightforward, right? Other way could also be there, but that's not a matter of concern. So just it is of no use. This discussion is not very important, but still if matrices are mentioned in the examination, you should be able to know what kind of matrices are there. Okay. So this is the problem. What you need to do? You need to make a joint matrix and a conditional matrix. So basically in the examination, they will not ask you the matrices. What they can ask, they can simply ask you this question. This question they can ask. So here you would know that sir, what this would be equivalent to? Sir, this would be equivalent to this particular thing. Probability of y2 comma x3 would be equivalent to probability of x3 dot probability of y2 by x3. So probability of x3 dot probability of y2 by x3, right? y2 by x3, y2 by x3. So probability of x3 that is 0.5, y2 by x3 would be multiply with 0.1. So answer would be 0.05. Is that clear to you? Very simple thing, right? So first let's make the joint matrix and then make the conditional matrix. Then we will find out all these things, probability of y1, y2, y3, y4, and then we will find out all these things, x1 by y1, x3 by y2, and x3 by y2. Okay, x3 by y2 two times I have written. So let's make it x2 by y2. Okay, let's find out x2 by y2. So all these things we will find out. You can do it on your own. How will you make the joint matrix? Sir, x1, x2, x3, y1, y2, y3, y4. 3 input symbols are there, 4 output symbols are there. So I will make this kind of matrix x1, x2, x3, y1, y2, y3, y4. So conditional matrix only y by x I am making. Okay, conditional matrix, sir, it could be of two kind, no? Y by x and x by y. So I am making only y by x. Okay, because x by y will take a lot of time. Some of the probabilities we are already covering here. Okay, so it will take a lot of time. So that's why I am ignoring it. What I will make, only y by x I will make. So how will I make y by x? y1 by x1 0.3, y1 by x2 0.2. So basically this is the line of x1, right? So y1 by x1 is 0.3, y3 by x1 is 0.7. So y1 by x1 is 0.3. Basically, what is the scenario? When x1 was transmitted, it went to two outputs, y1 and y3. It was getting y3 with the probability of 0.7. It was getting y1 with the probability of 0.3. 0.7, 0.3. Probability of y2 by x1. What is that? What I am asking? Just a second. Yeah. So what I am asking, what is the probability of y2 by x1? I am asking. What that would be equivalent to? 0. What is the probability such that y2 is received given that x1 is transmitted? So it is not even going here, no? It is not necessary that x1 should go to y1, y2, y3, y4, all 4 symbols. No. x1 is going to y1 and y3 only. So what is the probability such that y2 is being transmitted? Sorry, what is the probability such that x1 is being transmitted and y2 is being received? That is 0 because there is no line. So that is equivalent to 0. And what is your y2 by x1? That is also, sorry, what is your y4 by x1? y4 by x1. What I am asking, probability such that y4 is being received given that x1 is transmitted. That is also 0. y4 is being received given that x1 is transmitted. That is also 0. Right? For the next one, the line is of x2. So x2 is going to two guys, y1 and y4 with the probability 0.2 and 0.8. So x2 is going to two guys, 0.2 and 0.8. Like, is it necessary to mention this particular probability? No, it is not necessary. Why is that so? Because I know that basically if they are saying that it is not going to y2, it is not going to y3, then you would know that it is going to y1 with the probability of 0.2. That means it will go to y4 with the probability of 0.8, right? Because if x2 is being transmitted, some output it would be getting. Either it would be y1 or y2 or y3 or y4. y1 you are getting with the probability of 0.2. y2 and y3 you are getting with the probability of 0. That means y4 you will get with the probability of 0.8. And this we have already written here. Where we have written? Here we have written. x2 being transmitted. Where it is? x2 being transmitted, two kind of outputs are there, y1 and y2 would be equals to 1. Right? So similar thing is there. And now x3 is going into y2, y3 and y4 with the probability of 0.3, 0.4, sorry 0.1, 0.4 and 0.5. It is not going to y1. It is going with the probability of 0.1, 0.4 and 0.5. So this is your conditional probability y by x. That's it. How would you make the joint probability? So let's write down the first thing only. Probability of x1 comma y1. Sir, that would be equals to x1 y1 by x1. So sir, that simply would be equals to probability of x1 and this multiplied. So 0.3 into 0.3. That would be 0.09. If I make more, let's just say something very random I am making. x2 y3, or let's make x2 y3. So probability of x2 multiply with probability of y3 by x2, right? So probability of x2, whatever it is, I don't care, actually it is 0.2. It is 0.2. So y3 by x2, what is that? That is 0. So basically what is happening? If I multiply with the probability of x1 here, what I need to write down? I need to write down y comma x. If I multiply with the probability of x1 here, what is the probability of x1? That is 0.3. So if I multiply with 0.3 here, I will get my joint matrix 0.09, 0.21 and 0. You can check it. You can check this particular thing. Probability of y3 comma x1. So that would be probability of x1 y3 by x1. What is the probability of x1? That is 0.3. y3 by x1, that is 0.7. So 0.3 into 0.7, that is 0.24. So from this particular matrix, I can make the joint matrix very easily, right? From the conditional matrix, I can make the joint matrix very easily. Well and good. So simply I need to multiply. Now probability of x2 I need to multiply. Probability of x2 I need to multiply, that is 0.2. So 0.2 will be multiplied with 0.2, that would be 0.04, 0, 0 and 0.16. and next 0.5. So 0.5 will be multiplied with the whole. So 0.5 is being multiplied, right? So it would be 0.05 and 0.2 and 0.25. Now do one thing, you add all of them. What that would be equivalent to? That would be equivalent to 1. You add all of them. So 0.09, 0.0, this will be 0.3 plus 0.2 plus 0.5. So everything is coming out to be 1. And now addition of all these three lines, addition of this line, what this would represent? Probability of x1 comma y1 plus probability of x1 comma y2 plus probability of x1 comma y3 plus probability of x1 comma y4. What that would be equivalent to? So that would be equivalent to probability of x1. So if I add all of them, what I will be getting? I will be getting 0.21 plus 0.09, that would be equals to 0.3. So 0.3. So you don't need to mug up that in a joint matrix, if I do the addition of a row, I will get the probability of that particular symbol. No, nothing like that. It should be clear what this is representing. This is representing probability of x1 comma y1 plus x1 comma y2 plus x1 comma y3 plus x1 comma y4. That means x1 is being sent. Either I will receive y1 or y2 or y3 or y4. That means all of them would give me the probability of x1 only. Why is that so, sir? Because this is something that we have seen. x1 comma y2 plus x1 comma y1 plus x1 comma y2, x1 comma y1 plus x1 comma y2, that is equal to probability of x1 only. So this particular thing is equal to this particular thing is equal to probability of x1 only. So that only we are calculating. Is that clear to you? Does that make sense? Okay. So that's why these probabilities are, these matrices are taught. Okay. Because these matrices will be given. Now if it is given, people will usually mug up that what this will represent, what this will represent, what this particular thing would represent. They will also mug up that this summation would be equal to 1 only, which is pretty obvious. Probability of y1 by x1 plus probability of y2 by x1 plus probability of y3 by x1 plus probability of y1 y4 by x1 would be equal to 1 only, that we have already seen. So rather than mugging up some results, what we will rely on, we will be relying on our concepts that we have already seen, right? So what this would represent? This would represent the probability of x2 transmission, and this would represent the probability of x3 transmission. There you go, right? Okay. Next, what we need to find? Probability of y1 transmission. So what that would be equals to y comma x. Here only we have made it, no? So let's not make it. Next, what we need to find out? Probability of y1 transmission we need to find out. Okay. So how will I get probability of y1? So what do you see here? Probability of y1 I need to find out. So I know one thing. What do I know? That 4 kind of symbols are being transmitted, or 3 kind of symbols are being transmitted: x1, x2, x3. x1, x2 and x3. x1, x2 and x3. With respect to all these three symbols, you can get output y1. But you can see that y1 is coming only from x1 and x2. What does that mean? Or forget about it. If I make a Venn diagram, I will make a Venn diagram like this, that x1, x2, x3 all can throw y1. So what will be your probability of y1? So that would be x1 being transmitted, comma y1, plus x2 being transmitted, y1 received, x3 being transmitted, y1 received. So this area plus this area plus this area, right? So x1 comma y1, what that would be equivalent to? Probability of x1 dot probability of y1 by x1 plus probability of x2 y1 by x2 plus probability of x3 y1 by x3. So probability of x1 was 0.3, y1 by x1, that was 0.3 again, plus x2 was, I will tell you how to do it from the diagram as well, that you don't need to worry. Probability of x2 transmission was 0.2, y1 by x2 was 0.2 plus this was 0.5, but y1 by x3 was 0. So what you are getting? 0.09 plus 0.04. Okay, so answer is 0.13. So probability of y1 transmission is coming out to be 0.13. How would I do it from the diagram? What I need to find out? Probability of y1 being received. Probability of y1 being received. This is what I need to find out. So y1 can come from x2 and x1. So 0.3 multiply with 0.3. What I will write down? 0.3 multiply with 0.3 plus 0.2 multiply with 0.2. 0.2 multiply with 0.2. That's it. What will be the answer? 0.13. Similarly, if you need to write down probability of receiving y2, how will you write it down? Y2 is coming from, you can see if I stand at y2, I can see that y2 is only coming from x3. That's it. y2, if I stand at y2, sir, y2 is only coming from one way, that is x3. So 0.5 multiply with 0.1. What will be the answer? 0.5 multiply with 0.1. Answer is 0.05. What will be your probability of receiving y3? Sir, I will go to y3. I can sense that y3 is coming from two guys. It is coming from x1 and x3. So 0.7 multiply with 0.3. 0.3 multiply with 0.7 plus 0.4 multiply with 0.5. 0.21. Answer is 0.41. What is y4? When I go to y4, I can see that it is coming from two guys. 0.8 multiply with 0.2 and 0.5 multiply with 0.5. So this should be very simple for you. Why it is happening? So everything I have taught here, but in the examination you should not be making all these kind of things. Directly you should be writing it down. Okay, and you can add all of them, you would realize that it is coming out to be 1 only. Basically, if I add this probability of y1 plus probability of y2 plus probability of y3 being received plus probability of y4 being received, that would be equals to 1, and which is pretty obvious as well. So 0.13, 0.05, 0.41, 0.41. How did I get it? Simply I saw that 0.3 into 0.3, 0.2 into 0.2, y1 is coming from where? Y2 is coming from only one guy, y2 is only coming from x3, y3 is coming from x1 and x3, and y4 is coming from x2 and x3. Is that clear to you? All good? All fine? Next we need to find out these things. So how will I find out? If they are asking probability such that it is given that y1 is being received but it is coming from x1. So what they are asking? Next they are asking probability such that given that y1 is being received, what is the probability such that it is coming from x1? So this is what I need to find out. I know that, sir, this is not given in my transition matrix. Transition matrix? Let's forget this word transition matrix. Sir, this is not given in my transition diagram. This is known as transition diagram. Like x1 is being x1 is going to y1 and y3. So this is known as transition diagram or simply diagram. So sir, basically this particular thing is not given in my diagram. So what do I know? I know one thing, that sir, probability of transmission x1 multiply with, I am interested in x1 and y1, right? I am interested in x1 and y1. So probability of x1 transmission multiply with y1 being received such that x1 is transmitted, probability of y1 being received x1 by y1. This thing I already know. Or if I don't remember this particular thing, then at least I remember this particular thing, that sir, what this is equivalent to? Sir, this is equivalent to intersection divided by probability of y1. At least this much mathematics I have studied. Now sir, x1 comma y1, do I already know it? Yes sir. How do I know it? x1 comma y1, x1 comma y1. So sir, simply multiplication of both of them, 0.3 into 0.3. Basically I am directly solving it with respect to this diagram. So let me just copy this diagram there, because in the examination I need to solve it with respect to the diagram. So how will I solve with respect to the diagram that we are learning here? Okay. So this diagram was made in front of my screen. In front of my screen, this diagram was there. So what I need to calculate? x1 by y1. So first I thought of this particular formula. Now I know that x1 comma y1, what that would be equivalent to? Sir, simply multiplication of both of them. So that would be 0.09 divided by, sir, I need to calculate probability of y1. So probability of y1 would be, y1 is coming from this guy and this guy. So y1 is coming from two guys. So 0.3 into 0.3, that would be 0.09 plus 0.2 into 0.2, that would be 0.04. So sir, my answer is 0.09 divided by 0.13. So answer would be 9 by 30. So in this manner I can calculate anything, whatever that I want to calculate. What is given? X3 by y2. X3 by y2. So sir, what should click to me? Sir, this formula I know. X3 comma y2 divided by y2. Now sir, x3 comma y2. X3 comma y2. This is the thing. X3 comma y2. X3 comma y2, that means 0.5 multiply with 0.1. 0.5 multiply with 0.1 divided by probability of y2. Y2 is coming only from one guy only. So divided by 0.5 into 0.1, that would be equals to 1. And it is pretty obvious as well. Why it is obvious? Probability is such that y2 is received. Now what is the probability that it is coming from x3? You are standing at y2. Now what is the probability that it is coming from x3? It surely has to come from x3 only, no? Because y2 has only one chance that it has to come from x3. So it is pretty obvious that it would come from x3 only. So answer would be 1 only. Is that clear what I am saying? By the diagram, you know that y2 is received. That means you are standing here. What is the probability that it would have come from x3? 100% it has to come from x3 only, because y2 is having only one path, that is through x3. So probability of x3 by y2 would be 1. You can calculate anything else as well. Let's just say something very random we calculate. Probability of x2 by y4. This is something I need to calculate. So what that would be equivalent to? Divided by probability of y2, right? x2 comma y4. x2 comma y4, 0.2 into 0.8. y4 it is, x2 it is, 0.2 into 0.8. y4. x2 comma y. Now what is the probability of receiving y4? That is 0.2 into 0.8, 0.5 into 0.5. So simply I will simply write down the answer. 0.2 into 0.8 would be 0.16, right? 0.2 into 0.8. Now 0.5 multiply with 0.5, that would be 0.25. So 0.16, 0.14. So 16 by 41. Is that clear? So what is the probability such that y4 is being received? Now it is coming from x2. So y4 can come from x2 as well, it can come from x3 as well. So what is the probability that it is coming from x2? So this is the probability that it is coming from x2. Is that clear to you? Okay. Anything random you can calculate. y2, what you can calculate? x3 by y2 we have already done. y1 by x2, x2 by y1. Let's calculate x2 by y1. Or x3 by y4. Let's calculate x3 by y4. x3 by y4. So probability of x3 comma y4. Or let's not write down the formula this time. Directly I will write down x3 y4. So x3 comma y4 would come here. Better in the examination, always we should write down this formula. Let's not do it in a very quicker manner. This formula at least we should write down. After that I can do the calculation in quicker manner. x3 y4. x3 y4. 0.25 divided by y4. Probability of y4. This and this will be multiplied. This and this will be multiplied. So 0.16 plus 0.25, that would be 0.41. That would be 25 by 41, and which is pretty obvious as well, because y4 is coming only from two guys, x2 and x3. So if it is coming from x2, I know that y4 has been received. If it is coming from x2, the probability is 16 by 41. Then what will be the probability such that it is coming from x3? That would be equal to 25 by 41. Why is that so? Because if you add both of them, answer would be 1, right? Because I know that y4 is coming only from two guys. So I know that y4 is being received. So either it can come from x2 or it can come from, I know that y4 is being received, so or it can come from x3. The addition of both of them would be equal to 1. right? That is pretty obvious as well. So these kind of calculations are there which we can solve in a very easy manner and in a very efficient manner as well. So nothing we are mugging up, no matrix, nothing. In the examination they will not ask the matrix, they will ask these kind of problems. So do you really think that you need to make the matrix there? Do you really think that for finding out probability of y1 will you make the matrix? No. Directly. y2 directly. y3 coming from 2 y's directly. And if they are asking these opposite things, that also you can tell. If they are asking directly these things, completely visible, right? So everything you already know. Okay, let's go to next question. If there is any next question, no. Now there is next concept that is known as joint entropy. Okay, so as of now my head is aching, so I need to take break. Okay, tomorrow only I will record it. So joint entropy we will study, and we will study conditional entropy. So we have studied about joint probability. We have studied about conditional probability. Now entropy would come into action. Okay, so it's been roughly around 2 hours since we have been studying this particular topic. So I will record the video tomorrow. There tomorrow we will study about joint entropy, and in this lecture only, although that will be added in this lecture only, joint entropy and conditional entropy. Okay, very simple thing, and these are important as well. Okay, so let's study it in the next half of this video. Okay, yeah, welcome back. So let's study about joint entropy. So what was your entropy of x? This was your entropy of x, right? Summation was there, probability log 2 probability, right? And then there was a negative sign, and all the probability log 2 probability you were summing it up. So this was your normal entropy of source x. What do you mean by joint probability? Joint probability means the probability of x and y. So what do you mean by joint entropy? Entropy of x being transmitted and y being received. So what do you think, what should be the formula? So negative sign would be there. Probability of xi yj log 2 probability of xi yj. Summation you need to put with respect to I, summation you need to put with respect to j as well. Sir, formula is looking very complex, but it is not actually complex. You will be able to understand in a very easy manner. So this is the formula of your joint entropy. Okay, don't focus much on the formula, just focus more on the problem solving. Like basically what we are doing, we are only playing with the joint probabilities. So what would be your joint probability? Sir, p x1 y1, p x1 y1 log 2 p x1 y1. Then already minus sign would be there, so minus sign is there, plus p x2 y3. I am taking any random value, x1 y1, x1 y2, x1 y3, x1 y4, x2 y1, x2 y2, x2 y3, x2 y4, x3 y1, x3 y2, x3 y3, x3 y4. So all these probabilities will come, probability log 2 probability, and then minus sign, and we will add all of them. Is that clear to you? Very simple thing. People just focus more on the formula, so that's why they find it difficult. Okay, so let's first solve it with respect to the joint matrix. So what I'm going to do, I'm going to make a joint matrix here. So can you make the joint matrix for this particular scenario? Yes sir, we have already made. What you need to do, you need to make this particular matrix. This particular matrix, have we already made it? Yes sir. What all these probabilities are there? These probabilities will be multiplied with the corresponding symbol probabilities. That means 0.3 multiplied with 0.3, 0.09. 0.3 multiplied with 0, because x1 y2, there is no line, that means probability is 0, so this would be 0. x1 y3, 0.7 multiplied with 0.21, sorry, 0.7 multiplied with 0.3, 0.21. x1 y4, that would be 0. So in that manner, this probability matrix we have already made, because we have taken the same example. So this joint probability matrix we have already made. So these are all your joint probabilities: p1 x1 y1, x1 y2, x1 y3, x1 y4, x2 y1, x2 y2, x2 y3, x2 y4, x3 y1, x3 y2, x3 y3, x3 y4. Now what we need to do? Simply entropy we need to calculate. Minus sign will always be there. Then probability log 2 probability. Probability log 2 probability plus probability log 2 probability. What this would be equal to? 0 multiply with infinity. What did I tell you? Is it indeterminate form? No, it would be equals to 0. Although it is an indeterminate form, but we have seen it, limit x tending to 0, x log x is actually equals to 0. So this part would go to 0 only. This part would go to 0. The next 0.21 log 2 0.21 plus this part would go to 0 only. So I don't need to write it down. Next 0.04 log 2 0.04. Then 0 log to 0 0, 0 log to 0 0 plus 0.16 log 2 0.16, 0.05 log 2 0.05, 0.2 log 2 0.2, 0.25 log 2 0.25. So what you are getting when you solve all these probabilities, okay, 0.09 log to 0.09, there is no shortcut, you have to solve it, that's it, okay. You might be thinking, sir, is there any way or is there any trick? No, simply put 0.09 then log 2 into 0.09, whatever the value that you get, put it here, then whatever the value you get, put that, then put this value, put this value, put this value, and in that manner you have to calculate, and eventually you will get this answer, 2.57 bits per symbol, okay. So calculation might be a bit complex, but it is what it is. This is how you need to solve it. But in the examination, do you really think that you will make this metric and this is how you will solve it? No. In the examination, how will you solve it? This diagram would be there in front of your screen. What you need to do? Sir, I need to find out the joint entropy. They could ask me Hx of y, x and y, or they could have asked uncertainty in y and x. Both are the same thing only, no? Uncertain x and y, y and x. Both are the same thing. What you will do? Sir, joint probability they are asking. That means I am caring about joint probabilities. Joint entropy they are asking. So I will care about joint probabilities. So this would be one joint probability, right? Another joint probability will be this one. So basically I will keep on looking at all the joint probabilities. So this would be our first joint probability. 0.3 multiplied with 0.3. So minus sign would be there outside. So 0.09 log to 0.09. 0.3 multiplied with 0.7, so that would be 0.21 log to 0.21 plus 0.2 multiplied with 0.2, this will be your joint probability. So 0.04 log to 0.04. Then another joint probability will be this one, 0.16 log to 0.16 plus 0.05 log to 0.05 plus 0.2 log to 0.2 plus 0.25 log to 0.25. Whatever the zero part is there, we are not caring about that. So simply just by looking at the diagram, this is how I will be writing down all the expressions. Because I know that if I need to find out the joint probability, it is not tough. Probability multiply with the conditional probability. Probability multiply with the conditional probability. P of x1 multiply with P of y1 by x1 would give you P of x1 comma y1. So 0.3 multiply with 0.3, 0.09. 0.3 multiply with 0.7, 0.21. Then 0.04, then 0.16, then 0.05, then 0.2, and then 0.25. So all these things we are getting, right? So answer would be 2.57 bits per symbol. So we are not going to make these metrics in the examination, but we will be solving from here. And if these metrics are already made in the examination and they are asking you this particular expression, then it would be very, very easy problem. Why it would be easy? Because they have already made the matrix, right? So if they have already made the matrix, then it would be easy. Otherwise, directly from here, I can solve it in this manner. Is that clear to you? Very, very straightforward and a very, very simple thing. Next, we would be focusing on conditional entropy. Okay. So two kind of conditional entropy could be there. H of y by x, H of x by y. So sir, till now we have seen two kind of formula. Sir, H of x was probability log 2 probability and then summation. Sir, H of x comma y was probability of x comma y log 2 probability. And surely there was a negative sign. Surely there is a negative sign. So sir, expectedly what should happen here? This is what you would be expecting. yj upon xi, because here what is written, y by x, log 2 yj upon xi. Then took the summation, negative sign, summation with respect to I and j. This is the formula that you would be expecting. But there is a twist there. In place of this particular thing, joint probability would come. So what is the formula, sir? Why this formula is there? How would we solve the problem in the examination? Everything I will tell you. Just have some patience. So let me just write down the formula. Okay. What is the formula? Formula says, here I was expecting yj by xi, but actually yj comma xi would come. Okay. And log 2, inside the log the same thing would come. Whatever that you are expecting, the same thing would come inside the log. Inside the log, yj upon xi would come. Okay. So there is a small twist in the formula. What is that twist? The twist is this particular thing, that here we were expecting yj upon xi, probability of yj upon xi, but yj comma xi is coming. Is that clear to you? Okay. Why this kind of twist is there, sir? We will see everything with respect to example. Just have some patience. Okay. Summation with respect to j and I. You write down j first, you write down I first, doesn't matter. Here simply I am putting summation. Negative sign would be there. Yj xi or xi yj both are the same thing only. So here also the same thing would come up. But inside the log, what we are seeing, x by y. So here also xi y yj. Okay, negative sign outside. What you will call this one? H of x comma y. This would be called, in language I am saying, uncertainty in x and y, where x is the transmitted symbol, y is the received symbol. Here I am directly writing x and y. You already know what is x. X is the transmitted symbol, y is the received symbol. So uncertainty in x and y. This formula is there and this particular formula is there. Okay, what is the formula of this one? Formula of this one was this was the formula, right? So this was the formula. So when we solve, we do some mathematics, then uncertainty in x and y is equals to uncertainty in x plus uncertainty in y such that x is known, or uncertainty in y plus uncertainty in x such that y is known. Is that line clear to you? What I am saying, uncertainty in x and y is equals to uncertainty in x plus uncertainty in y such that x is known. What is the language of this one? H of y by x. This is your uncertainty in y. Uncertainty in y given x. Uncertainty in y given x, or you can say uncertainty in y. Better in the language I will write down given x. That means if I know x, if I know what is my transmitted symbol, then what is the uncertainty in the received symbol? If I know my transmitted symbol, then what is the uncertainty in the received symbol? That is shown by h of y by x. Is that clear to you or not? What this would be known as? If I know my received symbol, if I already know, if I am standing at receiver, if I know my received symbol, then what is the uncertainty in transmitted symbol? Sir, what is the use of all these things? We will see the use, but as of now just see the formula. Okay. If I know what is my received symbol, then what is the uncertainty in a transmitted symbol? So uncertainty in x, uncertainty in x given y. So this is your h of x by y. Is that clear to you? Okay. So what it is saying, uncertainty in x and y is equals to uncertainty in x plus uncertainty in y such that x is known, or uncertainty in y, or means equal. Basically both things are equal only. Uncertainty in y plus uncertainty in x such that y is known. Let's just say in the examination they are asking you this particular expression. If they ask you h of x by y, there you will be worrying. Why so? Because sir, this I can find easily. P of yj xi, this I can find easily, but sir, this thing I cannot find it easily, right? Finding this particular thing is not easy, because from the matrix, from the diagram, from this particular diagram, very easily I cannot find this particular thing. What I can find very easily, sir, I can find this particular thing very easily. I can find this particular thing very easily. I have enough practice of finding out these things very easily. So sir, if I can find out these things very easily, then I will calculate h of y by x. H of y by x. I can calculate h of x as well. I can calculate h of y as well. So if I am able to calculate all these things, then very easily I can find out h of x by y. Or what I would do, I will simply calculate h of x comma y, and then I will calculate h of y. From there I will calculate h of x by y. So basically we are never going to apply this particular formula in the examination hall, because if we apply this formula, we would be needing probability of x by y, which is very difficult to find out, because in the diagram y by x is given and probability of x are also given. So I can find out probability of x comma y and probability of y by x, but probability of x by y I cannot find out. So that's why I will not prefer this particular formula. What I would do, I would prefer these formulas. So in the language you should have the habit, again and again you will keep on revising it. Sir, uncertainty in x and y, comma means and, is given by uncertainty in x plus uncertainty in y such that x is known, or uncertainty in y plus uncertainty in x such that y is known. So this is very important. If you are solving a problem on information theory in your examination hall, then there is very high chance that you will be using this relation. Very important relation. Very important relation. Okay. Uncertainty in x and y would be equals to uncertainty in x plus uncertainty in y given x, or uncertainty in y plus uncertainty in x given y. Is that clear to you? Okay. And in the language as well, you should be able to know what to call all the expression. H of x comma y, uncertainty in x and y. H of x, y by x, uncertainty in y given x. H of x by y, uncertainty in x given y. Is that clear? Well and good. Let's solve the problem. Okay. What all things they are asking here? Uncertainty in y such that x1 is transmitted. Uncertainty in y such that x1 is transmitted. Uncertainty in y such that x2 is transmitted. Uncertainty in y such that x3 is transmitted. Then they are asking h of y by x. They are asking h of x by y. What we have already calculated? We have already calculated probability of receiving y1. How would we calculate probability of receiving y1? y1 is coming from two symbols, x1 and x2. So 0.3 into 0.3, that would be 0.09, plus 0.2 into 0.2, that would be 0.04. So that would be 0.13. Probability of receiving y2, sir, it is coming only from here. So 0.05. Probability of receiving y3, sir, y3 is coming from two symbols, 0.7 into 0.3, that would be 0.21, and 0.2. So it would be 0.41. What about y4? 0.8 into 0.2, that would be 0.16, 0.25, that would be 0.41. So these all are your probabilities. So I have find out the probability of receiving y1, y2, y3 and y4. So can you find out h of y? Yes sir. What would be your h of y? So h of y, minus sign always outside, 0.13 log to 0.13 plus 0.05 log to 0.05. Now 0.41 log to 0.41 and then again 0.41 log to 0.41. That means it will be happening two times. So what I can do? 2 into 0.41 log to 0.41. Right? 0.41 log to 0.41 plus 0.41 log to 0.41. This will be happening two times. So you will get this answer, that would be coming out to be 1.65 bits per symbol. Is that clear to you? H of x, can you find out? Yes. 0.3 log to 0.3, 0.2 log to 0.2, 0.5 log to 0.5 with the minus sign outside, you will get 1.48 bits per symbol. Right? Now h of x comma y, can you find out? Yes sir, we have already find it out. 2.57 bits per symbol. How did you find out? 0.3 into 0.3, 0.09. 0.3 into 0.7, 0.21. So 0.21 log to 0.21. So all these things we have already find out. Now we need to find out all these things. A, B, C, D, A, B, C, C के बाद D आता है यार. A, B, C, E, F. Okay, forget about D. Yeah. So let's find out. But let's first write down the values of these two guys. Can we easily write down the values of h of y by x and h of x by y? Yes, sir. Because what do I remember? Uncertainty in x and y is equals to uncertainty in x plus uncertainty in y given x. So, do I know this value? Yes, sir. What is this value? 2.57. 2.57. What is uncertainty in x? That is 1.48 plus h of y by x. What is that? So, it would come out to be 1.09, right? Yes, 1.09 bits per symbol. What about this particular thing? Another formula is there, uncertainty in y plus uncertainty in x given y. So 2.57 uncertainty in y. What is uncertainty in y? That is 1.65. Right. So 2.57 minus 1.65. What that would be? 0.93, right? Or 0.92, whatever it is. 2.57, 1.65. 0.82. Array 15, 0.92. So h of x by y. So very easily we can find out all these values, but a lot of methods we are going to see. Okay, a lot of methods we are going to see. Now let's focus on these parts first. H of uncertainty in y such that x1 is transmitted. So can you let me know these values? What I need to find out? Uncertainty in y such that x1 is transmitted. This is what I need to find out. So can you let me know the probability of y1, or forget about it, probability of y such that x1 is transmitted. This is what I need to find out. Or better, first find out probability of receiving y1 such that x1 is transmitted. What that would be? So that would be receiving y1 such that x1 is transmitted, that would be 0.3. y2 such that x1 is transmitted. y2 from x1 it is not even coming. y3 such that x1 is transmitted. y3 such that x1 is transmitted, that is 0.7. And y4 such that x1 is transmitted. y4 such that x1 is transmitted, that is 0. So what will be your uncertainty in y such that x1 is transmitted? This is not uncertainty in y such that x is transmitted. No, uncertainty in y such that x1 is transmitted. So what that would be? So that would be 0.3 log to 0.3. Surely there is a negative sign. Plus 0 log to 0 plus 0.7 log to 0.7 plus 0 log to 0. What I am doing again, what I need to find out? Uncertainty in y such that x1 is transmitted. What is this thing? There is a difference between these two guys. Uncertainty in y such that x is transmitted. Now x could be anything, x1, x2, x3. What I need to find out here? Uncertainty in y such that x1 is transmitted. So I know one thing, that I am transmitting x1. If I am transmitting x1, what I can receive? I can receive y1, I can receive y3. I cannot receive y2 and y4. So probability is such that y2 is received given x1, that is 0. y4 is received given x1, that is 0. So probability of y1 being transmitted, probability of y1 received given that x1 is transmitted 0.3 and this is 0.7. So 0.3 log to 0.3, 0.7 log to 0.7. That would be the uncertainty in y given that x1 is transmitted. Say yes or no. Okay. Now here you would be saying that, sir, why you did not put the joint probability here? Here joint probability should come. That particular formula is there only for h of y by x. Here, sir, you have wrote down the formula, joint probability you have written. But here you are writing down conditional probability only. Because here my outputs are fixed, no? Y1, X1, Y3, X1. So this is like simple probability. This is P1, this is P2. So two kind of symbols are there, P1 and P2. What will be their entropy? Two symbols are there having probability of P1 and P2. What will be their entropy? P1 log to P1, P2 log to P2. So this is the thing that I am doing. This is complete different thing, h of y by x. This is h of y by x1. So this is y by x1 is like a source, right? Which is having two kind of output. Y1 by x1, y3 by x1. Is that clear to you? It is working like a source, no? With the two kind of output. Y1 by x1, y3 by x1. So here I am applying the formula P log to P plus P log to P. P1 log to P plus P2 log to P, and then there is a negative sign. Is that clear to you? Because the input symbol is fixed, that is x1 only. Here input symbol could be x1 or x2 or x3. So basically what I am going to do now, I will find out entropy in y such that x1 is transmitted. I will find out entropy in y such that x2 is transmitted. I will find out entropy in y such that x3 is transmitted. And from there I will find out this particular expression. And then I will tell you how this formula came. So actually this formula that we are using, this particular formula that we are using, that came from here. Is that clear to you? So I will tell you how this formula came. Have some patience. But as of now, whatever the doubt that you are having, that sir, why you did not write down the joint probability here. So I will not write down the joint probability here because symbol x1 is fixed here. I am transmitting symbol x1. So what is the probability that I am receiving y1? 0.3. What is the probability that I am receiving y3? That is 0.7. And this is how I can calculate it. Is that clear to you? All good? Okay. So let's see what answer we will be getting for this one. 0.3 log 2 into 0.3. So 0.521 plus 0.7 log 2 0.7 plus 0.521. That would be 0.881. So final answer would be 0.881. In the similar manner, you will find out other things as well. So what would be your h of y such that x2 is transmitted? So probability of receiving y1 such that x1 is probability of receiving y1 such that x2 is transmitted, probability of receiving y2 such that x2 is transmitted, probability of receiving y3 such that x2 is transmitted, probability of receiving y4 such that x2 is transmitted. So if x2 is transmitted, what you are getting? y1 you are getting and y4 you are getting. So y1 by x2, y4 by x2, that is 0.2 and 0.8. So simply our answer would be, minus sign is surely outside. Zero 0.2 into 0.2, that would be 0.464 plus 0.8 into 0.8 plus 0.464. So it would be 0.721. So basically what people actually remember is that, look, you can see any notes, there directly this formula will be written and we will be solving the problem with respect to that. Okay. So usually people know how to apply this formula, they know how to find out h of y by x, h of x by y and h of x comma y. But they don't know how to find out h of y by x1, h of y by x2. So there is very high chance that this kind of question is coming in your examination in future. Okay. Very, very high chance. With respect to a particular symbol, what is the entropy in y? With respect to a particular symbol x2, what is the entropy in y? With respect to a particular symbol x3, what is the entropy in y? So they will fix the input symbol. They will fix the input symbol and then they will ask you the entropy in y. Is that clear to you? Okay. Now entropy in y such that x3 is transmitted. Okay. So if x3 is transmitted, you will be getting y2, y3 and y4. 0.1 probability, 0.4 probability, 0.5 probability. 0.1, 0.4, 0.5. So this answer would simply be 0.5 only. Okay, let's calculate the other answer. 0.332. Okay, 0.4 log 2 into 0.4 plus minus plus 0.332 plus 0.5, right? .36 bits per symbol. Okay, now what do you think, what will be your, so these things they expected from our side, a b c. Now what do you think, what will be your h of y by x? What I need to find out, I need to find out h of y by x. So what do you think, what will be the answer? H of y by x, that would be equals to probability of transmitting x1 multiply with entropy in y such that x1 is transmitted plus probability of transmission of x2 multiply with entropy in y such that x2 is transmitted plus probability of transmitting x3 multiply with entropy in y x3 is transmitted. Is that clear to you? So probability of transmission of x1 0.3, 0.2, 0.5. So probability of transmission of x1 0.3, entropy in y such that x1 is transmitted, entropy in y such that x1 is transmitted, that is 0.881 plus probability of transmission of x2 0.2, entropy in y such that x2 is transmitted, entropy in y such that x2 is transmitted, that is 0.721 plus 0.5, entropy in y such that x3 is transmitted, that is 1.36. You solve this particular thing, you will get the same answer. Okay, 1.36 divided by 2, that would be 0.68. Then 0.721 multiply with 0.2 plus 0.881 multiply with 0.3. What you are getting? 1.08, 1.088 or 1.09. So again here as well you are getting 1.088, that would be equals to 1.09 bits per symbol. Is that clear now? Are you able to understand how the formula came? Now what if they ask you to find h of x by y? So what do you think, what that would be equivalent to? Probability of receiving y1 multiply with entropy in x such that y1 was transmitted plus probability of receiving, how much we are receiving, y1, y2, y3, y4. So probability of receiving y2 multiply with entropy in x such that y2 is transmitted plus y3 entropy in x plus y4 entropy in x such that y4 is transmitted. Although if this particular question they are asking or this particular question they are asking, we are not going to solve in this manner. We are either going to solve in this manner, which is very easy. Which one? This one. Very easy, right? Because I already know the value of h of x comma y, I already know the value of h of x, I can find out h of y by x. Similarly, if I know the value of h of y, I already know the value of h of x comma y, I can find out h of x by y as well. So these are very straightforward. Very easily I will be able to get the answer of these two things, right? Or what I can do, I can apply the conventional formula as well. This particular thing I am not going to solve in the examination. It is just that I want you to tell that this is how we will solve everything and we will get this particular formula. What is the reason behind not putting yj by x1 here? Because y is also not fixed, x is also not fixed. Okay. So that's the reason. Sir, here why did you put it? Basically, if I ask you y1 x1 plus y2 x1, then in that manner you keep on adding up, then y1 x2 plus y2 x2 and so on, then y1 x3 plus y2 x3, and you keep on adding up all of them. What answer you will be getting? 1, right? And for the source x, for the source x, what it is giving you? it is giving you 3 symbols, right? So if I ask you probability of x1 plus probability of x2 plus probability of x3, what answer you will be getting? 1. So if the addition of probability is equals to 1, then probability log to probability, this formula is working. But if I ask you h of y1 by x1 plus h of y1 by x2, and in that manner I keep on adding up everything, what will be the summation equals to? It will not be equals to 1, it would be anything, right? y1 by x1 plus y1 by x2 plus y2 by x1 plus y2 by x2 plus y3 by x2 plus y4 by x2, right? So it would not be equals to 1. Is that clear to you? So if summation of probability is equals to 1, this is working. Summation of probability equals to 1, this formula is working. You can check here as well. Sir, here as well you have applied the same formula, no? Y by x1. Right? So here what you are doing? Sir, y1 by x1, y2 by x1, y3 by x1, y4 by x1. You add all of them. What is the summation of probability? 1. So this formula is working. Basically, probability log to probability and then summation. When it would work? It would work only when whatever the probabilities that you are putting, that should be summed, or the summation of all those probabilities should be equals to 1. Here whatever the probability that I am putting, 0.8, 0.2, that would be equals to 1. 0.4, 0.1, 0.5, summation of all the probability equals to 1. When you calculate h of x comma y, h of x comma y, 0.09, 0.21, 0.04, 0.16, 0.05, 0.2, 0.25, you add all of them, summation would be equals to 1. Is that clear what I am saying? Okay. So when you can put those formula, so somewhere here you can write down that entropy equals to summation probability log to probability. Works when summation of probability equals to 1. Is that clear to you? Summation of all the probabilities should be equals to 1. Here summation of all the probabilities, whatever the value of ij you are putting, summation of all the probability equals to 1. Whatever the ij value you are putting, summation of all the probability equals to 1. But here in this case, sorry. Here I am putting, this is a completely different formula. I was talking about this particular formula. So whatever the ij value you will put, based on that, whatever the probability that you are getting, summation of all those probability would be equals to 1. Sir, here also you applied the same formula for calculating y1 by x1. Yes. Entropy in y such that x1 is transmitted. So here I would require the probabilities of y. That means probability of y1 by x1, y2 by x1, y3 by x1, y4 by x1. If I add all of them, what I will be getting? 1. So let's just say if I need to find out this particular thing, h of x by, randomly I can put anything. This particular thing I need to find out. So what I can do here, if I need to find out this particular thing, so first I will be looking for x1 by y3, then I will be looking for x2 by y3, then I will be looking for uncertainty in x such that y3 is transmitted. So I already know, sorry, y3 is received. So I already know y3 is received. Now uncertainty in x, that means what I am sending, what has been transmitted, that uncertainty I am finding out. So probability of x1 by y3, x2 by y3, x3 by y3, and what I am sending, only 3 symbols I am sending. So forget about next one. x4 you are not even sending. Just let me know what will be the summation of all of them. Just let me know what will be the summation of probability of x1 by y3 plus probability of x2 by y3 plus probability of x3 by y3. What will be the summation of all of them? That would be equals to 1. Because if I know that y3 is being received, it would be coming from either x1 or x2 or x3. x1 or x2 or x3. If I know y3 is received, that means this would be equals to 1. So if addition of all of them equals to 1, then what formula I am going to apply here? So h of x by y3, that would be equals to probability of, surely there will be a negative sign first. There will be a negative sign. Probability of x1 by y3 log 2 probability of x1 by y3 plus probability of x2 by y3 log 2 probability of x2 by y3 plus x3 by y3 log 2 probability of x3 by y3. Is that clear to you? Or can I write it down in this manner? Summation, then there is a negative sign, xi yj log 2 probability of xi yj summation I, and that is equals to entropy of x such that yj is transmitted. Did you understand what did I write down here? What is this? If you don't understand this one, no need to worry, you can understand this one at least. Is that clear to you? What I am doing here, is that clear to you? What we are doing here? Uncertainty in y just such that x1 is transmitted. You need to take all those probabilities and then probability log to probability log to probability, answer you would be getting. And then finally what I need to find out, uncertainty in y such that x is transmitted. So probability of x1 transmission multiply with the uncertainty in y such that x1 is transmitted plus probability of x2 transmission multiply with uncertainty in y such that x2 is transmitted plus probability of x3 transmission multiply with uncertainty in y such that x3 is transmitted. You get the answer. Although in the examination we are never going to apply this formula, but the depth of this particular formula is clear to you now. Why we were not able to apply this kind of formula, why we were not able to write down yj by xi, is that clear to you? So directly I am not putting any formula, I am solving the problem. You should be knowing that why this particular formula is not applicable only in the case of y by x, x by y. So whenever you see y by x, x by y, at that time you need to be aware. So in the examination, if they are asking entropy of anything, first thing what you are going to see, that sir, whatever the probabilities that I am having, summation of all those probabilities, is that coming equals to 1? Yes. If that is coming to 1, then the formula will be probability log to probability plus probability log to probability plus probability log to probability, and in that manner I will keep on adding up with the negative sign. And if that is not coming out to be equals to 1, then something different is there for sure. So there was surely something different in h of y by x. Is that clear to you or not? Okay. So here we needed to find y by x1, y by x2, y by x3. So similarly here in this particular analysis, if they are asking h of x by y, you might need to find out h of x by y1, h of x by y2, h of x by y3, h of x by y4. Although if they are asking this particular question, then we will solve in this manner. But what if in the examination they ask you h of x by y2? That means given that y2 is received, what is the entropy of x? That means what is the uncertainty that it is coming from x1 or x2 or x3, right? So what I need to find out, probability of x1 by y2 plus probability of x2 by y2 plus probability of x3 by y2, that would be equals to 1. So I will get those probabilities and then I will apply this formula, probability log to probability, probability log to probability, probability log to probability with the negative sign outside, because summation of all these probability is actually equals to 1. What did I write down here? That sir, here xi is changing, that means x1, x2, x3, these guys would be changing, but yj will be fixed. So probability log to probability only I am writing down. Summation with respect to I am putting. I am putting the summation with respect to I. That means x1, x2, x3, they may change, but j will not change. Is that clear or not? I hope that is clear. A very, very in-depth discussion. Neither you are going to find out in NPTEL videos, nor you are going to find out in the textbook. Okay. You need to put so much of effort, then only these kind of content are designed. Okay. So I hope you are able to appreciate it, and I hope now it is clear that why this formula was not applicable. Is that clear? Okay. Yeah. Now another way is there, like using the help of matrix as well, I can find out the joint probabilities. Like basically if I need to find out these things, h of y by x, h of x by y. So for h of x by y, I don't have any matrix, right? For h of y x by y, the matrix would be probability of x1 by y1, probability of x2 by y2, probability of x3 by y2. That would be very difficult for me. So I don't make any matrix. I make only two kind of matrix, probability of x comma y, probability of y by x. In the previous questions as well, we have done the same thing. You see, y by x, y comma x. These probabilities only we are making. We never make x by y because that would be very difficult to make, right? So if I need to find out h of So these probabilities we have already made, right? Y by x, x by y we have already made. So let's just say I need to find out h of y by x. So what I would do in the examination? Only task is this question was asked, these two questions were asked, and this particular diagram was given. So what I would do in the examination with respect to the diagram only. So this diagram would be there on my screen in front of me. In front of me, this diagram would be there. Now what is my target? Sir, I know my target. I need to find out these things. H of y by x I need to find out, and h of x by y I need to find out. So how would I approach in the examination? So I remember the formula of h of y by x. In my mind I know what is the formula of h of y by x. So sir, in log 2 probability, here this probability will come into action, but before this, here what probability would come? Here joint probability would come. Here conditional, here joint, right? So what I would do? So 0.3 multiply with 0.3, 0.09, log 2, 0.3, conditional, joint, right? Then joint, log 2, conditional, that is 0.7. Next, joint, log 2, conditional. Next, joint, log 2, conditional. Never forget the negative sign. Everything is going with the negative sign. Plus, joint, log 2, conditional. Plus, joint, log 2, conditional. 0.25, log 2, conditional. So this is the calculation I will be doing in the examination, and I will get my answer. Okay, forget about sir h of x comma y, sir did you calculate this thing or that thing. Basically if I need to apply this particular formula, let's just say h of y by x I need to calculate. So first I need to find out h of x, then I need to find out h of x comma y. So two things I need to find out. After that I would be able to find out h of y by x. Now what if I directly need to find out h of y by x? So this is how I can find it out. Now sir, what about h of x comma y? So here I will hold on a bit, because I know that h of x by y, if I need to find out, then I will have to take help of this particular formula only. Entropy in x, entropy in y. So basically now I need what I need this particular thing. So I will see what is easy for me. If this is easy for me to find out, h of x, very easy. This I already know, right? And I can find out the probabilities of y, then I can find out this particular thing as well. From there I can get h of x comma y. And what if I directly find out h of x comma y, and then I find out h of y, then I can get h of x by y. So basically eventually you have to find out h of y for sure. So which would be easy? Finding out this is easy or finding out this is easy? I guess this one is easier, right? H of x I can find out very easily. So what I would do? I would find out h of x. H of y by x I have already found out. Then I will find out h of y, and then I can find out h of x comma y. And let's just say I did not find out h of y by x. I did not find out this particular value. So what I would do then? If I did not find out this particular value, then what I would do? Why would I calculate this particular thing? What I would do? I would directly see h of x comma y minus h of y, that would be equals to h of x by y. So I will find out this one, I will find out this one. Only two things I will find out. Is that clear to you? H of x comma y, very easily. All the joint probabilities I need to write down. All the joint probabilities. 0.09 log to 0.09, 0.21 log to 0.21, 0.04 log to 0.04, 0.16 log to 0.16, 0.05 log to 0.05, 0.2 log to 0.2, 0.25 log to 0.25. I will calculate all these things, and I will get my answer of h of x comma y. How will I find out h of y? So first I need to calculate the probabilities of y1, y2, y3, y4. That I can calculate easily from the diagram. So I will find out h of y as well, and then I will subtract both of them. I will get h of x by y as well. Is that clear to you or not? So did you understand how to approach in the examination? Okay, there is very high chance that you would have to calculate this particular thing only. They will not ask this particular thing, but who knows, they may ask it as well. Okay, so don't be too confident. Okay, they can ask anything. So h of y by x, with the diagram very easily I can find out. Joint probability log to conditional probability. Okay, what is given? It is given joint probability log to conditional probability. Joint probability log to conditional probability. How this formula came, sir? This formula came from here, from all these things that we have discussed. Okay, from all this discussion that formula came. Is that clear? So this is how I'm going to solve it. This matrix I just made it needlessly. In the examination you are not going to make these metrics, right? It's not that, sir, 0.09 log to 0.3, 0.21 log to 0.7. This is happening here, no? Like you pick this one, then log to 0.3. You pick this one, then log to 0.7. You pick this one, then log to 0.2. So it's not that, sir, first I will see this one, then I will make this matrix, then this matrix, and then I will write down this expression. No, you should have the habit of solving with respect to diagram only. So this particular question is there. Whatever you want to solve with respect to that question, you can solve it. So take it as a challenge that, sir, this particular diagram is given. One thing I can guarantee you, with guarantee I can write it down on paper, that no diagram will be difficult more than this. Like the diagram that is coming in the examination, that will be easier than this one only. Like here you can see 3 symbols, 4 output symbol, and then corresponding conditional probabilities you can see. So there are 1, 2, 3, 4, 5, 6, 7. 7 conditional probabilities are there. 3 symbols are there, 4 output symbols are there. In the examination, hardly 3 input symbol, 2 output symbol, 2 input symbol, 2 output symbol, 4 joint probabilities. These kind of condition would be there. 7 joint probabilities, 3 input symbol, 4 output symbol. That is very rare. So this is the toughest possible diagram that can be asked in your examination. Toughest possible. Okay. If the question is coming on information theory, this is the toughest possible problem that they can ask. They will not go tougher than this. Okay. So you can solve anything. You can find out these things. You can find out entropy of y, entropy of x, joint entropy, conditional entropy, whatever that you want to find out. You can find out anything with respect to this particular diagram. Another thing is there, that is probability of error. I guess that is our next topic only. So probability of error. First we will do the formula summary, and then okay, probability of error would be next to this one. So one interesting observation we are going to see about entropy, but before that let's do the formula summary. Okay, and then we will see some interesting observation. After that, what we are going to do, we are going to talk about probability of error. So in the probability of error as well, I guess we will be taking the same diagram. No, different diagram is there. So probability of error can also be find out with respect to this diagram. Okay, but before that, let's write down all the formula summary that we have seen. So what is the information content in your symbol xi? That is probability of xi log to probability of xi. Never ever forget the negative sign. What is your h of x? Sir, all the probabilities that are given, you will take all those probabilities. So whatever the symbols are there, x1, x2, x3, all those symbols you will put, surely there will be a negative sign. Sir, h of x comma y, first thing is that you need to remember this thing. Also, what is the what is the range of h of x? From 0 to log to k. What is k there? K is the number of symbols, right? Number of equiprobable symbols that has been generated by your source x, right? That would be your log 2k. Okay, this would be the number of symbols. Do you remember that thing? Surely you remember that 4 symbols it was generating, so log to 4, that was the maximum entropy we were getting. Okay, so entropy of x and y is equals to entropy of x, uncertainty of x, plus uncertainty in y given x, uncertainty in y plus uncertainty in x given y. Mathematical formula was, surely there will be negative sign. Ij would surely be there. Okay, again I have written h of x comma y. Why I have again written it. Only these formulas are there. So again there is no meaning of writing down h of x comma y. Okay, just remove it. Now what will be this one? If I want to write down the formula only. So sir, here joint probability would come. log 2 conditional probability. Log 2 conditional probability. Okay, this formula is there which you need to remember. Okay, how will you remember? Joint probability, conditional probability. Basically in the log, this, who is more important, y by x is more important or y comma x is more important? If you are finding out h of y by x, who will be more important? P of y by x will be more important, no? So which is more important, that would come in the log. That's it. So there will not be any confusion. Okay, whatever that is more important, that would come in the log. Or how you can remember? That higher value will be in the log. You can directly see 0.09, 0.3. Who is higher? 0.3 is higher. That is in the log. 0.21, 0.7. Who is higher? 0.7 is higher. That would be in the log. 0.2, 0.04. Who is higher? 0.2 is higher. That would be in the log. 0.8, 0.16. 0.8. 0.1, 0.05. 0.1. 0.4, 0.2. 0.4. 0.5, 0.25. 0.25. So anyway, you need to remember. Y by x if I am calculating. So conditional probabilities will be in the log, and joint probabilities will be outside. Joint probability will be outside. And this thing I have seen, that if whatever that I know, that is fixed, and whatever that I don't know, that is varying. That means y1, y2, y3, x1 is fixed. Here what is varying? X1 is varying, x1, x2, x3, but y is fixed. And these are all the joint probabilities. Summation of all of them would be equals to 1. So from this slide only you can revise everything that we have studied in this lecture so far. It's been roughly around more than 3 hours it is. In these 3 hours, whatever that we have studied, you can revise from this particular slide only. Okay. So let's end this lecture here. This is the first lecture. Let's end this lecture here because it's been more than 3 hours. Then we will study some interesting observation for the entropy. Okay. And this we are studying for discrete random variable only, because till this point everything that we have seen, that was only for discrete random variable. So very interesting observation we are going to see. That first there is a symbol x is given. Okay. And output symbol is y. You need to find out the entropy of h of y for this case, and this case, and surely you need to find out the entropy of h of x as well. So what will be the entropy of h of x? Sir, minus sign will be outside. 0.6 log to 0.6 plus 0.4 log to 0.4. That would be your entropy of x. Here y of 2x plus 1. So if x is taking value 1 and minus 1, then what values y will take? When x equals to 1, y will be 3. When x equals to minus 1, y will be equals to minus 1. So y will take value 3 and 1. What will be the probabilities of y equals to 1 and y equals to minus 1? That probability you will write down, and based on that you will see what you are getting. Okay. So we will solve this problem, and from this particular problem we are going to conclude something, and a very interesting observation we are going to see. So for that we will see it in the next video. Till then, thank you very much. Happy learning. Yeah, hi everyone, welcome back. So we are continuing our discussion on information theory only. In the last lecture as well, we studied about entropy. We studied about entropy, then joint entropy and conditional entropy, and we saw the formula, and we saw the numericals as well, and this was the summary of our last lecture. Now we are getting started with some interesting observation of entropy. Okay, it would be very interesting, right? And till this point there is no apparent question from this particular topic, but I feel that in next years the question is coming from this particular topic as well. So first we will solve the problem, and then we will see what we can conclude from here. So first we will solve this particular question. Okay. So this question is there. Two symbols are there with the probability of 0.6 and 0.4. So can you let me know what will be your entropy of x? So that would be probability log 2 probability. Surely there will be a negative sign, which I again and again forget. So let's write down again. Sir, it would be probability log 2 probability plus probability log 2 probability. And then we need to solve it. Whatever the answer we get, we will keep that answer, and then we need to comment on h of y. So first let's calculate 0.6 log to 0.6 into 0.6, that is coming out to be 0.442. So 0.4 into 0.4 plus 0.442. So it is coming out to be 0.97. Okay. Now what is the first question that is saying? First question is, sir, y is equals to 2x plus 1. So you need to comment on the entropy of y, or you can say I need to comment on the entropy of 2x plus 1, right? Entropy of y or entropy of 2x plus 1. What we are discussing on? We are discussing on discrete random variable. So whatever the discussion we are doing with respect to discrete random variable. Never ever forget it. Okay, for discrete random variable. So this is the discussion we are doing for discrete random variable. So now what I will be interested in, first interest would be that what all values y can take, right? Because x is taking value 1 and minus 1. So what values y can take? So y will take, when x is taking value 1, so y will be equals to 3, and when x is taking value minus 1, so y will be equals to minus 1 only, right? When x is taking value minus 1, so you put minus 1 here, minus 2 plus 1, that would be minus 1 only. So what will be the probability of y such that y is taking value equals to 3? That would be probability of x such that it is taking value 1, that would be equals to 0.6. And what will be the probability of y taking value minus 1? That would be equals to probability of x taking value minus 1, and that would be equals to 0.4. So here what did you see? Your symbol y is actually taking two values, that are y1 and y2, where y1 is equals to 3 and y2 is equals to minus 1. Corresponding probability to this one is 0.6, corresponding probability to this one is 0.4. When I am calculating the entropy, what I am interested in? Am I interested in this value? No, I am interested in the probability. So what is the probability I am getting? 0.6 log to 0.6 plus 0.4 log to 0.4. You do the calculation, whatever the answer you get, you will get the same answer, that is 0.97 bits per symbol. Okay, 0.97 bits per symbol. So entropy of 2x plus 1 is same as entropy of x. Okay, let's see this example. Y is equals to 3 to the power x. Y is equals to 3 to the power x. So x is taking two values. What is that? 1 and minus 1. So y will also take two values. What that would be? Sir, 3 to the power 1 and 3 to the power minus 1. So what will be the probability of y taking value 3 to the power 1? That would be equals to probability of x taking value 1. And probability of x taking value 1 is 0.6. Y taking value 3 to the power minus 1, that would be x taking value minus 1, that would be equals to 0.4. Again, I am interested in probabilities only. Basically, y was my random variable which was producing two symbols, y1 and y2. Probability of y1 was again 0.6. It was again 0.4. So what will be your entropy of y, or you can say what will be your entropy of 3 to the power x? That would be same as 0.97. So here this was your entropy of y, or I could have written entropy of 2x plus 1. Okay, so entropy of bits per symbol. C is y square equals to x, or y equals to x square. Y is equals to x square. So x is taking value 1 and minus 1. So y will be taking value what? If x is equals to 1, then y is equals to 1. When x is equals to minus 1, when x is equals to minus 1, y will be equals to 1 only. Is that clear to you? So y can take only one value, that is 1. So basically y can take only one value, that would be 1 only. So what will be your probability of y taking value 1? That would be equals to probability of x taking 1 or probability of x taking minus 1. This is very basic of random variable that we are studying, right? Very basic of random variable. Only one value y can take, that would be probability of x taking value 1, probability of x taking value minus 1. What does that mean? Probability of x taking value 1 is 0.6, 0.4. So y can take value only 1. So there was your random variable y which was generating only one symbol, that was having a probability of 1. So what do you think? What will be the uncertainty of y? Uncertainty of y you can write down, or uncertainty of x square you can write down. That would be equals to probability log to probability. A minus sign would be there, but log to 1 will be 0 only. So basically what did you see here? H of 2x plus 1 was equals to h of x and it was equals to h of 3 to the power x as well, and that was coming out to be how much? 0.97 bits per symbol, right? And what was your h of x square? That was not equals to h of x, that was not equals to h of x, or better I should write down h of x square was coming out to be 0, which was lesser than h of x, less than h of x, right? H of x square was actually less than h of x. So what conclusion we can make? Let's talk about the conclusion. Let me add a page here, and we will see something now. Okay, so question we have solved. Now what do I know? Do I know one thing, that h of x comma y is equals to entropy of y by x, entropy of y plus entropy of x by y. So forget about this thing, just look at these two things. H of x plus h of y by x is equals to h of y plus h of x by y. Those two things are equal. Is that clear to you? Now listen to me very carefully, okay? Now very important discussion is coming, okay? You need to put your full concentration here. Scenario is y equals to 2x plus 1. So from here, what will be the value of x? Value of x would be y minus 1 divided by 2. So just let me know one thing. If I know the value of x, forget about this example now, forget about this example. I am asking for any random example. If I know the value of x, can I comment on the value of y? Let's just see, if I say value of x is equals to 1, then you are 100% sure that value of y would be equals to 3 only. Let's just say someone says that x is equals to 5, then you are 100% sure that value of y would be equals to 11 only. Is that true? If someone says x is equals to minus 3, then you are 100% sure that value of y would be equals to minus 5. So what is the uncertainty in x such that I know y? What that would be? That is equals to 0. Uncertainty in x such that I know y, or I should write down opposite, uncertainty in y such that I know x. So if I know x, there is no uncertainty in y. Basically, if you know the value of x, you are 101% sure that y will be equals to 3 only. So there is no uncertainty in y, given that you know the value of x, that would be equals to 0. Similarly, from this scenario, what you can say? Sir, if I know the value of y, let's just say I know that y is equals to 1, then I am 101% sure that x would be equals to 0. Sir, if I know y is equals to 3, then 101% I am sure that x would be equals to 1. Sir, if I know y is equals to minus 3, then 101% I am sure that x will be equals to minus 2. Is that clear to you? So uncertainty in x such that you know the value of y, what that would be equals to? That would be equals to 0. So h of y by x equals to h of x by y equals to 0. Is that understandable to you or not? Uncertainty in x such that you already know y. So if I know the value of y, there is no uncertainty in x. If I know the value of x, there is no uncertainty in y. That means both these things are equals to 0. Now if I use equation 1, you can, like in brief, you can write down somewhere here whatever the example that I gave, like y equals to 1, x equals to this value, y equals to this value, x equals to this value, x equals to this value, y equals to this value, x equals to this value, y equals to this value. So you can write down these examples in your own language. I am keeping this space for you. Okay, this space is for you. You can write down anything you want to write down here. So what did you see here? If I use this equation, which is our equation 1, so h of y by x equals to 0, h of x by y is equals to 0. So from here, what did you see? H of x is equals to h of y. And what is that? Y is equals to actually 2x plus 1. And are we getting the same thing? Yes. So this was just your example, just to make you feel good. But this is the actual concept. Right? That was just to make you feel good, that this example I took just to make you feel good. Like numerically also you can verify that this is actually happening. But this is the actual concept. This is how you will be checking in the examination. Let's take the another example. Y is equals to 3 to the power x. Okay. So from here, what you can say? Sir, x would be equals to log 3y. Right? Clear? So if I say I know the value of x, then 101% I am sure about the value of y. If I say x is equals to 1, then value of y would be equals to 3. If I say x is equals to minus 1, then the value of y is equals to 3 to the power minus 1. So what you can say? So if I know the value of x, there is no uncertainty in y. Now if you know the value of y is equals to 1, then what will be the value of x? So that would be equals to 0. If y is equals to 3, then value of x would be equals to 1. So if y is equals to 9, then value of x would be equals to 2. Because there is only one value only, no? There is 1 to 1 mapping. This is the case of 1 to 1 mapping, no? If there is only one value of y, then there is only one possible value of x. Is that clear what I am saying? So if I know the value of y, there is no uncertainty in x. If I know the value of y, there is no uncertainty in x. If I know the value of y, I am 101% sure that value of x would be equals to 2 only. What does that mean? Again, you can see here, this is the scenario you are getting. But let's take the last case. Y is equals to x square. What is the case? Y is equals to x square. Y is equals to x square. So what will be your x? X will be equals to, sir, plus minus under root y. Now what I am saying? If I know x is equals to 1, then what will be the value of y? Sir, 100% it would be 1. If I say x is equals to minus 1, what will be the value of y? Sir, 100% it would be 1. If x is equals to 2, sir, 100% y would be equals to 4. So if I know the value of x, I surely know the value of y. If I know the value of x, I surely know the value of y. What does that mean? That means that I think I should use the next page. Let me add another page. So I will take this example. Our example was y is equals to x square. Okay. So what did I say? If I know the value of x, then surely I know the value of y. So uncertainty in y such that x is known, that is equals to 0. But if you know the value of y, if someone says that, sir, y is equals to 2, what someone is saying? Y is equals to 2. So y is equals to 2. 2 is equals to x square. Y is equals to 2. That means in place of y I can put 2. 2 is equals to x square. What will be the value of x? One can say value of x is under root 2. One can say value of x is minus under root 2. So uncertainty in x such that y is already known. From here also you can see that x is equals to plus minus under root y. So what I am saying? Uncertainty in x such that y is known, that is not equals to 0. That would be some non-zero value. And it would be positive value only, right? Surely it would be positive value. Why it would be positive value? Because uncertainty cannot be negative, right? Uncertainty cannot be negative, right? Uncertainty, some uncertainty is there, some information you are having. That means it has to be positive only. So what I am saying, from this particular expression, you can see that if you know the value of y, let's just say y is equals to 4, then x could be 2 as well, x could be minus 2 as well. That means if I know the value of y, there is non-zero uncertainty in x. So h of x by y is equals to non-zero. Now what will be the expression? The expression was, this was the expression, right? Uncertainty in y plus, this was the expression, right? Now you know that this is coming out to be 0. So what you are getting? So h of x is equals to h of y plus h of x by y. This is what you are getting. Now you know that this is some non-zero positive value. Let's just say h of y was 2. I don't know what is h of y. H of y was 2. This is some non-zero positive value. Let's just say it is 1. So what would be h of x? H of x would be 3. That means h of x would surely be greater than h of y. Right? From here you know that this is some non-zero positive value. Non-zero positive value. Then you are sure that h of x would surely be greater than h of y. That means h of x would surely be greater than h of x square. Were we getting the same thing here? Yes, sir. H of x is greater than h of x square. We were getting the same thing. So is this concept clear to you? How we are going to solve it? Now let's just say there was another example. Example D I am taking. That example was the relation between x and y was defined as y square is equals to x. y square is equals to x. And now you need to comment on hx versus hy. So what do you see from here? H of x by y and h of y by x. Which of either both will be 0 or one of them will be 0 or both will be non-zero? What do you think? If I know the value of y, let's just say y is equals to 2, then 101% x would be equals to 4 only. There is no other chance. If I know the value of y, let's just say y is equals to 3, then 101% x would be 9 only. So if you know y, then surely you know x. So uncertainty in x such that y is known, that is equals to 0. Is that clear to you? I am talking about x and y. So if I know the value of y, I surely know the value of x. So uncertainty in x such that you know the value of y, that is 0. Uncertainty in y such that you know the value of x. So if I say x is equals to 3, what I am saying, x is equals to 3. So y could be either equals to plus 3 or it could be equals to minus 3. Y could be either equals to either it could be equals to plus under root 3 or it could be equals to minus under root 3. So if I say that I know the value of x, then it doesn't mean you know the value of y as well, because it could be plus under root 3 or it could be minus under root 3 as well. So there are two chances. So uncertainty in y such that x is known, that is non-zero. Is that clear what I am saying? Uncertainty in y such that x is known. So let's just say x is 9. If x is 9, then y would be plus minus 3. So two values it can take. So if I know the value of x, I am not sure about the value of y. The value of y could be having two possible values. So uncertainty in y such that you know the value of x, that is non-zero. So from here, what do you see? From here, h of x plus h of y by x, that is non-zero, is equals to h of y plus h of x by y, that is equals to 0. So from here you can see that h of y is having more uncertainty than h of x. So this kind of questions can be asked in the examination. What they would say, that there is a random variable x having uncertainty of h of x. Some relation between y and x are defined. Okay, 4 options they will frame like this. Four options they will frame like this. What will be the relation between hx and hy? So here hx equals to xy, here also hx equals to xy, here something different would be there, here something different would be there. Here h of x would be greater than h of y, and here h of y would be greater than h of x. Is that clear to you? Okay. So will you mug up anything here? Nothing you are going to mug up. Okay. Nothing you are going to mug up. Just a pure concept. Just pure concept are there that you have already understood. Is that clear to you? Absolutely, it is clear to you. One more thing you can notice. This was the graph of y equals to x. This was the graph of y equals to x square. This was the graph of y equals to 3 to the power x. So here 1-to-1 mapping is there, no? Like if I know the value of x, I surely know the value of y. If I know the value of x, I surely know the value of y. If I know the value of x, I surely know the value of y. But in this case, if you know the value of x, it is not sure that you know the value of y. For x equals to 1, sorry, opposite I should say, sorry guys. If you know the value of x, you surely know the value of y, that would be the value of y. For x equals to 1, you know the value of y. But if you know the value of y, let's just say y is equals to 1, then you don't know the value of x, because this is 1-to-many mapping. 1-to-many mapping or many-to-one? Many-to-one. Yeah, it is many-to-one mapping actually. Although this graph thing is not important, okay? This concept was important. I am just trying to explain with respect to graph. Like if this kind of graph is there, that means 1-to-one mapping is there. Now with respect to one value of x, you will get one value of y. So basically, this is your invertible function. This is your invertible function, right? This is your non-invertible function. How do you check invertible and non-invertible? You draw a horizontal line. So if I draw a horizontal line, here it is cutting twice. If it is cutting twice, that means it is non-invertible. If I draw a horizontal line, if it is cutting only once, that means it is invertible. So for invertible functions, h of x would be equal to h of y. But for non-invertible function, it would not be equal. Although these conclusions are not important, this concept was important. With respect to this concept, you will be able to solve all the problems that are asked in the examination. But I am just telling with respect to graph as well, that with respect to graph as well, you can notice something beautiful here. That if you are able to draw the graph and you can see that 1-to-1 mapping is there, that means with respect to one value of x, you will get one value of y. So here in this case, h of x would be equal to h of y. Here in this case as well, h of x would be equal to h of y. But surely in this case, h of x would not be equal to h of y. Is that clear to you? Okay. So a very good discussion we have done. Well and good. Let's solve this problem. Input symbol is x, output symbol is y. Consider discrete case, that means consider discrete random variable. Relation between x and y is defined. Comment which one is larger, h of x or h of y. For a, y is equal to e to the power x. Y is equal to e to the power x. This is the graph. 1-to-1 mapping is there, right? With one value of x, value of y is defined. If x is equal to 1, y will be equal to e to the power 1. If x is equal to 2, y will be equal to e to the power 2. Similarly, opposite side is also true. X is equal to, what will be your x equals to? X would be equal to ln y. So if y is equal to 1, x equals to 0. If y is equal to 2, x equals to ln 2. If y is equal to 3, x equals to ln 3. So 1-to-1 mapping is there. You can simply draw the graph as well. 1-to-1 mapping is there. What does that mean? That means simply there is no uncertainty in x if I know the value of y, and there is no uncertainty in y if I know the value of x. What does that mean? That means h of x is equal to h of y. This is the case for first one. For the second one, y is equal to log x. Can you draw the graph of log x? This would be the graph of log x. Again 1-to-1 mapping, right? Base they did not define, so let's define the base as b. So what would be your x equals to? That would be b to the power y. So basically they are the opposite case only. Y is equal to e to the power x, x equals to ln y. Here y is equals to x equals to b to the power y, y is equals to log bx. So again you draw the graph. 1-to-1 mapping, yes. Draw a horizontal line, only once it is cutting, that means yes, 1-to-1 mapping is there. What does that mean? That means that if I know the value of x, I surely know the value of y. If I know the value of y, I surely know the value of x. Again the same case, the same thing is happening, Again the answer would be h of x is equal to h of y. Y is equal to x cube. Draw the graph. Can you draw the graph of y equals to x cube? This will be the graph. Again 1-to-1 mapping. For one value of x, you will get only one value of y. And what will be the value of x here? So the value of x would be cube root of y. Again the same thing. You can draw the graph. With respect to graph as well, you will be able to understand that 1-to-1 mapping is there. With respect to one value of x, you will get one value of y. With respect to one value of y, you will get one value of x. That means h of x by y is equals to h of y by x, that is equals to 0. So here as well, h of x is equals to h of y. Y is equals to sin x. What do you think? What will be the answer? Y is equals to sin x. What is the graph? This is the graph. So basically, if I say x equals to 1, then I am pretty sure what you can see here. If I say x equals to 1, then value of y would be equal to sin 1. If I say x equals to pi by 2, then value of y would be equals to 1 only. If I say x equals to pi, then value of y would be equals to 0. So if you know the value of x, surely you know the value of y. So entropy in y such that you know the value of x, that is equals to 0. But entropy in x such that you know the value of y. Let's just say I say y is equals to 1. So what could be the value of, if I say y is equals to 1, then the value of x could be, sir, pi by 2 or 5 pi by 2 or add more 2 pi, what that would be 9 pi by 2 and so on. So if you know the value of y, that doesn't mean you know the value of x as well. So uncertainty in x such that I already know the value of y. Non-zero uncertainty is there. What does that mean? I remember the expression. So this is non-zero, but this is 0. H of y is greater than h of x. So you can see that here as well, the same kind of answer that we were getting. H of x is greater than h of y. Sorry guys. Yeah, sorry. Basically, h of x will be greater than h of y. This kind of blunder should not be done. This is non-zero. So h of x, this value, in h of y something is being added, then you are getting h of x. That means h of x would be greater than h of y. Right? This kind of error should not have been there. Is that clear to you? H of x would be greater than h of y, or in the examination it could be written in this manner: h of x is greater than h of sin x. Is that clear to you? Okay, h of x is greater than h of sin x. What about this one? Y square equals to x. This we have already seen. Y square equals to x. Y square equals to x. This we have already seen. So here h of y was greater than x. Here what I could see, h of y was greater than h of x. Okay. Is that clear to you? So this is how you will be able to solve all these kind of problems. A very, very good problem, and surely it is coming in future GATE examination. Whenever it comes, I am not sure about it, but surely it is coming. And this we have seen for the case of discrete random variable. Okay, again I am saying for the case of discrete random variables. Is that clear to you? Okay, this discussion is very important. It is not mentioned in any textbook. It is not mentioned in any NPTEL lecture as well. You just need to think in this manner, and then you would be able to frame this kind of content. Okay, so yeah, I hope you are able to understand these kind of things, and you will be surely able to solve these kind of problems in the examination hall. Okay, let's go to our next concept, that is probability of error. But before that, let's solve this problem. This was asked in GATE 24 or 25, not in 25. It might be asked in 23 or 24, I'm not sure. So this question was asked. I'm pretty sure that you will be able to solve this problem. Like everyone was able to solve the problem. Even in the textbook, even in the PYQ solution books, a lot of PYQ solution books are there. This question has been solved and everyone got the correct answer. Like if you see the problem, what you can see, sir, 8 symbols are there. A symbol is chosen and it is determined by a series of yes or no, which are assumed to be truthfully answered. The average number of questions when asked in the most efficient sequence to determine the chosen symbol is. So basically, what you would notice there, that, sir, average number of questions they are asking, symbols, 8 symbols it is generating, and probabilities are mentioned. 101%, sir, I need to calculate average information or entropy. So you will do the answer, you will calculate the entropy, but this is not my target. That's why I took this question. I want you to understand the meaning of this problem. I'm pretty sure no one actually understands the meaning of this particular problem, because I have seen the solution in every PYQ book. They have just given the answer and everyone could have done it. Like in the examination hall, it would click to you for sure that they are asking entropy. What you would do? Sir, 1 by 2 log 2 1 by 2 plus 1 by 4 log 2 1 by 4. I am 101% sure that you would be doing this particular thing in the examination. Everyone would be doing this particular thing. There is nothing difficult in this one, right? You would be doing this thing and you will be getting the answer 1.98 bits per symbol. So you would put the answer 1.98. But does it make any sense? Is it making any sense? That, sir, why did we calculate the entropy, sir? What this question is trying to say? So our target is to understand what this question is trying to say. So basically you are having 8 kind of symbols, A, B, C, D, E, F, G, H. So what I am having these 8 symbols. Now there is some guy who will come and pick one of the symbols. He will pick one of the symbols. Now you don't know which symbol he has picked. There is some guy, he has came and he has picked that symbol. In his hand some symbol is there. You don't know. Okay, some symbol is there. But you know one thing, that A is occurring most of the times. Basically A is occurring for the 50% of time. A will occur for the 50% of time. Let's just say in this box there are total 128 symbols. I am saying in this box total there are 128 symbols. That means symbol A will be there for 64 times, because 50% time, probability is 1 by 2. So symbol A is there here, A, that is there 64 times. This is there 32 times. Symbol B is there. This is for symbol A. This is for symbol B. Then 16 times you will get symbol C. 8 times you will get symbol D. and in that manner you will get these symbols. Now from this box, from this particular box, this particular guy came and he picked one of the symbol. Now he has that symbol in his hand. He has that symbol in his hand. Now what you need to do? You need to ask this guy some questions. You need to ask this guy some questions, and based on that you need to tell what kind of symbol he is having, which symbol he is having. So what do you think, what should be your first question? What would be the first question you will be asking? He has picked one symbol. What do you think, what should be there in his hand? Most probably you will predict that in his hand A would be there, because more chances of A are there. No, there are 64 chances that in his hand A would be there. So what will be the first question you will be asking? What you will be asking? Is it A? If he says yes, that means A has been caught. But if he says no, what did you ask? You asked, is it A? He said no. That means he is not having A. Basically they are saying that truthfully answered. You can say truthfully answered. So he will be answering truthfully, okay? He is not telling any lie. So he said he is not having A. So what is the next question? What do you think you will be asking? You will be asking, is it B? Say yes or no. What is the next question you would be asking? Why you are asking is it B? Because after A, who is having more chances of? B is having more chances. If this guy is not having A in his hand, then who is having more chances? B is having more chances. That sir, more probability is there that B would be there. Are you able to understand this point or not? So what you will ask? Is it B? What he will say? Let's just say he said yes. That means B has been caught. Next question. Let's just say you asked, is it A? Let me just copy it. Next, what did you ask? You asked him, is it A? He said no. Then you asked, is it B? He said again no. Then what do you think what you will ask now? You will ask, is it C? What you will ask? Is it C? What he will say? Yes. Why you are saying I will ask, is it C? Because sir, if A is not there, B is not there, that means more probability is there, sir. More chances are there that he would be having C. That means you will be getting C. Now it might happen that you asked, is it A? Is it B? Is it C? In all three chances he said no. Then what you will ask? Is it D? Then what you will get? D here. Right? So for getting A, how many questions you need to ask? Number of questions asked. So this process you keep on repeating for 128 times. This process you keep on repeating for 128 times. So out of these 128 times, for the 64 times, you need to ask only one question. Because if you keep on repeating this process for 128 times, that means in 64 times you would be getting A only. Let me repeat what I am saying. You are repeating this process for 128 times, right? He will be picking one symbol, right? In out of those 128 times, for 64 times what you will be getting? You will be getting symbol A only. And what is the first question that you are asking? This is the first process that you have done. What is the first question that you are asking? Is it A? And then he will have to say yes. That means only one question you have to ask. You have to ask one question 64 times out of 128 experiment. Is that clear to you? What I am saying? So let's forget about this particular thing, 64 by 28. For getting B, how many questions you need to ask? You need to ask 2 questions. For getting C, how many questions you need to ask? Sir, 3 questions I need to ask. For getting D, how many questions you need to ask? Sir, 4 questions I need to ask. So basically, the one which is having lesser probability, you need to ask more questions, no? Less probability, more questions. Because if any event is having lesser probability, That means it is having more information. And to get more information, you need to ask more questions. Basically, if you don't ask any question, that means you are not getting any information. So if you ask more questions, that means you will get more information. That means lesser probability is equals to more questions. That means equals to more information. So to get to know about D, you will have to ask more questions. Basically, what you were doing is that in this box, there were total 128 symbols. Out of those 128 symbols, 64 were A, 32 were, let me make a clearer diagram here. You had a box. In this box, there were total 128 symbols. Out of those 128 symbols, 64 were A, 32 were B, 16 were C, 8 were D. Right? 4 symbols were E, 2 symbols were F, 1 symbol was G. One symbol was G and one symbol was H. Right? So for getting A, how many questions you need to ask? Number of questions asked. Number of questions asked. So this is how you will be asking the question. He has picked some symbol. What you will be asking, is it A? If he says yes, that means A has been caught. Now he will pick another symbol. You will ask, is it A? He said no. Is it B? He again said no. Is it C? This time he said yes. That means for getting C, how many questions you need to ask? 3. For getting A, how many questions you need to ask? 1. For getting B, how many questions you need to ask? 2. Here you will have to ask 4 questions. Here you will have to ask 5 questions. Here you will have to ask 6 questions. Here you will have to ask 7 questions. And here also you will have to ask 7 questions only. Is that clear to you? Because what you will ask, is it A? Is it B? Is it C? Is it D? Is it E? Is it F? Is it G? Right? And then you will have to ask these kind of problems. Right? These kind of questions you need to ask. Is that clear to you? Right? So one question you will have to ask for half time. Because probability of A occurring, out of 128, 64 times A would be occurring. That means for the half of the time you need to ask one question. For half of the time, for 1/4 of the time, that means 32, B is occurring 32 times out of 128. That means for 1/4 of the time, for 1/4 of the time you need to ask 2 questions. Right? For 1/8 of the time you need to ask 3 questions. For 1/16 of the time you need to ask 4 questions. For 1/32 of the time you need to ask 5 questions. So that means what is the average number of questions you need to ask? So if I want to find average number of problems asked, average number of questions asked, so what I will do, first I will add a page. What I need to find, average number of questions asked. So that would be question. If I am observing A, that means I need to ask only one question, but half of the time. If I am observing B, that means I need to ask 2 questions, but that would be 1/4 of the time. If I am observing C, that means I need to ask 3 questions, 1/8 of the time. If I am observing D, that means I need to ask 4 questions, 1/16 of the time. If I am observing E, I need to ask one question. Sorry, I need to ask 5 questions, 1/32 of the time. I hope you are able to understand the meaning of this particular problem. This was a very, very good question, but everyone got the correct answer luckily, because it is pretty obvious that you need to find out entropy only. But here I am telling you the actual meaning of this problem. There are total 128 symbols were there. If we take 128 symbols, 64 times A was occurring, 32 times B was occurring, C was occurring 16 times, D was occurring 8 times, E was occurring 4 times, F was occurring 2 times, G was occurring 1 time, and H was occurring 1 time. Number of questions you are asking: 1 question, 2 question for B in this manner, then 3 questions for C, then 4 questions for D, 5 questions for E, 6 questions for F, and for H, for G 7 questions, for H as well 7 questions. So this is what we are doing. So 6 question 1 by 64 times, 7 questions 1 by 128 time, and then again 7 questions for 1 by 128 times. So when you calculate this particular thing, it would be same as this one. What you can notice here, 1 by 2. What is log 2 1 by 2? Minus sign would be there, it would become 1 only. Plus 1 by 4. What is log 2 1 by 4? Minus sign is already there, so it would become log 2 4, that would be 2. Plus 1 by 8, this would be 3. Plus 1 by 16, this would be 4. Then 1 by 32, it would be 5. Then 1 by 64, it would be 6. Plus 1 by 128, 7. Plus 1 by 128, 7. This scenario you will be getting, and you can check the same scenario. 1 by 2 into 1, 1 by 4 into 2, 1 by 2 into 1, 1 by 4 into 2, 1 by 8 into 3, 1 by 16 into 4, 1 by 32 into 5. 1 by 32 into 5, 1 by 64 into 6, 1 by 28 into 7, 1 by 28 into 7. You are getting the same scenario. Answer would also be same, 1.98 bits per symbol. Or better, I should write down questions per symbol. So on an average, nearly around 2 questions you need to ask to determine one symbol. So if 128 symbols are there, so you are nearly asking 128 into 1.98 questions. This much questions you are asking. 128 into 1.98 questions you are asking. If we are performing this kind of experiment, then this much questions you need to ask to determine all these symbols. Is that clear to you or not? A very, very good question. Actually, it should have been solved like this. There is no communication system involved. This is pure mathematics. You either call it mathematics or you call it intuition, you call it whatever it is. It is aptitude as well. Okay, you can call it aptitude as well. So there was no communication system involved here, but here we just involve the communication system. You would see in all the textbook this solution is given, but there is, like, it doesn't teach you anything, right? The solution is not teaching you anything, and I'm pretty sure a lot of people did not get the meaning of this question, but this was a beautiful question, and this is how this was the meaning of this particular problem. Is that clear to you? Although in the examination, if this question has came, I'm pretty sure you would be also able to solve it, because directly, just by looking at the problem, you can sense that they are asking about entropy, right? But it is very rare that in the examination you would be able to understand what they actually trying to ask, right? So in that manner, you need to see whatever the symbol he is picking, you need to ask him questions. Is it A? Then you will ask, is it A? He will say no. Is it B? That means for getting B, you need to ask 2 questions. For getting C, you need to ask 3 questions. For getting D, you need to ask 4 questions. Now, 1 question you are asking half time, 2 question you are asking 1 by 4 time, 3 question you are asking 1 by 8 time, 4 question you are asking 1 by 16 time. So the average would be 1.98 questions for one symbol. So if you are performing this experiment 128 times, that means you are asking 128 into 1.98 questions. Is that clear to you? So that's it. This is the end. Okay. Now we are going to see our next topic, that is probability of error. So again, the same thing is there. Input symbols x1, x2, x3 are there. Received symbols are y1, y2. Okay. Now these y1 and y2 need to make some decision. Basically, this y1 need to say what we do in communication system. This is our communication system. We are transmitting symbol x1, x2, x3. So at the receiver, ideally what I should receive? x1 only I should receive, x2 only I should receive, x3 only I should receive. Now what is being received actually? Actually, I am receiving y1 and y2. So what y1 will say? The threshold detector will make some decision, no? So threshold detector will make the decision in a manner that y1 will say that, sir, x1 is received, or it can say x2 is received, or it can say x3 is received. y2 can say x1 is received, or x2 is received, or x3 is received. So y1 and y2 need to make some decision. So how will they make some decision? So decision rule could be given. Do you remember threshold detector? So there decision rule was given, that y bar, y cap was there and y was there. So if y is greater than lambda, then the decision would be made in favor of 1. And if y is less than lambda, then decision would be made in favor of 0. So this was given. Either it could be given, or what they can simply mention, that we are working on map based receiver, or we are working on ML based receiver. So this kind of thing they can mention in the examination. So how will you make the decision? So what this y1 will do, is that path clear to you? What is actually happening here? We have transmitted x1, x2, x3. there was some noise. Because of that, ideally we should have received x1, x2, x3 only, but actually we are receiving y1, y2. So now y1 and y2 will be making some decision. Y1 will be saying that x1 is received, or x2 is received, or x3 is received. Y2 will be saying that x1 is received, or x2 is received, or x3 is received. How they will be saying? So what we need to see, probability of x1 being transmitted and y1 is being received, probability of x1 being transmitted, x2 being transmitted and y1 is received, probability of x3 being transmitted and y1 is received. So the probability which is maximum, y1 will make decision based on that. Let's just say this is greater than this one and this is greater than this one. So what y1 will say? Y1 will say that x1 is received. So if you are getting x1, that means there is no error. And if any other symbol is received, symbol received, I know you are not getting you are not able to understand everything, but slowly when we solve the problem, you will be able to understand every single thing. Don't worry about that. If you receive any other symbol received except x1, then there will be error. Is that clear what I am saying? No, it is not clear. When we solve the problem, it will be clear. Okay, don't worry about that. I am just saying that how map based receiver will be working. Either it would be mentioned that y1 should give the decision in favor of x1 and y2 should give the decision in favor of x2. So now if x3 is being sent and let's just say x3 is going into y2 only, that means this particular scenario is of error. Basically, it might be mentioned in the problem that y1 should be giving decision in favor of x1 and y2 should be giving decision in favor of x2 only. Now what if x1 is resulting in y2? So that means this particular scenario is getting into the error, because x1 should result in y1, but it might happen that x1 is resulting in y1 with the probability of 0.7 and x1 is resulting in y2 with the probability of 0.3. So this particular probability, this particular scenario will be in error. So either it could be mentioned that y1 is making decision in favor of x1, y2 is making decision in favor of x2. Okay, and if any other symbol is received, that means that will be in error. Or what they can mention, directly they can mention that we are working on map based receiver. So what is the meaning of map based receiver? What it will see? Who needs to make the decision? Y1 needs to make the decision. So what it will see? Y1 will see that I am coming from x1, I am coming from x2 as well, and I am coming from x3 as well. So probability says that y1 is received, x1 is sent. Probability says that y1 is received and x2 is sent. Probability says that y1 is received and x3 is sent. So it will examine all these three probabilities and then he will see which probability is maximum. This probability is maximum. We are just assuming that this probability is maximum. So y1 will say that, sir, I will make the decision in favor of x1. So now if any other symbol except x1 is received, then I will say it is an error. Now how y2 will make the decision? So what y2 will check? x1 being sent, y2 received. x2 being sent, y2 received. x3 being sent, y2 received. Okay, let's just say this is the scenario. Let's just say this was the scenario that okay, here we cannot comment, actually here only we will be able to comment that this is maximum. Then what y2 will say? y2 will say that x3 is received, and if this is the scenario, then there is no error, otherwise there will be no error. Otherwise there will be error. So you are not able to understand much of the things from here. Let's do a realistic analysis. From this particular question you will be able to understand. Here what I have written, ML based receiver. What is the meaning of ML based receiver? These receiver we have already seen, map based and ML based. So what is the meaning of ML based receiver? It would be same as map only, but all the symbols will be equiprobable. Here any kind of probabilities would be there. If probability of x1 is equals to probability of x2 is equals to probability of x3, then you would say we can use ML based receiver. If these probabilities are different, then you will say map based receiver we are using. So if they are using ML based receiver, then they will not mention these probabilities. So by default you need to take that all these probabilities are equiprobable, and then you need to solve this particular analysis. So let's solve with respect to this particular question. What they are asking, what will be the probability of symbol error? So what y1 will see? y1 will see that I am being received from x1, x2 and x3. From all three I am being received. So y1 will see that probability says that x1 is transmitted and y1 is received. What is that? So 0.2 multiply with 0.2. This is your conditional probability, y1 by x1. So y1 by x1 multiply with x1, that would be 0.2 multiply with 0.2, that would be 0.04. x2 being transmitted, y1 received. So then he will see this path, 0.1 into 0.5, that would be 0.05. And then he will see x3 being transmitted, y1 being received, 0.15, 0.3, that would be 0.045. So which is maximum? This is maximum. So if your y1 is making decision in favor of x2, basically this particular path is good for him. Rest all the paths are path of error. So what will be the probability of symbol error in case of y1? That would be, if I am coming from here, that is the probability of error for me. Or if I am coming from here, that is the probability of error for me. Basically these are the probability of error and this is not the probability of error. Is that clear to you? Similarly, now y2 will make the decision. This was for y1. So y1 is making decision in favor of what? Y1 is making decision in favor of x2. Now y2 needs to make the decision. So let's just keep it a bit above here. Okay, now y2 needs to make the decision. So in which favor y2 will make the decision? So what it will see? Y2 will see that, sir, I am coming from x2 and I am coming from x3. So only two things I need to check. What will be x1 y2? That would be 0 only, because y2 is not even coming from x1. So that would be 0. What would be x2 y2? What is the probability such that y2 is coming from x2? That is 0.3. And what is the probability that it is coming from x3? That would be 0.75. 1 by 4, 0.075, right? And it would not be 0.3. Yeah, it would be 0.3 only. Yeah, 0.3. So y2 will also be making decision in favor of x2 only, because which is maximum? This is maximum. Is that clear to you? 0.25 multiplied with 0.3, what that would be? 0.075 only. So this is your maximum. So this particular part and this particular part will be resulting in error. So what will be resulting in error? 0.075 will be resulting in error, but this will not be resulting in error. Okay. So who is not resulting in error? So 0.05 is not resulting in error and 0.3 is not resulting in error. Now what about y3? What about y3? So where do we write down about y3? On the next page. Let's write down about y3. So what y3 will be making decision on? So y3 will say that, sir, I am coming from x1 as well, x2 as well, and x3 as well. So if I am coming from x1 given x3, coming from x1 given x3, that would be 0.16. Coming from x2 given y3, coming from x2, y3 is received. So 0.5 into 0.3, that would be 0.15 into 0.18. x3 y3, that is 0.18. Last one is 0.18. 0.3 into 0.6, that is 0.18. So who is maximum? This is maximum, right? So y3 is actually making decision in favor of x3. So if x3 is being received, he doesn't have any problem, but here and here he will have the problem. So where he is having problem? 0.16 and 0.15. And where he is not having problem? 0.18. So when you add all of these, what you are getting? 0.18 plus 0.5, 0.05, what that would be? 0.18 plus 0.05, what that would be equals to 0.23, so 0.53. So this is the probability of receiving the corrected symbol. And here if you solve it, it would be 0.47 only. You can check 0.045 plus 0.045 plus 0.04 plus 0.075 plus 0.31, so 0.47. It is coming out to be 0.47. So probability of error is 0.47, probability of receiving corrected symbol is 0.53. So what you will be actually doing in the examination? In finding out probability of symbol error, you could see that there are a lot of terms. But in finding out probability of corrected symbol, there is lesser terms. Only 3 terms are there, and here there are more terms. And you know one thing, that probability of correctness would be equals to 1 minus probability of error. So what you will find out? You will find out the probability of correctness. And if in the examination they are asking probability of receiving symbol error, that would be equals to 1 minus probability of receiving corrected symbol. That's it. Is that clear to you? Okay. In the examination, what you will be finding out? You will be finding out the probability of receiving the corrected symbol, and then you will subtract it from 1, you will get the probability of error. So how I will solve it? In the examination, what I would see, I will not do anything. This diagram would be made. This diagram would be there in front of my screen. What I would see, I will go to y1. I will see that y1 is coming from 0.2, 0.2, 0.04. Then y1 is coming from here as well, 0.05, and y1 is coming from here as well, 0.15 into 0.3, that would be 0.045. So which is maximum? Which path is coming out to be maximum? So this path is coming out to be maximum. So in the examination, what I will write down? Probability of receiving corrected symbol. So I will see 0.2 into 0.2. In the rough notebook, I will see 0.04. Then I will see 0.1 into 0.05. And then I will see 0.3 into 0.15, 0.045. Then I would know that this is the matter of concern for me. So this is the corrected symbol. Then I will go to y2. I would see y2 is coming from where? So I would see y2 is coming from where? So y2 is coming from 0.6 into 0.5, 0.3. Then 0.25 into 0.3, 0.045. Right? y2 is coming 0.25 into 3, 0.075. So who is more? This is more. So this is the corrected path for me. Right? So what all are the corrected path? 0.5 into 0.1, that is 0.05. Then what is the corrected path? 0.6 into 0.5, that is 0.3 plus. What about y3? y3 is coming from here, here and here. So 0.8 into 0.2, 0.16. Then 0.3 into 0.5, 0.15. Then 0.6 into 0.3, that is 0.18. So this is the corrected path for me. That means 0.18 is the corrected path. So what you are getting? Probability of corrected symbol, that is coming out to be 0.53. So this is the probability of corrected symbol. So in the examination, if they are asking probability of receiving the corrected symbol, then answer would be 0.53. If they are asking the probability of error, then answer would be 0.47. That's it. Is that clear to you? Very, very simple, very, very straightforward. Okay. So in the same manner, you solve this particular problem. Any other problems are there? No. So only this particular question is there. Here also there will be some twist. You will go to R0. R0, you would see that R0 is coming only from one part only. So 0.6 into 0.6. So R0 is coming only from this part only. So this guy will be maximum only. Basically, what I mean to say is that probability of receiving R0, M0 being transmitted, that is equals to 0.36. So probability of receiving R0 such that M1 is transmitted, that is equals to 0 only. Probability of receiving R0 such that M2 is transmitted, that is also equals to 0. So this is maximum only. So this is the corrected path. Right? What about R1? So 0.6 into 0.2. What that would be? For R1 I am writing down. 0.6 into 0.2. What that would be? Sir, 0.12. For R1, 0.4 into 0.3. That would also be 0.12. Sir, both are equal. So R1 will say that, sir, either I will make the decision in favor of M0 or I will make the decision in favor of M1. Right? So probability of correctness I am writing down. First one is 0.36 plus. Here you will write down 0.12 plus 0.12 or only 0.12. Basically, R1 will be making in favor of either in favor of M0 or in favor of M1. So if it is receiving M0 and R1 is saying that M0 is correct, that means M1 will be wrong, no? Like only one of them will be correct at a time. At a time, only one of them will be correct. If R0 is saying that, if R1 is saying that I will make a decision in favor of M0, that means M1 will be wrong. And if R1 is saying that I will make the decision in favor of M1, then M0 would be wrong. So in case of tie, there will be a tiebreaker. Now what is the rule of tiebreaker, that I don't know, but I am pretty sure that it would be making decision either in favor of M1 or in favor of M1. Either in favor of M1 or in favor of M0. So one of them will be resulting in error and one of them will be resulting in correctness. as of now I am writing down the correctness only, plus, then I will go to R2. What I will do, I will go to R2, then I will ask R2. Okay, R2 will say, what R2 will say, so 0.2 into 0.6, that would be 0.12. So 0.4 into 0.7, that would be 0.28. So I will be making decision in favor of that. So 0.28 will be our correctness. Okay. .28, 0.3, 0.3, 0.7, 0.666. Okay, fine. Yeah, so 0.36. Then what was the corrected path? Let's just say this was the corrected path for this one, because in R1 all paths were same only. So 0.6 into 0.2, that would be 0.12, right? Yes. And then 0.4 into 0.3, that would be 0.13 and 0.28 here. Okay. Yeah. So 0.28, this path is there in the final output. Okay. So what you are getting, 0.76, right? Because this will be 0.4, 0.76. So what will be probability of error? So that would be 1 minus 0.76, that would be 0.24. Is that clear? Okay, very easy question would be asked. You will be able to solve the problems in the examination, I am pretty sure. These two will be considered as a tough problem only. If you see the PYQs, very simple question have been asked. Let's just frame another problem, because I know that you are not much confident in this concept. So if you are not much confident, then let me frame another problem. X1, X2, X3. Okay. Or let's take only two symbol and take three output. Y1, Y2, Y3. So let's just say that X1 is resulting, and this is the scenario. Okay. And this guy is resulting in all three scenarios. Okay. Here it is going with the, if this probability, let's just say I say 0.4, then this probability will be 0.6. If I say this probability is 0.3 and I say this probability is 0.4, then this probability will be 0.3. Is that correct? All these probabilities? Yes. Okay. And let's just say I am saying ML based receiver we are using. What we are using? ML based receiver. So what you need to find out? Probability of error. This is what we need to find out. So ML based receiver means probability of x1 transmission is equals to 1 by 2 and probability of x2 transmission is equals to 1 by 2. So I will go to y1 now. I will go to y1. What I will see? Y1 will have two paths, 1 by 2 into 0.4, that would be 0.2, and 1 by 2 into 0.3, that would be 0.15. So in this favor he will be making decision. I will go to y2. Y2 is having only one path, that is coming from here. So 0.2 only, because 0.4 into 1 by 2, 0.2. So he will be making decision in favor of this only. And then I will go to y3. Y3 is also having two paths. So 0.6 into 1 by 2, that would be 0.3, and 0.3 into 1 by 2, that would be 0.15. So it will be making decision in favor of that. So this is the correctness. Okay. So what is the correctness? Correctness is 0.2 plus 0.2 plus 0.3. So correctness is 0.7. So what will be the probability of error? That would be 1 minus 0.7, that would be 0.3. So that would be your probability of error. And you can see that these are the error probabilities. So 0.15, 0.15, that is 0.3. Is that clear to you or not? So first I will find out probability of receiving corrected symbol. How will I find out? I will go to y1. Y1 will say that I am coming with the probabilities 0.2 and 0.15, right? 0.2 and 0.15. So basically, if you need to find out the probability of receiving y1, what will be the answer? This and this. So basically 0.2 plus 0.15. So this guy is actually, the probability of receiving y1 is 0.35. But out of this 0.35, 0.2 is correctness and 0.15 is error, right? Similarly, what will be the probability of receiving y2? That is 0.4 into 1 by 2, that would be 0.2 only. So this is pure correctness. And what is the probability of receiving y3? That is equals to 0.2 plus 0.15. So this is the correctness here. No, 0.3 plus 0.15. This is 0.3. So this part is correctness. So actually this was 0.45, but only corrected ones were this, and these were the error. 0.15 and 0.15 were error. So this path was corrected. This path was corrected. Okay, and then here only one path was there, that was corrected only, and here this path was corrected. So I hope now you will be able to solve all the problems. Okay, so go to the symbols one by one. Forget about this theory now. Forget about all this theory. What you will do, you will directly come to the problems. What you will do, you will go to R0, you will see from where I am coming. Then you will go to R1, you will go to R2, from where they are coming. Whichever the path is giving you maximum probability, that would be the corrected path. So then you can write down the corrected probability of receiving corrected symbol, and after that you will be able to find out the probability of a error symbol as well. Is that clear? I hope it is clear to you. Okay. Let's see the next question. This is pure aptitude. Okay, there is no electronics involved here. Pure aptitude it is. So what do you think what they are asking? Or shall I take a break? Binary symmetric channel also I will have to explain. Then here conditional entropy will also come. So I can take a break and then I will have to change the slide as well. So I will take a break and then I will come back. Okay. Yeah, welcome back. So did you try this question? So during a transmission of communication channel, this is purely based on aptitude. Okay, general aptitude problem it is. So what is the scenario? A communication system is sending 7 bits. Okay, it is sending 7 bits. Those bits could be B1, B2, B3, B4, B5, B6 and B7. So it is sending those 7 bits. Now bit error would be occurring independently with the probability of 0.1. That means probability of bit error is 0.1. That means what is the probability that you will receive corrected symbol or corrected bit? This is the bit probability, not the symbol. This is your complete symbol, right? This is your complete symbol. One symbol is having 7 bits. So probability of bit error they have given as 0.1. So this is the error and this is the correctness. Now what is the probability that at most 2 bits are received in error? So what they are asking you to find out? Probability that at most 2 bits are in the error. What is the meaning of 2 bits in the error? That means 0 bit could be in error, 1 bit could be in error, or 2 bit could be in error, where X showing bits in error. Bits in error. Let's just say I am sending all these 7 bits. Now I want to find the probability such that none of the bit is in error. That means all the bits are received correctly. That means B1 bit should be received correctly with the probability of 0.9. B2 should also be received correctly with the probability of 0.9. B3 should also be received correctly with the probability of 0.9. So that means 0.9, 0.9, 0.9, 0.9, 0.9, 0.9, 0.9. It will be multiplied 7 times. And why I am multiplying? Because of this particular word. All are received independently. That means receiving of B2 is not depending on B1. Receiving of B3 is not depending on B2 and B1 or B4, B5, B6, B7. All are independent to each other. So what is the probability such that whole symbol is corrected? That means none of the bit is in the error. All the 7 bits are received correctly. That probability would be 0.9 to the power 7. Now what will be the probability that one of the bit is in the error? What I need to find out? I need to find out that one of the bit is in error. This probability I need to find out. So I am having B1, B2, B3, B4, B5, B6, B7. So what I am assuming is that this is in the error and rest all are not in error. Okay, so if this is in the error, then its probability will be 0.1. What is the probability that B1 would be in error? That would be 0.1. And rest all are not in error. That means 0.9 to the power 6. But this you considered that B1 is in error. The similar scenario could happen with B2 as well. Or what may happen? The similar scenario that B2 is in error and rest all the 6 bits are not in error. Or the similar scenario could happen with B3 as well. Are you able to understand this point? So in the same way, the similar scenario could happen with all the 7 bits. What I mean to say is that it may happen that B1 is received in a wrong manner, all these 6 bits are received in good manner. So probability will be 0.1 into 0.9 to the power 6. Or it may happen that B2 is received in wrong manner, rest all are received in correct manner. Or it may happen that B3 is received in wrong manner, rest all 6 are received in correct manner. So it may happen with B1, B2, B3, B4, B5, B6, B7. That means it can happen with any of these one. So out of these 7, I need to choose one. That means there are 7 ways where 1 bit is in the error and 6 bits are not in the error. Have you studied binomial distribution in mathematics in probability chapter? So this is the same thing. Probability of success, probability of failure. So success you are getting only once, failure you are getting 0.9 times, failure you are getting 6 times. What is the success here? Getting the probability error, because success is x equals to 1. That means getting probability error, that is the success. Right? I hope you know what is binomial distribution. Even if you don't know the binomial distribution, still you are able to solve the problem with your basic aptitude. Right? Any of the bit could be in error, rest of the bits would be fine. So if they are fine, that means 0.9 to the power 6. If it is in the error, that means 0.1. Now it could happen with B1 or B2 or B3 or B4 or B5 or B6 or B7. That means it will be added 7 times. So what is the value of 7C1? That is 7 only. What is the value of 7C1? That is 7 only, right? Now what about probability such that 2 bits are in error? What is the probability such that 2 bits are in error? That means let's just say B1 and B2 are in error. B1 and B2 are in error, and rest all the 5 bits are not in error. Or it may happen that B2 B3, or it may happen B2 B3 B4, or it may happen B4 B5, or it may happen B5 B6, or it may happen B6 B7. Or what can happen? B1 B3, or what can happen? B1 B4, B1 B5, B1 B6, B1 B7, B2 B3, B2 B4, B2 B5, B2 B6, B2 B7, or B3 B4, B3 B5, B3 B6, B3 B7, or B4 B5, B4 B6, B4 B7, or B5 B6, B5 B7, or B6 B7. So all these scenarios can happen, right? 2 bits would be in error and rest of the bits will not be error. That means from 7 you need to choose 2. So what is the value of 7C2? That means there are total 21 ways. What all 21 ways are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah, total 21 ways are there. You need to choose, out of these 7, you need to choose 2 bits which would be in error. So 7C2, 2 bits would be in error and rest of the 5 bits will not be in error. So even if you don't understand binomial distribution, still you will be able to solve it. But if you understand binomial distribution, you will not have to do this analysis. Directly you will be writing down this expression. How did I write down this expression? Is that clear to you? Here I could have written no bit would be in error. So out of 7 I need to choose 0. So 7C0, that is 1 only. So let's not write down 7C0. So basically no bit is in the error. That means success, you are getting success chance 0 and you are getting failure 7 times. That means no bit is in the error, plus 1 bit in the error 7C1 0.1 0.9 to the power 6, 2 bit in the error 7C2 0.1 to the power 2 0.9 to the power 5. How did we get this expression? By the normal expression also I am teaching you, and by the binomial distribution as well you could have solved it. Is that clear to you or not? I hope it is clear. Binomial distribution we study in class 12th as well, right? All good, all fine. So you can solve this and you will get your answer. So this was the question based on probability of error, and it is important as well. It is important as well because these kind of questions recently they are not asking it. So I hope these kind of questions will be coming anytime soon. Okay, they have previously asked these kind of problems in GATE examination, but in future as well they can ask these kind of problems. So it is important. Okay, it is actually important. Now there is something called binary channel. It is very simple thing. Binary channel means two input, two output. Okay, what is the meaning of binary? Binary means 2. So 2 input would be there and 2 output would be there. So if symbols are 2, that means one symbol could be represented by 0 and other symbol could be represented by 1. They can have any probability of occurrence. Bit 0 is having probability of occurrence of px of 0 and bit 1 is having probability of occurrence of px of 1. Okay, so 2 input symbol and 2 output symbol. 2 input symbol and 2 output symbol. Okay, so this can be represented by 0 and this can be represented by 1, because 2 bits are there, no? So what I am saying, if I am transmitting 0 and I am receiving 0 only, I am transmitting 0, I may receive 1. I am transmitting 1, I may receive 0. I am transmitting 1, I may receive 1 only. So they can have any random probabilities. Okay. Let us say this probability is alpha. So what this probability will be? 1 minus alpha. Because if 0 is going to 0, having probability of alpha, then this can go as a probability of 1 minus alpha. If this is having probability of or let's write down, okay, whatever it is. If 1 is going to 1 with the probability of beta, then this can go. Usually, basically, what they write down, 1 minus beta here, they write down 1 minus alpha there, here they write down, and here they write down alpha. Here they write down alpha, and here this would be beta. So this is your binary channel. Here alpha beta could be different. Alpha beta may or may not be different. Is that clear to you? What is the meaning of binary channel? 2 input would be there, 2 output would be there. That's it. This is the meaning of binary channel. 2 input, 2 0. Other input would be shown by bit 1. One of the output would be shown by bit 0. One of the output would be shown by bit 1. Bit 0 is transmitted, bit 0 is received. Bit 0 is transmitted, bit 1 is received. Bit 1 is transmitted, bit 0 is received. Bit 1 is transmitted, bit 1 is received. What is the probability? Corresponding probabilities I have shown here. Corresponding conditional probability I have shown. Okay. Now, if these probabilities are equal, if alpha is equals to beta, then it is known as binary symmetric channel. What I am saying? From x0 to y0 you are going, from x0 to y1 you are going. Let's just say you are going from x0 to y0 with the probability of 1 by p. Sorry, with the probability of 1 minus p. That means probability of receiving y0 such that x0 is transmitted, that is 1 minus p. Then what will be the probability such that y1 is received given that x0 is transmitted? That would be p only, because addition of both of them should be equals to 1. Now, if this probability is p, then this has to be p. Then it will be known as binary symmetric channel. If this probability is p, then this is also p, then it will be known as binary symmetric channel. Now, you just let me know one thing, if this probability is p, then this has to be 1 minus p. Is that clear to you? Okay. So, so what it is saying, if I am saying that x0 is my bit 0, if I am saying this is my bit 0 and this is also my bit 0, if this is my bit 1, this is also my bit 1. So, probability of receiving bit 0 such that bit 0 is transmitted, that is 1 minus p, and probability of receiving bit 1 such that bit 1 is transmitted, that is equals to p. Now, probability of receiving bit 1, probability of receiving bit 1 such that 0 is transmitted, that is p, and probability of receiving bit 0 such that bit 1 is transmitted, that is also p. So, this is known as binary symmetric channel, and this p is known as error probability. What this p is known as? Error probability. Why error probability? Why this p is known as error probability? Can anyone tell? Because what this probability is showing? Probability of receiving bit 1 such that bit 0 is transmitted. That's why it is known as error probability. It is simply the name, nothing else. Okay. So, for binary symmetric channel, what you need to remember, that these crossover probabilities are equal. If they are equal, then surely they will also be equal. Okay. So, this is known as binary symmetric channel. Here kind of symmetry you can see, right? Well and good. So, this is the definition that I have written here. A binary symmetric channel is a discrete memoryless channel with binary input and a binary output. That means 2 input would be there, 2 output would be there, where each bit is transmitted correctly with probability 1 minus p. What is the meaning of transmitted with probability 1 minus p? That means if you are transmitting 0, received symbol is also 0, and if you are transmitting 1, received bit is also 1. That means this is the probability of correct transmission, that is 1 minus p, and this is known as probability of error. So, here probability of error is shown by p, that is like what they are saying, and received in error, that means flipped with the probability p. Flipped means 0 has been flipped to 1 and 1 has been flipped to 0. Okay. And the error probability is same for both of the symbols, making the channel symmetric. So, this probability is same for both of the symbols, making the channel symmetric. So, this is known as binary symmetric channel. Is that correct? All good? All fine? So, basically in the examination, they would be writing down binary symmetric channel. Along with that, they will make the diagram as well. So, don't take much pressure of this binary symmetric channel. Okay. Very simple thing it is. Basically, they will make the diagram as well. But in some PSU examination, what they can do, they can simply mention the value of p. So, you should be able to make the diagram on your own. But in GATE examination, they will make the full diagram. Don't worry about that. Now, what I am asking you to find out, I am asking you to find out conditional entropy. This entropy I am asking you to find out. Not this one. h of x by y, we will discuss it later on. We will surely discuss it, but we will discuss it later on. As of now, I am just asking you h of y by x. Can you do it on your own? Surely you can do it on your own. Here I am saying that probability of x naught transmission is alpha. So what will be your probability of x1 transmission? So that would be 1 minus alpha. This is what I am assuming. Okay, I can assume any value. You can directly put p of x0. You can directly put p of x1, but we are just assuming alpha and 1 minus alpha. So what I need to find out? H of y by x. A very interesting thing you will notice here that it will not depend on alpha. What is the formula of h of y by x? Joint log 2 conditional, right? Joint log 2 conditional. So alpha into 1 minus p log 2 conditional plus alpha into p joint log 2 conditional. Don't forget the negative sign. Negative sign is also going on. Now joint 1 minus alpha into p conditional log 2p, and then joint conditional. Okay, now what you can see, log 2p can come common, right? Sorry, log 2 1 minus p can come common. Log 2 1 minus p can come common. So minus sign is surely going outside. What I am doing, I am keeping this minus sign here. Okay, keeping this minus sign here. So log 2 1 minus p is coming common. What you can see, alpha minus alpha p plus 1 minus alpha p, sorry 1 plus alpha p minus alpha minus p, right? So what you can see here, this and this is getting cancelled, this and this is getting cancelled. You are only left with 1 minus p, and here what will be coming? Log 2p could be common, alpha p plus p minus alpha p, right? Log 2p I am taking common. So what you can see, 1 p minus alpha p minus alpha p plus alpha p. So this and this is getting cancelled out. So what you are getting? H of y by x. That is coming out to be minus sign was there. So minus sign I am taking here. So minus here p is left, log 2p minus 1 minus p log 2 1 minus p. This is your h of y by x that you are getting. Okay. So in the examination, in PSU examination, not in gate examination, in PSU examination, what they would do, they would simply mention the value of p. Let's just say p is given 0.4, and they will ask you what will be your h of y by x. So what you will do? Plus 0.6 log 2 0.6, because 1 minus p would be 0.6 only. So 0.4 log 2 0.4 plus 0.6 log 2 0.6, and then surely there will be a negative sign. So that would be the answer. Okay, so try remembering this formula if it is possible for you. P log 2p plus 1 minus p log 2 1 minus p, and surely there will be a negative sign outside. Okay, so try remembering it if it is possible for you. Okay, now let's see another thing. What we are doing, h of y by x, we got to know that it is not the function of input probabilities. Say yes or no. So no matter whatever the input probabilities are there, the conditional entropy is only the function of these probabilities. Conditional entropy is only the function of your conditional probabilities. Okay, no matter whatever the value of alpha 1 minus alpha is there. So your h of y by x, in a lot of textbook you would find out h of y by x would be written as h of p. That means it is eventually coming out to be a function of p only. That is minus p log 2p minus 1 minus p log 2 1 minus p. Now next question what I am asking is, you need to draw the graph of h of y by x with respect to p. Okay, what you need to draw? H of y by x with respect to p. And let's copy this diagram as well. Which diagram? Let's copy this diagram as well, because some intuition I will try to give you here. Okay, some good intuition I will try to give. Easily we can draw the diagram because this is a function which we can easily draw. H of y by x versus p you need to draw. This was your x naught, x1, y naught, y1. Okay, we will write down the probabilities, but what do you think? What will be the answer of h of y by x when p is tending to 0? H of y by x at p equals to 0. 0 into log to 0, that would be 0 only. 1 into log to 1, what that would be? 0 only. What will be the answer? 0. Again, let me repeat. I put p equals to 0 here. P equals to 0 I am putting. Okay. So 0 log to 0. What that would be? 0 log to 0. I told you, sir, it is not the indeterminate form, it is equals to 0 only. If I put 0 here, 1 log to 1. 1 log to 1. So this would be 0 only. So 0 minus 0, 0. So what you are getting? When p is equals to 0, then h of y by x when p is equals to 0 is equals to 0 only. Let's understand it with respect to the diagram. I am drawing the diagram with respect to p equals to 0. What does that mean? This probability will be 0, this probability will be 0, this probability will be 1, and this probability will be 1. That means these two lines are gone. Just let me copy it once. I will just copy it here. That means probability of receiving y naught such that x1 is transmitted, that is gone. Because these probabilities are 0, no? Right? So what does that mean? That means x naught is resulting in y naught and x1 is resulting in y1. So if I ask you for this particular case, what I am asking? For this particular case, I am asking you one thing, that what is the entropy in y such that x you already know. What is the uncertainty in y? X you already know. So if I know that, sir, x naught is being transmitted, I am 101% sure that y naught will be received. In this case, if x naught is transmitted, can you say what will be your output? You can say that, sir, it could be either y naught or y1. That means there is some non-zero entropy that is coming out to be this one. But in this case, when p is equals to 0, if I ask you, sir, if my transmitted symbol is x naught, then surely your received symbol will be y naught only. And if your transmitted symbol is x1, then surely your received symbol will be y1 only. So intuitively as well, just by looking at the diagram, you can say that h of y by x has to be 0. What if p is equals to 1? What if this p is equals to 1? If p is equals to 1, this will be gone. If p is equals to 1, then this will also be gone. If p is equals to 1, then only this will remain and only this will remain. That means if you transmit x naught, then y1 will be received, and if you transmit x1, then y naught will be received. So what will be the scenario? When your p is equals to 1, then what will be the scenario when your p is equals to 1? So the scenario will be that x naught will result in y1 and x1 will result in y naught with the probability of 1. Don't look at the formula, just look at the pure intuition. What do you think, what will be the value of h of y by x? Sir, that would also be equals to 0. Why is that so? Because if I am sending x naught, if I know the value of x, then I am 101% sure that, sir, it will result in y1 only. And if I know the value of x1, then I am 101% sure that, sir, it will result in y naught only. But if this was the case, then what you would say, sir, I don't know. Because if you know x naught, that if you know that I am transmitting x naught, then resultant could be either y naught or y1. But if this is the scenario, that if you are transmitting x naught, 101% your output would be only 1, that is y1. And if you are transmitting x1, that means output can only be 1, that is y naught. So what is the uncertainty in y? Given that you already know x, that is, that uncertainty is 0. So when p is equals to 1, at that time as well your entropy would be 0. What do you think when the entropy would be maximum? What do you think at what time the entropy would be maximum? When p is equals to 0.5. Why is that so? When p is equals to 0.5, why is that so? Why at that time your entropy would be maximum? When p is equals to 0.5. P is equals to 0.5. So 0.5 here and 0.5 here, then 0.5 here and 0.5 here. Right. So here if I ask you, sir, if I am transmitting X naught, where it will result in? Sir, you will say 50% chances are there that it will result in Y naught and 50% chances are there that, sir, it will result in Y1. Say yes or no. Again, let me repeat my statement. What I am saying, if I am transmitting X naught, what all are the chances that it will result in Y naught? And what all are the chances that it will result in Y1? That means here you are the maximum uncertain. Are you able to understand this point or not? H of Y by X. So you can put 0.5 here as well. What you will see? What is the answer you are getting? 0.5 log to 0.5 and the similar scenario would be there. So answer would be 1. So here the uncertainty would be 1. 1 bit of uncertainty would be there. 1 bit per symbol. This much uncertainty would be there. Why is that so? Because you know that this is the worst possible case. This is your worst possible case. When p is equals to 0.5, this is the worst possible case. Why it is the worst possible? Why it is the worst possible case? Because in this case you can see that from X naught, if I know that I am sending X naught, now what is the uncertainty of Y? You can say that, sir, 50% uncertainty is there in both of the, for Y naught and Y1, 50% chances are there. That means it is the most uncertain point. Forget about the formula. I don't want you to focus on formula. I want you to focus on the concept. Right? If I am just able to make this diagram, I would get to know that at 0.5 I am getting the maximum worst possible case. That means yes, the entropy, that means the uncertainty would be the maximum. So here uncertainty is maximum. Now if I ask you that I know the entropy at p equals to 0.3. So can you let me know what will be the entropy at p equals to 0.7? What I am saying, I know the entropy at p equals to 0.3. What will be the entropy at p equals to 0.7? Use your brain. Entropy at 0.3 I already know. What will be the entropy at p equals to 0.7? Both will be equal. Why so? Because what kind of diagram you will make? X naught, x1, x naught, x1, y naught, y1. Value of p is 0.3. That means this will be 0.7 and this will be 0.3. This will be 0.3. And next, this will be 0.3 and this will be 0.7. So in this case, whatever the uncertainty you are having, like basically if I transmit X naught, then I will ask you what you can receive. You can say, sir, more chances are there for Y naught, but Y1 can also come because 0.3%, 30% chances are there that Y1 can come and 70% chances are there that Y naught can come. But if P is equals to 0.7, then what will happen? They will interchange. This will become 0.3, this will become 0.7. They will simply interchange. This will become 0.7, this will become 0.3, 0.7, 0.3. Again, the scenario would be same only, no? You can see in the formula as well. 0.3 log 2.3, 0.7 log 2.7 or 0.7 log 2.7, 0.3 log 2, 0.3. That means at P and 1 minus P, the uncertainty would be same, and by the diagram as well it is completely clear. By this diagram only it is completely clear. If I am transmitting X naught and I ask you what will be received, then you will say that, sir, 1 minus P chances are there that Y naught will be received and P chances are there that Y1 will be received. And if I interchange it, then also there is no issue, no? So basically entropy at P and 1 minus P would be same. So what do you think, what kind of diagram you would be getting? This kind of diagram we get. Symmetric diagram, okay? So if I show symmetry here, if I say this point is some alpha, not alpha, let's call this point as gamma. If this probability is gamma, then what will be this probability? This probability will surely be 1 minus gamma, okay? Is this discussion clear to you? So whatever the intuition that I gave you here, that is more important, okay? Rest anything is not important, but whatever the intuition that we are getting here, that is important. Let me repeat what intuition we got. First we draw the diagram for p equals to 1. First we are drawing the diagram for p equals to 0. Then we are drawing for p equals to 1, and then we are drawing for p equals to 0.5. So when we draw for p equals to 0, we get to know that if I know x, then I surely know y. When I draw for p equals to 1, then also if I know x, I surely know y. But when I draw for p equals to 0.5, then this is the worst possible case, because here 50-50% chances are there that in both of the cases 50-50% chances are there. So this is the worst possible case that you are getting. That means h of y by x would be maximum here. Let's just remove it. Okay. So either you can put in the formula, you will get the same answer, or if you really need to learn communication, then this is how you will be learning it. Okay, is that clear? Right? And probability value cannot be greater than 1, so it would be, graph would be made between 0 to 1 only. After that, the graph will not be made. Is that fine? So this is the graph. In this lecture only we will study about mutual information, but I have to pause the video because slides have ended. Okay, I will add a new slide and then we will start studying about mutual information. Okay, this lecture is going to be very interesting. That is also very important point, mutual information. Usually people study it with respect to formula only, but you can see how much we are focusing on formula. Rather than focusing on formula, we are focusing more on the intuition. Okay, because information theory is purely intuition. It's not formula based. Needlessly we think that information theory is formula based. No. Okay, it is not formula based. So yeah, I will add up the slide and then I will continue. So I will have to pause the video for a while now. Okay, so I will pause the video and I will come back. We will start studying about information theory. Yeah, thank you. Hi everyone, welcome back. So we have been studying about information theory. In the last lecture we studied about entropy. First we studied about entropy of your source X. Then we studied about joint entropy. Then we studied about conditional entropy. We also studied about probability of error in channel. We also see how to represent the channel. Some basics of probability also we saw there. And then we studied about binary symmetric channel as well, which is a specific type of channel. So all these things we have seen in the last lecture. Now we are going to study about mutual information. So we will do this discussion. We will understand the meaning of mutual information. But before that, there is some discussion that I want to do. A very simple discussion. Mostly you know everything about this particular discussion. So what I am saying, there is a channel from the transmitter side. Symbol X has been transmitted and symbol Y has been received. Okay, transmitted symbol, received symbol. Okay, so this symbol X was having uncertainty of h of x. Right now, what is the meaning of h x by y? That means uncertainty in x such that I know y, that is equals to 0. Uncertainty in x such that I know y is equals to 0. Or what I can say, if I look at y, then I know everything about x. What I am saying, h of x by y is equals to 0. That means uncertainty in x is 0, given that I already know y. What could be the other way of saying it? That sir, if I observe y, if I look at y, then I would be able to know everything about x. Then only the uncertainty about x would be 0, no? What is the meaning of uncertainty? Uncertainty means not knowing something. If you know everything, if you know everything, what does that mean? That means there is no uncertainty, right? So if I am saying that there is no uncertainty in x, given that I know y, so if I look at y, I can comment on everything about x. This is the meaning of h of x by y is equals to 0. If I know y, I can comment everything about x. So isn't it showing the ideal transmission? Basically, what is the meaning of transmission? The meaning of what is the meaning of transmission? The meaning of transmission is that looking at the output, you should be able to tell everything about the input. Say yes or no. Isn't it talking about the ideal transmission? Isn't it ideal transmission? Why it is ideal transmission? Because here in this case, if I look at the input, if I look at the output, then I can tell everything about the input. So isn't it the case of ideal transmission? So h of x by y equals to 0 simply shows ideal transmission. Is that clear to you what I am saying? Again, let me repeat. H of x by y is uncertainty in x such that I know y. So looking at y, there is no uncertainty left in x. That means looking at y, I can comment everything about x. That means my h of x by y is equals to 0. And that shows the ideal transmission. So this is what I have written. If I know y, I can comment everything about x. If I know y, then I can comment everything about x. This is the meaning of h of x by y equals to 0. Second statement is, I say x and y are independent to each other. Independent to each other. What does that mean? That means that h of x by y, x and y are independent to each other. That means if I look at y, I cannot tell anything about x. They are independent of each other, no? Like there is no relation between y and x. What is the meaning of independent of each other? I and Ramesh are independent of each other. That means there is no relation between me and Ramesh. We don't know each other. We are independent of each other. So x and y are independent of each other. So when you looked at y, you asked him, what do you know about x? He said, I don't know anything. So looking at y, you cannot comment anything about x. Looking at y, you cannot comment anything about x. That means if I look at y, how much uncertainty is left in x? That would be equals to h of x only. If x and y are independent of each other, if I look at y, then how much uncertainty left in x? What is the meaning of this one? If you already know y, how much uncertainty is left in x? Sir, h of x is left. Complete uncertainty is left because I don't know anything about x. So if x and y are independent of each other, then h of x by y would be equals to h of x. Along with that, x and y are independent of each other. So uncertainty in y such that you know x. So if you know x, what will be the uncertainty in y? Sir, it would be equals to h of y. Because they are independent of each other. No, they don't know anything about each other. So if you go to x, you will say that, sir, I know everything about x. Now what I can comment about y? You can say you cannot comment anything about y. Because they both are independent of each other. So if you know x, you cannot comment anything about y. So basically someone says that, sir, I know analog electronics. Okay. So how much you know communication? Both are independent of each other. Both subjects are independent of each other. So you know analog electronics doesn't mean you know anything about communication. And if you know communication doesn't mean you know anything about analog electronics. It is simply an example, okay? Don't make any conclusion out of it. I am just giving an example. Is that clear to you? Or better example could be, here I could have put economics. Let us say someone says that, sir, I know economics. So how much communication system I know? So both are independent of each other. Economics and communication both are independent of each other. So if you know economics, that doesn't mean you know anything about communication. If you know communication, that doesn't mean you know anything about economics. So if x and y are independent of each other, that means this is the worst transmission, worst case transmission. Say yes or no. Basically, you transmitted x, then you went to y. You transmitted x, you received y. You went to y and you asked him, what do you know about x? Y said, I don't know anything about x. That means now you cannot even comment what was transmitted. What is the meaning of communication system? Like whatever that I am saying, that should reach to you. Whatever the statement that I am saying, that should reach to you. This is the meaning of communication system, no? Now let's just say I am saying something and nothing is reaching to you. That means what kind of transmission it is? Worst possible transmission it is, right? You are not getting, you are not understanding anything, you are not even listening to my voice. So whatever that I am transmitting, nothing is reaching to you. That means that is the worst case transmission. And what is the best case transmission? That, sir, whatever that you are saying, I am able to understand everything. That is the best case transmission. Is that clear to you? So if x and y are independent of each other, then you don't want it. But if your h of x by y equals to 0, that means uncertainty in x, given that you already know y, that is equals to 0. That means this is the best possible transmission. Ideal transmission it is. Is that clear to you? Now let's understand about mutual information. So first I will write down the formula of mutual information, then I will tell you the meaning of mutual information. Okay, first I will write down the formula. So again, my transmitted symbol is x, received symbol is y. Mutual information between symbol x and y is given by I x semicolon y. Okay, mutual information between x and y, x semicolon y. Okay, that is written by h of x minus h of x by y. This is the formula of mutual information. Sir, what it is representing, that we will see. But first, let me know one thing. If x and y are independent of each other, I am writing independent of each other. If x and y are independent of each other, then what will be the value of mutual information? If x and y are independent of each other, then h of x by y would be equals to h of x only, right? So h of x minus h of x, what that would be equals to? That would be equals to 0. So if x and y are independent of each other, then mutual information is coming out to be 0. And if I say h of x by y is equals to 0, then what will be your mutual information? Then mutual information will be equals to h of x. So what do you think now? What mutual information is representing? What is the meaning of mutual information? What do you think? Mutual information is the information that is carried by the channel. Mutual information is the information that is carried by the channel. How is that so? Sir, I was standing at y. Okay, I was standing at y. I asked y, what do you know about x? He said, I don't know anything. That means x and y are independent of each other. So mutual information came out to be 0. That means how much information this channel carried? Here this x was having uncertainty of h of x. So this x was having some information. Let's just say h of x was 2 bits per symbol. That means this source x was having information of 2 bits per symbol. What was the job of this channel? The job of this channel was to transmit this 2 bits per symbol information to the receiver y. When I went to y, I asked, what do you know about x? He said, I don't know anything about x. So how much uncertainty is left in x? I'm not talking about uncertainty of y. Forget about uncertainty of y. I'm only talking about uncertainty of x. So previously you did not know anything about x. When you went to y, again you don't know anything about x. Because x and y are independent of each other. If x and y are independent of each other, that means here as well you don't know anything about x. That means uncertainty in x, given that I already know y, that is equals to h of x. So h of x minus h of x, that is equals to 0. That means your mutual information is 0. What does that mean? That means this channel actually carried 0 information. 0 information about x. I don't know what this channel carried, but when from the transmitter, when I stand at receiver, I don't get to know anything about x. So isn't it the case of when x and y are independent of each other, I said that it is the worst possible transmission. Here also we are able to verify that my mutual information is coming out to be 0. If my mutual information is coming out to be 0, what does that mean? That means this channel is carrying 0 information. Is that clear to you? Now what is the meaning of h of x by y is equals to 0? That means when I looked at y, I know everything about x. When I looked at y, I know everything about x. That means now how much uncertainty is left in x such that I know y. Arey yaar. How much uncertainty is left in x such that I know y? So that is 0. When I looked at y, I know everything about x. That means uncertainty left in x such that I know y, that is equals to 0. If h of x by y is equals to 0, then mutual information is coming out to be h of x. That means this channel carried information equals to h of x. So this is representing, mutual information is representing the information that this channel is carrying. So this channel is carrying information equals to h of x. Is that clear to you or not? Let me give you one more practical example. Let's just say this is my class. Before attending this class, you had uncertainty about information theory. Okay, or let's talk about analog circuits. So before attending my class, you had this much doubts. You had 10 doubts. Before attending my class, you had 10 doubts. Okay, you had 10 doubts. Before attending my class, this much uncertainty you were having. Now you attended my class and you went out of my class. Now if I ask you how many doubts you are having, you say, sir, I am having 10 doubts only. That means how much information did you get through my class? 0 information. So here my uncertainty was h of x. Your uncertainty after attending the class, your uncertainty after attending the class, that is equals to h of x only. That means the information that you get in my class is 0. Uncertainty about the doubts, given that you have attended the class, given that you have received the output y. So that output was no good for x. You couldn't clear any of the doubt. If you couldn't clear any of the doubt, that means the information carried through my class was 0. Now if I ask you how many doubts you are having, you said that sir I am having 0 doubts. What is the meaning of 0 doubt? That means all the 10 doubts are cleared. So how much information my class carried? Sir, 10 doubts information your class carried. And now if I ask you how much uncertainty about x you are having after attending my class, you will say sir 0 uncertainty I am having. So if your h of x by y is equals to 0, then your mutual information is coming out to be h of x. This h of x is representing that this channel is carrying h of x amount of information. Is that clear to you? Is the meaning of mutual information clear to you or not? We will not simply mug up the formula. You can watch any of the lecture. They will simply write down the mutual information formula and job is done. Okay, if you just understand by formula, then this platform is not for you. Here I am here to tell you the meaning of each term. So what is the meaning of mutual information? Mutual information between x and y. So looking at y, if I know everything about x, that means my channel has carried h of x information. And looking at y, if I cannot comment anything about x, that means my channel has carried no information. Is that clear to you or not? Okay, so that thing we have written. So let's remove everything that we have written roughly. Everything would be written here, don't worry about that. Okay, notes and everything would be absolutely clear. Let's see another formula. What I mean to say is that just pure mathematics we are going to see. What is h of x comma y? So that is equals to uncertainty in x plus uncertainty in y given x, h of y, h of x given y, right? So let's just remove it. So I already know that both are equal to each other. Now what I can do, I can take this one here. So what I will get, h of x minus h of x by y would be equals to h of y minus h of y by x, right? Is that clear to you? H of x minus h of x by y equals to h of y minus h of y by x. So this could be equals to h of y minus h of y by x. Is that fine? Okay. So meaning we have understood by this formula, but for the mathematics we can use this particular formula. For maths, sir, why you are saying that for maths you will use this formula? Because calculating this particular thing is easier than calculating this particular thing. So this particular thing will be very easily calculated. So if I am able to calculate this particular thing and then this particular thing, I will be able to get the meaning. I will be able to get the expression of mutual information between x and y. Okay. So for maths we can use this particular formula, but actual understanding we are getting from this formula only. So mutual information between x and y is given by h of x minus h of x by y or h of y minus h of y by x. Is that clear to you? Okay. And what mutual information actually represent? So here is the theory written. What mutual information actually represents. So mutual information tells us how much information the channel output y gives about the source input x. How much information channel output y is giving about the source x. In simple words, how much you learn about x by observing y. How much you learn about x by observing y. If the mutual information is high, that means if your mutual information is high, as if your I of x comma y is equals to, what will be the maximum value of this one? What could be the maximum value of this particular thing? Highest possible value. Sir, if this is 0, because this cannot be negative. If h of x by y is negative, then positive minus sign, that could become more value. But sir, what could be the minimum value of this one? So that would be 0. So I of x comma y could be equals to h of x. This is the maximum we can get, or we can say that maximum of h of x. So although let's not write it down here, but what they are saying that if mutual information is high, that means receiver learns a lot about X, or receiver learns a lot what was sent, X was sent. So if mutual information is high, that means you are learning a lot of things about X. But if it is 0, that means output is not learning anything about the input. Is that clear to you? So all this information, the meaning of mutual information, I have already explained. I hope that is clear to you. So this is the formula that should be there in your mind. For problem solving, this formula will be used, but to learn the concept, we have understood other things as well. Is that clear to you or not? So h of x minus h of x by y. So that is the meaning of mutual information. Now whatever that we have understood, if x and y are independent of each other, what does that mean? That these guys are equal and these guys are also equal, right? Then what will happen? This particular thing is equals to h of x minus h of x by y. That would be equals to h of x minus h of x. What that would be equals to? That would be equals to 0. So this has been written here. If by observing y we get no information about x, because x and y are independent of each other, that means by observing y we get no information about x. It means that uncertainty of x even after knowing y remains the same as before. Hence the channel carries no information and the mutual information between x and y is 0. And now if your h of x by y is equals to 0, then that would be equals to h of x or h of y minus h of y by x. You have commented about h of x by y. You did not comment anything about h of y by x. So this remains as it is. Is that clear to you? This remains as it is. You did not comment anything about h of y by x. You are only commenting about h of x by y. So if h of x by y is 0, then what it is showing? The uncertainty of x given y is 0. The uncertainty of x given y is 0. It means that knowing y completely determines x. In this case, there is no remaining uncertainty in x, and the channel conveys full information about x through y. Is that clear to you? So basically what this is representing, that sir, I am commenting about h of x by y that is equals to 0, but h of y by x, I don't comment anything about it. It could be 0, it could be non-zero. What does that mean? That means, sir, if you are transmitting x, then you will receive y. Okay, you are transmitting x, you will receive y. So looking at this y, you can comment anything about x. But sir, what if you transmit y? Basically, whatever that I have received here, I transmit it through the same channel. And I am expecting that, sir, I will be receiving x. So that is not possible. If you are saying that h of y by x is non-zero, that means whatever that you have received, if you transmit that particular symbol, whatever that you have received, if you transmit that particular symbol through the same channel, then whatever the received symbol you will get, that will not be equals to x. Or if that is equals to x, then this x will not be able to comment on y completely. Is that clear to you? So basically it is not the reversible process. This is what I am saying. But if I am saying that h of x by y and h of y by x both are equals to 0, that means that is the reversible process. I will transmit x, I will receive y. I will transmit y, I will receive x. Is that clear to you? Okay. But here in this example, what we have taken, that x is the transmitted symbol, y is the received symbol. We have written down this formula. We got to know that this formula is equals to this one as well. So what this one is representing? This simply is representing that my transmitted symbol is y and my received symbol is x. This formula, what this formula is representing? That my transmitted symbol is y and my received symbol is x. But what will actually happen in the examination? In the examination, they will not say what is transmitted, what is received. X and y are there. So ideally, if in the examination they are saying that x is transmitted and y is received, we should apply this formula. But I know that this particular formula is equals to this one. So I will take the example of this, I will take the advantage of this particular thing. I will take the advantage because this is easy to calculate. Then I will calculate this particular thing and I will say that this particular thing is equals to this particular thing. So my mutual information has been calculated. Is that clear to you? Okay. So I am only commenting about h of x by y. If I am not commenting about h of y by x, that means I can take that equals to 0 or non-zero, whatever it is, I don't care. So if h of x by y is equals to 0, then my mutual information will be equals to h of x. That means this much information your channel is carrying. But you cannot comment anything about y. So this is simply representing that if I transmit y, then my channel will carry information equals to h of y minus h of y by x. It will not carry information equals to h of y, because x and y are different symbols. So if you are transmitting y, then your channel might not be able to eradicate this particular thing, h of y by x. Is that clear to you? So ideally what I should receive? H of x, and if I transmit y, ideally this channel should carry h of y information, right? If I am transmitting y, this channel should carry h of y information. If this channel is able to carry h of y information, that means my uncertainty of y looking at the output z, that would be equals to 0. So ideally it should carry h of y information, but who knows if it is carrying h of y information or h of y minus h of y by x information. Is that clear to you? So can you just simply tell me one thing, what this term is representing, or what this particular term is representing? If your input is having uncertainty of h of x, if your input is having uncertainty of h of y, then ideally your channel should carry this much information. Ideally your channel should carry this much information. Basically, if you are coming to my class, no matter if you are coming with a doubt of digital electronics or you are coming with a doubt of electronic devices, ideally all the doubts should be cleared. That means when you leave my class, the doubts that you are having, that should be 0, whether it is about digital electronics or it is about EDC, right? But what happened really was that when you left my class, you are having 2 doubts of digital electronics but 0 doubt of EDC. What does that mean? That means there is some noise present in my class, no? So isn't it representing noise? If my transmitted symbol was y, my channel should have carried h of y information, but actually it is carrying this much information, which is lesser than h of y. Let's just say h of y is 2 bits per symbol, and h of y by x is 0.2 bits per symbol. Bits per symbol. That means your channel is carrying 1.8 bits per symbol. This much information it is carrying. It was supposed to carry 2 bits per symbol information, but now it is carrying 1.8 bits per symbol information. That means 0.2 bits per symbol information has been lost in the channel because of the noise. So this particular term h of x by y and h of y by x is actually representing the noise. Is that clear to you? Okay. So h of x by y and h of y by x actually represent the noise. I hope everything you are able to understand. If you want to write down anything in a rough way, then all these space are for you. You can write down anything that you want to in rough way. You can write down this analogy as well, that 10 doubts of digital electronics and 10 doubts of EDC. Then here you are having 2 doubts of digital electronics, and here you are having 0 doubt of EDC. So with respect to EDC, there is no noise in my class. But with respect to digital electronics, there is a noise of 2 bits in my class. Sorry, yeah. There is a noise of 2 bits in my class, because eventually you are having 2 doubts as well. That means how many doubts got cleared here? 8 doubts got cleared here. And how many doubts got cleared here? 10 doubts got cleared here. Right? So here my class carried the information of 8 doubts, and in this case my class carried the information of 10 doubts. So 2 doubts were lost in the noise, right? Or it might happen that I was not a good teacher, right? So not being a good teacher, that means that is a noise only, right? If I am not able to clear all your 10 doubts, that means for 2 doubts I was not a good teacher, right? So that was the noise present in me. A similar thing is there with respect to the channel as well. I hope now you are enjoying information theory, which felt like mathematics, but now it is feeling like communication system. I hope you are enjoying it now. Let's see the mathematical formula. This is the mathematical formula which we are never going to use. Okay, so just for the sake of writing down in your textbook, you can write it down. I also don't remember this formula. If you want to remember it, you can remember it. But what we are going to use, if I need to calculate the mutual information, I will use this formula, or I will use this formula. Is that clear to you? Okay, so just for the sake of writing it down, you can write it down, but eventually we are never going to use it. Is that clear to you? Okay. So let's solve the problem that was asked in GATE 2025 examination. A lot of people solved this problem wrong. Like someone was saying 0.004 would be the answer, someone was saying something. Answer would be 0 only. So let's solve this problem. It is very simple question, very straightforward. Mutual information you need to calculate. Okay. X and Y are Bernoulli random variable taking 2 values 0 and 1. Joint probabilities are shown, and you need to calculate the mutual information. So what will be your mutual information? Sir, I know 2 formulas, h of x minus h of x by y, or sir, other formula could be h of y minus h of y by x. Sir, what I would go for? Surely I would go for this particular formula. Sir, first I need to know what is my h of y. For h of y, what you need to know? You need to know receiving symbols, probability of a received symbol. That means you need to know what is the probability that such that you are receiving symbol y equals to 0 and what is the probability such that you are receiving symbol y equals to 1. So what do you think? Can you calculate this particular thing? Probability of receiving y equals to 0. So y equals to 0 being received, x equals to 0 being transmitted, y equals to 0 being received, x equals to 1 being transmitted. So 0.06 plus 0.24, that would be equals to 0.3. So that is the probability of receiving y. Are you able to understand it or not? Like, this is very simple thing. Probability of receiving y, that would be equals to probability of transmitting 0 and receiving y, or probability of transmitting 1 and receiving y equals to 0. So probability of x equals to 0, y equals to 0, 0.06. X equals to 1, y equals to 0, 0.24. What that would be? 0.3. And probability of receiving y equals to 1, what that would be? Just add both of them, that would be equals to 0.7. So what would be your h of y? So h of y would be 0.3 log to 0.3 plus 0.7 log to 0.7. I have forgot the negative sign, which I again and again forget. Okay. Now one very important tip I am going to give you for problem solving. Okay. For the problem solving of information theory, never ever put the value in between. Never ever put the log value in between. What I mean to say is that you have calculated h of y. Now you know that I need to calculate h of y by x as well. So here I will never calculate h of y. What I would do, I would calculate h of y by x. I would be having the expression of h of y by x. I would be having the expression of h of y as well. And then I will put the values. Is that clear to you? Okay. Here I am not going to calculate h of y. Is that clear to you or not? Okay. Are you able to understand this point? So first I am going to calculate h of y. I am not calculating the final value. I know that this, whatever the value this can come, that would be bits per symbol. That would be some bits per symbol. That's it. I am not calculating the final value. Now I will calculate h of y by x. H of y by x. This is something that I need to calculate. Now I know that how to calculate this particular thing. So there is something interesting in this formula. So that thing is log 2. Here I will have probability of yj by xi. But sir, here probability of xi yj would come. Okay, ij. Is that clear to you? So this thing I already know, but I don't know this particular thing. What I need to calculate? Probability of y1 by x1, probability of y2 by x1. So all these things I need to calculate. Basically, I need to calculate this particular thing. And I need to calculate this particular thing as well. All these things I need to calculate, right? So what do I know? This y by x would be equals to x comma y divided by probability of x. So basically I would be requiring the probability of x as well. So first thing is that I would require the probability of transmitting x equals to 0. So what will be the probability of transmission of x equals to 0? So that would be x equals to 0 being transmitted, y equals to 0 being received, y equals to 1 being received. That means both will be added. I hope looking at this particular expression you can tell what will be the probability of x equals to 0 transmission. Just add both of them. What you will be getting? So 0.2, and here I will be getting 0.8. So now I know this particular thing as well. So what I need to calculate? X equals to 0, y equals to 0. X equals to 0, y equals to 0. So x equals to 0, y equals to 0, that would be 0.06 divided by probability of x equals to 0, that would be 0.2. So what would be the answer? 6 by 20. So 0.3. Right? Okay. So y equals to 1, x equals to 0, y equals to 1, x equals to 0, that would be 0.14 divided by, if you are using your pen, then only you will be able to solve it. Okay, don't feel like that, sir, I am just watchwatching you, you are just solving it, and sir, I am just sitting on my table and watching you. Don't do that. Okay, you solve it on your own. Divided by 0.2, that would be equals to 0.7. Here you would see y equals to, although this problem will be solved in a very quicker manner. When we study the types of channel, there will be a topic called types of channel. So then you will be able to solve it in a very quicker manner. I will simply tell you a channel called a useless channel. So when you are calculating these values, no, you will understand that it is a useless channel. Okay, useless channel means your information will be 0. So answer would be 0 only. Although here I need to apply the formula. So basically I want you to apply the formula, because if I had already taught you that what is the meaning of useless channel, then you would never apply the formula, you would never do the mathematics. But if you need to crack the competitive examination, then you need to do the mathematics as well. Not in the industry, when you go to the industry, their mathematics will not be used, but if you need to crack a competitive examination, mathematics is required. So that's why I am building up the practice. So x equals to 1, y equals to 0, that would be 0.24 divided by probability of x equals to 1, that is 0.8. So that would be 0.3, and y equals to 1, x equals to 1. It would come out to be 0.7 only, I can already tell you. But let's check that. 0.56 divided by 0.8. That would be 0.7. Okay. So these values I have calculated. Let's write down your h of y by x. This is also not a good way of solving it. What I could have done, look, I need to calculate this particular thing, no? From these values, I could have easily calculated the value of h of x by x comma y. Basically, there could be another way of another formula could be there, no? What do I know? I know that h of x comma y is equals to h of x plus h of y by x, right? So what I can do, if I don't want to calculate this particular thing, from here what I can see, sir, h of x comma y is minus h of x is equals to h of y by x. So now you can replace this formula here. So what you are getting? What you need? You need the value of minus h of y by x. So from here, if I put this formula here, h of y minus of this value. So what you are getting? H of x plus h of y minus h of x comma y. So another formula you are getting from here, right? Although you don't need to mug up anything, only you need to remember is this particular thing. And how would you remember? Very simple thing, uncertainty in x minus uncertainty in x given that I already know y. So from there you can derive this one, and now you already know this particular thing, then you can derive this one. So here, if I already know the probability of x equals to 0 and this particular thing I already know, so I could have easily calculated h of x. So let's not go by this formula. What I could have done, I could have easily calculated h of x here. What that would have been? So both of the methods we can do actually. So what we should do, if I have already written down this particular thing, so let's first calculate h of y by x only. So what would be my h of y by x now? So h of y by x would be joint probability log to conditional probability. So joint probability is 0.3. Minus sign will surely be outside. So 0.3 log to conditional probability. What is the conditional probability? 0.06 plus joint probability 0.7 log to conditional probability y equals to 1, 0.14 plus अरे यार उल्टा लिख दिया, 0.3 would come here and 0.06 would come here. Inside the log there will be larger value, no? 0.14 would be here and 0.7 here. Joint would be outside, 0.06, 0.14, then 0.24 log 2, inside what would be there? 0.3, right? 0.24, 0.3 plus 0.56 log 2, inside what would be there? 0.56 outside and log 2 inside 0.7 would be there. Okay, so if you see log 2 0.7 and log 2 0.7, what you can see, what you are getting? Minus sign. Log 2 0.3 and log 2 0.3. So what you can see here, this is coming out to be 0.3 log 2 0.3 plus 0.14 0.56, that is coming out to be 0.7 log 2 0.7. So this is your h of y by x, and you can notice that it is actually coming out to be h of y only. 0.3 log 2 0.3, 0.7 log 2 0.7, 0.3 log 2 0.3, 0.7 log 2 0.7, then there is a minus sign, that is coming out to be h of y only. That means the mutual information would be equals to 0, right? Or what could be the other way, that I would have calculated h of x. H of x would have been what? minus sign would already be there, log to 0.2 plus this is method 2 we are going with, plus 0.8 log to 0.8. This is your h of x. Another page I need to add now. Then what would be your h of x comma y? Simply mathematics it is, right? Nothing else. So at 0.06, 0.14, 0.24, 0.56. So basically 0.06 log to 0.06 plus 0.14 log to 0.14, 0.24 log to 0.24 plus 0.56 log to 0.56. Then I know that what is the formula of mutual information. So that came out to be h of x plus h of y minus h of x comma y. So h of x plus h of y minus h of x comma y. So let's put the value. So the value of h of x is minus 0.2 log 2.2 minus 0.8 log 2.8. What is the value of h of y? So h of y is coming out to be this one, minus 0.3 log 2.3 minus 0.7 log 2.7, and then this minus sign is there, so plus 0.06 log 2 0.06 plus, basically this minus sign and minus sign has become plus, that's why I am putting plus, 0.14 log 2 0.14 plus 0.24 log 2 0.24 plus 0.56 log 2 0.56. But again, if you put the values here, you might not get the value equals to 0, right? Because a lot of calculation is there and we are not able to cut down the values. Are we able to cut down the values? Can we cut down the values anywhere? Yeah, so no, not a good way, right? By solving this, I got to know that it is not a good way of solving it, because h of x, h of y, all these values you have put. Now you will calculate this particular value, all these values you will calculate, and it might happen that because of the log, like basically you will take the approximation, no, log to 0.2, you will take the approximation. So in those approximations, you might get some non-zero value. So even if someone has written down this answer 0.01, let's just say this answer was wrong, IITs gave 0.00 only. That's the answer. Okay, that's it. No lower limit, higher limit, only this is the answer, that's it. Right? So again, not a good way of solving it. I think that a lot of people, when this question came, a lot of educators solved in this manner. So when they solved in this manner, they were getting some non-zero answer. I saw the solution. But when I solved it, I actually solved in this manner only. Just when I was solving it, I thought that it could be solved in this manner as well. So now when I am solving in this manner, I get to know that we are not able to cut anything here, right? Cut means like some expression are getting cancelled out. That is not happening. Or is it happening? It is not happening, right? So expressions are not actually getting cancelled out, right? So if they are not getting cancelled out, then that's an issue. How we will cancel out all these things? So this is not a good way of solving it, right? Other way would be that we will make this matrix P of y by x. So here what I will write down, x equals to 0, x equals to 1, then I will make the matrix y equals to 0, y equals to 1. Okay, so x equals to 0, y equals to 0, this is 0.3, x equals to 0, y equals to 1, that is 0.7, right? And this will also be 0.3, this would also be 0.7, y equals to 0, x equals to 1. So 0.3, 0.7, 0.3, 0.7. So in this joint matrix, if your rows are same, for P of y by x, if your rows are same, then this is a useless channel. And for useless channel, you can see by the name as well, channel is useless. If it is useless, that means it is not carrying any information. So for useless channel, for joint matrix, rows will be same, but if I am calculating P of y by x, if you calculate P of x by y, then your columns will be same. We will understand about it, okay? So for this one, what you can do, you can calculate value of P of x by y, and then you can make this matrix. You would realize that columns are same. Sir, why this happens, everything we will see. Okay, so just by looking at the matrix, you would be able to know that it is a useless channel, and useless channel means your information would be, your mutual information would be 0. So without even solving anything, I would have directly told that answer would be 0.00. Is that clear? Okay. So that we will study. We did not study the types of channel. There would be useless channel, there would be deterministic channel, noiseless channel, lossless channel. So what all are the property of each channel? So this question was framed on that property only, basically. Okay. And here also you can notice one thing, that probability of y by x in this particular problem, what you can see, probability of y by x is actually coming out to be probability of y only. Probability of y equals to 0 divided by x equals to 0 is equals to probability of y equals to 0. Isn't it probability of y equals to 0? Yes, sir. Probability of y equals to 0 is 0.3. Y equals to 1 divided by x equals to 0. It is equals to probability of y equals to 1. Probability of y equals to 1. This is equals to probability of y equals to 0, and this is equals to probability of y equals to 1. That means P of y by x is actually coming out to be P of y. That means it is a useless channel. And you can see that probability of x equals to 0 divided by y equals to 0 would come out to be probability of x equals to 0. Basically, if I want to find out this particular thing, it would actually come out to be probability of x equals to 0, which is equals to 0.2. So this would come out to be 0.2 only. You can check that. Okay. So yeah. So this problem was framed intelligently. This was of 2 marks question. So it was framed intelligently. Like if someone is making this matrix directly, then he would know that it is a useless channel, and directly he would put the answer to be 0. Otherwise, if someone is stuck in this problem solving, then it would be problem for him, right? So even if I had started my problem from here, and just as I see this particular expression, I will stop here, because I know that this calculation is pretty bad. So I will drop it instantaneously, and then I will move to this particular analysis. Or better, if I am able to see this particular thing. Basically, if I am moving to this analysis, then I would be able to see these values, no? 0.3, 0.3. So I would understand that there is some symmetry for sure. So directly I will make this matrix, and I would have understood the property already that this would be a useless channel. If it is a useless channel, my answer would be done. Okay. Let's go to the next topic, that is known as channel capacity. So forget about electronics now. Like if I say what is the meaning of capacity. So whenever you talk about capacity, let's just say I say that one of my senior has a capacity of drinking 1 liter of, water, okay, nothing else, water. So one of your senior is having a capacity of drinking 1 liter of water. What does that mean? That means maximum he can drink 1 liter of water, maximum. Capacity means always maximum. So maximum your senior can drink 1 liter of water. So whenever you talk about capacity, you talk about maximum. So what would be your capacity of a channel? What do you mean by channel capacity? That means the maximum information the channel can carry. The maximum information the channel can carry. So channel capacity is the maximum information your channel can carry per second or per symbol as well. So anything could be the unit. Unit could be per second as well, unit could be per symbol as well. Mostly we would see that unit would be per second only. Channel capacity unit would be per second only. So whatever that has been mentioned in the options, that we will take. So unit of channel capacity could be bits per second or bits per symbol as well. So let me write down what would be your channel capacity. So how much information your channel can carry? Sir, information my channel can carry would be equals to mutual information. So that is equals to this particular thing, or that is equals to this particular thing. So this is my mutual information. That means this is the information that channel carry. But what I need to find out? I need to find out the capacity. Basically, let's just say today I am drinking 0.5 liter of water. Today I am drinking 0.5 liter of water, but my capacity is 1 liter. This is the capacity. Capacity is maximum I can drink 1 liter of water, but it is not necessary that always I will be drinking 1 liter of water. Someday I can drink 0.5 liter of water. So capacity tells maximum how much information you can send. It might happen that sometimes we are not able to send, sometimes we are not able to drink this much of water. We can drink lesser than that. So capacity is simply telling the maximum value. It doesn't mean that capacity is telling that this much information is being passed. No, capacity is telling that how much information it can actually pass. What this tells? That this much information is getting passed if my transmitted symbol is x and received symbol is y, or if my transmitted symbol is y and received symbol is x. So this is the actual information that is being passed. But what is the maximum information that your channel can pass? That would be given by maximum of this particular thing. Say yes or no. Is that clear or not? So I will calculate a maximum, I will calculate this particular thing and then I will maximize it. Okay. So what kind of questions can be asked from the channel capacity? So this is the channel capacity of a discrete random variable. Everything we are studying about discrete random variable. Till this point we did not introduce continuous random variable at all. Okay. So all the discussion from the last 5 hours, whatever the discussion that we have done, everything was going on discrete random variable, right? So channel capacity for discrete random variable is given by this one, that you need to find out the maximum value of a mutual information. It could be in bits per symbol, it could be in bits per second as well. As of now, for this particular expression, what will be the unit? What do you think? What is the unit of h of y? Bits per symbol. Bits per symbol. What is the unit of entropy? Bits per symbol. So bits per symbol minus bits per symbol. The unit will be bits per symbol only. So here the unit is bits per symbol. Bits per symbol. But if I multiply this bits per symbol with something called symbols per second, if I multiply this bits per symbol with something called symbols per second, then what will be the unit? Bits per second. And what is this symbol per second? Sampling frequency. What is the unit of sampling frequency? What is the meaning of sampling frequency? That this much samples are being passed per second. Sampling frequency. What is the meaning of frequency? Per second. Sampling frequency means this much samples, and here I told you in this lecture, in this particular chapter, sample and symbol both are the same thing. So this much samples or this much symbols are being passed per second. So in the examination, if my unit is given in bits per second, then what I would do? I would simply multiply with the sampling frequency. So we will solve the problem, it will be clear to you. So these particular topics are more problem solving oriented, okay, not theoretical oriented. So we will not spend much time in the theory. Simply what is the meaning of capacity? Capacity means, sir, something maximum we can transmit. So what is the maximum information your channel can transmit? That is your channel capacity. So these kind of questions can be asked. This is the problem. So this is your binary symmetric channel. Probability of x0 transmission is alpha. So what will be the probability of x1 transmission? So that would be 1 minus alpha. You need to find out the channel capacity for this binary symmetric channel, and then you need to draw channel capacity versus probability curve. Okay, so this is what you need to do. Now, sir, for finding out channel capacity, what I need to do? Sir, first I need to find out mutual information. So that would be equals to h of x minus h of x by y. Or sir, what I can write down? H of y minus h of y by x. Which formula you would prefer? This one I would prefer. Now, sir, how would I find out h of y? Sir, for finding out h of y, first I need to find out the probability of y0 and probability of y1. But do you need to find out the mutual information? No. What you need to find out? You need to find out the capacity. What is capacity? Capacity is maximum of this particular thing. So what I need to do? I need to maximize this particular expression. So what could be the maximum value of h of y? So basically your channel capacity would be h of y maximum minus h of y by x. Basically this I will maximize. Here what I will not do, like what people will be thinking that sir, probability of x0 transmission is given alpha, probability of x1 transmission is giving 1 minus alpha. So sir, you find out what will be the probability of y0 transmission. So that would be 1 minus p into alpha plus 1 minus alpha into p, and then sir you find out probability of y1 transmission. So that would be equals to p into alpha plus 1 minus p into 1 minus alpha, and then sir you calculate h of y. No, we are finding capacity, we are not finding mutual information. What we are finding? We are finding capacity, and capacity tells maximum. That means I will maximize this one. Is that clear to you? So I am finding capacity. So my target would be maximizing the value of h of I. Someone would be saying that, sir, that means you will minimize this one. Yes, I will minimize this one. So basically what I am doing is that I am finding channel capacity. That means this maximum value I will take and this minimum value I will take. But I know that my h of y by x will actually be depending on these probabilities. So I can change these guys, but these conditional probabilities I cannot change. This basically what I need to do is that I will find out my capacity in the expression of P. Then I will draw capacity versus P graph, and then I would see that at some value of P I will get the minimum capacity, and at some value of P I will get maximum capacity. So capacity is depending on this P for sure, but it is not depending on this alpha. Is that clear to you? Why it is not depending on alpha? Because I need to find out the maximum value of h of y, and maximum value of h of y would be equals to log 2k. K is the number of symbols. So what would be your h of y maximum? H of y maximum would simply be, what is the maximum value of h of y for any symbol? This is the thing that we have understood, right? Log 2k, where k is the number of symbols. So how many symbols we are transmitting? 2 symbols we are transmitting. So log 2 that would be 1. So maximum value here would be 1 minus h of y by x. For this channel, have we find out h of y by x somewhere? Yes sir, in the last lecture we find out h of y by x for binary symmetric channel. Sir, that was minus p log 2p minus 1 minus p log 2 1 minus p. So this we have already find out. So 1 minus this value. So what will happen is that, sir, 1 plus p log 2p plus 1 minus p log 2 1 minus p. This will be the expression of my channel capacity, which is coming out to be 1 plus p log 2p plus 1 minus p log 2 1 minus p. Now can you draw the capacity versus p graph? Capacity versus p graph. If p is equals to 0, 0 log to 0 will be 0, 1 log to 1, that would also be 0. So capacity would be coming out to be 1. If p is equals to 1, 1 log to 1, that would be 0, 0 log to 0, that would also be 0. Capacity will also come out to be 1. So this is your p equals to 0, this is your p equals to 0, and this is your p equals to 1. Basically, when this will have minimum value, or here I am using plus sign, so when this will have maximum value, what could be the maximum value of this guy? That could be 0. Or forget about it, just put p equals to 0, p equals to 1, I got these values. If I put p equals to 0.5, what I will be getting? 1 by 2 log 2 1 by 2 plus 1 by 2 log 2 1 by 2, and here there is 1. So 1 plus log 2 1 by 2 log 2 1 by 2. So 2 into log 1 by 2, so log 2 1 by 2 it would be, what will be the answer? I will be getting 0. So when p is equals to 0.5, your channel capacity is coming out to be 0. Your curve would come somewhat like this. And we will intuitively understand it for sure. Okay, don't worry, we will surely understand it intuitively. This curve, with the intuition as well, we will understand what this curve is saying. So let's first make the curve for p equals to 0. If your p is equals to 0, this is your x1, this is your x1 x0 x0 x1. So x0 x1, y0 y1. When p is equals to 0, okay. So let's talk about the mutual information. In this case, how much information your channel is passing? This is my channel with applied input of x and output is y, right? Applied input is x, output is y. So isn't it my channel passing the maximum information? Here then probability of error is actually 0, because if you look at y, you know everything about x. That means in this case, my h of x by y is equals to 0. If my h of x by y is equals to 0, that means mutual information is actually coming out to be h of x. And if I need to find out the capacity, what I will do? I will maximize this one. What that is equals to? Log 2k. K is number of symbol, that is 2. So what will be the answer? 1. So capacity is actually coming out to be 1. Basically, in this case, noise is equals to 0, no? This analysis we have already seen in the last lecture. In the end of last lecture, this analysis only we saw. If P is equals to 1, then what is the scenario? Transmitting x0, receiving y1. Transmitting x1, receiving y0. So here as well you are pretty sure. Here as well the same thing is happening, no? Looking at y, there is no uncertainty in x. That means capacity is that is equals to 1. And when your P is equals to 0.5. So this is your x0, this is your x1, this is your y0, this is your y1. This is 0.5 and this is also 0.5. So this is 0.5 and this is 0.5. This is also 0.5. This is also 0.5. So here there is maximum uncertainty. That means h of x by y is equals to h of x only here. That means actually your mutual information is coming out to be 0. So your capacity is also coming out to be 0. How h of x by y equals to h of x? Actually, looking at the diagram you cannot tell, but you can see there is some kind of symmetry. You see that x and y are independent of each other. If I go to y0, what y0 can comment about x0 and x1? Y0 can say I can either come from x0 or I can come from x1 because both of the probabilities are same. If I go to y0, what y0 will say? I can either come from x0 or I can come from x1 as well. Both of the probabilities are same here as well. So this is the case, this is the worst case. That means here the mutual information that is transmitted, that is equals to 0. So with respect to P, we have talked about mutual information as well and we have talked about our capacity as well. Is that clear to you or not? So your capacity is coming out to be maximum for P equals to 0 and P equals to 1. From the expression if you want to do the mathematics, then this is the mathematics. You can make the mathematics and you can draw this curve. And if you want to understand it, what is the meaning of capacity, what is the meaning of mutual information, then you have understood the meaning of capacity as well, you have understood the meaning of mutual information as well. Is that clear to you or not? Say yes or no. I hope it is clear. I hope this curve is also clear. Now this question was asked in GATE examination and believe me, this was asked during my attempt as well. So in the GATE examination, I also did it wrong, okay? But when the solution came, when the educator gave the solution, they also did it wrong, okay? Everyone did it wrong. Sorry to say that, but you can go and check out the solution of GATE 2022. Everyone gave the wrong answer. They gave 0.5. I also did the same. In the examination, I also did the same answer because I did not study information theory in this manner, right? I used to study this particular thing. Then I used to do the mathematics, I used to plot it. Here I would use to study that simply this is the formula, apply the formula, I get the answer. So this is what I used to study when I was a student, okay? But I know as a student what difficulties I face, that's why I am designing my content in this manner, right? So without even solving this problem, you would be able to tell me what will be the answer of this particular question. Without even doing no mathematics, with zero mathematics, you can tell what will be the answer of this question. What do you need to find out? You need to find out the value of alpha for which capacity is maximized. See the diagram and tell me what will be the value of alpha. Just see the diagram. Sir, alpha would be either 1 or 0. That's it. Because sir, if alpha is 0, that means what kind of diagram I will be getting? Sir, if alpha is 0. If alpha is 0, then 3 symbols are there and 3 received symbol I am getting. A, B, C. And received symbol also they are saying A, B, C only. So sir, if alpha is 0, then this will be the scenario. From A to A I am going, B to B I am going, and C to C I am going. So sir, in this case what I can see, there is no noise present. H of x by y is equals to 0. Looking at y, I can comment everything about x. Along with that, h of y by x is also 0. So simply my capacity would be equals to 1, or not 1, sorry, log 2k. Basically your capacity would be equals to h of x or h of y, you can say, h of x you can say. So that would be log 2k number of symbols, that would be 3. So capacity would be equals to log 2 3. For the case of alpha equals to 1, sir, what will be the scenario? For the case of alpha equals to 1, A, B, C, received symbol are A, B, C. Sir, if alpha is equals to 1, if alpha equals to 1, this will go here, this will go here, and this will go here. So A will go to B, B will go to C, and C will go to A. If alpha is equals to 1, with the probability of 1, with the probability of 1, and with the probability of 1. So what will be the capacity here? Again, uncertainty in x given y, that is equals to 0. So capacity would be h of x maximum. Here also I should have written h of x maximum only, because when I talk about capacity, I talk about the maximum value. So that would also be log 2k. So for alpha equals to 1 as well, this is the case. For alpha equals to 0.5, what will be the scenario? This is the worst possible case. Why is that so? Because sir, if alpha equals to 0.5, then everything would come into action. Again, sir, you would draw A, B, C, A, B, C. So A can go to B. This is the scenario. Now B can go to B and C. B can go to B and C, and C can go to C and A. So this is the diagram that they have given. So this was going with the probability of 0.5, 0.5, 0.5, 0.5, 0.5, and 0.5. Now here I can see that h of x by y is not coming out to be 0. Because if I go to A, I will ask him from where you are coming. He can say that with the same probability I can come from A as well, with the same probability I can come from C as well. So he is completely uncertain here. I will go to B, I will ask him the same question. I will go to C, I will ask him the same question, and he is uncertain. So alpha equals to 0.5 is the worst case. This is the worst case. So here your capacity would be minimum. Here your capacity would be minimum. But this is the best case. So pure intuition, no mathematics, pure intuition. Zero mathematics. What will be the answer? They are saying that alpha belongs to 0.2521. Basically, you cannot take alpha equals to 0. They are saying that alpha is belonging to 0.521. So what will be the answer? Alpha equals to 1. That would be the answer. That's it. Okay. Blindly people thought that answer would be 0.5. Without doing the mathematics, we are solving it. If I want to do the mathematics, then I can do the mathematics as well. What will be the channel capacity? Sir, it would be maximum of h of x minus h of x by y, or I can say maximum of y minus h of y by x. So I can do the mathematics as well now. What will be the maximum of y? So that would be log 2k minus h of y by x. So now I need to calculate h of y by x. So what would be my h of y by x? Let's take the equiprobable symbols. Okay, I am taking equiprobable. It is not given, but when I am calculating the probability, it is not necessary that you need to take equiprobable. So basically, let's take this is having transmission of this one is probability of A, transmission of this one is probability B, and transmission of this one is probability of C. So I am calculating h of y by x. So I am going to apply mathematics now, which will be a bit hectic task, but let's do it. So h of y by x I need to calculate. So P of A multiply with 1 minus alpha. P of A multiply with 1 minus alpha log 2 1 minus alpha. Then P of A multiply with alpha. P of A multiply with alpha log 2 alpha. Surely there is a negative sign which is going outside. Or what I can do is that better is that I can put minus sign here. Plus P of B multiply with 1 minus alpha log 2 1 minus alpha plus P of B multiply with alpha log 2 alpha plus P of C multiply with alpha log 2 alpha plus P of C multiplied with 1 minus alpha log 2 1 minus alpha. So this mathematics also I could have done. From here I need to add a page. If I add this page and I write down my h of y by x expression, minus sign is surely going outside. What I can see, P of A alpha log 2 alpha, P of C alpha log 2 alpha, P of B alpha log 2 alpha, and P of A plus P of B plus P of C would be 1. So what I can see, I am getting minus alpha log 2 alpha, and I am getting minus 1 minus alpha log 2 1 minus alpha. This is what I am getting. So my channel capacity is coming out to be 1 minus of this particular thing. So log 2 3, sorry, not 1, log 2 3. This is coming out to be log 2 3 plus alpha log 2 alpha plus 1 minus alpha log 2 1 minus alpha. This is the channel capacity I was getting. So for what value of alpha this will be maximum? I can directly see that if I put alpha equals to 1, so this part would go to 0. But what people did, that sir, I need to maximize the capacity, right? So what they did, sir, this C is a function of alpha, no? Sir, C is a function of alpha. And if you need to find out the value of alpha, for this is maximum, what you do? Sir, d of f of alpha divided by d alpha, that is equals to 0. So what they did, they differentiated this one and then they equated it to 0. So what they will be getting, you can do the differentiation on your own. This is what you will be getting. Okay, differentiation I need to do. So what I will do, first, as it is ln2 is a constant value that I can take outside. Basically I know the differentiation of ln alpha. So this is written log 2 alpha. So what I would do, sir, ln alpha divided by ln2, right? ln2 is a constant value that will go into 0 only. So forget about this ln2. So basically in my mind this is written log 2 alpha, but in my mind I am considering it as alpha, ln alpha only. So first, as it is differentiation of second plus second as it is differentiation of first plus first as it is differentiation of second plus second as it is differentiation of first, that would be equals to 0. Okay, so what I am getting, this would be 1, this would be minus 1. So 1 plus ln alpha minus 1 minus ln 1 minus alpha, that is equals to 0. So from this and this is getting cancelled out. From there what they are seeing, that ln alpha is equals to ln 1 minus alpha. That means, sir, alpha should be equals to 1 minus alpha, and from there they solved it, alpha equals to 0.5. So they were getting alpha equals to 0.5 answer and they put it here. And I did the same thing in the examination. I also did the same thing. So where I am going wrong in this analysis? When you differentiate and put that equals to 0, is it necessary that this will be maximum? It could be the case of minimum as well, no? When you differentiate and put equals to 0, is it necessary that this is the case of maximum? This could be the case of minimum as well. Differentiation equals to 0, always it will tell maximum case. Is it necessary? No. So this is the case of minimum. When alpha equals to 0.5, you will get the minimum capacity, and deliberately they asked about maximum capacity because they also knew, the professor who framed this question, he also knew that guys will be doing this particular thing. Those who don't go by intuition, those who go by mathematics blindly, they would be doing this particular thing, putting that equals to 0, will do the differentiation, put the answer 0.5. They did not think anything. But those who have studied from PrepFusion, or those who have studied in a good manner, what they would be doing, okay, this is the diagram they have given. Alpha equals to 0, alpha equals to 1, alpha equals to 0.5. So here if I see this diagram only, just by looking at the diagram, I know that if I put alpha equals to 1, then there is no certainty in x given I know y. That means my capacity would be maximum. That's it. Alpha equals to 1, 2 marks. And all these mathematics, even doing this mathematics is also not that easy in the examination. Like even if you are writing down all these expressions, then doing this mathematics, then also you are a very good student. Okay, just that you studied from the wrong platform. Just kidding. Okay, yeah, every platform is good, but PrepFusion is best, right? Every platform is good, PrepFusion is best. So yeah, what I was saying, if you solve in this manner, then this is the problem that you can do, because when you differentiate and put equals to 0, it could be either maxima or it could be minima as well. Here also you will get differentiation 0, here also you will get differentiation 0. So who knows we are talking about minima or maxima. So this was actually minimum case. Okay, is that clear? So if I draw the channel capacity, then this kind of curve you will be getting. You draw channel capacity here. So curve would be that at alpha equals to 0, you are getting the maximum value. That would be log to 3, and at alpha equals to 0.5, you will be getting the minimum value. So this curve you would have got. अरे भाई कौन ऑनलाइन थ्रेड दे रहा है मेरे ब्राउजर को. Okay, this is your alpha equals to 1. So you need to pick something from 0.5, 0.25 to 1. They are saying that alpha belongs to 0.5 to 1. So what should be the value of alpha? That would be equals to 1. So this would be the answer. Okay, is that clear? Right, just I am telling one thing, that in GATE 125 this information theory came for 5 marks. Okay, in GATE 2022, not in 2025. This was my attempt and I got 0 marks here. From 5, all 5 were wrong. All 5 were wrong. Okay, and every question was a good question. Every question was a good question. And all 5 were wrong because I studied formula based. I studied information theory formula based. That's why everything was messed up and I got 0 marks. If I had told this thing in the beginning, then you might not have studied from me, right? So when I got this 0 marks out of 5, at that time only I decided that no matter even if I get into education or not, I might be working in industry, whatever the path is there, but I will surely teach information theory on YouTube once in my life for sure. Okay, and in 2025 it came for 6 marks, but unluckily at that time I was teaching other subjects. At that time I did not take a communication system, but now I am teaching it. So should be studied in a better manner. Basically, when they framed 5 marks of question from information theory in 2022, this was just a message from the professor of IITs that now you should be studying information theory in a good manner. So now you need to redesign your content. Okay, GATE 124 analog question paper is also a message. GATE 122 analog question, not 122, 2021. Some questions are like a message. In always GATE examination, some questions are like a message that now we are building up our level in these particular topics. So now you need to study these topics in a good manner. So when we say educators analyze the question paper, this is the meaning of analysis. Okay, not giving some mathematical solution. No, analyzing a question paper, only the educator can get to know that what they are expecting from a student. So always when I am teaching any particular topic, any subject that when I am teaching, I always make sure that what IIT's professor are expecting from you. So whenever I say you need to remember this formula, you don't need to remember this formula. So whenever I say you don't need to remember this formula, so I have seen in the previous year question paper that IIT's professor are not expecting you to remember that formula. Okay, that's why sometimes I say that this particular formula a lot of students remember, but you don't need to remember it. That means those professors are not expecting. So looking at the question paper, you can always understand what they are expecting from you. So I have the clear idea. All other educator might also have the clear idea. So this is the job of educator, that you see the previous year question and you get to know the idea that what they are expecting from a student. Like I always take the interview experience, like after the GATE examination is done, you would be getting into ISC or IIT for interviews. Your IIT professor would be taking your interviews. Your ISC professor would be taking your interview. So I always take the interview experience. Whoever my student is there, I always ask him what type of questions they asked, because from there also I get to know that what they are actually expecting from a student and what they would be expecting from our GATE educator as well. Because if I'm an educator, like I need to teach up to their expectation as well, right? So always this is a very good thing that you always should understand. No matter whatever the competitive examination you are preparing for, you might be preparing for AJE examination. So you see the question paper of AJE and then you try to understand what they are actually expecting from you. So AJE guys are there, or ESE prelims or ESE mains, they are also expecting that you remember a lot of things. This is the expectation of AJE examination, PSU examination. But when it comes to GATE examination, they are not expecting that you remember a lot of things. They are expecting that you should have the problem solving skills. Your analytical skills should be better. They expect you to analyze everything. So you would hardly find that you need to remember any formula when you are appearing for GATE examination. In the preparation, you might mug up a lot of formula, but when you appear for the examination, in the examination hall, you will be hardly applying any formula. In 3 to 4 questions only you will be applying the formula, and in the rest of the question paper, you will be just simply analyzing it. So that's why I say that these lectures are very important. Understanding the flow is very important. Not the formula, not the final result. No. How I went to that formula, how I build up my intuition. Just by looking at the problem, how do I solve it? Not this year, but next year I will bring, I will solve all the previous year question paper. I will not solve the topic wise solution, I will not give. I will just simply take a question paper. Let's just say I am taking GATE 122 question paper and I will simply solve it. That what would be my approach? In the examination, how would I approach that question paper? So that approach is also very important. Solution is never only the matter of concern. Surely the solution is matter of concern, but you should also have the habit, or you should also have the intuition that how to get the best possible out of this particular question. So this is the best possible outcome of this particular question. Whatever that we have discussed, this is the best possible outcome of this particular question. That you see for the case of alpha equals to 1, alpha equals to 0.5, and then alpha equals to 0. Okay, and whatever that I made here, p equals to 0, p equals to 1, p equals to 0.5, the same thing has been done in NPTEL lectures as well. Ditto same thing. Ditto same thing has been done in NPTEL lecture as well. And ditto same kind of questions have been framed in NPTEL assignment as well. So whenever you watch NPTEL lecture, you should not watch it because I am doing the thing. So whenever I teach any topic, first I watch the NPTEL lecture, all the NPTEL lectures that are available for this particular topic. I will watch them. I will see what all things are relevant for you. How would I get to know what all things are relevant? I will go to their assignments. I will see their assignments. From which particular topics they are framing the problems, those are relevant for you. Okay, from which particular topics they are framing the problem in their assignment, those are relevant for you. And those topics I will teach in the best possible manner. And how would I take the reference? I will watch their lectures only. I will take the reference from there and I will design my content. So that's why my content comes after a time, after a delay. Okay, not blindly like 3 hours of lecture, sir, tomorrow I will upload it. No, it will take time, but it will go at least for a decade. Even after 10 years, you would see that this level of content is working. If I need to redesign my content, like next year, if I teach this information theory, I will surely redesign it. If I am teaching in this manner, next year, if I am teaching again information theory, I will teach it in much better manner. Okay, but even if you are studying this content after 3 to 4 years, this will still work. I am pretty sure. Okay, so whenever I design a content, I make sure that at least for next 10 years, it should be working. After 10 years, there should be some changes. Okay, so at least for 10 years, this would work, but surely if I teach next year as well, I will make some changes here. I will teach this information theory in a different manner if I teach it again. Okay, but yeah, at least for 10 years, this content would work. And this is not only for information theory, you can take any topic, any chapter. Like I will be teaching 10 subjects and all 10 subjects will be teaching in the same manner. Right, and you have been following me for a longer time. If this is not the first video that you are watching, so you might have watched analog circuits, you might have watched digital electronics, EMFT, EDC, or any other subject. Control systems next year I will be taking. You might have studied signal system. Like signal system is the best possible, like till this point what I feel is that signal system is my best possible creation, because that was the subject which people used to consider mathematical, but on a very different level we have studied signal system. Those who have already studied, they would realize it. Even with EMFT, people used to find that this is completely formula based, this is completely mathematical, but we have made EMFT completely based on visualization. Like, do you remember any formula for transmission line? In transmission line, you guys remember the formula, right? 2 pi beta max, this length, that length. Without remembering a single formula, we can solve all the problems of transmission line. Right? Smith's chart used to be considered as the toughest topic of electronics engineering. Forget about EMFT, Smith chart people never ever understand, but in a great manner we have understood Smith chart. So yeah, these kind of things are there in a content. So just appreciating the content or just letting you know that how you should follow, like which kind of content you should follow, because you are engineers, you are not preparing for JEE. JEE and GATE are different. Okay, preparation of JEE and preparation of GATE are different. Whatever that you study in JEE, that thing you are not going to work for your whole life, but whatever that you are preparing for GATE, it might happen that for your whole life you will be working on the same thing, right? You in future you are going to be a VLSI engineer, and VLSI engineer will be working on chips. Chip design means MOSFETs, right? And MOSFETs means there will be noise analysis, there will be that analysis, feedback circuits would be there. So everything, so whatever that you are learning, you will be working on that particular thing only in your future. So you should never learn it only for the examination purpose. You should learn in a better manner, and if you learn in a better manner, then examination purpose will be filled on its own. Okay, like whoever gets AIR1 in last 3 to 4 years, you can check all the AIR1s. I have talked to all the AIR1s and they never actually prepared sincerely only for GATE examination. When you sit beside them, you discuss your doubts with them, you would understand that what kind of depth they are having. So their depth is not limited to GATE examination. They just prepare the subject. They try to understand the subject on this level, and if they have the knowledge of this level in the examination, they would do surely pretty well. That's it. Okay, so someday I will make a video, detailed video on this, that what is the actual meaning of cracking a particular examination. So someday I will make the video, and I'm sorry that I wasted your time. But yeah, let's take a break. Okay, let's take some break, and then we will come back. We will study about information rate. So what is information rate? So directly we will solve some problem, and then we will develop some formula. So very simple topic. Next we need to study about information rate, but I will take a break and then I will come back. Yeah, thank you. Yeah, welcome back. So now we need to study about information rate. Okay, so what is the meaning of rate? If rate is written, what is the meaning of rate? Rate means simply per second. So what do you think, what is the meaning of information rate? That means information per second. Information per second. And what is the unit of information? Unit of information is bits. And what is the unit of rate? Rate means per second. So what is your information rate? Per second, how much information is passed? That is the meaning of information rate. Per second, how much bits of information you are passing? That is your information rate. So what do you think, what is given here? A discrete memory loss source is there. Let's just say this is discrete memory loss source X, which is generating 1000 symbols per second. So I don't know how many symbols it is generating, but I know that in 1 second it is generating 1000 symbols. How many total symbols it is generating, that I don't know, but in 1 second 1000 symbols are there. So 1000 symbols per second it is generating. 1000 symbols per second. Okay, and each symbol is carrying a information of 2 bit. So one symbol is carrying a information of 2 bits. That means information is, what is your information? Your information is actually 2 bit per symbol. And if it is bits per symbol, that means it is average information. So on an average, one symbol is carrying an information of 2 bits. This is what this question is saying. So 1000 symbol it is passing per second, and each symbol is carrying an information of 2 bits. That means how much information it is passing per second. So information rate. What is the meaning of rate? Rate means per second. So how much information per second it is passing? Sir, that would be 1000 into 2. Symbols per second will be multiplied with bits per symbol. So what you will be getting? Sir, symbols per second multiply with bits per symbol. So symbol getting cancelled out, bits per second. That means your information rate is coming out to be 2k bits per second. So your source X is transmitting 2 kilobits per second. This is the information rate. Very simple thing, very straightforward. It is nothing new concept. Everything you already know. So what is the definition of information rate? Average amount of information transmitted per second through a communication channel. It could be through a channel, or it could be information of a source X as well. So I will remove these lines. Basically, it is not necessary that it will be defined for a channel. It can be defined for anything. So it is not necessary for the channel. That's it. Information rate is simply the average amount of information transmitted per second. Okay. So what they can ask in the examination? They can say that your source X is having an uncertainty of Hx. That means it is having Hx bits per symbol. This much information it is having. Your source X can transmit any number of symbols, right? But on an average, your source X is transmitting Hx bits per symbol. So it can transmit any number of symbols. I don't know how much symbols it is transmitting. But I know one thing, that no matter whatever the number of symbols it transmit, each symbol is carrying this much information. Each symbol is carrying information of Hx bits. Okay. And then it is given that it is transmitting R symbols per second. What is given? Your source X is transmitting R symbols per second. Okay, R symbols per second. So 1, 2, 3 R symbols have been transmitted in 1 second. And each symbol on an average is carrying Hx bits of information. So what will be the information rate of the source? So that has been written, that would be R into Hx. So a source carries an information of h of x bits per symbol and transmits symbols at a rate of R symbols per second. Then the information rate of the source is given by R into Hx. Very simple thing. Do you really think that, sir, I need to mug up this formula? No. It is transmitting R symbols per second and each symbol is carrying this much information. So what will be the formula? R into Hx. Very simple thing. Now what if I talk about information rate of the channel? So basically, how much information your channel passes? How much information your channel passes? Sir, my channel passes information of this much symbols per second. Sir, my channel passes mutual information, not symbols per second. This much information in bits it passes per symbol. Sir, my channel passes this much information in bits per symbol. Okay, and let's just say R symbols are being generated per second. So what will be the information rate of the channel? So that would be R into I x comma y. So it would be a very simple process. Okay, we will solve the problem, you will be able to solve the problem. So don't focus too much on the formula, focus on the concept. That's why first I took the problem. Okay, so once I have taken the problem, you will be able to understand what is the meaning of information rate and how these formula came into action. So let's solve the problem first. So this is the question that is given. A baseband signal band limited to 100 Hz sampled at Nyquist rate. The samples are quantized into 4 independent message symbols with probabilities this much. Find out the information rate in bits per second. So what they are saying, there is a source X which is generating 4 symbols, X1, X2, X3, X4. 4 symbols are being generated. Okay, probability of occurrence of this one is 0.125, probability of occurrence of this one is 0.125, and probability of occurrence of these two symbols are same. 4 symbols they are generating. Okay, 1 and 4 are 0.125. Although it doesn't matter, still I would write down 1 and 4 are having the probability of occurrence of 0.125, and these two guys are same. And you know that P1 plus P2 plus P3 plus P4 would be 1 only. Plus P4 would be 1. So what you are left with, P2 plus P3, P1 plus P4 is 0.25. So P2 would be equals to P3, that is given, and that would be equals to 0.375. Okay. Right. So what is the average information this source is having? What is the average information this source is having? So can you calculate the value of h of x? That surely I can calculate the value of h of x. So that would be, here I will write down h of x, and that would be 0.125 log 2 0.125, and then similar thing would happen here as well. So I can simply multiply with 2. Okay, so 2 into 0.125 plus 2 into 0.375 log to 0.375. So answer I will get in bits per symbol. So this much information per symbol has been passed. Okay, so I will calculate this particular answer. I will pause the video and I will calculate this particular thing. Yeah, so it is coming out to be 1.81 bits per symbol. So per symbol, every symbol on an average is having this much information. Now what is given? A baseband signal is band limited to 100 Hz. So whatever that has been applied, that is band limited to 100 Hz. And now this 100 Hz, it is sampled at Nyquist rate. That means what was the sampling frequency? Sampling frequency was 2 FM. So basically your sampling frequency is coming out to be 200 samples per second. That means this source X is generating 200 samples per second, or you can say 200 symbols per second. So this particular source can generate 200 symbols per second, and each symbol is having 1.81 bits of information. That means what will be your information rate? That would be this Fs would become R only, right? So you don't need to mug up the formula R into Hx. This you don't need to mug up. You will simply see that I have find out the information. That means per symbol I am having this much of information, and per second this much of symbols is being transmitted. So per second how much information is being transmitted? So I will simply multiply both of them. Symbol and symbol will get cancelled out. Bits per second I will be getting. So 200 into 1.81. That would be the answer. So I will simply multiply with 200. So I will get 362.25. 362.25 bits per second. This is my information. So this much information have been passed per second. 362.25 bits per second have been passed. Answer is 362.4 or 362.25, whatever you are getting. Both will be nearly same. Is that clear to you? Okay, let's solve the next problem. Analog signal band limited to 4 kHz, sample at NIQ state. The samples are fed to a 8-bit quantizer. So basically what is the scenario? First there is a sampler, then there is a quantizer, and quantization levels are assumed to be independent and equiprobable. Find the information rate in bits per second. Okay, so basically this is the scenario. Sampler is there, quantizer is there. What this sampler is doing? This is band limited to, applied input is band limited to 4 kHz. So what this sampler would be doing? This sampler will be generating sample at NIQ state. That means Fs is equals to 2 FM. Value will be 8 kilo samples per second, right? So basically this sampler will be generating 8 kilo symbols per second. The quantization levels are assumed to be independent and equiprobable. So how many quantization levels would be there? It is a 8-bit quantizer. 8-bit quantizer is there. So how many quantization level would be there? 256. So basically it will generate 256 symbols. Say yes or no? It will generate 256 symbols. Your quantizer would be generating 256 symbols. And all symbols are equiprobable. What does that mean? That means P1 equals to P2 equals to all 256 symbols are equiprobable. Right? So what will be the entropy? All are equiprobable. So how many symbols are there? 256 symbols are there. What is 256? 2 to the power 7, right? Or 2 to the power 8? 2 to the power 7 only. Let's just simply do it. 256 log 2. 2 to the power 8. 2 to the power 8, sorry. Yeah. So basically, and it is pretty obvious, no, it would come out to be 8 only. Why I am wasting my time? Here 8-bit is there, no? If it is a 8-bit quantizer, it would come out to be equals to n only, no? N bits per symbol. N bits per symbol. This much information it is having. So value of Hx is actually coming out to be n only. Is that clear to you or not? Basically, it is transmitting total 256 symbol. What your quantizer is doing? Quantizer is transmitting total 256 symbols. And it is a 8-bit quantizer. 8-bit quantizer, and all are equiprobable. All symbols are equiprobable. If all symbols are equiprobable, what does that mean? That means how much information they would be carrying? On an average, they would be carrying the information of 8 bits per symbol. Say yes or no? Is that clear or not? Right? All fine? So this much information we are having, and this much symbols we are transmitting. So what will be our information rate? So we are transmitting 8 kilo symbols per second, and each symbol is having an information of 8 bits. So symbol and symbol is getting cancelled out. So 64 kilo bits per second. This is my information rate. Is that clear to you or not? Okay. Sampler was there. Sampler is producing 8 kilo symbols per second. Those are fed to the quantizer. Quantizer is a 256 level quantizer, or you can say 8-bit quantizer. All symbols are equiprobable. That means each level or each symbol would be having an information of 8 bits per symbol. per symbol 8 bit of information is there. That means total symbols are, basically I don't care about the total symbol. What I care about information per second. This is what I care about. So 8 bits per symbol, and per second 8k symbols are being generated. So 8k into 8, 64 kilobits per second. This much information has been transmitted. In the next question, what they have given? They have given that 4 quantization samples are transmitted per second. So here what I assumed, whatever the samples, total 8k samples were generated per second, and all of them, all the 8 kilo samples are transmitted per second. Basically, whatever this sampler is giving you, all are being transmitted. So till this point, when we were studying digital communication system, this is what we were assuming. At that time, what we used to write down? What is our bit rate? What is our bit rate? RB equals to NFS. Now here something I studied, that is capital R equals to HX. Here what did you get to know? HX is coming out to be N. HX is coming out to be N. What is this small r is coming out to be? Fs only. So isn't it N into Fs? Isn't it RB? So R is equals to RB in this case. But this is the maximum value of R. This is the maximum information rate. This is actually your maximum value of R. Because what could be the maximum value of Hx? What could be the maximum value of Hx? That would be Fs only. Sorry, not Fs. Maximum value of Hx could be N only. Is that clear to you? What is the maximum value of Hx? Maximum value of Hx is log 2k, where k is the number of samples. Number of symbols you can say, where k is the number of symbols. So what will be your number of symbols, or what will be your number of levels? So that would be 2 to the power n. So what that is coming out to be? N only. So maximum value of Hx could be number of bits, this 8-bit quantizer. So that is N. Now what is this R? R is how many symbols are being transmitted per second. So this quantizer is actually taking 8 kilo symbols per second. But it might happen that out of these 8 kilo symbols per second, it is transmitting only 4 symbols per second. Is that clear to you or not? Per second, only 4 symbols are being transmitted. It may happen. It may happen that it can transmit only 1 symbol per second, or it may happen that it is transmitting only 1000 symbols per second. But maximum it can transmit 8 kilo symbols per second only, because these many symbols are being generated. At the input of the quantizer, this is your quantizer, at the input of the quantizer, 8 kilo symbols are being generated. But now what quantizer is doing? Out of those 8 kilo symbols, it is able to transmit only 4 symbols per second. So maximum how much they can transmit? Maximum they can transmit 8 kilo symbols per second only. That means the value of maximum value of Hx was N. So maximum value of R could be equals to Fs only. And if nothing is mentioned in this problem as well, value of R we took equals to Fs only. R and Fs were equal here. Because here as well they did not mention that how many symbols are being transmitted per second, how many symbols are being transmitted. So we assume that whatever the symbols your sampler is generating, 200 samples per second. So all the samples are being transmitted. Here also I assume the same thing. Whatever the samples this sampler is producing, all the samples are being transmitted. But here what they are saying, that your sampler is producing, here also the same scenario is there. Ditto same question is there, that some signal would come, then there will be sampler, and then there will be quantizer, right? So sampler would be there, quantizer would be there. Your sampler would be generating 8 kilo samples per second, or 8 kilo symbols also you can say. So it is generating 8 kilo symbols per second. But this quantizer can generate only 4 symbols per second. So this is the value of R. Here R is 4 symbols per second. But what was your Fs here? Fs was 8 kilo samples per second. So here R was not equals to Fs. So your R could be less than or equals to Fs. This is the condition. Either it could be equals to Fs. If nothing is mentioned, by default we will say that R is equals to Fs. But if it is mentioned, then I will have to take that your quantizer is actually producing 4 symbols per second. So 4 symbols per second is being generated, and all symbols are equiprobable, that means your entropy would be n only, that means 8 bits per symbol. This much information we are having. We are having 8 bits per symbol. This much information we are having. Right? Now here someone would be having the doubt that, sir, why we did not take log 2 4? Why would we take log 2 4? Doesn't make any sense, right? We will take log 2 256 only, because this quantizer is 8-bit quantizer. So total output will be 256. This quantizer would be giving total 256 outputs, right? And all outputs are equiprobable. That means per symbol you are having 8 bits information. Per symbol, on an average, you are having 8-bit information per symbol, right? So what will be your information rate? Information rate would be 8-bit per symbol. Multiply with 4 symbols per second. So this and this is getting cancelled out. So here answer would be 32 bits per second. So here your quantizer was not that efficient. Quantizer was able to take only 4 symbols per second. But actually the sampler was generating 8000 symbols per second. Here it was generating 8000 symbols per second, but quantizer was able to take only 4 symbols per second. And here quantizer was taking all the symbols per second. Is that clear to you? So do you understand why in this formula I did not write down R equals to Fs? Because always R will not be equals to Fs. By default, R would be equals to Fs. By default, R would be equals to Fs. But in the problem, if they have mentioned that we are taking 4 samples per second only, that means only 4 symbols are being transmitted per second, and each symbol is having an information of 8 bits. That means per second we are transmitting 32 bits of information. So if it is specifically mentioned, then we will have to take the value of R as this one. Is that clear to you? So your information rate is small r into hx, where r is the number of symbols transmitted per second and hx is the average information per symbol that you are having. Okay, very simple concept, very straightforward. But one more important thing that you have understood here, the maximum value of information rate. The maximum value of information rate is equals to RB. Okay, what I am saying, maximum value of information rate is equals to RB. What does that mean? That means source can transmit maximum RB bits of information per second. What was the unit of RB? RB was having a unit of bits per second. That means your source can transmit maximum RB bits of information. Let's just say value of RB is coming out to be 32. That means your source is transmitting 32 bits per second. This much information it is transmitting. Your source is transmitting information of 32 bits per second. Is that clear to you? Okay. So maximum value of information rate is RB only. All fine. Now this question, try doing it on your own. If you just go by the unit, you will be able to solve it. So always these kind of questions are based on unit only. What you need to find out? Information transmitted per second. What you need to find out? Information transmitted per second. Yeah, sorry for the interruption. So did you try this problem? There is a TV which is transmitting 25 frames per second. Okay, there is a TV which is transmitting 25 frames per second. So 25 frames per second it is transmitting, and each frame is containing 4 into 10 to the power 5 pixels. Basically this TV is transmitting 25 frames per second, and each frame is containing 4 into 10 to the power 5 pixels. So these many pixels are there per frame. That means this TV is transmitting 25 into 4, that would be 10 to the power 1 into 10 to the power 5, that would be 10 to the power 6. So this TV is actually transmitting 10 to the power 6 pixels per second. So it is transmitting 10 to the power 6 pixels per second. Now each of these pixel can take any of the 10 brightness levels. So there are total 10 levels. There are total 10 levels. So it is basically there are total 10 symbols and each symbol is equiprobable. Each symbol is equiprobable. So basically I can say that there are 10 levels and each level is equiprobable. So what does that mean? Per level how much information is there? Per symbol how much information is there? So can I write down log to 10? That would be 3.32 as far as I remember. Log to 10 would be 3.32 only. Yeah, 3.32 bits per pixel. So this much information per pixel we will have, right? Basically we have find out the entropy. Entropy means average information. So per pixel this much information we will have, because any pixel can take any of the brightness level. So one pixel will be taking one of the brightness level with the probability of 1 by 10, right? So there are total 10 brightness level. So there are total 10 levels. Each level would be taken with the probability of 1 by 10. So what would be the entropy here? Entropy would be log to 10, right? Basically entropy would be 1 by 10 log to 1 by 10. Surely there will be minus sign and then it would be added for 10 times. So that would be log to 10, 3.32, because all are equilikely, right? Okay. So on an average, each level you can say is having information of 3.32 bits, right? So now what we need to find out? We need to find out amount of information transmitted per second in bits. So information rate only we need to find out. Information transmitted per second, 3.32 bits per second, sorry, bits per pixel. So just if you solve by unit only, then also your job would be done. Multiply with pixels per second. So pixel will get cancelled out. Answer would be 3.32 10 to the power 6 is megabits per second. So this is the answer. Okay, very simple straightforward problem. Just you need to solve by the units. If you solve by the units, your job will be done. First I will find out my entropy. Entropy I will find out and then I will see how many pixels per second are being generated. So these many pixels per second being generated, average information per pixel you are getting 3.32 bits. I will just multiply them, I will get my answer. Okay. So now what all things we have studied? Everything that we were studying till now, we were studying for discrete random variable, right? So first we studied entropy, or you can say average information. Then we studied about joint entropy, then conditional entropy. In between we studied about channel as well, probability of error as well. So that's a separate topic, so forget about that topic. Next we studied about mutual information and then we studied about capacity. So these things we have studied for discrete random variable. Now we need to study about continuous random variable. So there is a topic called differential entropy. So when the word differential entropy is given, basically if your x is discrete random variable, then they simply call it entropy. Now what if x is a continuous random variable? So they will call this as small h. They will represent it by small hx and they will call this as a differential entropy. Is that clear to you? Okay, just there is a change in the name. So what it is known as differential entropy. Similarly for continuous random variable, this can also be defined and this can also be defined. And surely these things can also be defined. So all these things can be defined for continuous random variable. what we will be focusing on, we will be studying this one, and then directly we will be studying capacity. So only these two are important. They are not even mentioned in the textbook as well. Rarely you will find them in textbook. Okay, because we would see that h of x does not represent anything practical. Okay, there is no meaning of h of x. There is no physical meaning of h of x. Which h of x I am talking about? I am talking about differential entropy. So there is no physical meaning of a differential entropy. Sir, why so? We will see that. Don't worry. So if there is no physical meaning of differential entropy, that's why rarely any question would be there. But this particular part, capacity for continuous random variable, that is very important. Even this particular part is also important. So only two things we will study. That's it. Okay. And in brief, we will study mutual information as well, because without studying mutual information, you can never get to know about the capacity, because capacity is nothing but a maximum value of mutual information. So we will study about mutual information as well. So basically, we are not going to see anything about this joint differential entropy or conditional differential entropy, because they will not be used anywhere. Is that okay for you? Fine. Although we can write down the formula, but no one will ask you determine the expression of joint differential entropy, determine the expression of conditional differential entropy. No one will ask you. So simply we need to see the formula, and then we need to see the problem solving skills, because this particular differential entropy is having no physical meaning. There is no physical meaning of a differential entropy. So what is differential entropy? It is simply the entropy of continuous random variable. So what formula we have studied for entropy, and it is denoted by small h of x. So what formula we have studied for entropy of a discrete random variable? So that formula was summation probability of your symbol xi log to symbol xi. Summation would go for all the symbols, there would be a negative sign. Now what do you think, what should be the formula of a continuous random variable? So for continuous random variable, entropy is defined as differential entropy. This is known as differential entropy. What will happen? Summation will be changed to integration. Minus sign would be there, minus sign would be there. In place of p of x, what you will write down? Basically, this is your PMF, right? Probability mass function. So here for the continuous random variable, what I will write down? PDF, probability density function. That's it. Okay, negative sign would be there, and the limit will go from minus infinity to infinity. So this is the formula. So should be there in your mind. Okay. So what it is known as differential entropy. Minus infinity to infinity, fx of x log to fx of x, and then outside there is a negative sign. So let's solve this question. X is a random variable uniformly distributed between minus a by 2 to a by 2. Find out the differential entropy for this one, and then find out the differential entropy for this one as well. Okay, so two questions are there, and from here we will make some conclusion as well. So can you write down what will be your fx of x? Basically, what is the formula of h of x? The formula of h of x is minus sign outside, minus infinity to infinity, fx of x log to fx of x dot dx. So what will be your fx of x? Sir, x is a random variable uniformly distributed between minus a by 2 to a by 2. That means my fx of x, without even making the diagram, I can tell that, sir, it would be having amplitude of 1 by a when my x is between minus a by 2 to a by 2. Otherwise, the amplitude would be 0. I hope this much thing till this point you should be comfortable with. If you are not comfortable with all these things, then needlessly you are learning your communication system. You should drop learning communication system if you are not able to write down this particular thing. Okay. Minus sign outside. Limit should go from minus infinity to infinity, but fx of x is non-zero between minus a by 2 to a by 2 only. So it is non-zero between minus a by 2, a by 2 only. What is the value of fx of x? That is 1 by a. Log 2 fx of x is 1 by e dot dx. Integration is done with respect to x. So isn't it constant? Yes, sir, it is constant only. So minus 1 by a log 2 1 by a, that is constant. It can be taken outside, and then integration is done from minus a by 2 to a by 2 dot dx. What will be the value of this one? Sir, integration of dx would be x, and then I will be putting the limit from minus a by 2 to a by 2. What that would be? Sir, a by 2 minus of minus a by 2. So it would come out to be a only. So what will be the value of this one? Value of this particular thing would be a, right? So what you are getting? Sir, minus 1 by a. Can I take 1 by a? Can I take a minus sign outside? Yes. So what I am doing? I am removing this minus sign. So log 2a, and here there was 1 by a already. Multiply with a. So this and a will get cancelled out. Answer is coming out to be log 2a. So what is your h of x? H of x is coming out to be log 2a. Don't mug it up, okay? Always derive it. Like basically very simply you can derive it like x is a random variable uniformly distributed between minus 1 by 2 to 1 by 2. So will you compare now? Answer would be sir log 2a is 1, answer would be 0. So you don't need to mug it up. You can simply do one thing, that what will be your fx of x? Sir, that would be 1 only. Fx of x would be 1 between x going from minus 1 by 2 to 1 by 2. So I will apply the formula 1 log 2 1. Sir, answer would be 0 only. Okay, so basically you can anytime solve it. Basically what I am saying, if it is between minus 2 to 2, let's just say this is the scenario, then you would know that sir what will be the amplitude? Amplitude will be 1 by 4, because between minus 2 to 2 area should be 1, so amplitude will be 1 by 4. So what I need to do? Sir, integration, limit should go from minus infinity to infinity, but it is non-zero between minus 2 to 2. Amplitude will be 1 by 4, log 2 1 by 4 dot dx. Then what will happen? Minus 2 to 2, this 1 by 4 and 4 will get cancelled out. Sir, answer is coming out to be log 2 1 by 4. Surely there is a negative sign. So answer is log 2 4, answer is 2. And you can compare from here as well. A by 2 is equals to 2 here. A by 2 is equals to 2. So value of A is 4. If you put A equals to 4 here, log 2 4 is equals to 2 only. This is the answer we are getting. Okay. So basically you don't need to mug up the formula. Very simply, in a very simple manner, you can do in the examination. Within seconds you will be able to get the answer. Answer is log 2a. Now let's just say a was equals to 1 by 2. If a was equals to 1 by 2, what would have been your answer? Sir, log 2 1 by 2, answer would be minus 1. So value of hx is coming out to be negative. So this differential entropy could be negative. Unit would be same, bits per symbol, but it could be negative as well. Now what is the meaning of negative information? No meaning. What I told you, that h of x would always be positive. This would always be positive. But this small h of x, it could be negative as well. Negative, or it could be positive as well. Negative or positive, anything. So this differential entropy, physically it is not representing anything. This is just mathematics. Okay. So it could be positive as well, it could be negative as well. Right? From here only you can see it. Next one is, you should be doing on your own. Your random variable x is normally distributed, having a Gaussian PDF it is having, with the mean of mu x and variance of sigma x square. So a very important expression that you are going to get. Most important expression. This is very important. And whatever the result that you are getting, that you need to remember as well. So let's do this particular thing, having a mean of mu x and a variance of sigma x square. So can you write down the expression of fx of x? Yes sir. I clearly remember 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square. As a communication student, if I don't remember this formula, then there is no meaning of studying communication system, right? At least this formula should be there in your mind, where x would be going from minus infinity to infinity. What I need to calculate? So this is what I need to calculate. I know the formula minus infinity to infinity. Surely there is a negative sign outside. Fx of x log 2 fx of x dot dx. Now derive this thing on your own. Just one hint I am giving. Don't put the value of fx of x here. Only put the value of fx of x here only. Okay. Just keep this fx of x as it is. So minus sign I will take this side. Minus h of x. Minus sign I have taken this side. Minus infinity to infinity. This fx of x I am keeping as it is. And in place of this fx of x I am putting this value. Okay. So I am putting this value here. 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square dot dx. Right. Now log a into b I can apply, log a plus log b, log 2a plus log 2a plus log 2b. So I will keep this aside and then this aside. So log a plus b I can apply. Fx of x one by under root 2 pi sigma x square plus log 2 e to the power minus x minus mu x whole square divided by 2 sigma x square dot dx. Can you solve this one? Sir, it would be equals to minus of x minus mu whole square divided by 2 sigma x square divided by ln 2. How did you do it? Look, the expression is log 2 e to the power minus alpha. This I am calling as alpha. Okay. Can I write down as ln e to the power minus alpha divided by ln 2? I can do it, right? Ln e to the power minus alpha divided by ln 2. This I can do. So ln e to the power minus alpha would be equals to minus alpha only. And ln 2, what is the meaning of ln 2? ln 2 is basically what I have done. I have simply write down log e to the power minus alpha divided by log 2, and base I have taken e this time. So this would become minus alpha and this goes upward. So it would become log base 2e minus alpha. Right? Is that clear to you? I hope it is all fine for you. So what I am left with, sir, minus h of x is coming out to be minus infinity into infinity fx of x multiply with this one. Okay, sorry, it is log 2 something. Well, let's go on the next page only. So minus hx is coming out to be minus infinity to infinity fx of x log 2 1 upon under root 2 pi sigma x square dot dx plus this is actually coming out to be log 2e minus alpha. So plus log 2e will be a constant value, so that I can take outside, minus infinity to infinity, that is a constant value that I have taken outside. Fx of x is there, fx of x is there, minus alpha. So minus sign I can also take outside, here I can take minus sign. And what is the value of alpha? Value of alpha is this one, x minus mu x whole square divided by 2 sigma x square, right? X minus mu x whole square divided by 2 sigma x square dot dx. If you use your pen, then only you will be able to understand. If you are just looking it, then you will not be able to understand. So 2 sigma x square, that is also a constant value, I can take this outside. Now this is also a constant value, I can take this one also outside. So 1 by under root 2 pi, again log I am forgetting. So log 2 1 upon under root 2 pi sigma x square, constant value. This is not a function of x. Sigma x will be a constant value, no power. That would be a constant value. We just write down sigma x. That doesn't mean it is a function of x. Now this is becoming minus infinity to infinity fx of x dot dx plus, or not plus, minus log 2e minus log 2e. 2 sigma x square can be outside, minus infinity to infinity fx of x, or better I write down x minus mu x fx of x whole square dot dx. What do you think what this is representing and what this is representing? So this will be equals to 1, and sir this would be equals to expectation of x minus mu x whole square. And if you remember the definition of variance, then this is the definition of variance, isn't it? Expectation of x minus mu x whole square. Yes, and this is the definition of variance. So this is representing nothing but variance, right? So what you are getting? Now let's take the minus sign as well. Okay, this minus sign is coming here. So minus log 2 1 upon under root 2 pi sigma x square, right? This is becoming 1 only. Then this minus sign is coming here, so this would become plus. So log 2e divided by 2 sigma x square multiply with this sigma x square. So this and this will also get cancelled out, right? So what you are getting now, h of x. Now this goes upward, under root 2 pi sigma x square, this goes upward, then minus sign would come outside. So basically I am writing down everything. So it is coming out to be 1 by 2 log 2 pi sigma x square plus log 1 by 2 is also there. I hope you have understood how did I write down this particular expression. Her under root is there. Under root means power minus 1 by 2. Minus 1 by 2 I am taking ahead. So minus 1 by 2, that would be plus 1 by 2. And this is 1 by 2 log 2e. So what you are getting? Sir, 1 by 2. 1 by 2 I can take common. Log alpha plus log beta. So what you are getting? Log 2 pi sigma x square e. So what you are getting? Differential entropy is log 2 under root 2 pi sigma x square. Extra term is e. That's it. Is that clear to you? Okay. So this should be there in your mind. You need to remember it. Log 2 under root 2 pi sigma x square into e. So how would you remember it? It's a very simple way of remembering it. When you write down the expression of fx of x, how do you write down? 1 upon under root 2 pi sigma x square. Now I am talking about entropy. In entropy I have seen that surely log 2 would come. Okay sir, log 2 would come. And this expression sir I already remember. Under root 2 pi sigma x square. Just e also I need to add. That's it. Usually people remember 1 by 2 log 2 pi sigma x square into e. But we will not remember 1 by 2. We already know that log 2 under root, this particular expression I already remember. This is whole under root, right? Under root 2 pi sigma x square, this is whole under root. So 1 upon under root 2 pi sigma x square, just e also I need to add up. That's it. Okay. So this is how I remember it. Log 2, this I already remember under root 2 pi sigma x square, then e also I will add up. I will get my expression h of x. Okay. So this is my h of x. So for Gaussian random variable, this is something that I need to remember. Is that clear to you? But for your this particular expression, that for uniform PDF I am not going to remember it, but for Gaussian random variable, if my x is Gaussian random variable having mean of mu x, and you can see that differential entropy is actually not depending on mean value, right? It is not depending on mean value, it is only depending on this particular thing. So that is coming out to be log 2 under root 2 pi sigma x square into e. Okay. So this should be there in your mind. We will write down in conclusion as well. Okay. But before that, let's see another question. You can treat this as a question, or from this question as well, we will make some conclusion. Okay. So do you remember one thing? For discrete random variable, h of 2x plus 3, what that came out to be? It came out to be h of x only. Why is that so? Because sir, if I assume this as y is equals to 2x plus 3, that means sir, h of x by y is equals to h of y by x, sir, that was equals to 0, then h of x was actually coming out to be h of y. So here everything conceptually we understood. Discrete random variable means concept, okay, and continuous random variable means mathematics. So conceptually we got to know that h of x equals to h of y, but here your concepts and everything, this will not work. Here what was the meaning of h of x by y? That means uncertainty in x given that I know y is equals to uncertainty in y given that I know x, that was equals to 0. But here small h of x, it is not representing the uncertainty. What it is representing we don't know. This is simply mathematics. So here also you do the mathematics, and with respect to mathematics you make some conclusion. Okay, so let's do the mathematics. What we need to find out? We need to find out h of y. First question is, what is given? X is given. So can you write down h of x? Yes sir. So that would be equals to 1 by 2 log 2 or what we remember, we don't remember this expression, we remember log 2 under root 2 pi sigma x square e. This is what we remember, right? Okay, h of x I know. Now second is y. Y is given as 2x plus 3. So what will be your h of y? Sir, h of y I know that it would be log 2 under root 2 pi e sigma y square. This would be the answer, right? So what will be the variance of random variable y? We have studied the chapter of a random variable. We know that it would be equals to 4 sigma x square. Say yes or no? Variance of random variable y would be equals to 4 into random variable of x. So what you are getting? Log 2 under root 2 pi e 4 sigma x square. That would be equals to log 2 under root 2 pi e sigma x square plus log 2 under root 4. So that is coming out to be h of x plus log 2 this value, because what is under root 4? That would be 2 only, right? So this is what you are getting. This is for the first one. Do I have the page? Yes. Let's see for the second one. Y equals to minus 2x plus 3. So can you just let me know what will be your sigma y square? So that would also be 4 sigma x square. So what do you think? What will be your h of y? If this is same, then here also I will put the same thing. So my h of y again would come out to be h of x plus log 2 this value but mode of this value, right? Are you able to understand this point? Because inside the log you can never have negative, no? What about this one? What do you think? What will be the answer for this one? Y is equals to minus x by 2 plus 5. So sigma y square is equal this thing, right? When you take the power, when you take the variance, minus sign doesn't matter. So sigma square by y. So what do you think? What will be your h of y? Under root 2 pi sigma y square into e. Sigma y square into e directly I will write down. So log 2 under root 2 pi e sigma x square divided by 4. So that would be equals to h of x plus log 2 1 by under root 4. That is coming out to be h of x plus log 2 1 by 2, or you can say it is coming out to be mode of minus 1 by 2, right? So what did you understand? If your x is having an entropy of h of x, okay, what we are making the conclusion here, if x is having an entropy of h of x and your y is defined as ax plus b, then entropy of y, differential entropy of y is given as differential entropy of x plus log 2 mod a. That's it. This is the conclusion. Only for the case of linear transformation we have seen. Only for this particular case we have this conclusion. It is given in NPTEL lecture, that's why we are writing it down. Nothing else. Okay. And here your x was continuous random variable. But for discrete random variable, if they are asking, we will go by pure concept. For discrete random variable, how will you write it down? Everything I have taught. Yes or not? Yes, sir. For discrete random variable, you have already taught everything, right? Only by the pure concept. We will look at the expression of y and x. We get to know that looking at x, I can comment everything about y. Looking at y, I can comment everything about x. That means h of x by y equals to h of y by x equals to 0. Then I know one thing, that h of x, not small h of x, capital H of x plus y by x is equal to h of y plus h of x by y. Sir, both are coming out to be 0. Then h of x would be equals to h of y, right? So this is how we show in our case of a discrete random variable. So when it comes to discrete random variable, pure concept is there. When it comes to continuous random variable, pure mathematics is there. So we are doing nothing here, simply we are doing the mathematics. So what we get to know, our h of y is coming out to be h of x plus log 2a. So just let's write down the summary. Another point is there, one more point we would see, and then we will write down the summary. But as of now, this is something that you have got to know, that in case of a continuous random variable, differential entropy is small h of x, y is defined as ax plus b, then h of y would be h of x plus log 2a. Now what if, sir, this kind of relation is there? Sir, this is your linear transformation, no? Linear relation is there, no? This is linear. Sir, what if some other random relation is there? Then there is no formula. Okay, there is no formula. Pure mathematics we have to do. Okay, only formula we have built up for linear relation. Formula is there only for linear relation. For non-linear relation, no formula is there. No formula for non-linear relation. For non-linear relation. Is that okay for you? There we will have to apply mathematics. How we will do it, that example also we will see. Don't worry. Okay, it will not be asked. Even this will not be asked, I am sure. Because here as well, complete mathematics is there. No, I don't think they will try to test your mathematics in communication system. They will try to test your concept. So if they want to test your concept, then this will come. If they want to try to if they try to test your mathematics, then this will come. But what I feel is that in information theory, they will try to test your concepts, not mathematics. So they will frame it from discrete random variable. This is what I think. Okay. Yeah. So what if there is nonlinear relation? What kind of a scenario we would get? How we will solve the problems? That also we will see. But that is not important. When we will solve the problem, I will write down there, not important. But still, if someone is having the doubt that, sir, how would I find out the entropy? Let's just say some x is given which is normally distributed, having a mean of 0 and variance of sigma x square. Now random variable y is defined, which is equals to y equals to x square. Sir, find out the entropy of y. How would we do it? So that we will see. Okay, we will see that. But before that, another point is there. This is also a very important point. I would say very, very important point. This is a question. With respect to this question, we will make some conclusion. So first, let me know what is the variance of x, what is the variance of y. Sir, variance of y is 1 by 3. 1 by 3. Sir, what is the variance of x? If you clearly remember, I told you one thing, power of x such that x is uniformly distributed between minus alpha to alpha. That would be equals to alpha square by 3, and that would be equals to variance only. Do you remember this thing? So what will be the variance? A square by 3. This will be the variance. Okay. So both random variables x and y are having the same variance. First you calculate what is the value of h of x. So that would be minus infinity to infinity fx of x dot log 2 fx of x dot dx. So this would be minus infinity to infinity. So fx of x would be, so limit would go from minus 1 to 1 only, because it would be non-zero between minus 1 to 1. So limit would be 1 by 2. Surely there will be a negative sign, which I keep on forgetting. Log 2 1 by 2 dot dx. So I would see that, sir, this is coming out to be log 2 2. That means it is coming out to be 1. So 1 bit per symbol. This is what we are getting. So entropy of x is coming out to be 1 bit per symbol. What will be the entropy of y? Sir, entropy of y is coming out to be log 2 under root 2 pi sigma y square into e. So log 2 under root 2 pi, what is the value of sigma y square? 1 by 3 into e. Okay, so solve it. 2 into pi into e. 2 into pi into e divided by 3. Then take the under root and then you take log 2, which is coming out to be 1.25. 1.25 bits per symbol. So what did you see here? For same variance, entropy of y was greater than entropy of x. What was your y? Y was Gaussian random variable. And what was your x? It could be any random variable. This is just an example. So this has been observed. What is the observation? that x could be any random variable. If the variance are same, x could be any random variable. If the variance are same, then entropy would be maximum. The differential entropy would be maximum for the case of Gaussian random variable. So Gaussian random variable would give you maximum entropy, a very important point. What kind of random variable would give you maximum entropy? Sir, Gaussian random variable would give me maximum entropy. Very important point, and this point will play a cameo somewhere in a very important topic. That topic would be channel capacity for continuous random variable. Okay, so channel capacity for continuous random variable, we are going to see a formula. When we derive that formula, this particular thing will play a very important role. So what I am saying, for Gaussian random variable, the entropy would be maximum given that your variance is same with some other random variable. Let's just say I take two random variables. One random variable is x, other random variable is y. Now I am saying that both are having the same variance. Now you choose random variable y in a manner that you get the maximum entropy. So I would say that, sir, I will choose the random variable y as Gaussian random variable. You take any mean, I don't care. Variance would be same as variance of x. So for the given variance, if you need to pick what kind of a random variable I will take such that my differential entropy is maximum, then you would say that, sir, I will pick the random variable to be Gaussian. Is that okay for you? Surely it is okay for you. And for the Gaussian random variable, sir, what is my entropy? That is log 2 under root 2 pi e variance. Log 2 under root 2 pi e variance. Is that okay for you? So all the conclusion we are going to write down. Another conclusion here we have seen h of ax plus b was h of x plus log 2 mod of a. Only for the linear transformation we have seen the conclusion. So this is the slide of conclusion. Okay. So from this slide you will be able to revise these particular slides. Every slide we started differential entropy from here. So whatever we studied about continuous random variable, just everything is written in this particular slide only. In which slide? In this slide. So differential entropy could be negative. Yes, sir. H of ax plus b, only for the case of a linear transformation, what you can write down, sir, it would be equals to h of x, b will play no importance. Here you have seen that this constant value is not playing any importance, this value is not playing any importance, this value is not playing any importance. So it would simply, and this is not applicable only for Gaussian, it is applicable for any kind of random variable. Okay, for Gaussian we have just taken the example. Just through the example I wanted to explain that this formula is coming. It is applicable for any continuous random variable. Okay, it is applicable for any continuous random variable. You can take the example of uniform distribution, you would see that same answer we are getting. Okay, so it is applicable for any continuous random variable, that would be equals to log 2 mod of a. Okay, and if your x is Gaussian random variable which is normally distributed with the mean of mu x and variance of sigma x square, then its differential entropy is given by log 2. Sir, we write down the expression of log 2 under root 2 pi sigma x square multiply with the simply e would also come into action. What will come into action? E would also come into action. So this is something that I can remember very easily. And for a continuous random variable x with the given variance, the differential entropy h of x will be maximum if and only if x is Gaussian. Okay, so if a random variable x is given for a given variance, then if I want to maximize the differential entropy, x should be Gaussian. Okay, so all these 4 points we have seen. Now just a note which you should not be forgetting, that for the case of discrete random variable this was the scenario, but for the case of continuous random variable this is the scenario that we are getting. So both are different thing. This is purely concept based, right, and this is mathematical. Fine. Now someone would be having the doubt, sir, this is linear transformation. What if non-linear transformation is there? So in case of discrete random variable, if non-linear transformation is there, have we seen the example? Have we seen this example, y equals to x square for discrete random variable? Yes, sir. Here what did you tell? That, sir, h of x by y, what that would be equals to? Sir, looking at x, can I comment on y? Surely I can comment. Or it is opposite. Looking at y, can you comment on x? No. This will be non-zero. What will be your h of y by x? Looking at y, looking at x, can you comment on y? Yes, sir. That means this will be equals to 0. So from there, I would get to know that h of x would be equals to h of y plus h of x by y. That means h of x would be greater than h of y. That means h of x would be greater than h of x square. So this kind of relation we have already seen, right? So all these things we have already seen for discrete random variable. Now for the continuous random variable, if this kind of question is coming, then what you will do? Here I am writing not important. Okay, will not be asked in any NPTEL video anywhere. It was not given, but I just thought that if they want to test your mathematics, then they can test a very high level of mathematics here. First thing is that this is nonlinear transformation, right? So when we were studying continuous random variable to continuous random variable transformation, there what did I tell you? That important part is linear transformation only. So there as well I told you that nonlinear transformation is not that important. Now this is not just transformation, this is transformation along with that entropy as well. So this becomes very less important, right? Are you able to understand what I am saying? That when we were studying, sir, continuous random variable to continuous random variable transformation, in that topic as well you said that only linear transformation is important. This non-linear transformation is not that important. Still we studied that. Without applying any formula, with zero formula, we studied this particular topic as well. Right? Now, sir, first I have to do the non-linear transformation, then I will have to calculate the entropy as well. So this becomes very lesser important. Okay, but still we will see that. So pure mathematics would be there, completely mathematics, no concept, nothing, pure mathematics. What you need to calculate? H of y. What will be the formula? Sir, minus infinity to infinity, fy of y, fy of y dy. Now I know one thing, that my x is taking value between -1 to 1. So y would take value from where to where? So x square will take value between 0 to 1, right? So x square plus 3 would take value between 0 to, sorry, if I am adding 3, so 3 I will add on all the side. So x square plus 3 will take the value between 3 to 4. I hope this much mathematics you know. If x is taking value between -1 to 1, then x square will take value between 0 to 1 because square is done. So all the negative value will become positive value. And x square plus 3, that means 3 will be added here, 3 will also be added here. So x square plus 3 will take the value between 3 to 4. So what is this x square? X square is y only. So y will take the value between 3 to 4. But distribution will be, what will be the distribution? The distribution will be uniform only. Is that correct? No. The distribution may change. The distribution remains same only for linear transformation. In case of linear transformation, the distribution never changes. Do you remember this statement? But in case of non-linear transformation, the distribution can change. But one thing I got to know, that limit will be between 3 to 4 only. Now what will be the distribution, that I need to find out. So our task is to find out fy of y. This is something that I need to find out. Do you know how to find it out? Yes sir, I have studied it. How we used to start from? First I would write down the CDF. CDF would say that probability of random variable y taking value lesser than small y. What is your y? Y is x square plus 3. Should be taking value lesser than small y. That means the value of x should be between under root y minus 3 to basically what would be your x square here? Probability of x square taking value lesser than y minus 3. So what should be the probability of x? It would be under root y minus 3 to under root y minus 3, right? So now I will draw the PDF of my random variable x, which is uniformly distributed between -1 to 1. So random variable x is uniformly distributed between -1 to 1. Okay, this is your fx of x. Now I need to find out the probability such that x is between minus under root y minus 3 to under root y minus 3, and I always told you that these points will be found somewhere in between. So this point would be minus under root y minus 3, and this point would be under root y minus 3, and this amplitude will be what? Half. Okay, so this probability will be half amplitude 2 under root y minus 3. So this would be under root y minus 3. So your fy of y is coming out to be under root y minus 3. So what will be your PDF? Sir, my PDF would simply be differentiation of CDF, right? So sir, that would be 1 by 2 under root y minus 3. So this would be my CDF with the value of y going from 3 to 4. 3 to 4. That's it. So I find out my Fy of y. What I need to find out next now? H of x. So not h of x, h of y. Again pure mathematics it is. Y is going from 3 to 4. What is my Fy of y? So that is 1 by under root 2 y minus 3 log 2. ये क्या लिख दिया यार मैंने? What I have written here? What is this? Fy of y minus sign is there, log 2 Fy of y dot dy, and y is going between 3 to 4, that doesn't matter. Okay, right? Yeah. So Fy of y log 2, this value will also come here. Now this integration I will leave up to you. Okay, can I leave it up to you? What you have to do? Assume this as t, then put the limit of t, then apply some formula. Integration is up to you. Even if you are not able to solve it here, once you are done studying mathematics, you would be able to solve it. Okay, can I leave the integration up to you? Okay, I am leaving the integration up to you. You will put the limit, you will do everything. Answer would come out to be minus 0.443. Okay, so this integration is homework. Integration on your own. On your own. If you are not able to solve it now, after studying mathematics, you would be able to solve it. And it is not important, these kind of questions will not come. Okay, very high mathematics is there, no? Again and again mathematics. Till this point, never in the GATE examination they asked about non-linear transformation. They always asked about linear transformation only. Always. In all the question paper, linear transformation only they asked. So first they would ask for non-linear transformation. That means first question that would be coming is finding out this Fy of y. Now the day this question has come, after that these kind of questions can also come. But first this problem would come. So first they would ask you to find out this particular thing, which we already know. So if we already know how to find out this particular thing, then only mathematics we need to do here. Okay, this integration is actually a good integration. So you will do it on your own, and after that you will get the answer. Okay, so Hy of Hy we have calculated. This Hy we have calculated, which will come out to be minus 0.443. I have already done the integration in rough notebook. You can also do it on your own. Okay, well and good. So this was the conclusion of everything that we have studied. This was just a problem. If someone was having a doubt that sir, how would we solve if non-linear transformation is there, then this is how you would solve it. And what was your h of x? In this case, what was your h of x? My h of x was, this case I have already calculated h of x. This was 1 bit per symbol. 1 bit per symbol. 1 bit per symbol. Okay, so h of y is coming out to be lesser than h of x only. H of y is lesser than h of x. Okay, yeah. Now we need to study this particular topic, channel capacity for continuous random variable. Very important, very important. But before that we will study about this channel. What is this channel? This channel will be our AWGN channel. So we will study about that, but first I will take some break and then I will come back. Okay, you can also take some break. So what we need to study? We need to study channel capacity for continuous random variable, but before that we need to make some comment on this channel. Although you already know everything about AWGN channel, but first we will revise it. And another important thing would be there. This time this channel will be band limited to some bandwidth, that is B. Okay, so we will write it and we will study everything about this AWGN channel. Some important point we need to see here, and then we will derive the formula of channel capacity for continuous random variable. Till this point, what is the conclusion? This slide is the conclusion till this point. If you just remember this one, you will be able to solve all the problems. Maximum from this slide, what they can ask? They can ask you the Gaussian random variable they will give you. They will mention the mean value, they will mention the this variance value, and they will ask you what is the entropy. So formula is log 2 under root 2 pi sigma x square e. So only thing that you need to remember is this one. If you want to remember this one as well, then you can remember this particular thing as well, that sir, h of ax plus b would be equals to h of x plus log 2 mod of a. But that is applicable only for continuous random variable. for discrete random variable h of ax plus b was actually coming out to be h of x only, right? And that was based on concept. This is completely based on mathematics. Now we need to study this particular topic, but before that we need to understand about AWGN channel, that we will see after a break. Okay, so flow is clear to you, everything is clear. So let me take a break and then I will come back. Yeah, welcome back. So we will study about channel capacity for continuous random variable now, but before that we need to see about the channel. So what kind of channel we will be using? So we will be using AWGN channel, additive white Gaussian noise channel. So the type of noise will be white Gaussian and the channel will be additive. What is the meaning of additive channel? Let's just say the applied input is x and the noise is n. So output y could simply be given as x plus n. Why did you simply add it up? Because it was a additive white Gaussian noise channel. That means this white Gaussian noise could simply be added with the input. That's why it is known as additive. Okay. So this is our additive white Gaussian noise channel, which will be band limited to B. This time this channel is band limited to B. What does that mean? Channel is band limited to B. So we will make that, but before that, let's talk about the PSD. So since it is a white noise, so PSD of white noise is, what is the PSD of white noise? PSD of white noise is n0 by 2 over all the frequency range from minus infinity to infinity. It is n0 by 2 from minus infinity to infinity for all the frequency range. This is the PSD of white Gaussian noise. So our channel is also having white Gaussian noise, but it is band limited to B. That means effectively channel is there between minus B to plus B only. The channel is there between frequencies of minus B to plus B only. Sir, white noise will have a PSD from minus infinity to infinity. Yes sir. For the frequency range, for all the frequency range, it will have PSD equals to n0 by 2 from minus infinity to plus infinity. But your channel is actually band limited to B. If it is band limited to B, then only this much PSD it will have, no? Right? PSD means power spectral density. So only this much power spectral density it will have between minus B to plus B. So this is your PSD of noise present in the channel. Noise which is present in the channel. Is that clear to you? So what is the total, how much total noise is present in the channel? So that would be n0 by 2 into 2b. So total noise present in the channel is n0 into b, and channel is band limited to bandwidth of b. And since it is white noise, so white noise will have zero mean as well. So what did you comment about the noise now? So noise is Gaussian, having zero mean and total power, or you can call it variance, or you can call it mean square value of n0 into b. Is that clear to you or not? So this is nothing but a variance of the noise. So let me explain everything about the channel once again. Applied input was x, AWGN channel was there. That means the noise was additive white Gaussian noise. So simply output could be written as y equals to x plus n. White noise will have a PSD of n0 by 2 over all the frequency ranges, but our channel was actually band limited to B. That means our noise is also band limited to B only. Our PSD of the noise will also be band limited to B only. So our total noise power would be n0 by 2 into 2b. That means the total noise power would be n0 into b. So this would be given in the examination, that your channel is band limited to b. The value of b could be anything. Now one thing I am asking you to remember. Okay, what I am asking you to remember. So there is a statement, if your channel is band limited to b, then maximum it can send 2b symbols per second. Let's just say the value of b is 2 kilohertz. So in 1 second, maximum it can send 4000 symbols. If your channel is band limited to B, then this channel can maximum send 2B symbols per second. Can you remember this statement for me? Okay, this has been written, just remember it. What we are saying? If a channel is band limited to B hertz, it can transmit a maximum of 2B samples per second, or symbols you can call it. Okay, it is band limited to B, so total maximum it can transmit 2B symbols per second. Can you simply remember it? Okay, it would be used somewhere in our derivation. So what I am saying, My channel is band limited to B, so it can transmit 2B number of symbols. How many symbols can be transmitted in 1 second? That is 2B symbols can be transmitted in 1 second. Okay, so just remember it. So we will move to our topic, but before that, just solve this question. What is our topic? Our topic is channel capacity for continuous random variable. So here I can write down my y would be equals to x plus n. Regarding the noise, what I can comment? Sir, it will be Gaussian noise having zero mean and total power of n naught into b. We can call it as variance of n, right? And what I can write down, y is equals to x plus n, that I already know. Sir, this is Gaussian. This is Gaussian. Now, sir, what I need to find out? First, I need to find out the channel capacity. That means first I need to find out the mutual information. Because what is capacity? Capacity is the maximum value of mutual information. So I will maximize this mutual information. Then what I will get? I will get the capacity. So first I will comment on our mutual information. So sir, this would be the mutual information, but this is not intuitive, sir. What I would be focusing on? I would be focusing on this particular formula more, because this would be easy for me to find out. So I would be focusing on this particular formula. So can I comment on h of y? We will try commenting on it. Can I comment on h of y by x? We will try commenting on it. But before that, you solve this problem for me. Y is equals to x plus n is given. Okay, where x and n are independent of each other. Here also the same thing would be happening, that the input random variable and this n would be given. They will be by default, you need to take that they will be independent of each other. Okay, both of them would be independent of each other. So that has been also given that they are independent of each other. You need to show that uncertainty in y given x is equals to uncertainty in noise given x is equals to uncertainty in noise. So basically this particular statement is already there, no? Like what I am saying is that x and n are independent of each other. Independent. What does that mean? That means this particular thing you already know. H of n by x. Basically, even if you know x, you don't know anything about n. That means whatever the uncertainty in n you are having, the same uncertainty is there, because they are independent. This thing we have already seen, right? For discrete random variable, this thing we have already seen, that if x and y are independent of each other, then h of x by y would be equals to h of x. If you know y, that means you don't know anything about x, because both are independent of each other. So this thing we already know. So what we need to prove? Basically, we need to prove h of y by x is equals to h of n by x. This is what we need to prove. So what I am saying, let x equals to 1. If your x is equals to 1, so what will be your y? Sir, y will be equals to 1 plus n. Now, do you remember this example? Y equals to ax plus b. Here in brief I am writing down y equals to ax plus b. So here what did we write down? Sir, h of y would be equals to h of x plus log 2 mod of a. Do you remember this particular thing? Basically, there is only the effect of b, not the effect of, sorry, there is only the effect of a. There is no effect of b. So if I say a is equals to 1, if I say a is equals to 1, so what I am saying, y is equals to x plus b. So what will be your h of y? So h of y will simply be equals to h of x only, because a is equals to 1. So log 2 1 would be 0. Here what is happening? Sir, y is equals to 1 plus n. So what would be your h of y? Sir, h of y would simply be equals to h of n. X plus b, b could be anything, no? Any random value. Y equals to x plus b. Basically, this is some different example I am taking. There is no relation of this yx and this yx. I am just explaining you that if y is equals to 1 plus n, or basically what you can say is that if I know about n, then I surely know about y. And this is happening for x equals to 1. Let's just say x equals to minus 3. Then what will happen? Then sir, y equals to minus 3 plus n. Then again what you are getting? H of y equals to h of n. So what do you see here? The uncertainty or entropy of y, the differential entropy of y, is coming out to be equals to differential entropy of n, given that you already know x. A very, very important result. Okay, you are not going to find out in any textbook. Very, very important result. How I am getting it? Y equals to x plus n. What is the value of x? X value is 1, x value is minus 3. So I already know x. Then how much uncertainty, or what is the differential entropy of y? Differential entropy of y is equals to differential entropy of n. Here also differential entropy of y is equals to differential entropy of n. So from both of the statement, what I can say, that I already know about x, then both of these entropies are coming out to be equal. I am not saying that h of y is equals to h of x plus h of n. This is not something that I am saying. No. If I know about x, then my differential entropy of y is equals to differential entropy of n. If I know about x, then differential entropy of y is equals to differential entropy of n. This is what I am saying. So are we getting the same thing? Yes, sir. If you know x, then differential entropy of y. If you know x, then differential entropy of n. Both are equal to each other, and that would be equal to h of n. So effectively, what I am able to write down, h of y by x is equals to h of n. Something pretty good, and the most confusing part of channel capacity we have seen here, that h of y by x is actually coming out to be h of n, right? H of y by x is coming out to be h of n. So if I do this derivation and I write down, sir, this is my mutual information where my h of y minus h of y by x is given. Sir, I don't know what I will comment about h of y by x, but I know one thing, that this could be replaced as h of n, right? So what I can do, this could be replaced as h of n. So what I can write down, h of y minus h of n. Can you comment on h of n? What is your noise? Noise is your Gaussian random variable with variance of n naught into b. So what would be your h of n? So log 2 under root 2 pi e, variance is n naught into b. So this would be your h of n. Log 2 under root 2 pi e, variance of n square. This formula I hope you remember. Just now, few minutes back only we studied this formula. So log 2 under root 2 pi e, then variance square. I should not say variance square, this is variance only. So what do you mean by variance square? So simply it is variance, not variance square. So under root 2 pi e, variance. Variance is n naught into b. Okay. Yeah, so this is our h of n. Now we need to comment on what we need to find out. We need to find out channel capacity. So what will be channel capacity? So channel capacity would be maximum of mutual information. Sir, what I need to do? Sir, I need to maximize this particular thing. Minus h of n, I already know. This is my h of n, which is a fixed value. Sir, I need to maximize this particular thing. Do you remember one statement? Which statement? This statement. For a continuous random variable x with given variance sigma square, the differential entropy will be maximum if x is Gaussian. So if I want it to be Gaussian, if I want it to be maximum, if I want this h of y to be maximum, then y has to be Gaussian. Say yes or no. Is that clear to you or not? So what I am assuming, I am not assuming, actually this is the true case, that y is equals to x plus n. I am already sure that this is Gaussian. If I want it to be maximum, then it has to be Gaussian. That means by default my noise has to be Gaussian only, because you know that x would be simply equals to y minus n. If this random variable is Gaussian, this random variable is Gaussian, then x has to be Gaussian only. What I have seen in a lot of lecture, people say that, sir, we have assumed that x is Gaussian. No, we did not assume it. X being Gaussian is not our assumption. What we are finding out, capacity is always found out with respect to maximum. Whenever we find out capacity, we always find it out with respect to maximum. So here we need to find the maximum value of h of y. If I want it to be maximum, that means I need to take y to be Gaussian. And if y is Gaussian, then x by default will be Gaussian. Is that clear to you? And is this thing also clear to you, that how h of y by x is written as h of n? In a lot of lecture I have seen that, sir, h of y by x represent noise. So that's why we can replace it by h of n. Absolutely wrong. This is the reason that y or h of y by x would be replaced by h of n. Okay, at a lot of places you would see that h of y by x is replaced with h of n. What they will say, this is just a component of noise, that's why you can replace it by h of n. Absolutely wrong, doesn't make any sense. And again, taking x as Gaussian, it is not our assumption. This is by default, it is coming out to be Gaussian only. Because if I want it to be maximum, it has to be Gaussian. If I want h of y to be maximum, that means y has to be Gaussian. Is that clear to you? Okay. So now can you write down something about channel capacity? So what will be your channel capacity? So again, let me write down channel capacity is nothing but h of y maximum minus h of n. What is the value of h of y maximum? What that would be? So log 2 under root 2 pi epsilon sigma y square minus this value already we know 2 pi epsilon sigma n square. Okay. Now y is equals to x plus n. Now both are independent of each other. That means their covariance will be equals to 0. This very basic thing we have already seen in our random variable chapter. So x and n are independent of each other. That means their covariance will be 0. So if they are independent, then simply you can tell one thing. What you can tell that what will be your sigma y square? So that would be sigma x square plus sigma n square. Right. So under root I am taking outside. What I am doing? So 1 by 2 under root I am taking outside. Log 2 pi e. In place of sigma y square, what I am putting? Sigma x square plus sigma n square divided by 2 pi e. Basically log a by log b. What I am doing? Log a minus log b. Log a minus log b. So it would be log a by b. So log a by b. One by 2 log 2 2 pi e would get cancelled out. Sigma n square divided by sigma n square, that would be 1 plus sigma x square divided by sigma n square. What we are getting? Channel capacity. What is this sigma x square? Isn't it the input power? Sigma x square, what is sigma x square? Isn't it the input power? Yes sir, it is input power. And what is this? Noise power. So isn't it representing SNR, signal to noise ratio? Sigma x square is representing your input power, which I am calling as P. And what is your sigma n square? That is noise power, that I am representing by n. So P by n could be represented as this particular thing, and that can be represented as signal to noise ratio. So this could be said 1 by 2. Just let me know the unit here. Just let me know. This is the first formula that is coming out to be, and let me know the unit. Nothing you need to remember. What you need to remember, we will write down everything in the conclusion. Just as of now, you keep on looking at the screen. That's it. So what will be the unit? From where did we start? From here we start. What is the unit of h of y? Bits per symbol. Bits per symbol. So this is also bits per symbol. Somewhere you would find out that unit is written as bits per channel use. Bits per channel use, or let me write it down in statement. Bits per channel use. What is the meaning of bits per channel use? That means over the channel at a time how much symbol you will be sending. One symbol only you will be sending. No? Let's just say your source is generating 10 symbols. Your source is generating 10 symbols. So when you are using the channel for one time, it is not 1 second or anything. Like if I am using the channel for one time, that at a time I can send only one symbol. No, like first x1 will go, then x2 would go, then x3 would go, then x4 would go, then x5 would go. So at a time only one symbol would go. No? Right? At a time only one symbol would go. So bits per symbol or bits per channel use, both are the same thing. That means if I am using my channel one time, so at a time I am sending one symbol only. So you can say that this much bits per symbol you are sending, or this much bits per channel use you are sending. That means if you are using the channel for one time, then this much bits you are sending. Now this is the channel capacity that you are getting, but you know that if my channel is band limited to B, if a channel is band limited to B, then we can send to be symbols per second over the channel. And what I need to find out? I need to find out capacity in bits per second. What I need to find out? I need to find out capacity in bits per second. So what I would do? 1 plus SNR, right? This I already got. Having the unit of bits per symbol, and I am sending 2B symbols per second. So what is the answer you are getting? 2 and 2 will get cancelled out. So channel capacity is coming out to be B log 2 1 plus SNR. So this is the formula that student directly remember, having the unit of bits per second. If I am a question paper setter, then deliberately in the question paper I would give the value of B, but I will ask you the capacity in bits per channel use or bits per symbol. What I am saying, in the problem what I will give the SNR value, I will give the channel bandwidth as well, okay, and then I will ask you the capacity in bits per channel use. Everyone will apply this formula and they will find out the capacity in bits per second. But what I would say, that how much bits of information is passed if I am using the channel for one time, and people will apply this particular formula, which would be wrong. You need to apply this particular formula. So what you remember this one, but always remember that this is in bits per second. And you know one thing, that if my channel is band limited to B, that means I am sending 2B symbols per second. And at a time, if I am using the channel for one time, that means I can send only one symbol. So that means if you are sending this much symbol, that means you are using the channel 2B times. So if you need to use the channel one time, then what you need to do? You get this expression and divide it by 2B. So if I divide it by 2B, what I will be getting? 1 by 2 log 2 1 plus SNR. So don't remember this formula. Don't remember this formula, because if you remember this one as well and this one as well, then you will be messing it up in the examination. Till this date, always they have asked this particular formula only. But what I feel is that this time they are going to ask bits per channel use. Okay. So don't remember this one. Which one you will remember? This one I will remember. If I remember this one, I know that it has been derived by multiplying 2B symbols per second. So what I need to do? I need to ignore this 2B symbols per second and I will get my answer. So I will divide this particular formula by 2B and I will get bits per channel use. So if I am sending only one symbol, here what you are doing? Here you are sending 2B symbols. So if you are sending only one symbol, then how much bits of information is being passed? Or better I should say, how much information your channel can actually pass. So this is the maximum information your channel can pass. What it is? It is the maximum information your channel can pass if you are using the channel only one time. Here your maximum information that can be passed through the channel in 1 second. In 1 second. This is in 1 second. In 1 second, how much information through the channel can be passed? How much maximum information through the channel can be passed? Is that clear to you? All the statement is clear. If you know the meaning of capacity, if whatever that I am saying, that would be clear to you. Okay, if you are only focusing on formula, then things will not be working for you. But if you are focusing on the concept, what is the meaning of capacity? Capacity was maximum information that can be passed. So maximum information per second that can be passed, that is this capacity. But if I am asking per symbol use, if I am asking per channel use, or if I am asking per symbol, then this is the formula that we need to apply. So both formulas are important. This is what I am saying. You remember only one formula, other one you would be able to derive. All good? So basically what did we show? Our y was equals to x plus n. So this was having a power of p and this was having a power of n. Okay, power of n only. Yeah. So then this formula came. So basically when you are writing down SNR here, no, so don't look at the input, don't look at the noise, look at the final expression of y. This expression output is important. In the output, how much part of noise is there and in the output how much part of signal is there and how much part of noise is there. What I mean to say is that let's just say your output is 2x plus 2n or 2x plus n. So this is the part of a signal and this is the part of noise. So when you write down log 2 1 plus, here b would be there, log 2 1 plus SNR. So what will be the signal power you will be writing now? Let's just say if random variable x is having a power of p. So what will be the signal power of 2x? That would be 4p, right? Basically, if x is having a variance of sigma square, then 2x will have a variance of 4 sigma square. So here power will be 4p divided by this noise power, that would be n only. Is that clear to you? So whenever you write down SNR, you look at the output because you see the derivation. You see the derivation. In the derivation, we cared about the output here. Sigma y square we replaced. What we replaced? Sigma y square. So here also we are going to do the same thing, no? If y equals to 2x plus n is written. So sigma y square, that would be written as 4 sigma x square plus sigma n square. And here in this part sigma n square only would come. So that would be divided by sigma n square. So this will get cancelled out, 1 plus 4 sigma x square divided by sigma n square. This is what you will be getting. And then log 2 would be there, and here 1 by 2 would be there, which will be multiplied with 2p. So are you able to relate the derivation? So from the derivation we get to know that our output expression is important for us. Not the input power, that is not important. This noise power, that is also not important. Whatever the output expression that we are getting, that is important for us. So we will see the output expression. Based on that output expression, we will write down our channel capacity. Log 2 1 plus signal power. Just let me know what could be your noise power. So that was n0 into b. You already derived it, sir. Here only you said it was n0 into b. Because our PSD is n0 by 2 and channel is band limited to 2b. So total power would be n0 into b. Okay. This is the thing. Now let's just say our symbol x was there, which was transmitting some number of symbol, I don't know. Some number of symbols, I don't know. So all these symbols were having EB energy, EB average energy. So can I say all these symbols were having average bit energy of EB? That means EB will have a unit of joule per bit. What is your EB? EB is the average energy per bit. Let us just say x1 was having 2 bits. So these 2 bits were having energy of 2 joule. So per bit you are having energy of 1 joule. Then x2 was having 3 bits and the total energy was 7 joule. So per bit you are having the energy of 7 by 3. Then you take the average of both of them, 1 joule plus 7 by 3 divided by 2. Whatever the answer that you are getting, that would be 10 by 6. So this is the average energy per bit you are getting. Is that clear? So what I am saying, whatever the symbols that are being generated, these symbols are having this much average energy. So what is the unit? Joule per bit. Right? I just need to replace the expression of power. What is power? Sir, power is watt. And I hope you remember this expression, sir, E is equals to PT. That means watt is nothing but joule per second. Right? Now what is our bit rate? Bit rate is this much bits have been produced per second. RB is the bit rate. This much bits have been produced per second. So what do you think, what could be the power? EB into RB, because what will be the unit? Bit and bit will get cancelled out. Joule per second. So power of source X could be written as EB into RB. Is that clear to you or not? EB is the average energy per bit and RB bits are being produced per second. So what will be the total power? EB into RB. Is that clear? By the unit everything is clear, right? EB is having a unit of joule per second, RB is having bits per second we are assuming. So total power is EB into RB. That means joule per second we are having. So what do you get to know? Channel capacity is B log 2 1 plus EB into RB and not B. But do you really think that, sir, I am going to remember all these formula? No, only formula that I am going to remember is this one. That's it. If I remember this one, everything I can derive. C equals to B log 2 1 plus SNR. That's it. This is the formula that I'm going to remember. SNR is find out with respect to the output. Signal component would be there, noise component would be there. So signal power divided by the noise power. So with respect to the output, you actually find out SNR, not with respect to the input or noise. In most of the cases, in 99% of the cases, y equals to x plus n would be given. But what if I change the problem, y equals to someday 4x plus 3n, this kind of output you are getting? Then you would know that, sir, here in the expression sigma y square, actually I would have been putting 16 sigma x square plus 9 sigma n square. And here in the noise, sir, I would have been putting 9 sigma n square only. So answer I would be getting 1 plus 16 sigma x square divided by 9 sigma n square. So this would have been the scenario, right? So derivation step, everything should be crystal clear to you. Every step should be crystal clear to you, because if I want to frame a good problem, then this is how I will be, like this is how I will be troubling you. Okay. Yeah. So the channel capacity versus bandwidth relation we are going to see. Now one simple thing is there. This is my channel, which is, I am saying that it is band limited to B. Channel is band limited to B. And what is the meaning of capacity? Capacity is maximum information that can be passed. Maximum information that can be passed. Now, if I am saying that my bandwidth is 0, forget about the formula. I am just simply saying one thing. If bandwidth is 0, how much information do you think you can pass? Let's just say there is some signal coming which is having a frequency spectrum of this much. This is the frequency spectrum of your input. Okay, this is the frequency spectrum of your input. Now, channel is having no bandwidth. No bandwidth means there is nothing. Basically, channel is not even existing. Zero bandwidth means you cannot pass any information, no? Simple thing, right? At zero bandwidth, your capacity would be 0. If it is 0, that means it cannot pass any signal. Some bandwidth has to be there, no? This kind of bandwidth could be there, this kind of bandwidth could be there. Some bandwidth has to be there to pass a particular signal. So if there is no bandwidth, that means I cannot pass anything. So capacity has to be 0. And by the formula as well, you can see. How would you see? Let's go by the mathematics. 1 plus signal power. So two things are there. You would be thinking that sir, if I'll be putting 0 here, then capacity would be 0. But no, this thing is also there, no? So this term would become infinity. So 0 into log to infinity. Do you remember this? 0 into log to infinity. What that would be? So that would be 0 only. No, 0 into log to 0 we have taught, not log to infinity. Sorry guys. 0 into log to 0, we know that it would be equals to 0, not infinity. So again, here we need to apply the formula. What we need to do? So let's just assume that I don't know the capacity is equals to 0 when your bandwidth is 0. So what I would do? So I need to find out the capacity C value such that B is going towards 0. So limit B tending to 0, B log to 1 plus P and not B. Okay. So this is 0. If I put 0 here, this would become infinity. Log to infinity is infinity, right? So I can make it infinity by infinity form. So limit B tending to 0, 1 plus P by N naught B divided by 1 by V. Now what I can do? I can apply L'Hopital rule, right? So L'Hopital rule we will apply, and we will see that the same answer we are getting. So this can be written as log I will have to replace by ln. So downward what I will get? ln2. Differentiation, I hope you know how to do this differentiation, right? I have done the differentiation of ln into 1 plus P by N naught into B. So that differentiation is 1 by ln2 is already there. 1 ln x is 1 by x. Then I have to differentiate this particular thing as well. And then 1 by B is minus 1 by B square. So this and this will get cancelled out. If you put B tending to infinity, what you will be getting? This would become 0. ये क्या हो गया? something is wrong. Arey yaar, b tending to 0 we need to put, not infinity. What I am doing, b tending to 0 we need to put, no. So this b square and this b square is getting cancelled. If I put b equals to 0, what it would become? Infinity. 1 plus infinity is infinity. 1 by infinity is equals to 0. So such that, I hope you have understood this. B tending to 0 I need to put. This b square is getting cancelled out. B tending to 0. So 1 upon 1 plus b tending to 0. This is p by 0, that would be infinity. 1 upon infinity, what that would be? That would be equals to 0. Right? And it is pretty obvious as well from your simple intuition that if channel bandwidth is 0, capacity would be 0 only. Right? So at 0 channel bandwidth, capacity is 0. Okay, which was pretty obvious as well. No mathematics was required. But now what do you think? First thing is that, sir, if I increase the input power, if I increase the input power, then sir capacity would increase. It is pretty obvious. If input power is increased, like if you are passing a very good signal which is having good power, then surely your channel would be able to pass more information. So if I increase the input power, my capacity would increase, right? But if you increase the bandwidth, now if more bandwidth is there, that means I will be able to pass more information. This is what it feels like. Like if this is the bandwidth, then what if I have made the bandwidth something like this? So if more bandwidth is there, that means more information I will be able to pass. That means if infinite bandwidth is there, so I will be able to pass infinite information. If bandwidth is increasing, that means I will be able to pass more information. That is pretty obvious by our intuition. Forget about the mathematics. But what our intuition would say, that if you keep on increasing the bandwidth, then infinite information you would be able to pass. That means the value of your capacity at infinite bandwidth would be infinity. Is that true? If you put infinity here, infinity log to 1 plus some value whatever it is, divided by infinity. So what it would become? Infinity into this would be 0, log to 1 is 0, infinite into 0, undeterminate form. Again it is a undeterminate form. So if it is an undeterminate form, that means you need to apply the mathematics. So it feels like that if you keep on increasing the bandwidth, then channel capacity will increase. That is fine. But at infinite bandwidth, are you able to transmit infinite information? No. Some constant value would come. So capacity will increase, but later on it will saturate. Is that clear to you? So what constant value will come, that we will see. But is the concept clear what I am saying? If I keep on increasing the bandwidth, more bandwidth, more information could be passed. Right? But at infinite bandwidth, what will be the value of your capacity? So limit b tending to infinity, capacity would be 1 plus SNR, which will be signal power and not into b. Right? So again it is coming out to be 0 into infinity. So I can make it 0 by 0 form. So what I would do, limit b tending to infinity. This mathematics you should be doing on your own. I will make it ln. Why I am making it ln? So that I will, because I know that I will have to do the differentiation. So I am making it ln. So this 2 goes downward and this becomes 1 by b. Okay, every single thing we have already seen. Log 2 1 plus p by n naught into b would be there. So I have made it ln so that this goes downward. This ln 2 goes downward. Right? So let's do the differentiation now. I can apply the L'Hopital rule. So what I will be getting? So limit b tending to infinity 1 upon 1 plus this particular thing minus sign will surely be there, divided by This ln2 is a constant value that will surely be there. Okay. Now what do you see? This b square and b square will get cancelled out, and this negative sign and negative sign will get cancelled out. And if you put b tending to infinity here, what it would become? P by infinity, that would be 0. So this part would become 1 only. If b is tending to infinity, this part would become 1. So what you are left with? Sir, this part has become 1. On the upper part, sir, I am left with p by n naught, and sir, downward I am left with 1 by ln2. So what answer we are getting? At infinite channel bandwidth, that means b is tending to infinity. So limit b tending to infinity, your channel capacity is 1 by ln2. What is the meaning of 1 by ln2? Basically 1 by ln2. It is nothing but 1 by log base e2, that could be written as log base 2e. So that is coming out to be log base 2e into p by n naught. So you will be remembering it. Okay, this formula you will be remembering it. Log base 2e will have a certain value. As far as I remember, it is 1.44. As far as I remember, it is 1.44. Yeah, 1.44. So better you remember this expression 1.44 p by n naught. So any of the expression that you want to remember, just you will remember one thing, that channel capacity. This I am ignoring it. Okay, you already know how to write down this expression p by n naught, and this 1 by ln2 could be written as log 2e. So channel capacity at infinite bandwidth is coming to a constant value, that is 1.44 divided by 1.44 p by n naught. In the examination you will not be deriving it. Okay, this L'Hopital rule you will not be applying there. So better you remember p by n naught 1.44, or log 2e you can remember. But in the examination people can get confused, log base e2 was there or log 2e. But you know that in information theory always we are writing down formulas with log base 2 and then some value. So log base 2e p by n naught. So you will remember it. And can you see one thing, capacity versus bandwidth curve? If we see, this is capacity versus bandwidth, keeping this power constant. Okay, this power is constant, keeping this power constant. What we are varying? We are varying our bandwidth only. So this kind of curve we are getting. At some time, after some time, it is saturating. At infinite bandwidth, it is going to saturate. At very high bandwidth, it will saturate. So this kind of curve we can make, right? So with increasing bandwidth, surely your capacity would increase, but after some time, it will saturate to your maximum value, and that maximum value it can attain would be for a given band, for a given power p, and for a given noise phd, it can achieve the maximum value of 1.44 p by n naught. P by n naught. Okay, so this is actually a very important answer which should be remembered. So let's write down all the summary that we have seen, or let's first revise what we have studied. This was our AWGN channel, right? What kind of channel was there? AWGN channel, additive wide Gaussian noise, PhD of n naught by 2 over all frequency, but it is band limited to b. That means our total noise would be n naught by 2 into 2b. And then this particular thing that we find out that if this expression is there, y equals to x plus n, then h of y by x would be equals to h of n, right? And then we saw this derivation where we can replace this as h of n, and then we go to all these answer. From here we go to know that this is the answer we are getting in bits per symbol, but if channel is band limited to b, that means 2b symbols per second we can transmit. So this much bits per second information we are able to transmit, which is b into log 2 1 plus SNR, where SNR is the signal to noise ratio, but that is calculated looking at the output expression, not input or noise expression. Okay, looking at the output, in output how much things we are having, looking at that particular expression you are writing down this channel capacity. Okay, Then we saw at the 0 bandwidth, channel capacity would be 0 only, because if bandwidth is 0, you will be able to transmit 0 information only, right? But if bandwidth is infinity, you felt like that, sir, I will be able to transmit infinite information. That means my capacity would be infinity, but actually it is coming out to be 1.44 into input power divided by n naught. This is what it is coming out to be. So this is the everything that we have studied, and we can write down all the conclusion. If x is Gaussian random variable, then with respect to x, what is something that you need to remember, that sir, if x is Gaussian random variable, then its differential entropy would simply be, sir, log 2 under root, again and again we have written down this formula. So till this point you should be able to remember. And sir, if x is passed through a channel, AWGN channel, which is having PSD of n naught by 2 and channel is band limited to b, then our output y could be written as x plus n. We will assume that both x and n are independent to each other, okay. Then channel capacity was actually coming out to be b channel capacity. So let's write down everything that we know. So channel capacity C was coming out to be, sir, b log 2 into 1 plus SNR, okay. So that was bits per second. Sir, if I need to write down in bits per symbol, then sir, it was 1 by 2 log 2 1 plus SNR. So bits per symbol you can call it, or you can say bits per channel use, for one symbol, bits per symbol. So how much information per symbol is passed? Then we saw that, sir, at 0 bandwidth my capacity was 0, but sir, at infinite bandwidth you expected that capacity would reach to infinity, capacity would go to infinity, but sir, actually it was saturating to this much value. Is that clear? 1.44 into P divided by n naught, okay. So this is the conclusion of a differential entropy. Like from here as well, whatever that you are studying, this was one last slide, not on this one. On this slide we have seen the conclusion and all these conclusion that we have seen, and then this is the slide which is of the conclusion, okay. So when you are revising, you will revise all these things only. Try this question, it is very easy, okay. I will take a break, you try this question, you try this one as well, then we will see some relation between channel capacity and information rate, okay. So try this one and this one, very simple question, and then we need to see some concept, very simple concept, very easy concept as well. So let me take a break and then I will come back. We will continue our discussion on problem solving, okay. So signal power is P, Gaussian random variable it is, x is a Gaussian random variable having 0 mean, the signal power is P. Two kind of channel are there, both are in parallel, okay. So both AWGN channel are having, both are same channel, both are identical channel. So both identical channel having PSD of n naught by 2, band limited to b, and x and n are independent to each other. Basically x and this n are independent to each other. So this should be given, x and independent. This would be given in the problem. Band limited to b, this is y. What you need to find out? You need to find out this total channel capacity, okay. This whole channel that you see, that channel capacity you need to find out. So this is the problem. You would see it is a good question. You can kind of you can call it a good question. Otherwise, you would be able to solve it in one line only. So you try doing it. I will come back and we will solve it. Okay. So x and n are independent to each other. I will write it down with a different color of pen. X and n independent. Okay. So yeah, I will come back and I will solve it. Yeah. So did you try this question? So first task would be to find out the channel capacity in bits per channel use, okay, and then we will multiply with the 2b or 4b. What we will multiply with, that we will see. So first task would be that you find out the channel capacity in bits per channel use, bits per symbol you can say, or bits per channel use. This is what you find out. This is the first task. So one method would be that you go by the formula, other method would be that you forget about the formula, you go by the pure concept. So first let's go by the pure concept. So what do you think, what is your y? First let me know. We are seeing method 1. What is your y? Sir, here x would be added with n, x plus n. Here as well, sir, x would be added with n. And then, sir, both will be added. So simply y would be 2x plus 2n. So I am not applying any formula, nothing like that. I am simply going by the pure concept. Now you know that your n is Gaussian, right? N is a Gaussian random variable having 0 mean, and since your channel is band limited to b, that means its power will be n naught b, or I can say simply it is having a mean square value of n square, where sigma n square would simply be n naught b. Now what about 2n? Can you comment something on 2n? Sir, 2n will also be a Gaussian random variable with zero mean and variance of what? Comment after taking some time. What will be the variance? 2 sigma n square or 4 sigma n square? It would be 4 sigma n square, right? Basically, y is equals to 2x. So sigma y square would be equals to 4 sigma x square. So n is replaced with 2n. If x was having a variance of sigma x square, then 2x would have a variance of 4 sigma x square, right? So similar thing is happening here. Okay, so 2n is nothing but a random variable only. So I am calling this random variable as n dash. So 2n is a random variable n dash, which will also be Gaussian only with zero mean and a variance of 4 sigma n square. Okay, same goes for 2x as well. Like 2x is having x is having zero mean and a power of p. So x is your random variable, which will also be Gaussian only, and it is given as well. It is Gaussian with zero mean and a power of p, that means variance of p. So what do you think? What will be your 2x? 2x will also be a Gaussian random variable with the power of 2p or 4p? 4p, right? Because 2x, that means variance will be 4 times. So power of 4p. So this also I am calling as x dash. So what is my scenario? Y equals to x dash plus n dash. Now this particular thing I have seen. Like basically what was the problem with this one, sir? Sir, you solved with respect to y equals to x plus n. You did not solve with respect to y equals to 2x plus 2n. So that's why, sir, we are not finding it good to apply the formula here. What we find it good, we can apply the formula here now. So sir, what will be the formula now? So now I can find out the capacity per channel used would be, sir, this formula I remember, log 2 1 plus SNR. So here what you will write down, sir, 1 by 2 log 2 1 plus power of x bar divided by power of n bar. Is that clear to you now? Or what you could have done, like simply you could have gone by this approach. In a very quick manner I am solving it. What would be the channel capacity? It would be h of y maximum minus h of y by x, right? Now h of y maximum, you already know what that would be. So log 2 1 by 2 will be outside, 2 pi sigma y square. So there is no issue with this one. Now what about h of y by x? So what will be your h of y by x? So sir, y is equals to 2x plus 2n. Now if I put x equals to 1, then y is equals to x plus 2n. And if I put x equals to minus 1, then y is equals to minus 2 plus 2n. So basically what I can see is that, sir, here also 1. So basically what I can see that entropy of y, here entropy of y is equals to entropy of n plus log 2a, right? Because this is the scenario of ax plus b. So this a will also come into action, no? So here entropy of y is equals to entropy of n plus log 2a, where a value of a is 2. So what you would write down? Entropy of y such that x is known is equals to entropy of noise, entropy of n, not 2n, entropy of n such that x is known plus log 2, that would be 1. So you put down this value, you do the whole analysis here. Then basically h of y by x would be replaced with h of n by x minus 1, because there is a negative sign. Now h of n by x, noise and x are independent of each other, so this would be replaced with h of n. Now can you comment on h of n? Surely I can comment on h of n. So 1 by 2 log 2, so 2 pi sigma y square. What will be your h of n? So this would be 1 by 2 log 2 2 pi sigma n square. And what could be your 1? It could be 1 by 2 log 2 4, right? 1 could be written as 1 by 2 log 2 4. Because what I need to do, I need to make this form 1 by 2 log 2, 1 by 2 log 2. I want to make this form. That's why I am doing so. And then you would realize that you will be getting the same answer. Is that clear to you? I did not want to do this much of whole analysis. That's why I put smartly here, because I know that if my n is Gaussian random variable, then 2n will also be Gaussian random variable and 2x will also be a Gaussian random variable only. And with respect to Gaussian random variable, I already know the formula. But what does the formula say? That you go with the expression of y equals to x plus n. Some power, signal power plus noise power. You go by that formula, then sir I am applicable. So we converted this form into this form, and now I can confidently apply this formula. Otherwise, this kind of method also I could have done if I am not comfortable with the formula and all. So without applying the formula, this is how I could have proceeded. This is the pure mathematics, like this is how you should have thought. The best part was here your h of y by x was not equals to h of n by x. It was equals to h of n by x plus 1. This 1 is also coming because of this 2n. Is that clear to you? Right? So in the examination, better you take the signal part one side. Basically this was your signal part, this was your signal part, and this was your noise part. So take the signal part one side and then analyze it separately. Here we have analyzed the signal part separately, right? This analysis about the signal part we have done, and this analysis about the noise part we have done. So take the signal part, take the noise part, and then put your y, okay, and then apply the formula. That would be the best possible way. All good? Otherwise you could have gone by the other method as well that I showed. I will leave one page for you. I will leave this page for you. You can put the analysis that just now I showed here. Okay, this analysis that I showed here, that analysis you can put on this blank page if you want to put. Otherwise in the examination we would be going by this approach, and that approach simply says that 1 by 2 log 2 1 plus power of x dash, power of, and this is coming, okay, this is coming in your gate examination very soon, either in 26 or in 27 or in 28. Within 3 years you would see that they will put 2 channels in parallel for sure. For sure I am saying. What may happen is that they will call this one as n1 and this one as n2. But for sure they are going to do this thing. Even if this is n1 n2, you would be able to do the analysis. Right? So power of x dash would be power of x dash, that is 4p plus power of n dash, sorry, divided by power of n dash. Power of n dash is 4 sigma n square. So what did you notice here? Even if there was one channel, then also we were getting the same channel capacity. What will be the unit? Bits per symbol or per symbol we can write down. So are we getting the same thing? Yes sir. What was the formula that we studied? 1 plus log 2 SNR. So our applied symbol was X. If there was only one channel, then only one noise component would have been there. So applied input was X. That means here I would have written the signal power, that would have been P. And then only one channel would have been there. That means that would be the noise power. I would have put here sigma n square. So I would have got the same answer. Now the task would be that, sir, I will find out the answer in bits per second. So what did you say? That if your channel is band limited to B, if your channel is band limited to B, then a channel band limited to B can transmit a maximum of 2B samples per second. Right? So this statement is actually not completely true. What I should have written is that if your channel is band limited to B hertz, then the source can transmit. If your channel is band limited to B hertz, then your source can transmit a maximum of 2B samples per second. Basically, from where the sample would be coming? The samples would be coming from the source only, no? Source, let's just say source is generating some 10,000 samples. Source has generated some 10,000 samples. Now the value of B is 2 kilohertz. So in 1 second, only 4 kilo samples, that means only 4,000 samples can be passed. That means from the X, 4,000 samples can be passed per second. Is that clear? Right? So here it should have been mentioned that if your channel is band limited to B, then your source will be able to pass 2B samples per second through the channel. Okay. Now a very interesting part would come, like what people will be thinking in this analysis, that sir, if I need to find out C here, what you would multiply with, sir, 2B or 4B? Like someone would say that, sir, 2B samples can pass through this channel and 2B samples can pass through this channel. So total 4B samples would be passing. You are correct if here you would be having x1 and here you would be having x2. That means source were different. If you were having different sources, then from x1 you would have passed 2B, from x2 as well you would have passed 2B. But there is this whole channel. Basically, what is the scenario? That there is this one whole channel, applied input is x and output is y. Now what is happening here in this channel, I don't know. I don't care about that. Effectively, this is my channel and I am finding the capacity of this particular channel. I am finding the capacity of this whole channel. Right? Is that clear? Now there is only one kind of source, right? Only one kind of source. This channel can take 2B samples per second from here, and this channel can also take 2B samples per second here. And both will be taking the same samples only, no? Like if they were x1, x2, then this channel would be taking 2B samples of x1 and this channel would be taking 2B samples of x2. So 2B sample of x1 and 2B sample of x2, both were different. So effectively this was transmitting 2B different samples, this was transmitting 2B different samples. So total 4B different samples were being transmitted. But here only one source is there. This channel will say that, sir, I will take 2B samples. This channel will say that, sir, I will take from x, I will take 2B samples. And this will also say that I will take 2B samples. And both are taking the same 2B samples only. Are you able to understand this point? If x1, x2, two different inputs were there, if two different sources were there, then this would have taken different 2B samples, this would have taken different 2B samples. But if only one kind of sample is there, if only, I should not say sample, if only one kind of symbol is there, or one kind of source is there, if only one kind of source is there, that means this is also taking 2B, this is also taking 2B, but the 2B that they are taking, they are same only, no? So effectively your channel is transmitting 2B samples per second only, no matter how many channels I put. Let's just say here I have put 10 channels. In parallel, I have put 10 channels still. Effectively, from the whole channel, from this whole setup, 2B samples of X is being transmitted because all those samples are same. Is that clear or not? I hope it is clear. Okay, like from the textbook from where I have taken this particular question, in that textbook they have asked till here only. Okay, and in the examination as well, I am pretty sure they will be asking till this point only. But if they are asking after that as well, like in bits per second, then you would notice the input. If input if inputs are different, that means 2B samples here, 2B samples here, so total 4B samples are being passed. but if the input is same, if input is same, that means from your source X only 2B samples are being passed, although all the channels are carrying 2B symbols, but they are the same symbol only. So through the channel, effectively in 1 second 2B symbols are only being passed because the input is same. Is that clear to you or not? Okay, but like in the examination, I am pretty sure they will ask till this point only. Pretty sure I am. Okay, the unit they would mention is bits per channel use. Basically, this setup would be given, and then the question would be stating, they will not ask channel capacity. The question will simply say, find out then find out the maximum number of bits that can be passed through this channel if we are using the channel one time. Okay, per channel use, how many bits of information could be passed through this channel? This would be the language of the question. Maximum number of like maximum information in bits that could be passed through this channel per channel use. What that would be? So basically they are asking about capacity only. Okay, so this would be the answer, right? So bits per channel use. Now what I am writing down, since x1 equals to x2 equals to x, 2B symbols from source X are being transmitted per second over the channel. So your channel capacity would be B log 2, because 2b will be multiplied here. So 1 by 2 into 2b would be B log 2 1 plus sigma n square bits per second. That would be the answer. Is that clear? Okay. Other analysis also I taught you that you can write down here. Somewhere here you can write down. So this was a good question. Basically, these kind of setup they can make. They can make other kind of setup as well. Like basically, you should be having good enough knowledge of solving this kind of setup. Shall we make another problem? Like we can frame one more question as well. I can try framing it with respect to discrete random variable as well. Like x is taking. This question was there in that book only. Like till this date, whatever the questions have been framed in information theory. Although from that particular book, I will write down all the questions. Don't worry about that. So till this date, whatever the questions have been framed from information theory, all the questions are directly from the textbook. Okay. You can ask me the name of that textbook on the Telegram group. I will tell you the name. Okay. Here I am not telling the name because I actually don't remember it. Okay. That is written by some IIT professor only. His lecture only I am following. I forgot his name as well. The playlist name is Information Theory, Coding and Cryptography. Okay. In our syllabus, information theory and coding only there. Cryptography is not there. But he has taught everything. He is from IIT as far as I remember, and he only wrote that book. Until this point, like you can pick up any question from gate examination from information theory, you would find all the question ditto all the question would be there in his textbook. So whatever the questions that are remaining, that we are solving here. Okay, so those would be surely coming in your examination in future. I will see the name of the textbook and I will tell you. In the Telegram group you can ask me, or in our WhatsApp group you can ask. Yeah, so this is your x input random variable is there, discrete random variable it is. Okay, now z is some noise. Let's just say z can take two values. Z can take two values that are 0 and a. Okay, probability of z taking value 0 is equals to probability of z taking value 1 is not 1, it is a, is equals to 1 by 2. Okay, and a is not equals to 1. This is also given, right? And now the setup is defined as this is how the setup is defined. Addition x z y. Okay, this is your channel. So z is simply a noise only, right? Z is simply a noise, but this time discrete random variable is there. Okay, channel capacity. Channel capacity you need to find out in bits per channel use. And surely x and z are independent to each other. Okay, yeah, where x is the input like transmitted symbol and this is the received symbol. All these things would be nicely written in the problem, so you would be able to understand. Now yeah, try finding it out. What do you think what you would be doing? So channel capacity I need to find out. That means I will maximize my mutual information. So my first task is to write down my mutual information. What would be the mutual information? Discrete random variable these are. So sir, h of x minus h of x by y. I don't think I would be getting anything good from here, but surely sir I can get something good from here. Right? Now if I look at this guy, I need h of y and h of y by x. Now what is my y? Here y is equals to x plus z, right? So x is taking value 0, 1, z is taking value 0, a. So what all values y can take? What all values y can take? 0 plus 0, 0 plus a, 1 plus 0 and 1 plus a. Say yes or no? 0 plus 0, 0 plus a, 1 plus 0, 1 plus a. So your y can take these values 0, a, 1, 1 plus a. Where a is not equals to 1, so these two 1 are not same. Right? Is that correct? Why I am doing so? Because I need to find out the hy of maximum. No, this is what I need to find out. Because eventually what I need to find out, maximum value of this one. So hy max I need to find out. What will be your hy max? So you can see that there are total 4 symbols. Number of symbols are 4. So what do you think? What will be your hy max? Number of symbols are 4. That means hy max would be log to 4, 2 bits per symbol. So hy max job is done, right? Next, what I can do? Can I comment on h of y by x? This was there in their textbook only. Just I thought that I can frame this question here and we can solve it. So let's talk about h of y by x now. So what is your y? Y equals to x plus z. For sure I can comment that h of y by x would surely be equals to h of z only. Right? Can you comment that? What could be the other way that y equals to x plus z is given? Right? So what I do, on both of the side I divide by x. On both of the side I divide by x. Now this I call as y dash and this I call as z dash. Basically this is my y dash and this is my z dash. So y dash equals to 1 plus z dash. From here you know that h of y dash is equals to h of z dash. That means h of y by x is equals to h of z by x. Just another way of solving it. Otherwise you could have said that sir x equals to 1, that means y equals to 1 plus z, entropy of y is equals to entropy of z. That means if you know x, that means entropy of y is equals to entropy of z. Now h of y by x is equals to h of z by x and x and z are independent to each other. So this is the scenario, right? So here what you will be putting? H of z. So capacity would be hy max minus h of z. What will be your hy max? That is 2 bits per symbol, or let's simply write down 2 minus what is your h of z? From here can you find out h of z? You will do it on your own. 1 by 2 log 2, 1 by 2, 1 by 2 log 2, 1 by 2, and then minus sign would be outside. So simply it would be coming out to be 1 bit per symbol. Okay. So 2 minus 1, answer is 1 bits per 1 bit per symbol. 1 bit per symbol. So per channel use you can say 1 bit per channel use. That's it. 1 bit per channel use. That's the capacity it is having. That's the capacity this particular channel is having. Now someone might be having this doubt that sir, you said that h of y by x is equals to h of z by x and then you solved from here. Sir, what if I try to solve from here? Sir, h of x max, like h of x maximum value. Sir, only 2 symbols are there, so this value would be 1. Now what would be your h of x by y? Sir, h of x by y would have been simply equals to my h of x by y. So that would be simply equals to h of x by y I need to comment, right? So my x is simply y minus z. Negative sign doesn't matter much. Like if I had solved from here, then what would be the issue? So x would be simply y minus z. Then also I would have said the same thing that h of x by y is equals to h of z by y. right? But now you cannot say that sir h of z by y is equals to h of z. You cannot say that, right? Basically, if someone tried to solve from here, then he would have commented something about this one, but he would not be able to comment on this one, h of x by y. Because what he would have done, sir, h of x by y, if I go by the same method, then he would say that, sir, h of x by y is equals to h of z by y. But now x and z are independent to each other, but y and z are not independent to each other, right? And again, like this thing you cannot do, so you cannot solve it actually. And it is additive wide Gaussian noise, no, right? Additive wide Gaussian noise. So I don't think that would be like doing this particular thing is also not good. Actually, additive wide Gaussian noise means z could be added with x and z could be added with y as well. So no issue. You can do this one. No need to worry about that. But problem is h of z by y could not be written as h of z because z and y are not independent to each other. I don't know about that. I am surely sure that it is given in the problem that x and z are independent to each other. So that's why I can follow this step. But I am not sure about z and y. Are they independent to each other? I don't know. So h of z by y could not be written as h of z. So here my analysis would be stuck. Is that clear to you? Okay. Yeah. So this was also given in their textbook only. So this was also a good question. So these kind of questions are surely coming in future. These kind of questions you will not find in PYQs. And forget about the lecture series. In no lecture series you are going to find even near to this. Forget about reaching till this point. Even near to this, no one will be teaching you. Okay. So at least we are learning something good here. Okay. Yeah, that's it. Let's find out this particular thing as well. What is the relation between channel capacity and information rate? I hope you guys would be knowing it and you guys would be understanding on your own that channel capacity should be maximum, sorry, should be greater than information rate. Because what is information rate? Info transmitted per second. Like this is the actual information that you are transmitting per second. And what is channel capacity? Channel capacity is nothing but the maximum information that you can transmit. That can be transmitted. Through the channel. Through the channel that you would know. Through the channel only. So basically, what does the capacity would say? Let's just say channel capacity is 2 bits per symbol, okay, or 2 bits per second. Like this is in the per second only. Like information rate would be in second only. So channel capacity also I will say in second only. So this channel can transmit 2 bits of information in 1 second. And let's just say the source is delivering 3 bit of information per second. The source will say that, sir, I will generate 3 bit of information per second. Channel is saying that I can transmit only 2 bit of information per second. Then it will not be a reliable transmission. So for reliable transmission, here I should have written for reliable transmission. Channel capacity should be greater than your information rate. Is that clear? What is R? R is information rate only. Right? By the simple example you can understand. If channel capacity is 2 bits per second and X is giving information 3 bit per second, that means your channel will not be able to pass this 3 bit of information in 1 second. But what if this was 4 bit per second? That means channel is saying that I can transmit information, I can transmit the information of 4 bits per second, and channel is saying that I am generating information in 1 second equals to 3 bit. That means 3 bit of information should be passed through a channel which can pass 4 bit of information. That means, yeah, a reliable transmission can be achieved. Okay. Right. Now, just let me know what will be the maximum value of R. That would be equal to RB, bit rate. Right. Because what was your R? Sir, R was small r into Hx. Then I said that, sir, this could be equal to Fs and sir, this could be equal to N. So this is NFS, which is RB. So if I talk about the maximum, this is your maximum. So maximum value of R could be RB. So if I make the channel capacity greater than RB, basically this R can maximum reach up to RB only. Basically someone is saying that I will be happy if Virat scores more than 50 runs. And someone says that, sir, I will be happy if Virat score more than 70 runs. Okay, so to make both of these guys happy, how much runs Virat should score? If Virat has scored 71 runs, then everyone is happy. So similarly, this R, let's just say it could be 2 bit, it could be sometime 3 bit, it could be 4 bit, but maximum it is 4 bit per second only. So I will make sure that my channel capacity is such that this is greater than the maximum value of information rate. Is that clear to you? Basically, I will try to set up the channel capacity maximum greater than the maximum value of R. Like this is the best case, no? Like this is the best possible case that I will try to set up my capacity greater than equals to RB. And even if I am able to achieve this particular thing, then also it is fine. Because I know that information will not be transmitted more than RB, no? So why do you need to care about RB plus something? Basically, if your capacity is equals to RB, then also you are fine. Because if this guy is generating maximum information per second, if it is generating maximum information per second, then also your channel would be able to take it. So limiting condition is also fine for you. Is that clear? I hope it is clear, right? So this is known as limiting case. This is your limiting case. So very simple thing, like on your own as well, you can understand you can understand these concepts. Like what is the relation between channel capacity and information rate? Channel capacity should be greater than the information rate, which is pretty obvious, right? If this kind of question is given in the examination, will you be able to solve it? What should be the minimum signal to noise ratio required to support the information transmission through a telephone channel having a bandwidth of 3.4 kilohertz and a data rate of this much? So what is this data rate? This data rate is nothing but information rate is given kilobits per second. One thing I know that, sir, bandwidth is given, that means value of B is given. So surely here something called channel capacity. This is known as channel capacity theorem actually. This expression that we have derived, where we have derived this expression that we have derived, this expression that is known as channel capacity theorem. So here I will understand that channel capacity theorem will be applied here because value of B is given, R is given. So what do I know? That my channel capacity should be greater than or equals to R, right? So what is channel capacity? Sir, this is your channel capacity, should be greater than equals to R. Now log 2 1 plus SNR. R by B, what is the value? R by B. R is 4.8K divided by 3.4K. So from here you can get the value that SNR should be greater than or equals to this much. .66. Okay, so your signal to noise ratio should be greater than 1.66. That would be the answer. So what they are asking? Minimum they are asking, minimum SNR, so that would be 1.67 because 1.660, so minimum SNR minimum value is 1.66 only. Okay, I hope I have done the calculation correctly. Let me check it again. 4.8 divided by 3.4, 1.41. Yeah, okay, fine. Okay, very simple question it was, very straightforward. So these kind of questions like formula based problems you can solve, right? Let's solve this one. A communication channel having a bandwidth of 1 megahertz, input power is given, that is 10 milliwatt, sorry, not volt, and channel is having bandwidth of 1 megahertz and two-sided PhD is given. So what is the value of N naught that has been given? N naught by 2 is equals to 2 into 10 to the power 9, that means N naught value is 4 into 10 to the power minus 9 watt per hertz is given. So what will be your noise power? What do you think? noise power. So you know that channel is band limited to 1 megahertz. So this is the bandwidth. So noise power would be, sir, n naught by 2 into 2b. So that would be, sir, n naught into b. So I can see that 10 to the power 6 will be multiplied here. So it would be 4 milliwatt. So noise power is 4 milliwatt. And sir, what would be the SNR? 10 milli divided by 4 milli. That would be 2.5. Because why I calculated SNR? Because I know that I need to calculate channel capacity. So channel capacity would simply be B log 2 into 1 plus SNR, right? So what is the value of B? 1 mega log 2 1 plus 2.5. Right, let's check the calculation. 4 milli. C1 is 1.8 into 10 to the power 6 symbols, sorry, bits per second. Bits per second. Okay, so this is the answer. 1.8 megabits per second. This is the answer, right? Second one is, if the bandwidth is reduced to 0.5, then what will be the new signal power P2 required to maintain the same capacity? So this capacity I need to maintain. So in the second problem, what they are saying, that capacity is given. Which capacity you need to maintain? 1.8 into 10 to the power 6. This capacity you need to maintain, sir. Now signal power will be changing. Along with that, noise power will also be changing, no? Because bandwidth is reduced now. So what will be your noise power? The noise power is n naught into b. What is the value of n naught? N naught is 4 into 10 to the power minus 9. 4 into 10 to the power minus 9. And what is the value of b? Value of b is 0.5 into 10 to the power 6. So that would be 2 milliwatt. Okay. So 2 milliwatt is the noise power. So SNR will be changing. This is what I am saying. Now channel capacity I need to maintain. So again I am applying the same formula. C equals to B log 2 1 plus SNR, right? So capacity is 1.8 into 10 to the power 6. Value of B is 0.5 mega log 2 1 plus, let's keep SNR as it is. Okay, as of now we are just keeping SNR as it is. So 2 to the power 3.6, right? Because this would come here, 1 by 2 would come here, 10 to the power 6, and 10 to the power 6 will get cancelled out. This would be 3.6, 2 to the power 3.6 minus 1, 11.12. So SNR is coming out to be 11.12, and that would be equals to, previously what was the SNR? 2.5. Now SNR is coming out to be 11.12. And what would be the SNR? Signal power that has been represented by P2 divided by this N naught B, that will be 2 milliwatt. So your P2 would be coming out to be 22.25 milliwatt. Okay. In the previous case, what was your P1? Here it was 10 milliwatt. So basically what I am doing, let's analyze the case. Bandwidth was 1 megahertz, right? Bandwidth was 1 megahertz. Bandwidth was 1 megahertz. Where is, in the previous case, bandwidth was 1 megahertz. What was the capacity? Capacity was 1.8 megabits per second. And what was your signal power? Signal power was 10 milliwatt. Now bandwidth is reduced. Bandwidth is reduced. Capacity remains the same. So to maintain the same capacity, what I have to do? I have to increase the signal power. And it is pretty obvious, no? Like basically this was the bandwidth. I was having good enough bandwidth. So with some particular signal power, this was the bandwidth that I was having. With some particular signal power, I was able to transmit some information. Now the bandwidth has been reduced. So whatever the signal that I was having, I have to make that signal stronger. Say yes or no? If the bandwidth is reduced, so the signal should be stronger, no? And what is the meaning of stronger signal? That means more power. Forget about the formula, just think. If your bandwidth is reduced, there are two things, power and bandwidth. One thing we got to know that, sir, if bandwidth is increasing, here we saw a curve, that sir, if bandwidth is increasing, then our channel capacity would increase, right? But here P was uniform, like for a certain P is fixed. The signal power is fixed here. Signal power we took constant. When we were doing the differentiation, signal power is not changing with respect to B. So signal power we took constant. So here what we saw, that if B is increasing, if bandwidth increases, then channel capacity increases, although after some time it will saturate. At infinity, it's not that capacity would go to infinity, right? So after some time it will saturate. Now what I am saying is that if my power is increasing, if my power increases, then my capacity should also increase. Because you just think about it, at infinite bandwidth, your capacity is simply proportional to power. So if I, on this curve only, if I say this is the curve for power P1 and this is the curve for power P2, then can you find out the relation between P1 and P2? Yes sir, P1 would be greater than P2. Why is that? So from this expression you can see, or you can see that, sir, if capacity is lower, that means input power is lower. From this formula also you can see, if capacity is low, that means input power is also low. So there is a trade-off, no? If you increase the bandwidth, what do? You can reduce the input power. And if you are decreasing the bandwidth, what you need to do? You need to increase the input power to maintain the same capacity. Is that point clear? Like very simple point it is. So if I am reducing the bandwidth, then my signal should be stronger. So signal power has to be increased to maintain the same capacity. Capacity is maintained same. So if this guy got reduced, this guy got increased. This increased, this guy got reduced. This was reduced and this was increased. Is that clear to you? And this was same only. These two guys were same only. So this is the point that I have written. I am going to use this particular statement somewhere. Okay, and a very, very important statement. It is surely coming in your examination in future. So we are going to draw two more curves now. Okay, two more curves we are going to draw. So what we need to do? We need to draw EB divided by N naught versus RB by B plot. This plot we need to make for some certain condition, that I am saying that my capacity is equals to RB. For the given case that your capacity is equals to RB. So what is the formula of capacity? Sir, capacity is simply bandwidth log to 1 plus SNR, signal power EB into RB, divided by signal power was EB into RB. So your signal power is proportional to your bit energy, right? Divided by N naught into B. Now I am saying that my capacity is equals to RB. So if your capacity is equals to RB, then what you will be getting? RB would be equals to B log to 1 plus EB by N naught into RB by B. So this will be RB by B log to 1 plus EB by N naught RB by B. Now with the help of mathematics, I don't think you can draw the graph, right? This graph with the help of mathematics, can you draw? It would be very difficult. So let's go with our intuitions. RB by B versus EB by N naught. Here, what will be the value of bandwidth? At this particular point. At this particular point, your RB by B is tending to 0. RB is the bit rate, that would be constant. N naught, this also I will take constant, like this would be introduced by the channel. So don't care about N naught, like don't look at N naught and don't look at RB. Only our matter of concern would be B and EB, okay? Bandwidth and the power. This is simply your power. Although it is energy, but power is proportional to bit energy, no? So this is simply your power and this is your bandwidth. So 1 by bandwidth versus power plot we are doing. 1 by bandwidth versus power. This is the plot we are making. 1 by bandwidth versus power. Okay, 1 by bandwidth versus power. So here your bandwidth is actually infinity, right? For infinite bandwidth such that your bandwidth is infinity, what is your capacity? Sir, 1.44 P by N naught, right? Now what is C? C I am putting as RB only, 1.44 EB into RB divided by N naught. RB get cancelled out. From here, value of EB is coming out to be, value of EB by N naught is actually coming out to be 1 by 1.44. 1 by 1.44. Okay, this value is 1 by 1.44. And when you convert it into dB, then it will come out to be 1.6 dB as far as I remember, but let me solve it. 10 log 10, right? Yeah, minus 1.6 dB. Just let me know one thing, will it be the minimum value? Like after that graph would go, somewhere graph would go. For the same capacity such that C is equals to RB, capacity is fixed. For fixed capacity, how the graph would go? Here I am having this value, minus 1.6 dB. So graph would rise up like this or it would go down like this. What do you think? So just think about it. To maintain the same capacity, I will draw some graph. Let's just say the graph goes like this. On this particular graph, the value of capacity would be same, no? Capacity is fixed. This is fixed. So on the whole graph, I need to maintain the same capacity. Now when I am going towards this side, what is happening? Sir, your bandwidth is reducing. When you are moving here, your bandwidth is reducing. Why so? Because RB by B is increasing. If 1 by B is increasing, that means your bandwidth is reducing. Now if your bandwidth is reducing and you need to maintain the same capacity, listen to the statement very carefully. Your bandwidth is, if you are going here, your bandwidth is reducing. To maintain the same capacity, you need to increase your signal power. If bandwidth is reduces, then to maintain the same capacity, signal power should be increased. So when you are walking towards this side, your bandwidth is reducing. On this curve, I need to maintain same capacity. So for that, I need to increase my signal power. That means I need to increase my EB value. So what does that mean? How the curve should go? Sir, the curve should, at infinite bandwidth, you have find out this particular value was there. Now how the curve should go? Sir, the curve should be going somewhat like this. Say yes or no. C equals to RB. This was the case of C equals to RB. Again, let me repeat, and this value was minus 1.6 dB. Again, let me repeat what is happening here. Okay. So RB by B is low here, that means bandwidth is infinity. Bandwidth is infinity. For infinite bandwidth, if bandwidth is very large, that means weaker input signal will also work. If bandwidth is very large, then weaker input signal will also work. That means value of EB would be minimum. And to maintain the same capacity on the curve, if you are going in this direction, your bandwidth is actually reducing, then what you need to do? To maintain the same capacity, what you need to do? You need to increase the input signal power. Is that clear to you or not? Surely 101% I am telling with guarantee that within 2 to 3 years, these curves are coming in your examination. And after that, it would be there in everyone's notes. As of now, it is not there. Okay. Once it is asked in the examination, then these notes would be there. Then these curves would be there. So very important curve. Surely they are coming in your examination in future. So like if the question is coming on information theory, my first target in the examination hall would be that I go with my intuitions rather than my formula and everything. If the question is coming on curves or whatever it is, I will see the scenario, that what is the scenario that is telling me, and I know everything about information theory, I would be able to solve it. Is that clear to you or not? So what I am saying, again let me repeat, bandwidth is infinity here. If the bandwidth is very large, weaker signal would work, right? But if the bandwidth reduces, then what will happen? The signal power should be increased, right? Now there would be two conditions. This is the curve of C equals to RB. Now just let me know two conditions. Which portion will be for C greater than RB and which portion would be for C less than RB. Basically, if I draw two more curves, I draw two more curves like this. One curve is this one, another curve is this one. Or let's change the color. Let's change the color to blue. Okay. So just let me know one thing. Which curve will tell that C is greater than RB and which curve will say C is less than RB? Take your time, pause the video, do rough work in your notebook, think about it. Which curve will say C is greater than RB? Which curve will say C is greater than RB and which curve will say C is less than RB? Take your time, take the pen, you want to do mathematics, whatever you want to do it and then let me know. In the examination, this kind of a curve would be given and they would be asking you, they would be saying that middle curve is C equals to RB and then they would be saying this is C greater than RB, this is C less than RB, this is C less than RB, this is C greater than RB, which of the following option is correct? And in two of the more options, they will draw the curve like this, like in decreasing manner. So those two options will be cut already and then the task would be between C greater than RB and C less than RB. So what do you think, which will be C greater than RB and which will be C less than RB? So let's check that out. Okay. So first I will let you know that this is my C equals to RB. If you do mathematics, then you will be able to understand, but without doing the mathematics, how we can comment? Sir, here this value is more, right? That means at infinite bandwidth, you need to put more input power. At infinite bandwidth, you need to put more input power. So if you need to put more input power, that means your capacity is more. Sir, in both of these, if I am here, sir, in all the cases, let us say this is the case 1, case A, case B, case C. In all these three cases, sir, bandwidth is same. Bandwidth is infinity. Bandwidth is same. Or let's not go here, let's go somewhere in between. Let's go in the middle. Let's go somewhere in the middle. So what I would do, I would go somewhere in the middle here. Sir, at this particular bandwidth, in all the three cases, my bandwidth is same. If your bandwidth is same, but capacities are different, here you are having more capacity, here you are, sorry, not capacity, input power is different, here you are having more input power, here you are having lesser input power, and here you are having even lesser input power. So bandwidth is same. What is the formula of capacity? B log 2 1 plus input power divided by N naught into B. Sir, this is same. Bandwidth is same. Sir, this is also same. And this is the formula of capacity. So sir, if this is more, that means this is also more. So this has to be C greater than RB. And this has to be C less than RB. Is that clear to you or not? At a particular bandwidth, I have fixed a bandwidth. I have make the bandwidth fixed. Fix this bandwidth, right? So if your bandwidth is fixed, but here required value of input power is this one, required value of input power here is this one, and required value of input power here is this one. So here required value of input power is more, here required value of input power is lesser and even lesser. So if input power is more, that means capacity is more. That's it, very simple thing. Or you can see from infinite bandwidth as well. Like at infinite bandwidth, what I mean to say is that at B tending to infinity, your channel capacity is 1.44 EB by N naught, right? So if EB by N naught is more, that means your C is more. If the value of EB by N naught is more, that means C value is more. No, that's it. Or you can say that for C greater than RB, if C is greater than RB, that means this value is greater than RB. That means your EB by N naught would be greater than, if C is greater than RB, then this value is greater than RB, greater than RB by 1.44. right? Am I doing the correct mathematics? So basically this was 1 upon 1.44. Like I have given enough intuition to you. I hope you are able to understand now that this particular curve would be for C greater than RB and this particular curve would be for C less than RB. Is that clear to you or not? Right? So this particular area would represent C greater than RB. Okay, and this particular area would represent C less than RB. Is that understandable to you or not? At a particular bandwidth, if you are applying more signal power, that means the capacity would be more. That's it. At a particular bandwidth, if you are applying more signal power, then the capacity will be more. So this is your C greater than RB, this is your C less than RB. Now I have drawn EB by N naught versus RB by B. Now what I am asking, RB by B versus EB by N naught. So in a lot of textbook or in a lot of lecture, you would see this curve would be drawn. Like basically, you need to draw the opposite curve. If I can draw the curve of Y versus X, let us say Y versus X curve is this one. So can you draw the curve of X versus Y? Yes, sir, surely. This much task you can do. Like this curve will go from here. Basically, value of Y was when X was equals to 0. When your X was equals to 0, Y was this one. So when X is equals to 0, Y would be this one. At this point, X is equals to 0, Y is this one. And then if your X is increasing, then Y is also increasing. So this kind of curve would be there. So if I have made this particular curve, so basically you need to see this curve from here. Look the curve from this side. I need to draw EB by N naught on X axis and RB by B on Y axis. RB by B on Y axis. EB by N naught on X axis and RB by B on Y axis. So can you draw the curve? Surely I can draw the curve, sir. It would go somewhat like this. This is your, or it would keep on increasing. Like there is no saturating point. It's not that it is saturating. So it would keep on increasing like this. This point would be minus 1.6 dB. REB by N naught value is minus 1.6 dB. This point would be C equals to RB. This area would be C greater than RB and this area would be C less than RB. Right? Inside the curve, this area was C greater than RB. So just I am looking from the opposite side. This area is C greater than RB. So this would represent a reliable transmission, right? Because if C is less than RB, then reliable transmission might not be taking place. So reliable transmission. And this is not reliable transmission. So what did you understand? That if I want to do reliable transmission, then in the worst case, I will make sure that my EB by N naught is minus 1.6 dB. In the worst case, this is the worst possible case. That if I am using infinite bandwidth, best bandwidth if I am having, even if you are having the best bandwidth, at least this much EB by N naught you would require. So this is the worst case EB by N naught that you require if you want to do reliable transmission. Not the best case. The more signal power you are having, the better you are. More signal power, you are in the better condition. But sir, I want to take the worst possible input power and I want to do reliable transmission as well. Then sir, what could be the worst possible signal power? So that would be minus 1.6 dB. Not signal power, EB by N naught value. Is that clear to you what I am saying? Again, let me repeat my statement. What did I say? That you need to do reliable transmission. First thing is that sir, I am expecting I will do reliable transmission. And second thing is that sir, my input power is weak. So sir, what kind of worst possible input power I can have? It's like some guys saying that sir, I need to clear the cutoff, but I am not hard working. So sir, what is the least amount of effort I need to put? So I will say that at least you study for 1 hour per day. Least amount of effort. If you are studying more than 1 hour, then it is fine. Like you would be able to do very well. But he says that sir, I need to clear the cutoff. So what is the worst possible thing I need to do? That at least study 1 hour per day. If you are studying lesser than that, then there is no chance that you would be clearing the cutoff, then you would be falling in this category. So similar thing is that I want to do the reliable transmission, but my signal power is worst case. That means my EB by N naught ratio should be equal to minus 1.6 dB, or you can say the value is 1 upon 1.44. 1 upon 1.44. Okay. So what I am saying, for reliable transmission, at best bandwidth, at best bandwidth. Best bandwidth means B tending to infinity. Worst case EB by N naught is 1 by 1.44, or you can call it minus 1.6 dB. Directly they can ask it, you don't need to mug it up, you would be able to solve from this particular analysis that we have done. Channel capacity you will remember, sir, P by N naught 1.44, 1.44 P by N naught, that you would write down EB into RB divided by N naught, then RB will get cancelled out, so EB by N naught would be 1 upon 1.44. From there you would get to know that it is coming out to be minus 1.6 dB. All clear? All fine? So I hope this is understandable to you. Let's solve this question. Yeah. So are you going to mug up anything? No, simply you will solve this particular problem. What this question is saying, a voice grade AWGN channel with bandwidth is given, two-sided PhD is given, bandwidth is 4 kilohertz, two-sided PhD is given, value of N naught is 5 into 10 to the power minus 5 watt per hertz, right? If information at a rate of this much is being transmitted over this channel with the arbitrarily small bit error rate, then the minimum bit energy is required. So this is the information rate that they have given, right? Okay. Information rate is 52 kilobits per second. Bandwidth is given, so surely I know that, sir, this particular thing would be there. That my capacity should be greater than the information rate. Okay. So minimum bit energy required they are asking. That means, sir, B log 2 1 plus SNR. Sir, SNR would be EB into RB and not into B. Here, sir, it should be greater than R. So in place of RB, I will put R only, right? Like basically, only information, they are saying that information is being transmitted over this particular thing. So source X is transmitting information at this particular rate. That means they are talking about bit rate only. So this is the bit rate only. So here I will put R only, right? Okay. How do you write down EB into RB? Considering that your source is transmitting information at RB rate. So here they are saying that source is transmitting information at R rate. So here I will put R, right? All good? Now you just need to put down the values and you will get the minimum value of EB. So value of B is this one, R value is 54. So 54 divided by 2, that would be 13. So 2 to the power 13, 1 plus EB into R. R is 52K. And not into B, 0.2. 0.2 should be greater than R by B. What is the value of R by B here? 13. So EB into 52K divided by 0.2, 12. 2.4. 12 into 0.2 divided by 52. So 0.046, or you can say 46.15 millijoule. You can check the calculation. The process is clear to you, right? Process is clear. Let's just check the calculation that 46.15 millijoule power would be required. So EBR 52K, this much, 0, 1 plus. Sir, here 46.15, but sir, here it was 1 upon 1.44. 1 upon 1.44, sir, that would be 694.44 milliwatt best bandwidth. That was the value of EB by N naught actually. Yeah, forget about it. Just see this calculation. Is this calculation correct? Value of B is this, R is 13. 13 minus 1, that would be 12. 12 into N naught into B, 0.2, so 2.4, 2.4 divided by 52, 4 divided by 52, okay, it is not 2.4 divided by 52, 2.4 divided by 52. So this is the answer already in millijoule you are getting. Then you will multiply with 1000, and this answer is in microjoule actually, microjoule. Now if someone would have applied this formula blindly, then that's our EB by N naught is equals to 1.44. So this was the case for best bandwidth, no, B equals to infinity, B tending to infinity. But here they have mentioned the bandwidth, no, bandwidth is 4 kilohertz. So bandwidth is mentioned here. Like this is the best case in case of bandwidth and worst case in case of power. Basically, if I need to use worst case power, that means my bandwidth should be best case, right? Both are having a trade-off. If bandwidth is best, then power could be lesser, and if power is high, then bandwidth could be lesser. So this formula is for best case bandwidth. That means bandwidth is infinity, right? This is the formula for best case bandwidth. So here they are not asking best case bandwidth, they have mentioned a particular bandwidth, that at this bandwidth, if I want to do reliable transmission, then how much bit energy I need to have. And just mark this thing that it is EB by N naught, not EB. So EB by N naught 1 upon 1.44. That's why I am saying that it is not worth to remember this particular thing. So you don't need to remember this value. You just need to know the concept that they are saying that if I am having best case bandwidth, then this is the worst case EB by N naught I can have. But here they are not talking about the best case bandwidth. In the examination, it might happen that they have directly mentioned best case bandwidth. That means the bandwidth is very high, they can mention, or they can say bandwidth is infinity. That means you would understand that they are expecting me to do this analysis, that capacity is equals to 1.44 P by N naught, then I would replace EB by R divided by N naught, then I would know that at least for the reliable transmission, the value of capacity should be equals to R. Then R and R will get cancelled out. EB by N naught would come out to be 1.44. 1 divided by 1.44. Value of N naught would be mentioned, and I will get the value of EB. Right? So if they have mentioned best case bandwidth, then I will take this case. So this example I took only to let you know that blindly you would never apply this formula. So remembering this particular answer is not worth it. This is what I am saying. Yeah, try this question. This is also a very good question. Okay, this will just test your knowledge. It is based on what do we call? It will be based on your entropy. Okay, like basically it is based on discrete random variable. You can see what they are saying. A miniature circular keyboard consists of 24 keys. There in this circular keyboard, there is a circular keyboard which is having 24 keys. So let's just say A, B, C, D. In that manner till X it will have 24. U, V, W, W, X, U, V. So in that manner total 24 keys it is having. Right? Due to noise, the adjacent keys on either side may also get pressed. Whenever the user intends to press a key, due to noise, the two adjacent keys on either side may also get pressed with equal probability. What does that mean? That if I want to transmit symbol A, it might happen that received symbol will be X. Basically on the keyboard, if I am typing A, it might happen that you are getting X, it might happen that you are getting A, or it might happen that you are getting B. What they are saying, adjacent keys, two adjacent key. That means if you are clicking on A, result could be B, result could be A, or result could be X. And what probabilities they are saying? Equiprobable. So this can go with the probability of 1 by 3, this can go with the probability of 1 by 3, and this can go with the probability of 1 by 3, and it would be happening with all the keys. It would be happening with all the keys that are present. Basically, what would be happening with B? With B, what would be happening? That when I am clicking on B, it might happen that I get the result of when I am clicking on B. So it might happen that I am getting the result of B, or it might happen that I am getting a result of A, or it might happen that I am getting a result of C. Is that clear? Result of A, or result of B, or result of C. with the probabilities of 1 by 3, 1 by 3, 1 by 3, right? Similarly, what would happen with x? X is the last number, no? So what is adjacent to x? A and W. So it might happen that when you are clicking on x, I will get x only, or it might happen that you are getting W, or it might happen that you are getting actually A, right? So this would be happening with x. Is that clear to you? Is that clear to you? This is the scenario, right? And all are equally likely, that means 1 by 3, 1 by 3, 1 by 3. Probabilities are 1 by 3, 1 by 3 and 1 by 3. That is, if a key I is intended, then key I minus 1 or I plus 1 mod 24 may actually appear as output all equally likely. Okay. What is the meaning of mod 24? If you know the meaning of mod, then you would be able to understand. What is the meaning of mod 24? That means, let's just say x is 24th key, right? X is 24th key. So with respect to 24th key, 24th key or 23rd key or 25th key can be priced, but 25th is not there. So 25th mod 24. What is the meaning of mod? Mod means remainder. So 25 divided by 24. What will be the remainder? 1. That means with respect to 24th key, 23rd could be pressed, 24th could be pressed, or first key could be pressed. So this is the meaning of mod here. Okay. Find the channel capacity in bits per symbol of the noisy keyboard channel. So find the channel capacity. So what is your channel capacity? H of x by y. That would be equals to h of y minus h of y by x. But maximum of this one or maximum of this one. H of x by y, sir, I don't think I can comment on anything on. I don't think I will be able to comment on anything on this one. But sir, h of y by x I can comment. All these probabilities are mentioned, so h of y by x I can comment. What will be your h of y maximum? How many outputs are there? 24 outputs are there. Total 24 outputs. Right? So what do you think? What will be your h of y maximum? Sir, my h of y maximum would simply be log to 24. And in the information theory, I have told you never ever put down the final result. So h of y maximum is log to 24. So hold on to this particular thing. I need to calculate h of y by x as well. So what do you think? What will be your h of y by x? Sir, with respect to a, there are three probabilities: 1 by 3, 1 by 3, 1 by 3. So h of y by x, joint log to conditional, joint log to conditional. So joint probability of a into 1 by 3 log to 1 by 3, right? Minus sign outside, probability of a 1 by 3 log to 1 by 3, plus again the same thing would be happening, probability of a 1 by 3 log to 1 by 3, probability of a 1 by 3 log to 1 by 3. So this would be happening how much time? Probability of a 1 by 3 log to 1 by 3 plus probability of a 1 by 3 log to 1 by 3. Now this thing has happened with a. The similar thing would be happening with b as well. Probability of b 1 by 3 log to 1 by 3. Probability of b 1 by 3 log to 1 by 3. Probability of b 1 by 3 log to 1 by 3. I hope you are understanding what I am doing. Joint probability log to conditional probability. So all this is happening 3 times. That means this particular thing has been multiplied 3 times, no? So what we will get? Probability of b 1 by 3 log to 1 by 3, it will happen for 3 times. So what you can see, it is happening for 3 times. So 3 into 3, that would be 1. So probability of b, basically what is this? Whole summation is going here. Probability of a 1 by 3, it is happening for 3 times. So this and 3 gets cancelled out, 1 by 3. So probability of a log to 1 by 3, this is what is happening, right? So similar thing would be happening, probability of b log to 1 by 3 plus probability of c log to 1 by 3 and so on. Probability of x log to 1 by 3. And you can see that I can take log to 1 by 3 as common, and minus sign is already there, so this would become log to 3. If I have taken this as common, the probability of a plus probability of b and dot dot till probability of x. what this value would be equals to? This would be equals to 1, because these are the symbols that are being transmitted. This would be equals to 1. So log 2 3. So what do you think, what will be your capacity? So capacity would be log 2 24 minus log 2 3. So that would be log 2 24 by 3. That is 3 bits per symbol. That's the answer. Okay, a very good question, and 101% I am pretty sure that it is coming in 26 or 27 or 28. 101% sure, because that's the next thing that they will try out, and this question is also given in that particular textbook. Okay, so you don't need to solve that particular textbook because I am taking all the problems. So let's end this lecture here. Some more miscellaneous concepts are there regarding this particular information theory only. Basically what we have understood about this x, then h of x and small h of x as well, then h of x by y, then h of x comma y, then I of x y, and then capacity. So we are learning these things only, just we are learning some new concepts regarding them. Otherwise, like, our discussion is revolving around all these things only, right? So all these we have understood. Just some miscellaneous concepts are there that we are going to see in the next lecture. So as of now, let's end this lecture here. I hope you are enjoying the pure concepts of information theory. Okay, so if you are enjoying it, then do share it with your friends. Yeah, okay then. Yeah, thank you very much. Let's meet in the next lecture. In the next lecture, we are going to learn some more new things. Yeah, thank you very much. Happy life. Hi everyone, welcome to PrepFusion. So now we are going to understand information theory only. We have been studying about information theory. We will continue our discussion, but here you will not feel like that, sir, I am learning anything new. Older things only you are learning, but just in a different manner. So what we are going to do now, we are going to cascade two discrete memoryless channels. So if we cascade two discrete memoryless channel, what kind of questions can be asked? They can ask you probability of receiving Z1. So just let me know, can you find out probability of receiving Z1? They can ask you these things as well, x2 by z3. They can ask you to make a joint matrix. They can ask you z3 by x2. So whatever the things that they can ask, that I have put here. So first thing is, can you find out probability of receiving z1? Yes sir, z1 is coming only from y1. So probability of receiving z1 would be simply 0.7 into probability of receiving y1. Now do you know how to find out the probability of receiving y1? Yes sir, probability of receiving y1. So did you understand the meaning of cascading two channels? There was one channel, input was x, output was y. Now that output was fed to another channel as an input. So y has become input for channel C2, and then the received output is z. So final output is z, final input was x. Y is in between output, or you can call it input as well. It is the output of C1 and the input of C2. So this is the meaning of cascading, right? Basically both channels are connected in series. This is the meaning of cascading. So probability of receiving y1, what would be probability of receiving y1? So it is coming from x1, it is coming from x2, and it is coming from x3. So from x1 it is coming with the probability of 1, 0.2, probability of receiving, probability of transmitting x1, 0.2 into 1 plus 0.3 into 0.4. So all these things we have already seen, plus 0.5 into 1. So what we are getting? Sir, you are getting 0.82. And probability of receiving y2 would be 0.18 as well, but we can see it that it is coming from, y2 is only coming from 0.3. So 0.3 into 0.6, that would be 0.18. So these things we already know, right? Now we needed to find probability of receiving z1. So probability of receiving z1 is nothing but 0.7 into probability of receiving y1. And now sir, probability of receiving y1 also I have find out, that is 0.82. So 0.82 multiply with 0.7. Do I have my mobile here? Yes. So 0.82 multiply with 0.7, that would be the answer. .574. Similarly, can you find out probability of receiving Z2? Now everything you should be doing on your own. So Z2 is coming from sir y1 and y2. So 0.1 into y1 plus 0.1 into y2. Sir, it would be 0.1 only, because 0.1 would come common. Probability of y1 plus y2, that would be 1 only. So it would be 0.1, or you can simply put here, you will get that it would be 0.1 only. Probability of receiving Z3. So Z3 is coming from here and here. So 0.2 into y1, 0.2 into y1, that is 0.82 plus 0.6 into y2. 0.272. And what will be probability of receiving Z4? So Z4 is only coming from here. So 0.3 into probability of receiving Y2, that is 0.18. So 0.054. So if we add all of them, answer should be coming out to be 1. Basically, probability of receiving Z1 plus Z2 plus Z3 plus Z4 should be 1. So let's check that. Plus 0.1 plus 0.574. Yes, it is coming out to be 1. That means this particular calculation is completely correct. So we have find out probability of receiving Z1, Z2, Z3 and Z4, which was pretty simple. Without even looking at this particular slide, you could have solved it. Now you need to find out this thing, Z3 by X2. So what is the meaning of Z3 by X2? Probability of receiving Z3 such that X2 is transmitted, right? Receiving Z3 such that X2 is transmitted. So certain method is there that how would you reach to Z3 through X2? How would you reach to Z3 through X2? So sir, this path is there, one path, and sir, another path is there. So just multiply these probabilities and then add them up. What we are doing, let me tell you, and two methods I will tell you, don't worry about that. So what we need to do, now we need to make the transition matrix, or you can say simply this channel I need to make, considering my x1, x2, x3 is as input. Basically this is generating x1, x2, x3, and my final output is z1, z2, z3, z4. And this channel will be my whole channel. So considering C1, C2 cascaded, considering that only one channel, I will make the channel diagram now. So this kind of diagram I am going to make, right? This is one channel which is cascade of C1 and C2, and input is X, output is Z. So what I would see, from X1 where I can go? Sir, from X1 you can go to Z1. Sir, from X1 you can go to Z2, and sir, from X1 you can go to Z3. From X1 can you go to Z4? No. There is no path from X1 to directly going to Z4. Like from X1 you will go to Y1, Z1. From X1 you will go to Y1, Z2. From X1 you will go to Y1, Z3. From X1 can you go to Y2? No. Right? So only three paths are there. Basically from X1 you can go to Z1, Z2 and Z3. Okay. So three paths are there. Z1, Z2 and Z3. So what all will be the probability? From X1 to Z1 only one. From X1 to Z1 only one path is there. So 0.7 multiply with 1. What that would be? So that would be 0.7 only. From X1 to Z2. From X1 to Z2. Again only one path is there. From X1 to Z2. That's it. You will go here and then here. So 1 into 0.1, that would be 0.1. Now from X1, this is 0.7, this is 0.1. So this has to be 0.2. And we can check that as well. This would be 0.2 only. So you would see that from X1 to Z3, that is 0.2 only. 1 multiplied with 0.2, that would be 0.2 only. Is that clear to you? Now we will go from X2 to, from X2, from where I can go? From X2 to I can go to Z1. From X2 I can go to Z2. From X2 I can go to Z3. From X2 here as well again I can go to Z2. Basically X2 is going to Y1 and now Y1 is going to Z1, Y1 is going to Z2 and Y1 is going to Z3. Right? These three paths are there. So basically from X2 you can go to Z1, Z2, Z3. Along with that, from X2 you can go to Y2 and Y2 is going to Z2, it is going to Z3 and it is going to Z4. So basically through X2 you can go to Z1, Z2 and Z3 and then coming back Z2, Z3 and Z4. So from X1 you can go to Z1, Z2, Z3, Z4. All four you can go. So from X2 you can go to Z1, Z2, Z3 and Z4. Now what is the path of going from X2 to Z1? So X2 to Z1, only one path is there, right? X2 to Z1, one path is there. Can you agree to this point? 0.4 into 0.7. Look, this is a very tough matrix, okay? This is a very tough diagram. This much tough diagram will not come. And sir, how we will use this much of brain in the examination? So another trick I will tell you. Another method is there, that also I will tell you. But as of now, like in the examination, whatever the diagram is coming, that would be much simpler than this one. So by using this method only, you would be able to solve. But one more method would be there, that would be matrix method. So that also I will tell you. But as of now, let's understand by this method. From x2 to z1, only one path is there. 0.4 into 0.7, that would be 0.28. Sir, from x2 to z2, now look carefully. x2 to z2, one path. Okay. From x2 to z2, another path. So two paths are there, right? x2 to z2, two paths are there, no? So 0.4 into 0.1, 0.6 into 0.1, that would be 0.04. Basically, x2 to z2, two paths are there, no? 0.1, 0.4 into 0.1 and 0.6 into 0.1. So 0.04 plus 0.06, that would be 0.1. Now x2 to z3, x2 to z3, x2 to z3 and then x2 to z3. Again two paths are there, right? x2 to z3 and then x2 to z3. So 0.36 and 0.08, right? Basically 0.08 plus 0.36, what that would be? 0.44. Is that clear? So directly I am writing down, this would be 0.1 only. Another method I will tell you, don't worry about that. If it is looking like a tough method, but in the examination, easier diagram would be coming, so you would be able to solve it in a quicker manner. Here you can see 0.4 into 0.2, 0.6 into 0.6. What about this one? From x2 to z4, only one path is there, that would be 0.18. 0.18. One thing is for sure that 0.28 plus 0.1 plus 0.44 plus 0.18 has to be equals to 1. Is it equals to 1? 0.38 it would be there. Then 8 if I give you, yeah, it would be equals to 1 only. So you can check that from x2 you are going to z1, z2, z3, z4 with the probability of 0.28, 0.1, 0.44 and 0.18. So addition of all of them should be equals to 1, which is actually coming out to be 1 only. Now coming to x3. From x3 where you can go? You can go to y1 and now y1 is going to z1, z2 and z3. Right? That's it. From x3 you can only go to y1 and these three paths are there. So from x3 you can go to z1, z2, z3. From x3 you can go to z1, z2 and z3. So with these probabilities you can go there. So what all are those probability? So from x3 to z1 you need to go. So 0.7 multiply with 1, what that would be? That would be 0.7 only. Next 1 multiply with 0.1, that would be 0.1 and then 1 multiply with 0.2, that would be 0.2. So this would be 0.1 and this would be 0.2, right? 1 multiply with 0.7, then 1 multiply with 0.1 and 1 multiply with 0.2. So start from here and then reach here. See all the path and then reach here. So in that manner you will be able to get. So all these are the probabilities, like anything could be asked now. Now someone asking you what they asked here, z3 by x2. z3 by x2. So can you see in this diagram z3 by x2, z3 by x2, that is 0.44, right? So anything could be asked. Now what they are asking here, x2 by z3, x2 by z3. So what do you think, what should be the answer? I told you one thing, that sir, probability of x2 transmission multiply with x2 transmitted, z3 received is equals to probability of z3 received, x2 transmitted divided by z3 received. So this is something that I need to find out. Do I know the value of x2 transmission? Yes sir. Do I know the value of x2 transmission? Yes sir, 0.3 multiply with 0.44. Do I know the probability of receiving z3? Yes sir. What is the probability of receiving z3? Sir, that is 0.272. 0.272. So x2 by z3 we will be getting. Okay. So 0.3 into 0.44, 0.3 into 0.44 divided by 0.272. So this is coming out to be 0.485. So this answer is 0.485. Okay, so if you have patience, then you will be able to solve these kind of problems. So if this particular question is coming in the examination, let's just say directly they are asking this particular thing, what I would write down? First I would write down this step. Then I would know the value of this one. then I know how to find out Z3 by X2. So that means I need to start from X2, I need to reach to Z3. So one path is there, then second path is there. So I will write down this probability as well, which will be very simple, 0.08 plus 0.0 plus 0.36. So that I would be able to write down. Probability of X2 transmission also I already know. Then probability of Z3 transmission I would be requiring. So what all are the paths are there from Z3? So Z3 is coming from Y1 and Y2 with the probability of 0.2 and 0.6. So this particular step I will write down. Then I would require the probability of receiving Y1. So I would calculate these values and I will get 0.272. And then I will divide it, I will get my answer. Path is long, but if these kind of questions are asked, then you will be able to solve it. Now, sir, what about this matrix? Making this matrix are very, very difficult. So basically what is happening here? What we are calculating? Probability of receiving Z such that X is transmitted. All these probabilities are, what all are all these probabilities? These are sum Zj or Zk divided by Xi. Say yes or no? This is your probability of Z1 by X1, this is your Z2 by X1, this is your Z3 by X1. So Zk divided by Xi. So basically you are calculating matrix of probability of Z by X. That would be equals to, do you already know the probability of Y by X? Yes, sir. And do you already know the probability? Do you already know the probability of Y by X? Yes, sir. I already know this matrix. And do you already know the probability of Z by Y? Yes, sir. So just do the matrix multiplication, you will get your answer. What I am saying, sir, Y by X this matrix and Z by Y this matrix. So make this matrix, then make this matrix. Do the matrix multiplication, you will get your answer of Z by X. So can you make this particular matrix? Surely I can make it. Y by X, that means two output Y1, Y2, input are X1, X2, X3. 1, 0, 0.4, 0.6, 1, 0. You can see here. 1, 0, 0.4, 0.6, 1, 0. Then 0.7, 0.1, 0.2. 0.7, 0.1, 0.2, last would be 0. And then 0.1, 0.6, 0.3. 0.1, 0.6, 0.3, this would be 0. Now if I do the matrix multiplication, do I know how to do the matrix multiplication? Yes, sir. What would be my input? Input would be, sir, X1, X2, X3. And what would be the output? Sir, output would be Z1, Z2, Z3, Z4. Output would be Z1, Z2, Z3, Z4. So do I know how to do the matrix multiplication? Surely, sir, I know how to do the matrix multiplication. So 1 multiply with 0.7, 0 multiply with 0, 0.7. 1 multiply with 0.1, 0 multiply with 0, 0.1. 1 multiply with 0.2, 0.2. 1 multiply 0, 0. And are we getting the same thing? 0.7, 0.1, 0.2. 0.7, 0.1, 0.2. So if a very big diagram is coming, let's just say, which is very, very rare, if very big diagram is coming, and here you might feel like that, sir, I may mess it up, then go with the matrix method. Simple thing is there, Y by X, Z by Y. This matrix multiply with this matrix. Okay? If very big diagram is coming. And if you feel like that, sir, I can go with this method as well, then you can go with this method. If I am a student, and if this kind of diagram is coming in the examination, I would go by this method. Because I don't want to do any minor mistake, right? Here there are chances of minor mistake, but here everything is very smooth. Simply this will be multiplied with this one. So 0.4, 0.28, then 0.04 plus 0.06, so that would be 0.1, then 0.08, 0.36, that would be 0.44, and then 0.18. So 2814418. 2814418, yeah. And the last line 712 would come. So you can see 0.7, then 0.1, and then 0.2, and then 0. So this is the matrix I have made. From here I can find out anything. What they are asking? Z3 by X2. So Z3 by X2. What that would be? 0.44. Answer would be 0.44. Very simple thing. So this is also how I can solve it. All good. Now they can ask anything, like if they are asking mutual information between, they can ask this particular thing. Can you calculate this particular thing? Surely I can calculate. If they ask the channel capacity, this channel I am calling as C. So if they are asking channel capacity, what you can do? H of Z minus H of Z by X. This would be maximum value of this one. So this would be log 2 4, and then H of Z by X you can surely calculate, right? From here H of Z by X you can surely calculate, because you are having these probabilities as well. So things are very simple, right? Everything you can do. Although till this date they never asked the cascading. Only one channel was given always. But next point, if they want to ask something good, then they can ask cascading as well. So if they are asking cascading, then this kind of question would be coming. But it would take a lot of time actually. Basically, this will be time taking, and you are not testing your brain here. Like, do you really think that it is tough? It is easy only, like anyone would be able to understand this particular thing. Any guy would be able to understand, and if he knows the concept, he will be able to solve. So here a professor will not be able to judge you. If he wants to judge you, then he will frame some good questions from other topics, no? But here judgment will not be done. Like everyone would be able to solve it. It's just that it will take time. So that's why you would see that these kind of questions have not come, and that's why I'm not writing down that it would be coming in 26 or 27, because it is not that difficult, right? But if a professor wants to judge you, then he will be framing problems from the previous topic that we have studied, from the channel capacity. From there, they can frame very good questions. Here, everything is very straightforward, right? Now, what will happen to channel capacity if we are cascading? So, this is a good point. From here, questions can be framed. I will put 1 star here. That's a good point. And from here as well, the questions are not coming. So, what is there? So, there is a channel A, diagram is given. There is a channel B, diagram is given. And the combined channel I am calling as channel AB. So you need to find out the capacity of A, you need to find out the capacity of B, and you need to find out the capacity of AB, and then you need to determine the relation between capacity of AB and CACB. Is that clear to you? So can you find out the capacity of this one? Yes, sir. Can you find out the capacity of this one? Yes, sir. Can you find out the capacity of the whole channel? Yes, sir. How will you find out? Sir, I will make the matrix. From x1 to z1, how many paths are there? 2 paths are there. 1 by 3 into 1, 2 by 3 into 1. So from x1 to z1, 2 paths are there. 1 by 3 into 1 and 2 by 3 into 1, that would be equals to 1 only. Now from x2 to z1, one path is there with the probability of 1 by 2 into 1, and another path is there 1 by 2 into 1 by 2, right? 2 paths are there, no? 1 by 2 into 1 and 1 by 2 into 1 by 2. So this would be 1 by 4 plus 1 by 4 plus 1 by 2, 3 by 4. And from x2 to z2, 1 by 4. Okay. So we need to find out capacity of channel A, capacity of channel B, and capacity of channel AB. So these values are given, but forget about these values. What I can do, first I can find out the capacity of, this is our channel AB, right? This is our channel AB. Channel AB. So directly here only what I will do, capacity of AB, what that would be? So that would be H of Z maximum minus H of Z by X, right? So H of Z maximum would be log 2 2, that would be 1 only, because two symbols are there, two output symbols are there, so it would be log 2 2 minus H of Z by X. So I can surely calculate H of Z by X as well. What that would be equivalent to? So this probability is 0.1 and this probability is 0.9. So 0.1 multiply with 1, then log to 1. 0.1 multiply with 1, then log to 1. Surely there is a negative sign, never ever forget the negative sign. So I am putting the negative sign here, plus, then 0.9 into 3 by 4. Let's do it on the next page only. Okay, let's do it on the next page only. So what is our H of Z by X? Again, calculation is there, but from the calculation we will bring a good result. So in place of 0.9, I am putting probability of x1 only. So probability of x1 multiply with 1. This is what we are getting. Probability of x1 multiply with 1. Probability of x1 multiply with 1, then log to 1. Plus negative sign I am putting here. Probability of x2 multiply with 3 by 4. Probability of x2 multiply with 3 by 4 log to 3 by 4, plus probability of x2 1 by 4 log to 1 by 4. Okay, is that clear to you? So what will be your capacity of AB? That would be log 2 minus H of Z by X. This value would be 0 only, right? And this is already negative, so what answer you would be getting? Let's keep everything as it is. So this is already negative sign, so this answer we would be getting that probability of x2 is outside 3 by 4 log 2 3 by 4 plus 1 by 4 log 2 1 by 4. That's the answer we are getting. This is the channel capacity AB. Now let's talk about the capacity of A. Capacity of A. So capacity of A would be Hy maximum minus H of y by x. So what would be your Hy maximum? Log 2 3 minus H of y by x. So minus H of y by x would be equals to 1 by 3 probability of x1, 1 by 3 probability of x1 log 2 1 by 3 plus 2 by 3 probability of x1 log 2 2 by 3, 1 by 2 probability of x2, 1 by 2 probability of x2 log 2 1 by 2 plus 1 by 2 probability of x2 log 2 1 by 2. Okay, so what you are getting? Capacity of A log 2 3 plus probability of x1 1 by 3 log 2 1 by 3 plus 2 by 3 log 2 2 by 3 plus probability of x2 log 2 1 by 2 is there, log 2 1 by 2 is there, and twice it is, so it would be log 2 1 by 2. Okay, so this is your CA. Let's find out CB now. Again, like just doing the calculation, nothing else. So H of Z maximum minus H of Z by Y. So what is your H of Z maximum? So H of Z maximum is actually log 2 2 minus H of Z by Y. So minus H of Z by Y, what that would be equals to H of Z by Y. The probability of y1 into 1 then log to 1, and then probability of y2 into 1 log to 1, that would be gone, right? Probability of y2 into 1 log to 1 plus probability of y1 into 1 log to 1, because log to 1 is equals to 0 only. So if transition probabilities are 1, I don't need to care about it. These 1 probabilities are there, then I don't need to care about it. So 1 by 2 probability of y3, 1 by 2 probability of y3. So you can do it on your own. It would eventually be coming out to be probability of 1 by 3, sorry, probability of y3 into 1 by 2 log to 1 by 2, but it will be multiplied twice. So this will be multiplied twice. So eventually it is coming out to be probability of y3 log to 1 by 2, right? So what is your CB coming out to be? CB is coming out to be log 2 2 plus probability of y3 log 2 1 by 2. Log 2 1 by 2. Now what is your capacity of A? This is your capacity of A. And what was your CAB? Where is your CAB? This is your CAB. So should we put down the value, or we can make the conclusion from here only? Without even putting down the values, can we make some conclusion? Basically, the conclusion would be, you can put down the values and the conclusion would come out to be, this would be the conclusion. And it is pretty obvious as well. Why it is obvious? Can you intuitively let me know why it is obvious? Like this kind of statement could be directly written in your examination, that which of the following option is correct. Two are cascaded. Now this channel is saying that I can maximum transmit 2 bits of information, and this channel is saying that I can maximum transmit half bit of information. Let's just say from here What this is saying that I can transmit 2 bit of information, and this is saying that I can transmit a 1.5 bit of information. From here 3 bit of information is going. So this would be able to transmit 2 bit of information. Now from this 2 bit of information, this would be able to transmit 1.5 bit of information only. So total how much information is being passed? 1.5 bit of information is being passed, but that's the ideal case you are taking, no? Like there is a pipe from where you can pass 1 liter, and then another pipe is there from where you can pass a half liter. So eventually how much water you will be able to pass? Minimum water, right? So this is saying 2 bit, this is saying 1.5 bit. So whatever the information that is reaching here, from that information I can only pass 1.5 bit. But it might happen that when this 3 bit information went from here, it might happen that here only you are not able to pass 2 bit of information, some lesser information you would be able to pass. This may also happen, no? Like what I mean to say is that from here only the information that was going, that was 1.3 bit. Or this would not happen actually. Basically, there could be the effect of noise as well, no? Are you able to understand this point? This is the best possible case they are taking. This is the best possible case they are taking. But every time both of the best possible case will not be aligning. Are you able to understand what I am saying? This is saying that best case is I can pass 2 bit, and this is saying best case I can pass 1.5 bit. So for the whole channel, best case you can pass 1.5 bit, but it could be lesser than that as well. Basically, if you put the values, I think that it would be coming lesser than that. So capacity would be either the minimum value of CACB or lesser than that. And I have verified it as well. Okay, this has been verified as well. You can check the value. Let's check the value. Let's put down the values. What is the probability of Y3? Probability of receiving Y3 is, what is the probability of receiving Y3? That is 1 by 2 into 0.9, right? Here only I can write down probability of receiving Y3 is, because in this expression what I would be needing, I need probability of receiving Y3, I need these probabilities, so only probability of receiving Y3 I need. So that is 1 by 2 into probability of X2, that would be 0.45. So this is the value that I would be requiring here. Log to 2 is 1 plus 0.45 log to 2, right? And this would be the minus sign. So answer would be 0.55. So this answer is coming out to be 0.55. And let's check this value. Or first let's check this value. This is 1 only. What is probability of X2? That is 0.9. 0.9. Now what about this one? Minus 1 by 2. This is minus 1 by 2. Now what about this one? 3 by 4 log to 3 by 4 into 3 by 4, right? So this is coming out to be minus, let me do the calculation again, 0.75 log to 0.75 into 0.75 minus 0.311, 0.25 log to 0.25 into 0.25 minus 0.311 into 0.9 plus 1, so 0.27. This is coming out to be 0.27. And let's check this one. So if I put the values, log 2 3 plus probability of x1, what that was, 0.1. So 0.1, and then these values I need to put, and then what this value would be, some value I will put here. What would be this value? Probability of x2 is 0.9, so this would be minus 0.9, right? Log 2 2 would be minus 1, probability of x2 is 0.9, this would be minus 0.9. This value I need to put now. So what that would be? So 2 by 3 log to 2 by 3 into 2 by 3, so minus 0.389, and then here 1 by 3 log to 1 by 3 divided by 1 by 3 log to 1 by 3 into 1 by 3, so minus 0.528 minus 0.389 multiply with 0.1. multiply with 0.1 minus 0.9. So minus 0.99. So basically it is coming out to be minus 0.99. Now log 2 3 3 log 2 3 minus 0.99. So it is coming out to be 0.59. 0.59. So you can say that it is capacity of AB is lesser than the capacity of minimum value of what is minimum between both of them. Minimum between both of them is 0.55. So this capacity of AB is even lesser than 0.55, that is 0.27. Is that clear? In some cases it can come equal as well. So sign would be lesser than or equals to. The capacity of AB would be lesser than or equals to minimum value of CACB. So directly this statement could be written. They will cascade two channels and they will ask you which of the following statements are true. Okay. Somewhere they will put the greater than sign, somewhere they will put the lesser than sign. In case of minimum, they can write down maximum as well. Right. So minimum, maximum, in that manner they can frame four options. Minimum, maximum, greater sign, lesser sign. So they can frame four options and they can directly ask you this particular thing. Is that okay for you? Okay. Yeah. So this discussion is completed now. Now let's study about the types of channel. So cascading of channel is completed. Next topic is types of channel. All these are some discrete topic we are studying. First we studied about cascading. Now we will see the types of channel. So what do you understand by noiseless channel? So first I will write down the conditions, then I will tell you the trick to remember as well. So noiseless channel, what is the meaning of noiseless channel? That means there is no noise. Noiseless channel. So this is our channel, applied input is X, received output is Y. So noiseless means if your input is X, output is Y. If your input is Y, output will be X, and in both of the condition H of X by Y would be equals to H of Y by X, and that would be equals to 0. Basically the noise part is equals to 0, noiseless. Considering this as input, this as output, or this as input, this as output. Basically if I look at X, if I already know Y and then I look at X, then I can tell everything about X. If I already know X, then I look at Y, then I already know about Y. Uncertainty in X, given that I already know Y, that is equals to 0. Uncertainty in Y, given that I already know X, that is also equals to 0. So this is your noiseless channel, and here mutual information would simply be equals to H of X, because minus H of X by Y, that is equals to 0, and that would be equals to H of Y. Is that clear to you or not? Okay, so H of X would be equals to H of Y. That means it is a noiseless channel. Okay. Lossless. Lossless means H of X by Y would be equals to 0. That means looking at Y, if I know Y, then there is no uncertainty in X, but this will be non-zero. Both cannot be 0 here. One of the value will be non-zero. Okay. So looking at X, if I already know X, then I cannot comment on Y, but if I already know Y, then I can comment on X. So uncertainty left in X such that you already know Y, that is equals to 0. Uncertainty in Y such that you already know X, that might be equals to non-zero. So what do you think, what will be the value of Ixy? So that would be equals to H of X, because this is equals to 0, but it would be equals to H of Y minus H of Y by X. Is that clear or not? Okay, well and good. What about deterministic channel? So in deterministic channel, output is determined. Deterministic, what is the name? Deterministic. That means output is determined. Output is determined, that means there is no uncertainty in the output, given that I already know X. That might be non-zero. So what do you think, what will be your mutual information? So mutual information would be H of X minus H of X by Y, that is equals to H of Y. So you just need to remember this condition, then you need to remember this condition, then you need to remember this condition. If you remember these conditions, you will be able to write down everything. What is the meaning of useless channel? What do you think, what should be useless channel? Channel is useless, that means it is not transmitting any information. What does that mean? X and Y are independent of each other. Independent of each other. If they are independent of each other, what is the meaning of that? That this would be equals to H of X and this would be equals to H of Y. Or what would be your mutual information? That would be equals to 0. And what is your general noisy channel? So if your channel is not falling in any of these categories, then it would be a general noisy channel. Like it is not necessary that your channel will have to fall in these categories. Like we have seen the example where this was also non-zero and this was also non-zero, and they were not independent as well. Like basically x and y are not independent. Along with that, this is also non-zero and this is also non-zero. Okay, then it is known as general noisy channel. So the channel which is not falling in any of the categories above, none of the above categories. Okay, so only this slide you will remember, nothing else you will remember. Like if you have already studied this particular topic, then this topic is taught for noiseless channel this kind of matrix would be there, for lossless channel this kind of matrix would be there. You will not remember anything. You will just remember these things. Noiseless is h of x by y, h of y by x equals to 0. Confusion would be between lossless and deterministic. That would be the confusion. So what do I remember? I remember XL, t-shirt size XL, or you can remember dy, dy by dx or dy. What do you mean by that, sir? When the L is coming, lossless L, that is related with x. So that means h of x by y would be equals to 0. XL. Or dy, when deterministic d is coming, that would be related with y. That means h of y by x would be equals to 0. Don't try to build up any concept that's deterministic, that means output will be determined, so h of y by x would be equals to 0. That concept will not be working in the examination. You will be getting confused there. So it was x by y or y by x. So don't make any concept, just remember the way. How will you remember? Sir, lossless L, XL, XL, t-shirt size is XL, right? So XL, XL, so x is 0. So h of x by y is equals to 0. Deterministic dy, dy, deterministic y, so h of y by x would be equals to 0. So in that manner I try to remember. You can write down any trick. If you want to write down this XL trick, then you can write it down here. Okay, XL dy trick, if you want to write down, you can write down anyway, or if there is any trick that you want to make on your own, that also you can make. Okay, so anyway we need to remember these, and only this slide we will remember how we will solve the problem. So let's try solving the questions. So input output relation is given. You need to determine the type of channel. So I guess you would be able to solve this problem if you have listened to the discussion that we did in the first lecture. Y is equals to 2x plus 1. From here what you can see, sir, x equals to y minus 1 divided by 2. So let's go to this guy. Sir, if I know the value of y, I am 100% sure about the value of x. That means if I know y, there is no uncertainty in x. Let's go to this guy. What does this guy say? Sir, if I know the value of x, 101% I am sure about the value of y. 1-to-1 mapping is there. No, y equals to 2x plus 1. This would be the graph. 1-to-1 mapping is there. So if you know the value of x, you know the value of y. If you know the value of y, you know the value of x. Both are 0. What does that mean? Noiseless. There is no noise. Best case it is. This is your best case transmission. What about, sir, y equals to x square? So again, from here x would be equals to plus minus under root y. Right? So let's go to this guy. Sir, if I know the value of y, do I know the value of x? No. Let's just say y equals to 1. So x could be plus 1 or it could be minus 1. So this is non-zero. Right? This example, everything we have already seen. If I know the value of y, it doesn't mean I know the value of x as well. So uncertainty in x such that I know y, there is some uncertainty, because if y is equals to 1, then x could be either equals to plus 1 or it could be minus 1. So surely there is some uncertainty. But what is this thing? So that would be equals to 0, because if you know the value of x, surely you know the value of y. If x is equals to 2, y will have to be 4. If x equals to minus 2, y will have to be 4. If x equals to 3, y will have to be 9. So that is equals to 0. So dy by dx, that means it is deterministic. Y is 0, deterministic dy. So it is your deterministic channel. Okay, deterministic channel. Y square equals to x, and it is important as well. Okay, this kind of questions have never been asked in the GATE examination, and surely it is coming. There people will be doing something like, okay, that concept we have studied, this concept we have studied, what formula we need to apply. Nothing formula, nothing. Okay, if the question is coming from information theory, that means rather than focusing on formula, I should focus on my intuitions, right? So y square equals to x. So from here y is equals to plus minus under root x. So if I go to this guy, if you know the value of y, you are 100% certain about the value of x, h of x by y. If I know the value of x, then I am not sure about the value of y. If x is 2, y could be plus under root 2 or minus under root 2. So here what do you see? X is 0. That means XL, L lossless. No relation between x and y. What does that mean? X and y are independent of each other. X and y are independent of each other. Of each other. Or this is not making much sense. That's it. Only 3 types of channel are necessary. Okay. Or but directly it could be written that x and y are independent of each other. What does that mean? This is your useless channel. Well and good. Okay. Let's solve this problem. If this kind of diagram is given, so you need to determine what kind of channel it is. So what you will do? We need to comment on these things, h of x by y and h of y by x. What is the meaning of h of x by y? That means you already know y, then there is no uncertainty in x. If you already know y, then what is the uncertainty in x? That is x by y. If you already know x, what is the uncertainty in y? So let's go to this guy. What this is saying, h of x by y, what this is saying? That if I already know y, then what is the uncertainty in x? So if I already know that, sir, y1 is received. I already know y1 is received. So can you let me know by looking at this diagram from where y1 would be coming? Sir, 101% it is coming from x1 only. If you already know y2, can you let me know from where it is coming? Sir, 101% it is coming from x1 only. If I already know y3, can you tell me from where it is coming? Sir, 101% it would be coming from x2 only. If you already know y4, can you let me know from where it is coming? Sir, 101% it is coming from x3 only, and same goes for y5 as well. Sir, 101% it is coming from x3 only. So if you know the output, then corresponding input you already know. That means there is no entropy left. But if I know the input, if I know x1, then can you let me know what will be the output? Some guy can say that, sir, output could be y1, and some guy can say that, sir, output could be y2. So if you know x2, some guy would be saying that, sir, here there is certainty, like if you already know about x2, then 101% y3 will be received. If you know about x3, then some guy would be saying that, sir, output could be y4, and some guy is saying that output could be y5. So there is uncertainty in this one, there is uncertainty in this one. So total uncertainty is surely non-zero. Is that clear? That means Lx, XL, this is lossless. So I have seen people mugging it up that this kind of diagram would be there, then it would be lossless. Doesn't make any sense. You are engineers, right? Right? You are not preparing for UPSC CSE. Even UPSC CSE doesn't require mugging up nowadays. Like if you see the question paper of UPSC CSE, nowadays they are framing like very good questions. There also brain is used. Previously it used to be the exam of memory, but now you cannot clear ESC prelims. Prelims is very tough now. Okay, so forget about UPSC CSE. Why we are talking about CSE now? So yeah, is this concept clear to you? Let's go to the next diagram. Just one thing I want to tell here. Here what you can see, only this greater than sign is there. No? Only greater sign is there. Here also this simple line is there. So only one kind of sign is there. Can you see that anywhere this less than sign is becoming? Like can you see less than sign anywhere in this diagram? We will come to this concept later on. It is not a concept, it is just an observation. So we will come to that later on. Okay. So what about this one? Again, I need to comment on these two guys. So if I already know y, do I know about x? So if I already know y, if I go to y1, can you let me know from where y1 would be coming? Some guy would be saying that, sir, it is coming from x1, and some guy would be saying that, sir, it is coming from x5. So it is non-zero. There you go. Only one of the symbol I require, no? Like if one of the symbol is having uncertainty, that means uncertainty would be equal to non-zero. What about h of y by x? Sir, if I already know x, then I am certain about y. So if I want to put it equals to 0, that means all the symbols I need to check. So first I will go to x1. I will ask x1, if I know about you, do I know what will be the output? Yes, sir. Output will surely be y1. If I know about you, do I know about the output? Yes, sir. Output will surely be y2. If I know about you, do I know about the output? Yes, sir. Output will surely be y3. If I know about you, do I know about the output? Yes, sir. Output will surely be y2. If I know about you, do I know about the output? Yes sir, output will surely be y1. So with respect to each symbol, you are having one output only, uncertainty is 0. So if I know x1, then surely output will be y1. If I know x2, surely output will be y2. If I know x3, surely output will be y3. If I know x4, output will surely be y2. And if I know x5, output will surely be y1. So this uncertainty is 0. What does that mean? dy, deterministic. Okay. But here, like other things are there. y2, you will go to y2, y2, you will ask y2. So two kind of output could be there. You will ask y3, only one. So here it feels like that uncertainty is 0, but these two guys will result in non-zero uncertainty. What about this one? If I go to x1, he will say only one output could be there, that is y1. If I go to x2, he will say only one output there, that is y3. Only one kind of output would be there, that would be y3. If I go s3, then only one kind of output would be there, that is y2. If I go to y1, only one kind of input could be there, that is x1. If I go to y2, only one kind of input could be there, that is x3. And if I go to y3, only one kind of input could be there, that is x2. So uncertainty in x such that I already know y, that is equals to uncertainty in y such that I already know x. So that is equals to 0 only. What does that mean? Sir, lossless. Sorry. Noiseless. No noise. Noiseless from both of the end. If input is x, output is y. If y becomes input, output will be x. Okay, so noiseless it is. What about this one? Probabilities are not written here. So what do you understand here? In this diagram, this greater sign is there. In this diagram, this greater sign is there. Right? In this diagram, this lesser sign is there. In this diagram, this lesser sign is there. But here you go. In this diagram, this sign is there. This sign is there. Along with that, this sign is also there. So surely it will be some general communication channel. It would be general communication channel. Sir, whether it will be lossless or not, that we will see. It might be lossless, it might not be lossless. So it would be lossless or not. For that, I will have to give the probabilities values. So with respect to probability value, how will you determine whether it is lossless or like it is useless or not? That we will see. But surely it is not useless. Sorry, surely it is not noiseless. Surely it is not lossless and deterministic. Basically, these three answers cannot be there. It is not lossless. It is not deterministic. And it is not noiseless. Sir, why you are saying so? Let's check that. Okay, let's check that. If I go to x1, he is sure that y1 will be received. If I go to x2, he is sure that y1 will be received. If I go to x3, he is sure that y2 will be received. But if I go to x4, he is not sure that either y2 can also be received and y3 can also be received. So this part is gone. So uncertainty in y such that I already know x, that is coming out to be non-zero. What about y1? If I go to y1, he can say that I can either come from x1 or from x2. Job is done. Right? That means uncertainty in x such that I know y, that is also non-zero. What does that mean? These three are not there. Okay, these three are not possible. So in the examination, what would be mentioned here? They will mention random probabilities and they will ask which of like this channel is option A lossless, option B deterministic, option C noiseless, option D none of the above. So answer would be none of the above. Some would be calculating mutual information, some would be calculating this thing, that thing. They will keep on calculating the things and it will take a lot of time. But if you want to solve in a quicker manner, that means you need to go by the intuitions. So if an IIT professor is framing this kind of problem, like what most of the people would do, either they will try to remember that what we studied. Okay, if this kind of matrix is there, that kind of matrix is there, so they will try to remember those things, or what they will do, they will try to calculate mutual information. Okay, not here. They will try to calculate mutual information. First, they will calculate the value of hx, then they will calculate the value of h of y by x. They will try to calculate the value of h of x by y, and after that, they will make the conclusion. So it will be a very hectic process, right? It will take a lot of time. But if you go by your simple concept, look at y, talk to x, look at x, talk to y, your job is done. Okay. So what if these kind of metrics are given in the examination, then how will I solve it? I will make the diagram. If this matrix is given and they are asking you what kind of channel is there, will you go by something that you remember? No, I don't remember anything. Right? And this thing you might have already noticed that if you are studying from this platform, you need to remember minimum things. Because we are making engineers, we are not making some random guys who memorize the thing. So this doesn't require, gate examination never requires memorizing the things. I'm not saying that you should never memorize anything. You should surely memorize some things, but not everything. I have seen that even the content is taught in a manner that this you remember, that you remember. Doesn't make any sense. What I will do, I will simply make the diagram. That's it. And once I have made this diagram, my job is done. And do I know how to make these diagrams? Very easily I can make these diagrams. So what I will do? Sir, from x1 to y1, probability is 1 by 3. Then x1 to y2, probability is 2 by 3. 1 by 3, 2 by 3. And if you remember a lot of things, then in the examination, you will not be able to remember all those things. Basically, you might feel like that, sir, I have remembered this thing. So as of now, it will feel good. When the teacher is teaching, you will feel good, okay, sir, I can remember it. But when 10 subjects are compiled up and you go in the examination hall and that particular thing is coming in front of your screen, you would forget what you have remembered. Okay, so always from wherever you are studying, always try to remember the minimum things. And if you are remembering something, at least make some trick. If you make some tricks, then it will be there in your mind for a longer time. But even the tricks will not be there for a longer time, but for the examination purpose, you can at least make some trick. So what do you think? If I go to x1, will I be able to determine the value of y1, y2? No. It can say either I can go to y1 or I can go to y2. So if I already know x, this is coming out to be, better I should write down here. Where I should write down? For this one I am writing down. Uncertainty in y such that I already know x, that is non-zero. Uncertainty in x such that I already know y, what that would be. If I go to y1, it would be equals to x1. If I go to y2, it would be equals to x1 only. If I go to y3, he will say that I am coming from x3 is going to y4, right? x3 is going for y4. x3 is going to y4. So this will, y3 will say that, sir, I am coming from x2 only. y5 will say that, sir, I am coming from x2 only, and y4 will say that, sir, I am coming from x3 only. So what do you see? This is equals to 0. So x is 0, Lx lossless, right? Lossless. Like here, if I don't tell you the trick, I say that, sir, here also you need to remember the concept. Then that would be wrong. Like I say the lossless. What is the meaning of lossless? No loss will be there in the forward direction. That means h of x by y would be equals to 0. So you remember it by some concept. You cannot remember it by concept. Here trick should be necessary. So there is always some equilibrium. When you are cracking a competitive examination, there has to be some equilibrium between concepts and tricks and tips, right? So that equilibrium is always maintained. Now again here also I will make the diagram only. Sir, I have 3, 4, 5 input and 3 outputs. So let's make the diagram, sir. x1, x2, x3, x4, x5, y1, y2, y3. So from x1 to y1 I am going, then x2 to y2 I am going, and then x3 to y3 I am going, right? Then x4 to, from x4 to y2 I am going, and then from x5 to y1 I am going. Okay. So they are going to one guys only. y1, this is going to y2, this is going to y3, this is going to y1, and this is going to, not y1, this is going to, x4 is going to y2, and this is going to y1, x3 is going to y. But y1 will say that, sir, I am coming from x1 and x5, x1 and x5. So uncertainty in x such that I know y, that is non-zero, because y will say that, sir, I am coming from 2 guys. But uncertainty in y such that you know x. So if you know x, surely you know y as well. So that is equals to 0. That means it is deterministic, right? And I am pretty sure those guys who are mugging up by the method of matrix, they will put noiseless, because this matrix and this matrix both looks nearly similar. Are you able to understand what I am saying? A lot of guys would be putting this particular matrix as noiseless, because this is the matrix of deterministic and this is the matrix of lossless. You will see that it is lossless only, and both are looking nearly similar. But if better we go with this concept, no, better we make the diagram. So x1, x2, x3, y1, y2, y3. So here each guy is going to each guy, and each guy is coming from each guy, one guy only. So x1 is going to y2, x2 is going to y3, and x3 is going to y1. So you can see that everyone is going to one guy. y1 is sure about x3, y2 is sure about x1, y3 is sure about x2, x1 is sure about y2, x2 is sure about y3, and x3 is sure about y1. So what do you see here? Uncertainty in x such that I know y is equals to uncertainty in y such that I know x, that is equals to 0. What does that mean? That means it is noiseless. So noiseless and deterministic, both matrix look similar but they are different. Now what about this one? So if this kind of matrix is coming, what I would do? I would solve it. Most probably I will solve it, but this is your x1, this is your x2, this is your y1, this is your y2. So nothing would click to me. Basically, if I see here x1, x2, y1, y2. So if I make the matrix, what I would see? Sir, from x1 is going to y1, y2 both, and x2 is going to y1, y2 both. So this is 0.3, this is 0.7, this is also 0.3, and this is also 0.7. Right? So x1 is also not sure about y1, y2. Both guys are there. x2 is also not sure about y1, y2. y1 is also not sure about x1, x2. y2 is also sure not about x1, x2. So either it could be general noiseless channel, general noisy channel, not noiseless, general noisy channel, or it could be useless, right? So both of the things are there. So what I would do, I would calculate h of y by x. First thing is that I would calculate h of y by x, and I would also calculate h of y as well, because I need to check. First thing is that why I am calculating h of y by x, because it is easy to calculate, right? Which is easy to calculate, h of y by x or h of x by y? H of y by x, right? So I will calculate h of y by x. For that I would require the probability of x1 transmission. That would be, what would be the probability of x1 transmission? That I will not be able to check from here, right? You cannot check the probability of x1 transmission, neither you can check the probability of y1 transmission as well. Can you check the probability of y1 transmission? You can simply find out the relation, but you cannot check the probability of x1 and y1 transmission, right? So let's see what I will do. I need to calculate h of y by x. So I'm assuming that probability of x1 transmission is alpha, so this would be 1 minus alpha. Okay, so what will be the scenario? And it is not binary symmetric channel, because 0.7 and 0.7 both should have been same. This is 0.7, this is 0.3. So what I would do? So 0.3 into alpha, surely there is a negative sign. So 0.3 into alpha log to 0.3 plus 0.7 into alpha log to 0.7, 1 minus alpha into 0.3 log to 0.3 plus 1 minus alpha into 0.7 log to 0.7, right? So what we are getting, log to 0.3 and log to 0.3 can be coming common. This much part and this much part can be coming common. Then 0.3 log to 0.3. This minus sign I can take this side. Now I can take this minus sign here. So this is the value of h of y by x. I am calculating h of y by x. So this is your h of y by x is coming out to be minus 0.3 log to 0.3 and minus 0.7. This log 2.7 and log 2.7 is coming common, and 0.7 is also there. So minus 0.2 log 2.7. So this is the answer of h of y by x. Then I can calculate h of y as well. So what would be my h of y? So for h of y, what will be the probability of receiving y1? The probability of receiving y1 would be 0.3 into alpha plus 0.3 into 1 minus alpha. That would be equals to 0.3. So probability of receiving y1 is 0.3. And what will be the probability of receiving y2 then? So that would be equals to 0.7. So what will be the answer? Minus sign will surely be outside, log 2.3, and minus sign will surely be outside, log 2.7. So both are same, both same. What does that mean? That means it is useless. Okay, it is your useless channel. If both were not coming same, that means it was not useless. So this you could have done. Or if I see this kind of matrix, that means sir, surely there is some symmetry. Rows are same. Either rows could be same or column could be same. Now what is the meaning of useless channel? Useless channel, that means y is independent of x. Useless means y and x are independent of each other, right? So if y and x are independent of each other, can you let me know what will be the value of p yj by xi? For useless channel, x and y are independent of each other, that means this value will be probability of j and this value will be probability of xi. Say yes or no. Now when I make the probability of y by x, what do I write down? Sir, here you write down x1, here you write down x2, here you write down y1, y2, y3 and so on. So this would be your y1 by x1, y2 by x1, y3 by x1. So how this will be reduced to? So this will be reduced to this much. That sir, probability of y1 by x1 would be probability of y1 only. Sir, y2 by x1 would be probability of y2 only. Sir, y3 by x1 would be probability of y3 only and so on. Now y1 by x2, y1, y2 by x2, y2, y3 by x2, y3 and so on. Rows are same row. So for useless channel, the rows would be same, but you don't need to mug it up. Which condition? Probability of y by x condition. If you are making x by y condition, then column would be same. If you are making x by y matrix, then x1 by y1 would be replaced with x1. x2 by y1 could be replaced with x2. x1 by y2 could be replaced with x1. x2 by y2 could be replaced with x2 and so on. You can see that here what are same? Columns are same. So don't mug it up. If you see rows or columns same, something symmetry you see, that means you know that sir, I need to come here. Then you would make probability of y by x, then you would write down this step and then you would see that if rows are same, for the joint matrix of y by x, not joint, sorry, for the conditional matrix of y by x, if rows are same, then it would be then it would be useless channel, and for the joint matrix of x by y, if columns are same column, then it would be useless. So this is the condition for useless channel. So how would you determine whether the channel is useless or not? You would make the matrix. No matter whether this kind of diagram is given, even this kind of diagram is given, then also you would make the matrix. You would make the matrix and you would see that some symmetry is coming or not. So if rows are same for the matrix of probability of y by x, then you would say it is useless channel, otherwise it is not useless. Is that clear to you or not? So let's just say here this value has to be 1 in this condition. x1 is only going to y1, so it has to be 1. Like, can you write down the probabilities here? It has to be 1. x2 is only going to y1, so this also has to be 1. x3 is going to y2, this is also going to y2 only, so this also has to be 1. Now x4 is going to y2 and y3, so if it is going to y2 with the probability of alpha, then this would be 1 minus alpha. So this kind of scenario would be there. Although I did not write down the probabilities here, but this should be your task, that sir, I am able to write down the probabilities. If you are able to write down the probabilities, now what you can do? You can make the matrix. What kind of matrix you can make? Probability of y by x. This matrix you can make. Sir, if I can make this matrix, what do I see? That surely, sir, my rows will not be same. First thing is that, sir, I know all these things. That means these 3 options are cut. Now 2 options would be left, that it could be either a general noisy channel, or it could be useless. So sir, I am checking whether it would be useless or not. So for checking whether it is useless or not, what I am making? I am making this matrix. So x1 by y1, that is 1. x2 by y1, that is also 1. Then x3 by y1, these are not even coming. Now x1 by y2 by x1, that is 0. y2 by x2, that is also 0. y2 by x3, that is 1. y2 by x4, that is alpha, and 4 inputs are only there. No, why I am making 5 input? 4 inputs are only there. This was 0 1 0 alpha. Now what about this one, sir? Y3 by x1, y3 by x1 not even coming, y3 by x2 0, y3 by x3 0, and this is 1 minus alpha. Yeah, so this is the matrix I have made. So surely it is not useless, right? Why it is not useless? Because there is no chance that your rows could be same. Rows are not same. This row and this row is same, but this row and this row can never be same. Basically all 4 rows can never be same. If this is 1, this is coming out to be 0, then your rows can never be same. If rows are not same, that means it is not useless. So it would be a general noisy channel. So option D, I will not frame none of the above. Option D, I will frame general noisy channel. Okay, and in one of the options I will put useless as well. So there the student would be confused that whether it could be useless or it could be general noisy channel. Because if someone has studied on good level, then he would know this thing. But if someone has studied on a very good level or very good level, then he would know this particular thing as well, that rows are not same. Okay. So basically from all the discussion that we have done, only thing you need to remember is this slide. If you remember this slide, all the analysis you will be able to do. All this analysis, matrix analysis, then this matrix, whatever the analysis that we have seen, everything you would be able to do if you only remember which discussion? Only this particular discussion. Is that clear? Crystal clear? Job done? Now we are going to see some discussion of expectation of fx. So this is not related to information theory. You can say that, sir, it is a topic of random variable. Okay, it is a topic of random variable. Nothing would be related to information theory here. But what I saw is that in 2 of the NPTEL assignment from different professor, this particular concept was given. So that's why we need to study this concept, because in the NPTEL assignments, the questions were there from expectation of fx. What they would do? They would give you expectation of x, okay, and then they can ask you to comment on expectation of fx. They would give this particular thing and they will ask you to comment on expectation of fx. Now fx could be anything. Let's just say fx is 2x plus 3. So can you comment on expectation of fx? Yes, sir. It would be 2 into expectation of x plus 3. Right? If I need to find out expectation of fx, then you would know that, sir, expectation operator would go here. 2 is constant valued, so 2 into expectation of x plus 3. But what if I give you fx is equals to x square plus 3? Not x square. I give you something else. Log x plus 3. Sir, so expectation of fx would be expectation of log x plus expectation of 3, that would be 3. Now, what do you comment on expectation of log x? Someone would say that, sir, it would be equivalent to, sir, log x fx of x dot dx. Yes, it is fine. Expectation of log x would be log x fx of x dot dx. It is fine. But this distribution I did not give. I only gave the value of expectation of x. I gave the value, let's just say expectation of x is 2. Then someone would say that, sir, I know this value now, fx of x dot dx minus infinity to infinity, that is equals to 2. So something I will try to find out. It would take a lot of time. You will not be able to find out. So what is a certain way there? What kind of things, what kind of conclusion is there? So there is a particular theorem. So that theorem we are going to see. Is that clear what we are going to see? But before that, there is some prerequisite. So if a graph is looking upward, if the graph is looking upward, it is known as graph between y and x. So it is known as convex. Okay, and if it is looking downward, it is known as concave. You don't need to remember it. Just for the theoretical purpose I am telling you. Okay, you don't need to remember it. What I am saying, if the graph is looking upward, it is known as convex. If it is looking downward, it is known as concave. You don't need to remember it. What we will just say, looking upward, looking upward, looking upward, looking downward. So apart from linear graph, every graph will either look upward or it will look downward. What I am saying, apart from the linear graph, every graph will either look upward or it will look downward. Let's just say I talk about this graph. It is looking upward, but someone says, sir, linear graph, so it is not looking upward or downward. But we are not interested in studying expectation of fx for the linear case, because if fx is linear, that means this would be the scenario, and here I can easily find out the expectation of 2x plus 3. So we are not looking for the linear case, we are looking for non-linear case. So this fx and x will be having non-linear relation, because for the linear case we already know everything, right? So is that clear? Like someone would say that, sir, what if the graph is like this? So till this point it is looking downward, then after that it is looking upward. So both nature is there, looking downward nature is also there, looking upward nature is also there, right? So every graph would be either looking upward or it will be looking downward. So convex, concave, I don't need to remember. For the theoretical purpose only I have written down convex and concave, but what I will remember, looking upward or downward. Why you need to remember that we will see, but before that let's solve a problem. From this problem we will make some conclusion. So x is given, probability of x equals to 1 transmission, probability of x equals to 4 transmission given. You need to find out the expectation of x, then you need to find out the expectation of x square. Here expectation of x and expectation of under root x you need to find out. Okay, both are very simple questions. Here basically y is equals to x square is given and you need to find out the expectation of y, right? Because y is equals to x square, so this is what you need to find out. And here y is equals to under root x is given and you need to find out the expectation of y only. Okay, what about this graph? What is the graph of y equals to x square? So this graph is actually looking upward. And what is the graph of y equals to under root x? This is the graph of y equals to under root x, because x has to be greater than 0 here. So this graph is looking downward. So this is a looking upward graph, this is looking downward graph. From both of these questions we are going to make some conclusion. Okay, so solve it on your own. I will take a break and I will come back. So you should be able to solve it. Like it is a very simple question. If you are not able to solve this one, then needlessly you are studying information theory, or even you needlessly you are studying your communication system. At least you should be able to solve this particular problem. Okay then, yeah. So let me take a break because it's been more than 65 minutes or 75 minutes. I will take a break, drink some water, and then I will come back. Yeah, welcome back. So did you try this question? What will be the expectation of x? So random variable x is taking value 1, it is taking for half time, then it is taking value 4, it is taking for half time. So 2 plus 0.5, it would be 2.5. So expectation of x is 2.5. What will be the expectation of x square? Sir, x square will take value 1 and 16. X square will take the value 1 with the probability of 1 by 2. It would take the value 16 with the probability of 1 by 2. So 1 by 2 plus 8, what we are getting? 8.5. And what will be your expectation of under root x? Sir, under root x would be taking value 1 and 2. 1 value it would be taking with the probability of 1 by 2 and 2 value it would be taking with the probability of 1 by 2. So answer would be 1 by 2 plus 1, that is coming out to be 1.5. Okay, so these three answers we are getting. So here what you can see, that your expectation of x square is greater than something. It is not necessary that it is greater than expectation of x, just you need to know that expectation of x square is greater than something and expectation of x is and expectation of under root x is less than something. Basically here expectation of x square is greater than your expectation of x, or greater than some value I need to write down. Let's just say the value that I need, that I am writing down, that is 2.5, and your expectation of under root x is less than 1.5. So expectation of x was 2.5. When I did x square, the value got increased, and when I did under root x, the value got decreased. Now what all are the graphs? What is the graph of x square? What is the graph of x square versus x? And what is the graph of under root x? These two examples I am telling just to make you remember something. Like you should not be getting confused in the examination. You should not be forgetting the equation directly. That's why I took these examples. So this is the example of y equals to x square. Y equals to x square versus x. And this is the example of y equals to under root x versus x. So this is looking upward. Looking upward. And this is looking downward. Okay. So there is some theorem. The theorem says that for the graph that is looking upward, expectation of fx is greater than f of expectation of x, greater than or equal. And for the graph which is looking downward, expectation of fx is lesser than f of expectation of x. Sir, what is the meaning of this one? I will tell you. Don't worry about that. Is that clear? Like, can you remember these two things? Concave and convex, you don't need to remember. Only you need to remember looking upward. So if you are looking up in your life, then you will be greater than something. So expectation of fx would be greater than something. And if you are looking down in your life, expectation of fx would be less than something. And that something is that f goes outside, e goes inside. So what do I mean to say here? Expectation of fx, looking upward graph, this graph is looking upward, right? This particular graph is looking upward. So expectation of fx would be looking upward. That means expectation of fx would be greater than f of expectation of x. Now expectation of fx, what is fx? Here our fx is equals to y, which is equals to x square. So expectation of x square would be greater than or equals to f of expectation of x. What is expectation of x? Sir, expectation of x is 2.5. So your expectation of x square would be greater than f of 2.5. What is the value of f of 2.5? From here, can you find out the value of f of 2.5? Yes, sir. That value will be 2.5 square. That would be 6.25. 6.25. That means no matter whatever the example you take, expectation of x square would always be greater than 6.25. Like here, a random example we took, there we calculated the expectation of x, but no matter whatever the random example you take, this equation will always be followed. So what they could have mentioned, they could have given a question in a manner that your expectation of x is 2.5, right? Expectation of x is 2.5. Now another function fx is defined as x square. Then find out the minimum value of expectation of fx. What will be the minimum value? What they are asking to find out the minimum value of expectation of fx. So you know that, sir, this equation will be followed. Expectation of fx is greater than or equals to f of expectation of x. What is the expectation of x? That is 2.5. That means expectation of x square would be greater than f of 2.5. Then I will put 2.5 here. So expectation of x square would be greater than or equals to 6.25. That means minimum possible value for expectation of x square would be equals to 6.25. Okay. Here randomly I took some example. We got to know that yes, surely it is greater than 6.25 only. Is that clear? So what kind of questions can be framed? So these kind of questions were given in that NPTEL assignment. And from there, then some lecture, I went to some lecture and then I studied this concept. If graph is looking upward, then this equation is there. Looking upward. So if you are looking up in your life, like you are not looking down, you are looking up in your life, that means you will be greater than something. If you are looking down, then you will be less than something. Okay. Similarly, here as well, you can do the same thing. This graph is looking downward. This is fx of x is under root x. So expectation of fx would be less than or equals to f of expectation of x. So expectation of fx, what is fx? Under root x. So expectation of under root x would be less than f of 2. Now what is your f of 2? From here you can see that, sir, f of 2 would be simply equals to under root 2. So your expectation of under root x would be less than under root 2. So expectation of under root x is less than 1.414, which is lesser. अरे भाई ये क्या हो गया? अंडर रूट 4 2, ओहो हो, ये क्या आ गया भाई? समथिंग इज रॉन्ग. एफ ऑफ या इट इज 2.5 यार, क्या कर रहा हूँ मैं? एक्सपेक्टेशन ऑफ एक्स इज 2.5. एक्सपेक्टेशन ऑफ एक्स इज 2.5, राइट? So under root 2.5. Now you can calculate the value of under root 2.5. $1.58. Okay. This will be 1.58. So expectation of under root x, the maximum value of expectation of under root x would be 1.58, and you can see that it is coming out to be 1.5. So here I could have written that it would be lesser than or equals to 1.58, and here I could have written that it would be greater than or equals to 6.25. Is that clear? Okay. So only thing you need to remember is this particular slide. This particular discussion you need to remember. Will you be able to remember this particular discussion? Looking upward graph, looking downward graph. So this was the question given in NPTEL assignment. Although it was not a MCQ there, it was not MSQ, I have made it MSQ. Okay. So x is a random variable having expectation of 2. What could be the possible value of expectation of x ln x? Like x could be any random variable, we don't know about that. So based on the random variables, what all values they can take? This is what they are asking. So first I need to know the nature of this graph. My graph is x ln x. So can you draw the graph? X ln x will be looking upward. I already know it. And surely x is greater than 0 because ln x will not be defined. So here it should be given in the problem that x is greater than or equals to 0 is also not taken. So x would be greater than 0 or equals to 0. ln 0 is minus infinity only. So yeah, you can define it actually. So x greater than equals to 0. Okay. So what will be the value of fx? What will be your f of 0? Sir, 0 ln 0. Sir, it is 0 into infinity, undeterminate form. Indeterminate or undeterminate, whatever it is, indeterminate form. But sir, do I need to solve it? No sir, you have already said that 0 ln 0 is coming, it would be 0 only. We have already solved it. No, you can apply L'Hopital. L'Hopital rule you can apply. Ln x divided by 1 by x. So here the differentiation would be 1 by x. Here it would be 1 by x square. Right? Negative sign would be there. So x square divided by x. Answer would be x. Then you are putting 0. So x put 0. What will be the answer? 0 only. So this we have already seen. F of 0 is 0. Now we need to find out minima maxima, whatever it is. So what I will do the differentiation and then put that equals to 0. It is simply mathematics. I am drawing the graph of x ln x. Why I am drawing the graph of x ln x? Because I need to apply that equation. What equation I need to apply? That's our expectation of fx and f of expectation of x. So there would be some relation between both of them. Expectation of fx and f of this f goes outside and e goes inside. So there will be some relation, sir. Whether it will be greater or it will be lesser, that I need to check. So that's why I am making the graph. Whether the graph is looking upward or looking downward, that I need to check. Now, sir, what if the graph is looking downward and upward both? Let's just say, what if sir, the graph comes out to be in this manner? That sir, till this point it is looking downward and then till this point it is looking upward. So this is the graph of fx versus x, right? So there what you will define, if the value of x is between 0 to 1, then looking downward, that means this equation will be valid. And if the value of x is between 1 to infinity, then this equation would be valid. Is that clear to you? Are you able to understand? Like if the graph is looking downward, then this equation is valid. And if the graph is looking upward, then this equation is valid. So when graph is looking downward, when your random variable x is taking value between 0 to 1, then this equation will be valid. And if it is taking value between 1 to infinity, then this equation will be valid. Okay, if both of the natures are there. In a graph, if you see both kind of nature, then this kind of conclusion you will write down. Okay, I would say it is important because in a lot of NPTEL assignment, this kind of question is there. So, and GATE also did not ask this kind of question in like never they asked this kind of question. So it might be coming anytime in future. Okay, so what we are doing, we are just drawing the graph of fx. Our target is to draw the graph of fx versus x. This is our target. So I am finding the minima or maxima. I'm not sure whether I will get minima or maxima. So let's check that. So x ln x plus ln x, that should be equal to 0. So x is coming out to be 1 by e. Okay. So at 1 by e, what you will get? You will get minima or maxima. So there are n number of methods you can check from that. It will be minima only. Why you are saying, sir, it will be minima only? Because you can check the value of fx at 1 by e. What is the value of fx at 1 by e? So that would be 1 by e ln 1 by e. So it would be minus 1 by e. So at 0 you are getting value 0, and at 1 by e, you are sure that whether it would be maxima or minima. If it was maxima, let's just say if it was maxima, then the graph would have gone like this. That means at 1 by e you would get a positive value, but you are actually getting minimum value. That means this is how the graph would go. So graph is actually looking upward. Now what will be the value at infinity? What will be your f of infinity? So that would be infinity into ln infinity. So again L'Hopital I can apply. Limit x tending to infinity ln x divided by 1 by x. So limit x tending to infinity 1 by x square. Sorry, 1 by x square minus sign, and ln x is 1 by x. So this goes upward. Answer is coming out to be minus infinity. At infinity, the answer is minus infinity. Is that so? Are we doing some mistake? It will not be minus infinity, no. There is only one guy. How it will be minus infinity? What is the graph of x ln x? At infinite, the value will be minus infinity or plus infinity? It should be plus infinity only. The value will keep on increasing, no? It will not decrease. Why I am getting minus infinity then? Okay, sorry. This is wrong, right? This is wrong. Why it is wrong? Because infinite into infinite. Is this indeterminate form? No. Very high value multiply with very high value. Is it indeterminate form? No. It is not indeterminate form. This is infinity only. Okay. Very bad mathematics from my end. If you need to calculate f of infinity, then infinity ln infinity. Infinite into infinite. It is not the indeterminate form. Very large value multiply with very large value. What that would be? That would be very large value, no? 0 into infinity. That is indeterminate form, because very lesser value and very large value both will be multiplied. Now you are not sure what will be the answer. Very less, very large. So now you are not sure whether it would be going towards 0 or it would be going towards infinity or it would be somewhere in between. But very large multiply with very large, that will be very large only. Very low multiply with very low, that will be very low only. But very low multiply with very large, that would be your indeterminate form. Right? Fx of x versus x. Okay. So whatever the value is, basically you got to know that graph is looking upward. This graph is looking upward. And if the graph is looking upward, now you know one thing, that sir, expectation of fx would be greater than or equals to f of expectation of x. So expectation of fx, which is x ln x, which is x ln x, would be greater than f of expectation of x. What is the value of expectation of x? That is 2. Okay. So expectation of x ln x would be greater than f of 2. What is the value of fx here? Fx is x ln x, right? Fx is x ln x. So what will be the value of f of 2? Sir, f of 2 will be 2 ln 2. So what will be the value of 2 ln 2? You can solve it and you will get the answer. So 2 ln 2, that would be 1.386. 1.386. So expectation of x ln x should be greater than or equals to 1.386. 1.386. That means value should be greater than 1.386. So this value is possible and this value is possible. There you go. Okay. A very good question. This kind of a problem can be asked in your examination. Next example is this one. X is a random variable. Expectation of x is 2. The possible value of expectation of ln x. Now your fx is ln x. And now you already know the graph of ln x. Right? I hope this much mathematics you already know, and surely it should be given in the examination that here your x is greater than or equals to 0, right? So graph of ln x versus x, how the graph would look like? This is how the graph would look like, and this value will simply be 1 by, this value will simply be 1, right? So graph is looking downward. You can directly see that graph is looking downward, right? So this is your looking downward graph. So if it is looking downward, then expectation of ln x would be greater than, or better we should write down in this manner only, like expectation of fx would be less than or equals to f of expectation of x, f of expectation of x. So what is fx? That is ln x should be less than f of expectation of x, that is 2. Now what is the value of f of 2? From here we can see that f of 2 is ln 2. So expectation of ln x would be less than equals to ln 2. Can you find out the value of ln2? Yes sir, it would be 0.693. So expectation of ln x would be less than 0.693, less than 0.693, less than 0.7. It would be this one and this one. There you go. Okay, so these are the answers. It may be coming in your examination very soon. Okay, so you should star mark it. Just simple thing is that this line I will remember and my job would be done. So within seconds I will be able to revise this particular topic. Okay, so you can consider this topic as a topic of random variable, right? It is not information theory. There is no concept of information theory, but it could be taught as a concept of random variable. All good, all fine. Let's solve this problem. A very good question. I told you for the binary symmetric channel we will discuss about h of x by y. Along with that we will discuss mutual information as well, and in GATE 2026 it is coming, or in 2027 or in 2028. In these 3 years you would see this kind of question coming. We are not discussing h of y by x. Have we already discussed h of y by x? Have we already discussed the capacity? Yes sir. Both of the things have been already discussed. You have made the waveform as well. Now sir, you are discussing h of x by y with respect to q. Q is the probability of transmission of bit 0 and bit 1. Like q is the probability of transmission of bit 0, probability of transmission of bit 1 is 1 minus q. With respect to q you are discussing for different values of p. What does that mean? That means you will draw the graph of h of x by y versus q. So value of q would be between 0 to 1, right? Now let's just say for graph of this graph you are getting for p equals to 0.5. Then it might happen that this graph you will get for p equals to 0.3. That means for different value of p you will draw the graph. Is that clear? And similar thing you need to do with mutual information as well. Don't apply any mathematics. Go by the intuition. These are the options. You let me know. These are the options for conditional entropy, and these are the options for your mutual information. So which of the option would be correct? Okay, see the option, take the screenshot if you want to take the screenshot. See this option, if you want to take the screenshot you can take the screenshot, and then sit with a cool mindset and try solving this problem. Surely, very surely I am pretty sure that this question is coming any soon. And if you go by the mathematics it would become very difficult. Go by your intuition. Take the value of q equals to 0, q equals to 1, p equals to 0, p equals to 1, somewhere in between value of q. So in that manner you think, and what do you think, what kind of graph you will be getting? Okay, so do that kind of that kind of problem solving you need to do. So let's get started. First we will be talking about uncertainty in x given I already know y. Okay, so I will be taking that q is equals to 0. If I take q equals to 0, that means bit 0 is not being transmitted. 101% bit 1 is transmitted. If q is equals to 0, what does that mean? That means probability of bit 0 transmission is 0 and probability of bit 1 is transmission is 1. That means what will be the uncertainty in x? What do you mean by x? X is the input. Okay, this should be given in the problem. That these are your x and this is your y. So now you are 101% sure that sir only bit 1 is transmitted. That means what is the expectation of x? But sorry, what is the uncertainty in x? But we are not caring about uncertainty in x. We need to care about uncertainty in x such that y is known. So basically probability of bit 0 is not being transmitted. Only bit 1 is being transmitted. Only bit 1 is being transmitted. Okay, and two kind of output could be there, 0 or 1. Now what do you see? This output you are getting with probability p, and this output you are getting with probability 1 minus p. Now I ask you, what would be your h of x by y? If I already know about y, do I already know about x? If I go to bit 0 and I ask you from where you are coming, he will say sir I am surely coming from 1, and he will also say that sir I am surely coming from 1. Let's call this as x1. Okay, this as x1. So if I go to this bit 0, then he will say sir surely I am coming from x1, and he will also say that surely I am coming from x1. That means uncertainty in x is that I already know y, that is equal to 0. So if q is equal to 0, this will always be 0, and same goes for q equals to 1 as well. Do you agree to this point or not? What I mean to say is that let's add some page Let's add this page here and add this page also upward only here. So what I am saying is that if q is equals to 1, what does that mean? That means probability of bit 0 transmission is 1, but probability of 1 transmission is 0. That means only bit 0 is being transmitted. Bit 0 is transmitted, received bit could be 0 and 1. Bit 0 is received with the probability of p, and it is received with the probability of 1 minus p. P and 1 minus p. This is your probability of bit 0 transmission, that is equals to 1 only. Now if I go to y, let's call this as x0. If I go to y, if I go to bit 0, I will ask him that from where it is coming. He will say I am surely coming from x0. He will also say that I am surely coming from x0 only. So uncertainty in x is that pi is known, that is equals to 0. So what is the first conclusion that I have made? If your q equals to 0 or 1, then your h of x by y would always be equals to 0. Is that clear to you? So what we are doing? We are drawing the graph of h of x by y versus q for different value of p. H of x by y versus q for different value of p. Now without even defining the value of p, I get to know that at q equals to 0, this value will be 0. At q equals to 1, this value will be also 0. Forget about the value of p. I am not even talking about the value of p. For any random p, if q is equals to 0 or 1, then h of x by y would be equals to 0 for any p, for any random value of p. I am not even talking about the value of p. Now let's take the case of q equals to 0.5. Q equals to 0.5. If q equals to 0.5, that means probability of bit 0 transmission is 0.5 and probability of bit 1 transmission is 0.5. Now here you go, bit 0 and bit 1. This will be received with probability p. This is also p or p. Okay, it was actually opposite. This was p, this is 1 minus p, but it doesn't matter actually. This is 1 minus p and this is also 1 minus p. Now if I go to this guy, I will ask him from where you are coming. He will say, sir, I can either come from 0 or I can come from 1. I will go to this guy. This I am calling as x0 and this I am calling as x1. So if I go to bit 0, it will say either I can come from x0 or x1. This will also say I can come from x0 and x1. So surely here you are having non-zero entropy. That means h of x by y would be equals to non-zero. Along with that, this would be maximum as well. Why is that so? Because both of the probabilities are same, no? Here, probability of bit 0 transmission is equals to probability of bit 1 transmission, that is equals to 1 by 2. So here if I ask you, if I go to this bit 0, I call this as y0 and this as y1. So if I go to y0 and I ask him from where you are coming, he will say, sir, I am completely uncertain. I can come from x0 as well, I can come from x1 as well. But what if the scenario was something different? The scenario was that your q is actually equals to 0.3. What I am saying? What if the scenario was your q is equals to 0.3? So if q is equals to 0.3, then probability of bit 0 transmission is 0.3 and probability of bit 1 transmission is 0.7. Right? Okay. So bit 0 transmission is 0.3 and this is 0.7. Now I ask to this guy, I ask to y0 that from where you are coming. So y0 will say that, sir, I will come from x0 and x1 only, but more chances are there that I will be coming from here. Say yes or no. So when q is equals to 0.5, then you are having the maximum uncertainty. Surely it is non-zero. Here also it is non-zero. Here also it is non-zero, but maximum would be in this case. As of now, we are not even caring about the value of p. I am only talking about q. So if q is 0.3 or if q is 0.7, because what if q is 0.7? What if your q is 0.7? Because 0.3 plus 0.7 is 1. So what if your q is 0.7? The similar scenario would be happening here, no? Like this probability of 0 transmission would become 0.7 and this would become 0.3. Probability of bit 0 transmission becomes 0.7 and probability of bit 1 transmission becomes 0.3. 3, right? So for again he will say x0, x1, but now he will say that sir, more chances are there that I am coming from x0, from x1 as well I can come. That means uncertainty in x given that y, that is also non-zero. But for 0.3 and 0.7 both would be same. So what kind of graph you would be getting? What do you think? So sir, graphs I will be getting, that would be in these manner. In these manner I will be getting this kind of graph. But sir, a lot of kind of graph I can get, because I need to draw it for different values of. So no matter whatever the value of p is there, at q equals to 0 this will be 0, at q equals to 1 this will be 0. So this kind of graphs I will get, sir. For sure I will be getting this kind of graphs. I will be getting this kind of graphs for sure. Okay. So this is my q equals to 0.5. At q equals to 0.5 you are getting the maximum value. But now what about the probabilities? What about the value of p? What about the values of p? This is for a particular p, this is also for a particular p, and this is also for a particular p. So what about the values of p? For which of the value of p this graph would be maximum? What do you think? If p is equals to 0, let's just say I don't care about the value of q now, I care about the value of p this time. I will have to add more and more pages. Now what I am saying is that I don't care about the value of q, now I care about the value of p. Let's just say p is 0.5 or p is 0, sorry, p is 0. If p is 0, what does that mean? This is your x0, this is your x1, y0 and y1. That means if p is 0, that means this part is 0. So basically x0 is not going to y1, x0 is directly going to y0 and x1 is directly going to y1. This is the scenario, right? So uncertainty in x such that I already know y. If I go to y0, he will say that sir, I am surely coming from x0. He will also say that I am surely coming from x1. Answer would be 0. So if p is equals to 0, then h of x by y would always be equals to 0. What if p is equals to 1? Then also the same scenario would be happening. If p is equals to 1. If your p is equals to 1, then what will happen? These guys will not be there, these guys will not be there, these guys would be there. These guys would be there, right? So if I go to y0, he will say I am surely coming from x1 and he will surely say that I am coming from x0. So what would be your h of x by y? That would also be 0. So when p is equals to 0 and 1, they will be surely 0. But when p is equals to 0.5, what will happen? x0, x1, y0, y1. When p is equals to 0.5. This is 0.5. This would also be 0.5. This would also be 0.5. And this would also be 0.5. Just let me know one thing. Are you the most uncertain here? Surely, sir. I am the most uncertain here. Because 0.5, 0.5, 0.5, 0.5. And let's just say q is also 0.5. Then this is the worst possible condition. Let's just say I am saying that p is equals to 0.5 and I take q equals to 0.5 as well. That means probability of x0 transmission is 0.5, probability of x1 transmission is 0.5. You go to y0, what y0 will say? Sir, I am coming from x0 and x1 with the same probability. Probability of receiving y0 such that x0 is transmitted. 0.5 into 0.5, that would be 0.25. Probability of receiving y0 such that x1 is transmitted. That would also be 0.5, 0.25. That means y0 will be most uncertain than when p is equals to 0.5 and q is equals to 0.5. For q, we already know that at q equals to 0.5, your answer would be most uncertain. But completely uncertainty would be there when your p is equals to 0.5. So this was the graph for p equals to 0.5. If I don't care about the value of q, here also I can see that if I go to y0, that I already know y. So what is the uncertainty in x? So he will say that with 0.5 probability I can come from here, although probability of x0 will also come into action. Here also probability of x1 will also come into action. But on top level, if I see, y0 will say that, sir, I can come from x0 as well, I can come from x1 as well. So I'm not sure. So this would be non-zero. But what if your p is 0.3 or 0.7? So without even drawing the diagram, you can let me know that, sir, this will also be non-zero. If p is 0.3, then what this value would be? This value would be 0.7. This kind of diagram you will be getting. 0.7, 0.7, 0.3, 0.3. This diagram you would be getting. Right? So again, here also the same scenario would be there. I will go to y0. Y0 will say that, sir, more chances are there that I would be coming from x0. More chances of x0 are there, but x1 chances are also there. So uncertainty is there, but not as much as this case. And same goes for 0.7 as well. So where the uncertainty would be maximum? This would be maximum. This particular case would be maximum. This uncertainty would be maximum. So what do you see? What kind of graph I will be getting? P equals to 0.5. This would be 0.3, 0.7. And this would be 0.1, 0.9. And another graph would be there, which will be this one, which is there for P equals to 0 and 1. So can you see the graph, how the graph is going? P equals to 0.5, and then this is how it is reducing. From 0.5 to downward it is reducing. Is that understandable to you or not? Okay, a very deep discussion. Forget about finding these in notes, like nowhere you are going to find it out. And even if this question is coming in the examination, I hope it comes and you would see the solution, how people will give the solution. They will apply this mathematics, that mathematics, this formula you apply, then you do the differentiation with this particular scenario. Like no engineering involved. But here complete engineering is involved. Engineering means you need to use your IQ level. You need to use your intuitions. So always we need to think like engineer. Okay. So this is how we are able to think, and we have commented on h of x by y. So the answer would be 0.5, 0.28. This I have written down. This would be the answer. Okay. This is for the probability 0, 1, 0.1, 0.9, 0.2, 0.8 and 0.5. So this would be the answer of h of x by y. These will be cut down very easily. Okay. Now similar analysis you need to do for I x semicolon y as well. That means you need to find out mutual information. So our next analysis would be based on mutual information. I need to do this analysis, that I know that it would be equals to h of x minus h of x by y. So as of now I already know about this one. So let's take this into action now. H of x. So when h of x would be maximum? When your h of x would be maximum? If we want this to be maximum, if I want this to be maximum, although what they are asking the graph, but graphs are already made. So if I just need to check the option, what I would do? I can check from the options. How I can check? That what will be the maximum value of this one? This will be maximum when q is equals to 0.5. Why so? Because what is the diagram? Sir, this is the diagram. Diagram is this one. Forget about the probability of p. I don't care about the probability of p. But I know that if both of the symbols are equiprobable, if both of your symbols are equiprobable, if both of these symbols are equiprobable, then h of x would be maximum. Right? So if I want it to be maximum, that means my q should be equal to 0.5. So when q is equal to 0.5, you should get the maximum value. So if I look at the options, when q is equal to 0.5, you are getting minimum value. So these options are gone. C and D are gone. You are left with A and B. I am telling how to solve with respect to options. So C and D are gone, because with respect to q equals to 0.5, I know that this value will be maximum. If this is maximum, that means this will also be maximum. But now the race would be between p equals to 0.5 and p equals to 0 or 1. So let's take the case of p equals to 0. What we need to do? P equals to 0 versus p equals to 0.5. So which will have more mutual information, that we need to check. So let's take the case of p equals to 0. What is the meaning of p equals to 0? Sir, same diagram you can copy. Same diagram you can copy. If p is equals to 0, what does that mean? These guys will not be there. This would be 1, this would be 1. And in this case, I know that h of x by y would be equals to 0. So whatever that is being subtracted, that is minimum. Are you able to understand this point? When p is equals to 0 or when p equals to 1, whatever that is being subtracted, that is minimum. If that is minimum, what does that mean? That means you are getting the maximum mutual information. So what do you think, what should be the answer? Sir, answer would be this particular option. And at p equals to 0.5, what will happen? When p is equals to 0.5. Sir, again I can copy, but here the scenario would be that 0.5 here, 0.5 here, 0.5 here, 0.5 here, whatever it is, I don't care. And I can see that if I make the matrix of p of y by x, p of y by x, if I make this matrix, what do I see? 0.5, 0.5, 0.5, 0.5. Or even you make the matrix of p of x by y as well, what do you see? Same rows. I don't care about these values. This is q, this is 1 minus q. I don't care about these values. But when your p equals to 0.5, you are getting same row. What does that mean? Useless channel. And what does that mean? This is equals to 0. That means for p equals to 0.5, this would always be 0. So this is the final answer. Are you understanding this point or not? So very easily, like if these options are made in the examination, very easily I would be able to solve the problems. It will not take me much time. Why it will not take you much time? Because options are already made, no? Right? So you will just check at the certain values. Q equals to 0, Q equals to 1, then you check at the midpoint where you are getting maximum, you will be able to click on that. So no mathematics, nothing. Only pure intuition, only pure meaning of symmetric channel or pure meaning of uncertainty you should know. If you know the meaning, then you will be able to solve it. Otherwise, you will apply this mathematics, that mathematics, and you will simply mess it up. Is that clear to you or not? And with this particular discussion, your information theory has ended. Okay? What has ended? Information theory. So only the information theory part has ended now. Next, our discussion would be source coding. But I will take a break and then we will start source coding. Within 1 hour, we will be able to complete source coding as well. Very, very simple topic, very straightforward. Okay? But it is interesting. You will enjoy it. That I can say. Enjoyment would be there for sure. Okay? So information theory part has been ended. Next is source coding, and then we need to study channel coding. So source coding is very, very simple. Within 1 hour, you will be able to understand, and then we will move towards channel coding. Okay? So let me take a break and then I will come back.